Hey guys, my name is Lakshay and I'm a research analyst at Scalar Academy and welcome to another video of ours. Now before we start with the session, make sure you subscribe to our channel and hit that bell icon so that you never miss any updates from us. Now with this, let's see how much you are going to learn and what things you are going to learn in this session. So first we'll start with basics like how to answer tell us about yourself in a job interview, followed by 8 most popular Microsoft coding interview questions and with 6 most popular amazing coding interview questions. Now apart from this, we'll start with some interview questions related to specific topic. So we'll start off with Python, followed by C++, with data structures, SQL, DBMS, and we'll wrap up with AWS. So with this, let's start with our first topic.
Tell us about yourself.
Hello sir, my name is Vidya. I come from a family that consists of 4 people. My mom, dad, my brother and me. My father is a businessman and my mom's a housewife. Are you sure you want to sound like that? We are guessing it's a loud no. That's exactly why we are here with another edition of preppy videos to help you not sound how I just did. As boring as an interview prep can get, you can make it all fun and games if you start indulging into it rather than freaking out about it. Switch your narrative. Start looking at the interviewer as some stranger from the local bus talking to you out of nowhere. That idea is any day less awkward than an interviewer interviewing you. To help you get this switch and master the answer to this classic interview question, let's quickly dive into this video. Since this question in itself is so personalized, not all of you can have a common answer. Because individuality. You cannot tell them something about yourself on the basis of what your best friend spoke about themselves in an interview round. That's not even plagiarism, that's just hitting your head hard on the rock and then complaining about why it's hurting. But even though the answer cannot be same and we cannot curate the perfect answer for you, we got you tips and tricks that should help you note your answers around. But before we start discussing what elements need to be a part of your answer, you need to understand why this is a standard question asked in most interview sessions. Just the way you are nervous and wondering how to strike a good conversation with your interviewer also has a flow of conversation planned so they can evaluate your efficiency accordingly. Tell us about yourself is an open-ended question that can pave a lot of possibilities of how the conversation can flow after that. Your interviewer is trying to gauge what they should be asking next on the basis of your answer you provide to that question. So basically, how you answer this question will be a maker or breaker of the conversation that comes ahead of that. Besides it being an icebreaker, the question will also help the interviewer achieve their major goal, that is to getting to know you. It's not always necessary that the question is placed exactly like this. The interviewer may end up asking you to tell them something that's not mentioned in your resume. Give us a little background about your journey. Walk me through your resume. These are some form of questions that basically are asking for one thing. Tell us about yourself. So without further ado, let's get into discussing elements that need to be present in your answer for this question. You can start off with your current status and accomplishments. It's usually the first part, what to speak first, that keeps us stuck. We contemplate that perfect beginning for anything we have to say or write. We know for a fact that once we figure out this beginning, what to speak next will follow easily. So to not sound vague, start off with your current status. What you have accomplished till now, what you are currently doing will make a good start to your answer. That way you won't even be beating around the bush and just cut it to the point where what you say truly matters. Your beginning needs to be impactful, and what's better than showcasing your current situation and how you're working towards personal growth that contributes in your professional world. So if you're a graduate, you can start off with how you have pursued your degree and picked other learnings to complement the existing one. You can talk about various online courses and tricks you have learned along with your main course and speak about your growth graph in terms of grades. And say if you're someone who is switching to a different firm, speak about your contribution with the company you were working with so far. How you have proven to be a valuable asset to them. Back your statements with stories of your work experiences so that it doesn't seem like you're boasting. Moving on, talk about where do you see yourself. No one wants someone who is out here milking a momentary lifestyle. Your interviewer needs to know you are a visionary person. They need to know you are an individual that has mapped out where he would want to see himself in the future. Let that reflect in your talk. Speak about what your aims are. Talk about how this opportunity will help you meet the vision you're working towards. Don't hesitate on how unreal your expectations from yourself sound like. We are all on a learning curve for our entire lives. You may end up learning something from a 5-year-old at the age of 30. So it's a forever process. And being honest and bold about your vision will show how much faith and integrity you carry in your work. So even if you are developing a system that no one has ever imagined sounds way too unreal, say it out loud. Acknowledge that this job is going to play a huge role for you to map out how you will meet that end goal. When you are an employee of a company, it's not just you working for them, it's you working and growing with them. The interviewer would be more than pleased to hear how your future is aligned with the company and your will to grow with it. Next up, mention how will the company help you grow. Like we mentioned previously, your vision shouldn't be a me speech. When you plan to associate with any company, it's a unit. When you talk about your vision, your plans, don't forget to mention how that specific company can help you groom into a better performer. Do a little research on the company's background and back your talk with some real life examples. Say if the company you are interviewing was established in 2000, acknowledge how far it has made it. How they not only expanded as a company but took well care of their employees' growth. This point in your answer will talk about how keen you are about being a part of their firm, hence you perform the research. They'll be able to sense the dedication and motivation you'll be able to bring to the table. Ensure them that you are not here to be associated with the company just for some numbers, but to spend good amount of years and bring your vision to life with them. Next up, don't forget to mention your potential contribution. So far, you have talked about your vision, your learnings as yet, and how the company will be able to help you enhance your skills. But you also need to mention your potential. No one knows everything, but you could be one of those people who is willing to learn whatever comes your way. Speak about how you are willing to tap the truest potential with them. Let them know how well you function under challenging circumstances, tough deadlines, teamwork, and even alone. You don't have to narrate these qualities like a bot, but share real-life incidents that reflect these traits. Say there may have been some camp in your college or some tech fest that you largely contributed to. Or maybe your experience at internship or experimenting your first college project with your college mates. The point is, it's not necessary that your stories have to be work or academic related, but the story should come down to the qualities you are trying to showcase them. Narrate and communicate, that's the key. Make sure you fuse in passion and professionalism both. While we all know that you are there to land the job, don't make everything revolve just around that. Let the interviewer learn a little bit more about the kind of person that you are. This bit of your answer will make it a little more personalized and authentic. Most importantly, a little light-hearted. Let's be honest, interviewing so many people from the same field can get a little boring, where 50 different people are constantly talking about the same industry over and over again. Here's how you can break the chain. You don't have to go all out like, in my free time I like playing guitar or listening to songs. No, we are no school kids. But you can talk about where your passion is rooting from. Frame your statements like, besides this, since my childhood, I've always been fond of being on the creative side of the things. I've always looked up to my grandmother talking about how art drives us through thick and thin, and hence I like to indulge into creative activities. I have tried not restricting my experiments, so I end up painting, learning instrument, even writing for myself sometimes. I believe it's a good form of release. That right there talks about so many qualities and how you quickly find inspiration, how you don't restrict yourself and trying anything and everything, how you always break the cycle of mundane by snapping out of it. These little qualities as a whole make you appear as a strong candidate for the role you are seeking for. Make sure you make it very conversational. This is so important. We know how nervousness can shake up your tone in front of the interviewer and how your confidence can take a hit. But take a deep breath and calm down. Talk to them. Look at them. I'm sure they have 2 eyes, 2 legs and 2 arms and speak a human language, so do you. So don't panic, because that's exactly when you start sounding robotic. The same constant tone like you are reading out some news information. No, you are not. This is yourself you are talking about. Nobody knows better than you do. So there is literally nothing to fear about sounding right or wrong or perfect, because whatever you talk about is going to be absolutely fine. So don't enter that room memorizing the answer you have drafted for the interview. Instead, just practice it out once. Hear the tone you are picking. Keep shifting your tone so you are not too boring to listen. Remember the point you want to mention and let the story flow out naturally instead of mugging them up. Because believe me, you will sound like you are answering a question in 5th grade when your science teacher is asking you what's mitochondria. Trust me, don't do that. Just hold up your confidence upright and speak calmly. Be audible and clear. Lastly, keep it positive. Let your energies flow in your conversation. If you have entered the room even with the slightest feeling of failing at this, it's going to reflect in your talk. You might end up framing your sentences around negative prefixes even when you're trying to state something strong about yourself. It's natural because this is a part of the drill. So enter the room with your head high and fuel your willpower because you know you got this. You need to remind yourself of how everything you are, how your individuality comes as a leverage to you instead of comparing yourself with someone else and having your positive outlook take a hit. And worse come worse, even if after all of this you fail to crack this interview, believe me, it's for the best. You'll hear a lot of successful people preach one thing most often: failure is your best teacher. If you got everything in one go, you might never take time to rectify your shortcomings and strive to work on them. You would get too comfortable for being accepted for who you are and your growth will take a hit. So focus on the brighter side of things and you shall genuinely do better. We are sure, even though we haven't drafted an answer for you word by word, your mind has already curated the first draft to this question and we feel good that the purpose is achieved. Bottom line is that bring the authenticity to your answer. Rest everything shall follow with it. Now make sure you note down all the thoughts that crossed your mind while watching this video. That will make an ideal point for your answer and get to practicing it. Don't forget to manage your tone through the conversation. Don't be a bot. And hey, don't panic either. You got this. We really hope you guys liked this video. Make sure you don't forget to like and share this video. For any queries, comment below and we will get right back to you. Thank you so much.
Hey everyone, welcome to another exclusive video tutorial by Scalar Academy. Before moving forward, please subscribe to our channel because a lot more tutorials are coming up and you don't want to miss them.
In this video, let's talk about the problem trailing zeros in factorial of n. As per the problem description, we are given an integer n and we have to return the number of trailing zeros in factorial of n. So please note that your solution should be in logarithmic time complexity. As per the problem constraints, n lies between 1 to int max, and in the example input we are given n as 5. The example output is 1 because the factorial of 5 is 120. Here there is only one trailing zero. So therefore we will simply return 1. Now what is a trailing zero? So if you look at here and if you say there are 3 trailing zeros, then you are wrong. Why? Because a trailing zero is the one which is at the rightmost end and that has no non-zero number to the right of it. So here there are only 2 trailing zeros. This will not be counted as a trailing zero. Let's see how can we approach this problem. So the brute force solution to this approach is that first we can calculate the factorial of n and then count trailing zeros in the result. So we can find the trailing zeros by repeatedly dividing the factorial by 10 till the remainder is 0. So what do we mean by that? So let's say the factorial, the n is equal to 10 and we'll do 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 and into 10. This will give us the number as 3628800. Now to find the trailing zeros, we will simply mod it with 10 to get the last digit. So we will get 0. Now since this is 0, we will simply increment our count. Next, we will divide the number by 10 to check the next number, the next digit, that means this number. So after dividing it, we will get nothing but 362880. So that means this digit has been removed, the last digit. Now we have got this. Now in the next iteration, we will simply do the mod of it to get the last digit. We got it as 0. So again, we will increment the count. Next, we will divide it by 10. Right, so here we have divided it by 10. Again, find the mod of it and we get a non-zero number. That means here we have to stop because we have found out all the trailing zeros. And since we have got a non-zero numbers, that means we do not care what is there at the left of it, right? So we will simply stop and return the count. And this is what written in this snippet, that we have got the factorial as 120 of 5 when n is 5. So we will run our loop till this factorial is greater than 0. So if f mod 10 is equal to 0, we will simply count it up and we will divide f by 10. And else if it's not 0, then we will simply break because we do not care what is there on the left and we will simply return the count. But the problem with this approach is that the above method can cause overflow for even slightly bigger numbers, as the factorial of a number is a big number. So even if the number is as small as, let's say, 22, then it's going to cause overflow, because the factorial of even a small number is so big that it is certain to cause overflow, right? Therefore, this method is not the appropriate one. So what should we do now? Let's see what is a better approach. So how can we find a trailing zero in any number? So when a number is multiplied by 10, we get a trailing zero, right? So let's see 24. If it's multiplied by 10, we get 240. So here we have got a trailing zero just because we have multiplied it by 10. Then we have, let's say, 240, and if we multiply it by 10, we get 2400. We have got another zero which is contributed by this 10. Right, so in 2400, if we do into 10, we will get 24,000. So another zero which is contributed by 10. So here there's an observation to make that a number, if multiplied by 10, it will give us a trailing zero. So for example, if n is equal to 10, then we'll get this as this is the factorial of 10. So 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. The factorial is this, and we can see that there are two zeros, the two trailing zeros. That means there must be two tens, right? There must be number of tens is equal to 2 that are contributing to two zeros. So how are we getting that? So 1 10 is here, and 1 10 is formed by the combination of 2 and 5. So if we multiply 2 and 5, we'll get 110, right? So this is 110, and we will get 110 from here. So that accounts to two zeros. So this tells us that if in a number we look at the number of pairs of 2 into 5, then we'll be able to count the number of trailing zeros. So if in a number we look at that how many number of 2's are there and how many number of 5's are there, then we take the smaller number, we take the smaller power of a number. Let's say 2 is x and 5 is y. So let's say y is smaller than x, then we will take this, the number of 5's, and that is going to be the answer. Why? Because let's see with the help of this example. So in this case, the power of 2 is 3. That means there are number of 2's as 3. So this is 1, and 2 into 2 gives us 4. So 1, 2, 3. So there are 2 3's, and 5 is just 1, right? So 5 will pair up with a single 2 to form 10. Therefore, we will look at a lesser power from between 2 and 5, right? Now, do we really need to find the power of 2? Do we really need to find a power of 2? Well, here the observation is to be made that if we carefully look, then every second number is a multiple of 2 and every fifth number is a multiple of 5. So, if we are just able to find the power of 5, then they can pair up with that many number of 2's to produce a trailing 0. So let's look above with the help of example. So in this case, every alternative number, so this is a multiple of 2, then this is a multiple of 2, 6 is a multiple of 2, 8 is a multiple of 2, then 10 is a multiple of 2. So at every second number, we are able to find the multiple of 2, which will give us the number of 2's, right? That will give us the number of 2's. And every fifth number is going to be the multiple of 5 that will contribute to a power of 5, right? That will contribute to the power of 5. So as we can see that the number of multiples of 2 are greater than number of multiples of 5, that means we are going to get more number of 2's as compared to 5. So the number of 2's are going to be greater as compared to the number of 5. So we need not calculate the power of 2. Instead, we can simply calculate the number of 5's or the power of 5. So the problem has now reduced to finding the power of 5. So this is a generalized equation, like if we want to find a power of any number, then we can apply this formula. Here our x is equal to 5. So here we are actually trying to find the power of 5, and let this be any number, the remaining number which when multiplied with the power of 5 gives us factorial n. So how can we find the power of 5, or how can we calculate the number of 5? So for that purpose, we can simply take the floor of n by 5. For example, let's say n is equal to 11. Now n by 5 gives us 2.2. The floor of 2.2 is nothing but 2. That means the factorial of n is going to have 2 zeros. If we see here, then the factorial of 11 is nothing but 3991680. So there are 2 zeros, the 2 trailing zeros. Because in 11, how many multiples of 5 are there? It's 5 and 10. So this has contributed to 1 5 and this has contributed to 1 5. Therefore, the total number of 5s are 2, and therefore the trailing zeros are 2. But we are not through yet. Why? Because what about if n is equal to 28? What will happen in that case? So if n is equal to 28, so in 28 factorial, what are the multiples of 5? So the multiples of 5 are 5 itself, then 10, 15, 20 and 25. 5 will contribute to 1 5, then 10 will contribute to another 5, 15 another 5, 20 will also contribute to 1 5, but here 25 is going to contribute to 2 5s. So by taking floor of n by 5 with the formula n by 5 and taking floor of it, we'll get 1 5, right? So if we do n by 5, that means 28 by 5, this is going to give us 5 only, right? So that means here we are going to get just 5 zeros. But here we can see that there are 6 zeros in total. So for getting the left out 5, that means the 5 which is still to be counted, we'll have to divide it by next power of 5, which is 25. So now we actually have to calculate the power of 25. But now what about 128? So in that case, we'll get 125 as well in the multiples of 128 factorial, the multiples of 5 in 128 factorial. So it's going to be 5, 10, 15, then 20, 25, 30 and so on, then 125 as well, right? So 125 has 3 number of 5s. So after dividing by 5 and then by 25, we'll still be left with one more 5. So for that, we'll have to divide it with the next power of 5, which is 125 to actually get the third 5. Now the formula has become, so the count of number of 5s in prime factors of n factorial, it's equal to floor of n by 5 plus floor of n by 25 plus the floor of n by 125 and so on till the number is greater than n by power of 5. So the time complexity of this approach is going to be order of log base 5n. What was the question? That we have to find a logarithmic time complexity, and we have actually achieved that. So why? Because we are incrementally dividing n by powers of 5. So first we are dividing n by 5, then n by 25, then n by 125, so on till n by 5 to the power k, which reduces to 1, and n by 5 to the power k is equal to 1. So n is equal to 5 to the power k. After taking log both sides, we will get k as log base 5n. That means log base 5n number of steps we have to take to get the solution, and therefore the time complexity is going to be order of log base 5n. So this was it.
Let's talk about the problem anagrams. So given an array of strings, you have to return all groups of strings that are anagrams. Represent a group by a list of integers representing the index in the original list. Let's look at this sample case for clarification. So an anagram is a word, a phrase or name formed by rearranging the letters of another. For example, spar and rasp Both are anagrams because they have same set of characters, the frequency of characters are same, but only the order is different, right? Also note that all inputs will be in the lower case. So for example, the input is cat, dog, god and TCA. So you have to return 1, 4 and 2, 3. So basically we have cat over here, then dog, then god and TCA. So this is 1, 2, 3, 4. Right, so cat and TCA, they are anagrams because they have same set of characters, even the frequency is same but the order is different, right? So we have taken them together, that means 1 and 4 are together. Likewise, dog and god, they both are anagrams because again the characters are same, the frequency is same but the order is different. So 2 and 3 are anagrams. So we have to basically return the answer like this. Now here in the explanation it's written that cat and TC are anagrams which correspond to index 1 and 4. Dog and god are another set of anagrams which correspond to index 2 and 3. So the indices are 1 based. The first element has index 1 instead of 0. So let's see how can we approach this problem. So the solution approach is that we can sort the given strings. Now how does this intuition came? So basically from the question itself, it said that anagrams are the words that have different order of the same set of characters. So if we sort both the strings, then if those strings become equal, that means they are anagrams, right? Because the order was different only, but they have same characters. So if we sort them, then the strings which are anagrams will become equal. And after that, we can simply group them together, right? So here we have got the input as act, DGO, DGO and act. So we have actually got them by sorting the individual strings given in the input. So ACT represents cat, DGO represents dog and DGO again represents god and ACT represents TCA, right? So we have basically sorted them. Now we know that a group of anagrams can be represented by a key, which is nothing but the string we get after sorting characters present in those strings, right? So here both cat and TCA are anagrams and they can be represented by a string which is ACT. So this we have got after sorting the characters present in them. So now to group the strings basically we can perform hashing. So how can we do that? So a key can be the string, right? This unique string. Here the group of anagram is cat and TCA, right? So we can have a unique string for them which is ACT. Likewise for dog and god we can have a unique string as DGO. So we can have a string and then we can have value as vector of int because we have to basically keep track of the indices of the anagrams, right? So now we will simply iterate over this array, the sorted array. So first we are at act, then act is not present in our map. So let's put the string and the index present is 1. So let's put it in the vector, right? Now we are at DGO, right? So DGO is also not present in the map. So let's put it in the map and the frequency and the index present is 2. So let's put it in the vector. Now let's move ahead. So DGO is already present in the map. Now let's include the index, right? So we have included 3. Now we are at the 4th position and act is already present in the map. So let's simply include the index. So here we have the set of anagrams represented by their indices. Now the only task is which is left, that is to iterate over them and store it in the vector, right? So here we have vector 1 and 4 and we have a vector 2 and 3. So we will push them into a vector and we will simply return this in our answer, right? Also we will only put the vector in this resultant vector which have a size of greater than 1, right? If a string has size of just, so if the vector has size of just 1, then that means there is no anagram present for that particular string. So we can simply ignore that, right? So now For the time complexity, let's look at how we are going to sort the strings. So for sorting the string, basically we can perform counting sort. We are able to perform counting sort because here the range of characters is fixed, right, which is 26. So we have 26 characters and therefore the complexity is going to be order of n into k, where n is the number of strings and k represents the length of the longest string. So the time complexity turns out to be order of n into k. Now, if we don't want to sort the strings up, then we have another approach as well. So we can actually maintain a frequency array, right? Now what is a frequency array? So let's suppose we have this as a string. To form a frequency array of this, we will have a character set. We will have an array of 26 characters which have a range from 0 to 225. So why 26? Because we are in the input we are given that only lowercase alphabets will be there, right? So we maintain a frequency array of size 26. Now basically we will be mapping small a to index 0, then small b to index 1 and so on, and we will be representing small z by index 25. So basically here we will be storing the frequency of all the characters. So frequency of 0 denotes that it is the frequency of character a and so on. Here the frequency of a is nothing but 1. So we will put 1 over here. Then frequency, so basically we will be iterating over the string. So let's do that. So here b is there and frequency of b is nothing but 1. So at index 1 we will put 1. Now b is nothing but only 1. So let's put 1 at index 3, right? Then a is there, so let's put 1 at index 0. Then c is there, so let's put 1 at index 2. And e is there, so let's put 1 at index 4. Initially all will be initialized to 0. So here's how we have built this frequency array, and likewise we can do for this string as well. And if the frequency array of both these strings come out to be equal, that means they are anagrams of each other. And likewise we can check this for all the strings given in the array. So for this purpose we can basically have a map where the key can be, instead of string, it can be the vector of it. So here it represents the frequency array. The strings having the same frequency array will be pushed to the corresponding vector. So let's see how we will maintain this. So here we have cat, right? Frequency array for cat will look something like this. So here in this will be the key, right? Since this was not present, so first we will be pushing it, right? And then we will be placing this 1 over here. Then we will be moving on to dog, and frequency array of this will look something like this. And we will simply put 2 over here, right? Then we will move on to God, right? The frequency array of God will look something like this. So we will put 3 over here. And for TCA, the frequency array will look something like this. So we will put 4 over here. So that's how we can do it, and then the last thing left will be to simply iterate this like we did previously and return the answer. The time complexity for this approach is going to be, so for creating frequency array for a string, it's going to be order of k, where k is the length of the string, and the total time complexity will be order of n into k, where n is the number of the strings, so it's going to be order of n into k. So this was it. Thank you so much.
Hello everyone. So I'm Naman Bhala. So today I will be solving 2 problems from binary search, and let us say one other problem, that whatever comes in my mind. Okay. So let us solve the problem of, let us say that we will solve the matrix median and we will implement the power function. Let us start with the matrix median. The problem says that we are given a matrix of integers A, the name of the matrix is A, and the dimensions of the matrix are n cross m, okay, in which each row is sorted. Okay, so basically each row is sorted, and we have to find and return the overall median of the matrix. No extra memory is allowed, and rows are numbered from top to bottom, and columns are numbered from left to right. Okay, so basically we have to take order of 1 space to find the median of the matrix. Median of matrix is nothing but the the middle element of the whole matrix. Okay, and if the total number of elements in the matrix are even, then it is the what we say, it is the mean of the two middle elements of the matrix. Okay, we're only given the matrix A. Is it given that the total number of numbers will be odd? No, right? That is not given. So okay, n into m is odd. It is given that. Okay, so it is always going to be the middle element of the whole matrix. Basically, the element, I mean, like in equal number of elements are less than that element, and equal number of elements are greater than that element. Okay, so that element will be the answer. Okay, so this is an extension of a very simple binary search question, which is known as find median of an array. But this has some optimizations. Okay, first of all, let us see how we solve the find median of an array question. Suppose we have to first find the smallest and the largest number of the matrix. The largest number of the matrix will be any of these three, right? It can be 5, it can be 9, or it can be 9. Why? Because all the rows are sorted. Similarly, the smallest number can be any of these three. Okay, because it is not given that elements are individually sorted, but only the rows are sorted. Okay, columns are not sorted. So it could have also been a 1. So first we find the smallest and the largest element. How we can do that? Let us say minimum element is initially int max and maximum element is initially int min. Okay, so we do for int, let's first calculate the dimensions of this. N is equal to a dot size and m is equal to a0 dot size. Okay, now we've tried to find the minimum and the maximum element of the whole matrix. So I say for int I equals to 0, I less than n plus plus I, minimum is equal to min of the present minimum, comma, ai 0. Okay, similarly, maximum is going to be the max of present maximum and ai m minus 1, right? Great. So now we know the minimum and the maximum element. So once we know the minimum and the maximum element, what can we do? Once we know the minimum and the maximum element, now we can binary search to find, I mean, which can be the answer, what can be our answer, right? So let us say initially the answer will be a number in the range of minimum to maximum, right? So because all the numbers are within that range. So let us say L is equal to minimum and R is equal to maximum. Okay. Initially we don't know the answer, so we set the answer variable by -1. Okay. Now we try to do the binary search. Okay. By the way, in binary search, I always try to maintain one template, the exact template that I'm writing now, because this avoids all the what we say as overflow issues and infinite loops as well. So this template works perfectly fine. Okay. So now we need to check if there are less than or equal to n into m by 2 elements for mid, right? I mean, like if there are less than or equal to n into m by 2 elements, then this mid. How can we do that? Then one way to do that is we have to iterate over the whole arrays, over all the arrays, over all the rows and all the columns, and we try to find how many numbers in the matrix are less than or equal to mid. Correct? That is one way. The other way is because all the rows are sorted, rather than traversing, we can actually binary search over each of the row and find how many numbers are less than or equal to the mid, right? We can find that in order of log n. So how can we do that? Let us say that one of the rows is currently, let us say 1, 3, 5. Okay? So let us say the row is 1, 3, 5. And suppose our mid is 4. Now, how many numbers in this row are less than or equal to 4? 2, right? There are 2 numbers in this row that are less than or equal to 4. What we can do is we can binary search upon this matrix and we can find the first index greater than mid in the row. Okay. So basically first index in this case will be 2. Okay. And basically whatever will be the first index that will be greater than mid, that is our answer. Correct? Okay. Now, what are the edge cases? The edge cases that index 0. I mean, like, let us say, suppose our mid was 0. In that case, 0 would have been the answer. So that is perfectly fine for us. But there is also an edge case. No element is greater than mid, right? In that case, we should assume, we should assume answer is equal to n. What I mean by n is basically the number of elements in the row. Okay, so for example, it can be 0, it can be 1, it can be 2, and let us say had there been a 3 here, probably that would have been the largest element. So we can say that this 3 is the answer. Okay, so now we have to binary search upon each row and find in the whole matrix how many elements are less than or equal to mid. Okay, so let us say less equal count is initially 0. Okay, then I will do on each row I will try to do the binary search. Okay, in this row also I will have to find L, which is, let us say, 0, and R will be equal to M minus 1, and answer can be considered to be, it's a normal binary search, so answer can be considered to be initially M, right? Because if none of the elements are less than equal to mid, M is the answer, right? This is actually M, not N. Okay, so how will we do the binary search? I will again do the same. While L is less than equal to R, int mid is equal to L plus R minus L by 2. Okay, now what are the cases? The very first case is if array I mid is less than, or I have to make this mid 2, right? If array I mid 2 is less than equal to mid, that means either answer is equal to mid 2, or in that case, this will actually find me the last element that is less than equal to mid, right? And L is equal to mid plus 1. Okay, else R is equal to mid minus 1. Okay, but I have to find the very first element that is greater than mid. Okay, how can I do that? Let us actually change it a bit. Let us say that if array I mid 2 is greater than mid, in that case I set answer is equal to mid 2 and R is equal to mid minus 1. Else L is equal to mid plus 1. Why am I doing this change? Because I need to find the very first index that is greater than mid. So suppose the element at this particular index is greater than mid. Now either this can be the answer or the answer is somewhere to the left, right? So if I do it this way, then I will satisfy the property, and then I can say less equal count plus equals to answer. Okay, so now at the end I will know how many elements are less than or equal to the current mid, right? This should be R is equal to mid 2 minus 1, and this should be equal to L is equal to mid 2 plus 1. Now I have to check if less equal count is what? If the less equal to count, so let us say that for a matrix, what should be the answer? Suppose our matrix is this 1, 2, 3, 4, 5. So if the elements that are less than or equal to this are, in this case, n is equal to going to be 5. If the elements that are less than equal to mid are what is going to be 5 by 2? 5 by 2 is going to be 2, right? 5 by 2 is going to be 2. So I have to find the first index for which this is equal to 3, right? Okay, so I can say if less than equal to count is greater than mid plus 1, greater than n by 2 plus 1, then this can be the answer, or answer can be somewhere to the left. Okay, so I can say if less than equal to count is greater than or equal to n into m by 2 plus 1, in that case my answer can be mid, or it can be somewhere on the left, right? R is equal to mid minus 1, else L is equal to mid plus 1. Now my answer will be the real answer, and I can finally return answer, right? Because I'm setting this here. Will it work? Yes, it is the correct answer. Yeah, here I have done one bad coding practice. I'm using the same variable names here as well, right? But why this is going to work? Because the upper L and R are not really going to be affected, right? Ideally, this should have been a different function in itself. Okay, a function, this thing actually should have been something like a function that has two parameters. That can be integer less equal count, to which you pass the array A and you pass the mid, and this returns count of numbers less than or equal to mid. So ideally this thing should have been abstract it into a function, but I haven't done that. Why? I'm like, just to be a bit fast, okay? But as you see that the answer is correct, and I think even in submit it should be fine. Correct, we got 218 points. In binary search, I'm like, just an advice, always try to use this template, because this is always going to work perfectly fine, and you have to only remember one template in your mind, so that actually helps you a lot. So what we are doing here is, we are in this particular case, right? In this particular case, we are trying to find for each row, this for loop is running for each row. For each row, I'm trying to find count of elements that are less than equal to mid, right? Why can I do that? Because each row is independently sorted, right? As each row is independently sorted, I can do a binary search over each row and find the count of numbers that are less than or equal to mid. Okay. So how it helps me is that now, in how much time can I find the count of numbers that are less than or equal to mid? I can find this in order of n log m, right? Otherwise, had I not done a binary search, it would have taken me order of n into m time. Okay. Now, what is the overall time complexity of this algorithm? This loop, this while of L is less than equal to R loop runs for order of log of maximum minus minimum, right? Basically, that is a range of numbers. So the overall time complexity is going to be order of n log m into log of maximum minus minimum. Got it? I'm finding the count because I need to find which is the number that is the median of this matrix, right? Now, which is the number that is going to be a median? The median is that number, the count of numbers less than equal to that is equal to the count of numbers greater than equal to that. Okay. Now, how can we find the number is equal to count of numbers that is greater than equal to that? We can do a binary search, right? Because why can we do a binary search? So definitely we know that, let us say this matrix. Okay. Suppose X numbers are less than or equal to 6. Then we are definitely sure that greater than X number are going to be less than equal to 9, right? So as this property is a monotonous function, that means we can use binary search to find the index. Okay. I'm not sure if you have seen this question, find median of an array, find median of an array, median of a constant array. Okay. If the array was not constant, you could just sort it and then find the middle element, right? But suppose you were not allowed to modify the array, then what you can do is you can use binary search over the answer range. Okay, cool. Okay, what this does is, so the very first thing is we are given that each row is individually sorted, right? 135 is sorted, 269 is sorted, and 369 is sorted. Okay, but it is not that 5, the element at this place is less than equal to element at this place. Okay, only the rows are sorted. Okay, now you are asked to find which number in this matrix is going to be the median. Suppose you would have converted this matrix to an array. What is going to be the median? The median is the element that is the middle element of a whole array, right? Okay, so basically median is the element. Suppose an array of size n is sorted. Okay, so let us say that the array was 1 2 3 4 5. Okay, middle is going to be, for this case n is equal to 5, right? Middle is going to be nothing but the element at the index n plus 1 by 2. Clear? Okay, so that is what the median is going to be, right? Median is going to be the element at this particular index, which in this case is 3. Okay, awesome. Actually, the third element or the element at index n by 2. Index is going to be n by 2. N by 2 in this case will be 2, and 2 is this particular index, right? Okay, so that is the median element that is going to be. But how can we search for this element? Now, suppose I try to do a binary search. The question then changes to finding the n plus 1 by 2th smallest element of the array, right? I'm not sure if you have seen this question as well. all these questions follow the same property. Find kth smallest element of the array. Okay. This question is a very, popular question of binary search. Okay. A median problem is nothing but find kth smallest, where k is nothing but n plus 1 by 2. Right? This is what the problem reduces to. Now, what code I'm doing here, this code is nothing but the code to find the kth smallest element of the array. Okay. So that is why I try to, if I go here, I try to find if, if this is greater than equal to k, then I do. This is the exact observation that you do. Let us actually discuss the kth smallest problem as well. Kth smallest element has a lot of ways in which you can solve this. The very first way in which you can solve this is sort the array and return a k minus 1, right? This has order of 1 space, but order of n log n time. Okay. Okay. The second way is use a priority queue. Use a heap or priority queue. Okay. This has order of k space and time complexity of order of n log k. Correct? The third way in which we can do that is binary search. Binary search allows you to do this in order of 1 space and time complexity of order of n log of range. Okay. So in the questions when you are not allowed to use an extra array, in the questions when you are not allowed to use an extra array or extra space, in this case the binary search works. Okay. Also, in some cases you might not be allowed to modify the array. In that case you can't use sort, right? Unless you create a copy of the array, which you don't in most of the languages, right? So this will have order of n space only if you are not allowed to modify the array, because in that case you will have to create a copy of the array, right? Cool. So actually, if you have not seen this question before, try to solve this particular question as well, kth smallest element, in all the 3 ways. Okay, using the array, using a heap, and actually, if you want to solve it in even a better way, there is also quick select. Quick select allows you to find this in order of n, probabilistically. This intuition is just like intuition of quick sort. So there are multiple ways to solve this simple problem. Okay. So if you actually encounter this problem in an interview and you tell all these ways, person will be impressed. Okay. Cool. Do try to solve this question. After this question, also try to solve this question. Find median of an array. When you will solve this particular question, you can solve this in binary search on answer way. Okay. Then the question that we solved today, find median of a matrix, is nothing but an extension of the web question. Extension of median of an array. Okay. Cool. I think let me actually explain how this quick select works, but let me just give you a brief idea of this. In quick sort, what you do, in quick sort, you partition and solve 2 subproblems, right? And that is why the time complexity that you get is a tree, and then you get a time complexity of order of n log n, correct? But in quick select, you partition, that is the very first step. Okay. Now, what are the possible scenarios after you partition? Okay. The scenario 1 is that partition is at an index, like pivot is at index greater than k. In that case, solve problem only of left side. Like the problem is then find kth smallest on left side. Find kth smallest on left side. Okay. And the other scenario is pivot is at index greater than k, right? At index less than k. In that case, the problem is find basically which smallest. Suppose pivot is at index less than k. Let us say that in this index is u. So the problem is just find k minus uth smallest on right side. Okay. So now the time complexity T of n is going to be nothing but T of order of n plus T of n by 2. Right. Now this time complexity, if you try to solve this particular recursion relation, is order of n. Okay. Yes, but in this case, we will have to modify the array. So this will only work works only if we are allowed to modify array. Okay. So basically, if we are allowed to modify the array, the best solution probabilistically is quick select. But I mean, like in worst case, this can be order of n square. So that is a takeaway that you have to do. So one question, it can be solved in multiple ways, right? Even if we are not allowed to, I mean, like even if we were not given a sorted array, we can use binary search to find the median, but then the time complexity that will be needed will be order of n into m into log of range. Okay. So basically, I mean, like let me give you an idea of that. Okay. How you can get an idea of that is, let us say that you were given an array like this: 7, 3, 9, 4, 2. Okay. Okay. Now what you try to do is you have to find the median element, right? So first of all, in the very first step you do, suppose you calculate a mid element. Okay. Suppose initially the L will be 2 and R will be equal to 9. Okay. So you try to see, in the case 1, you try to see, can suppose what is mid. Mid comes out to be suppose 5. Now you find how many elements are less than equal to 5. How many elements are less than equal to 5? In this particular array, only 2 elements are less than equal to 5. ठीक है, लेकिन अगर 5 को median होना था, I mean, like if 5 had to be a median, how many elements should have been less than equal to 5? 3, right? I mean, like if 5 was to be a median, so I mean, like if we would have sorted this array, this would have become 2, 4, 2, 3, 4, 7, 9, right? Acha. So if mid is 5, how many elements are less than equal to 5? 3. Okay. Acha. Agar 5 ko median hona tha, to how many elements should have been less than equal to 5? 3, right? Because the element that is the median, I mean, like in this case 4 is the median, there are less than or equal to 3 elements. I mean, like there are 3 elements that are less than equal to 4. Acha. So 5 can be the answer. So सबसे पहले mid is equal to 5. Then we do an order of n iteration over this array and we see how many elements are less than equal to this. ठीक है? अच्छा. Now when we see that, okay, the answer is 3. अच्छा. So if 5 would have to be the median, then how many elements would have to be less than equal to 5? 3, right? अच्छा. तो यानी 5 can be the answer. This means 5 can be the answer. But something less than that can also be the answer, right? Can also be the answer. I mean, like suppose हमारा mid would have been 7. हमारा अगर mid 7 होता, तो how many elements would have been less than equal to 7? 4, right? तो शायद ये answer होता, but something smaller than that would have also been the answer. ठीक है? In the next iteration, suppose our mid comes as 3. Then we again do an order of n loop and we see that only 2 elements are less than equal to mid. So can 3 be the answer? No, 3 cannot be the answer, because अगर वो median होता, so there should have been less than equal to 3 elements that are, ठीक है? अच्छा. So now the range reduces to 4 to 5. I mean, like या तो 4 होगा, या तो 4 होगा आंसर, या 5 होगा. ठीक है? In this case, mid will be 4. ठीक है? Now we again do an order of n loop. How many elements are less than equal to 4? 3. So that means now my range changes to 4 to 3. This is an invalid range, so my answer is 4. Okay? So this is how we solve it. So how many different mids we will have? We will have total of order of log of range mids. And to verify if a particular mid can be the answer, we need order of n time. So that is why the total time complexity is order of n log range 2. Okay? Cool. Let us solve one more question then. Cool, we will solve one backtracking question and then we will call the end of the day. Okay, so let us take this question. Palindrome partitioning is the next question. Interesting. So the question says that we are given a string S. We have to partition S such that every string of the partition is a palindrome. Okay. And we have to return all possible palindrome partitioning of S. Okay. Okay, like this is one palindrome partitioning, this is another palindrome partitioning. Okay, then we have to order the results in such a way that smaller entries should come first. Okay, and I mean, like first smaller entries should come first, and yeah, so that is the only thing. I mean, like the partitions should be sorted by the length. Okay, So AAB should come before AA comma B. Why? Because length of AA is greater than the length of A. So that is actually a very easy thing to do. Okay. How can we solve this question? Okay. So in any, what we say, backtracking question, you have to first think that about what thing will I make a decision for, right? In this case, what can I make a decision about? In this case, I can make a decision about, hey, can I partition at after this particular index? Can I break the string after this particular index? That is a decision that I can make, right? Okay. But when can I partition after this particular index? When can I partition after this particular index? I can partition after this particular index only if the current string is a palindrome, right? Because I can partition only if the current string is a palindrome, right? Okay. So I'm like, how can I check if the current string is a palindrome? One way to check that is, hey, I maintain what is the start index, where is the partition starting from, up to the end index, and then I do an order of n loop to see if that particular string that we made is a palindrome, right? Let me actually implement it in that way, and then I will try to even give an optimized version of that. Okay. Acha. So let us, I'm like, how I solve the backtracking questions. I first try to write the recursive function, and then you will see that how we solve it. Okay. Recurse. What is the thing that I'm making? First of all, what is the thing that I need? Firstly, I need the string itself, right? Firstly, I need the string itself. So I will need the string A. Okay. And what is the next thing that I need? I told you that I need to know where is the current partition starting from, right? So I need to know what was the start index of the current partition. Okay. Okay. What do I also need to know? I also need to know the current index, because after that only can I make a decision that, hey, should I partition after this or not? Okay, because that is the thing I'm making the decision about. Okay. So I need the current index. Do I need anything else? I also need to store what was the current, what are all the other partitions that I've already made before the start index, right? I mean, like I already, suppose I have to make the partition at B. I already need to know that AA partition has already been made. Or I mean, like in this case, when I'm going to make the partition of B, I need to have an array where I have already stored that I have made these two partitions, right? So I can also have a, I mean, like vector of string current partitions, current parts. Okay. Awesome. Acha. What is the base case? The base case is when the current index is equal to the end index, right? So I mean, like if current index is equal to what I say a dot size, in that case probably that is the base case. I'm like, how will I solve this base case? I don't really know right now, but let us say that this is the base case. But first of all, let us try to recurse. I mean, like, what will we do for other cases? Other cases, we have two choices. The very first choice is not partition here, and the second choice is partition here. Okay. Acha. First of all, if I do a partition after this particular index, and that is a valid partition, should I first partition or should I first take the case of not doing a partition? I should first take the case of doing a partition. Why? Because that will give me a smaller value of the current string, right? Okay. So I mean, like smaller length palindromes should come first. I mean, like A should come before AA. So that is the thing that we have. That is the only order that we need to maintain. Okay. So that is why we should first take the case of partition here, and then we should take the case of not partition here. Why? Because this will lead to a larger sized current partition, right? And we'll need a larger size current partition at the end. Okay, later. Okay, cool. So first of all, let us say when can we partition? To partition, we need to ensure that the string from start index to current index is a palindrome, right? So how can we do that? So we say int L is equal to start index, int R is equal to current index, while L is less than R, and if AL is not equal to AR, in that case, is palindrome is equal to false, and I can break. Okay. Otherwise, I do a plus plus L and I do a minus minus R. That is a normal function of how you check if a string is a palindrome. Awesome. Asha. If it is a palindrome, in that case, I can do a recursion of recurse A. Start index will now change to current index plus 1, right? Because I have made the string till here a partition. So the next string will start from the current index plus 1, right? Acha. Then what is the current index? Current index is also going to increase by 1. So that is current index plus 1. What is current parts going to be now? Now I can do current parts dot push back the substring of A dot substring from the index start index of size current index minus start index plus 1, right? So I do this to current parts. So my current parts will now change to this. Awesome. In backtracking, once you come out of recursion, what do? You undo the effects of recursion, right? So what can you do here? You can do current parts or pop back. Amazing. And what is the case of no partition here? The case is simple. We just recurse a start index doesn't change this time. Current index changes to current index plus 1 and the current parts remains as it is. Okay. Acha. Now we have to take care of the base case. What will be the base case? I have to push this to the answer if current index is equal to A dot size and start index is also equal to the current index. Why? Because I mean, like in this case, I will do answer dot pushback of current parts. Why will I do that? I mean, like if start index is equal to current index, that means there was a partition that ended till the last index, right? I mean, like otherwise there is the last part of this string that is not yet partitioned into a palindrome. Okay. What is the difference between start index and current index? Start index in this particular scenario is the index where the current partition is going to start from. Okay. I mean, like let us say for this case, I mean, like suppose our string was something like this: A, B, A, double B, A. Okay. So once we are at A, suppose start index was A. This means we are considering this part of the string. क्या ये palindrome हो सकता है? So we need to know somehow that where is the current partition going to start from? Okay. Where did the last partition end basically? Okay. And current index is the particular index that we are trying to make last index of another part. That is the difference basically. Okay. Okay. So now I will need to have an answer as well. So this will be a vector of string. Answer. Okay. So if I have a global answer, I will need to clear it. Okay. And then the question is simple. I recurse from 0 to what we say recurse 0. Start index is initially 0 because the first partition is going to start from 0. Current index will also initially be 0. And then what will be the initial current parts? Initial current parts will be an empty array, right? Because initially there is no part. So we can say that current parts is empty and we can pass this current parts to the variable. Okay, great. And then we can finally return answer. Let's try to test it. I hope I have not done any issues. A, comma 0, comma 0. So this should be an A. That is all. Correct. So this is working perfectly fine. And let us try to submit. Great. So yes, we are done with another question. So there is a doubt, sir. I always confuse backtracking step. Can you please explain why we pop that string if we finally need to print it? Awesome. Yeah, let me tell you. Okay. Acha. So now take this case. Okay. When will we come back to this line? We will come back to this line only, only after we have completed the recursion and we are trying to, we are back from the recursive stack, right? So that means we have already printed the answer. What backtracking helps us with is, otherwise, what were the different choices? Otherwise, first of all, you would not have passed a reference of the vector, but you would have passed a copy of the vector. Okay. Then in this case, what you would have done, you would have included this substring in the I mean like in the copy, and then pass this, right? This would have been the first case. So I mean like this is the normal recursion, right? Hey, the very first part is I partition after this particular index. In this case, I include the current substring to I mean like my current parts, and the other cases I mean like when I don't include them. So this is the normal case. But what is the issue with this? The issue with this is that hey, you need to create a copy of the answer variable every time, right? You need to create a copy of this current parts every time, which adds an additional order of n complexity. Creating a copy is not order of 1, it's order of n. So if you have to do it order of 1, what you can do is basically put something to the answer. I mean like give something, but once that particular recursive call is done and you're back, take away something from that. Take away that thing that you gave back from it. Okay. How you can do that? So basically backtracking, the general approach is, I mean like in swapping question as well. So suppose in backtracking, you do swap a comma b, then you do recursion. After that, you again do swap a comma b. Okay. So the steps is something like this is do some work, go ahead. Okay. And once you are back to your life, undo that work that you had done. So I'm like taking an example with your general life. Suppose you make a very bad decision in your life. Then what do? First of all, you don't know if the decision that you have made is a bad decision, right? So you make that decision. So I mean, like do some work is a bad decision that you made. And now you proceed with your life. At the end stage of the life, you encounter that, oh, I had done bad work. But I mean, like, even if you had done good work, but suppose someone gives you an opportunity to live the life again. So what will you do? Because you have already seen a part of the life, and when you come back to the same situation, now you will take a different road. That hey, I could have also made this particular decision, right? But before you take that different road, you have to undo whatever change you had done at the previous stage of your life, right? So what can you do? I mean, like you just first undo the work that you had done here, and then take another decision in your life. Got it? So I mean, like in Sudoku question, that thing is more clear. In Sudoku question is first decision is let us put 1 at current index. Okay? Acha. Then you proceed solving the remaining Sudoku. Okay. Acha. So once suppose you are done, I'm like suppose you have solved this Sudoku, then you will never come back to the same state of life, right? But if you later encounter that hey, because of the decision that I had made here, I cannot solve this Sudoku now. I mean, like I was not able to solve this Sudoku. So what will you do? The very first thing that you will do is undo whatever changes you made here, right? So undo the decision and then decide to take 2 at current index and so on. Okay? Cool. Okay, guys. So that was all from my side. Bye-bye.
Hey guys, so the first question that we are going to discuss today is the question longest valid parenthesis. And this question was previously asked in Google. So what the problem says is that given a string A containing just the characters opening parenthesis and closing parenthesis, find the length of the longest valid well-found parenthesis substring, right? So what will the input format? The input format will be just only one single string. What will the output format? We need to return the length of the longest valid parenthesis substring, right? And here you can see that the string can be of at max 75 into 10 raised to the power 4, right? So let's say this is the given example. So for this given example, the output will be equals to 2. Why? Because the longest valid parenthesis is equals to this section. Whereas in the input 2, the output will be 4 for the longest valid parenthesis as the pair of the first 2 parentheses and the second 2 parentheses. It's one of the very important questions, and this has been marked as 700 on interview bit. So let's just see that how we are going to solve the problem. Okay. So here you can see that the problem says that you need to find the longest valid parenthesis, right? Okay. So what we can surely say is a pair of parentheses will be said valid when we have the opening parenthesis balancing the closing parenthesis. So this is a valid parenthesis. Maybe we can say this is also a valid parenthesis. We can say this also has a valid parenthesis. Maybe this one is also a valid parenthesis, because here you can see that all the opening parentheses are balancing the closing parentheses. So what observation can we make? So the first observation that we can make for sure, that for any index, if the character at that index is equals to an opening parenthesis, right, then obviously the longest valid parenthesis ending at this position will be equals to 0. Why? Because this is an opening parenthesis and we need to have a closing parenthesis corresponding to it to have it balanced. Yes or no? Okay. Apart from that, let's say that if the character at any index is equals to closing parenthesis, right? If the character is equals to closing parenthesis, then there can be few cases. Let's just see what they can be. Let's say that the character of previous index, let's say the current index was I, so the previous index will be I minus 1. So if the character at the previous index is equals to an opening parenthesis, right, then here you can see that the I minus 1th index and ith index will be making a balanced valid parenthesis pair. Yes or no? So what we can say is, whatever our answer for this particular index will be, this will depend on the fact that, let's say there were some characters still here, then at I minus 1th index we had an opening parenthesis, and at the ith index we had a closing parenthesis. So what we can say, the answer at I will be depending on the fact that what was your answer till the index I minus 2. Answer at I minus 2 plus 2. Why we are adding 2? We are adding 2 for this pair of valid parentheses, right? So whatever your longest valid parenthesis pair or longest valid parenthesis substring was till the index I minus 2, we will just add plus 2 into that. Yes or no? So this will be the case when the previous index parenthesis is equals to a closing parenthesis. Now there can be a case that the character of previous index is equals to a closing parenthesis, right? So now what you can suggest here, that if this is not an opening parenthesis, instead it is a closing parenthesis, then what we can say is this will be looking like something this one. We need to find the answer for this index I, and at I minus 1 we are having a closing parenthesis. So what we can say is we need to find the counterpart of this ith index closing parenthesis somewhere to the left side. So what we can say is, whatever our longest valid parenthesis will be for this I minus 1th index, the length of the longest valid parenthesis substring for this I minus 1th index is, let's say, something like this one. So what we can do is we will just add 2 to the answer of this one. Why? Because if we are able to find, let's say that if we are able to find one more opening parenthesis to the just left side of this, so what we can say is this is on and whole are making valid parenthesis, right? So to sum my statement up, what I'm saying is, if you are having a closing parenthesis and just previous index element is also a closing parenthesis, then you need to find the longest valid parenthesis for this I minus 1th index element. So let's say it was looking something to this one. Now, if the just previous index, so let's say this index was X. If the just previous index element, that is X minus 1th element, is also an opening parenthesis, then can we say that this on and whole are going to make continuous substring of valid parenthesis? Yes or no? So what we need to do, we need to just check that if the previous index element, the previous index closing parenthesis is having whatever substring there it is having, just before the starting index of that substring, if I am having an opening parenthesis, then obviously I can make a balanced pair of parentheses here. So we will just add this to our answer. So what we can say is, in this case, answer at I will be equals to, we will first need to check also, that if I minus, let's say answer at I minus 1 minus 1. So this will give me the X minus 1th index. If this is greater than equal to 0, that is it exists in the string. And what I can say is we can say str dot char at I minus answer at I minus 1 minus 1 if this is equals to an opening parenthesis. So in this case, this will be satisfied. So what we will say, answer at I is going to be equal to answer at I minus 1 plus 2 for what? 1 for this opening parenthesis, 1 for this closing parenthesis, and this will be stored in answer at I minus 1 plus whatever the answer was till this index, right? Till this index, whatever our answer was, we will add this particular subsequence, or we can say with this particular substring to that particular answer. So how we will extract that answer? We can just have that as, we can have answer at I minus, answer at I minus 1 minus 2. Why I'm doing a minus 2 here? Because doing minus 1, we were getting this index. By doing minus 2, we will be getting x minus 2 index, right? So this is how we will be able to extract the answer when we are having a closing parenthesis, and just before that, we are having a closing parenthesis, right? So let's just try to code this solution and see that if this logic is working or not. So let's just first extract the length of the string, right? So I'm going to code the solution in Java. So we can have int n is equals to s dot length, right? So this answer, the answer array that I was making here, this is equivalent to the DP array that we need to make, right? But before that, we need to have a check here that if n is less than equal to 1, right? That is, if the length of the string is 0 or the length of the string is 1, then our answer is always going to be 0. So no need to compute anything. Apart from that, what we can do, we can make a DP array equals to new int of size n, right? Because at any particular index, we will be storing the longest substring of valid parenthesis till this index I, right? Now, what we can say is if, let's say, char ch is equals to s dot char at 0, we'll check that what is the first index element. So if ch is double equals to a closing parenthesis, so let's say if the first character that we were having was equals to a closing parenthesis, so irrespective of this fact, we can say dp of 0 is equals to obviously 0, because for the first character there can never be a valid parenthesis string. Now we need to check for the first index character. So if the ch was equals to a closing parenthesis, right? So this ch is representing what? The 0th character index. So what we can say is, let's just instead extract this one, right? If this is a closing parenthesis and s dot char at 0 is an opening parenthesis, right? So if the first index character, so I've changed this to first index. So if the first index character is equals to a closing parenthesis and the 0th index character is equals to a opening parenthesis, what we will do, we will store dp at 1 equals to 2, because the substring length will be equals to 2, right? Otherwise, dp at 1 will be equals to 0, right? So the base cases for our dynamic programming array is set up. So now what we will do, we'll check that for int I equals to 2, I less than n, I plus plus, right? So we are going to iterate over all the possible characters, right? Now we'll extract the character as ch is equals to s dot char at I, right? Now if ch is double equals to, and so what cases we were having here? So here you can see if we are having an opening parenthesis at any point of time, if we are having an opening parenthesis, so our answer will be equals to 0. So what we can say, dp at I equals to 0. Else, if we are having a closing parenthesis, we will check that, okay? If s dot char at I minus 1, if this was double equals to an opening parenthesis, right? So this is the case where we are having the previous index element as the opening element. So what we will do, we will do dp at I is equals to dp at I minus 2. We will be having dp at I minus 2 plus 2, right? So 2 for the sake of the new valid parenthesis pair. Else, we will check that if for the current index, that is I minus dp at I minus 1, if this is greater than equal to 0, right? That is, this index exists, and s dot char at I minus dp at I minus 1 minus 1, if this is double equals to, so let me just this is double equals to an opening parenthesis, right? So let me just bind this in one pair of parentheses, right? If this condition holds true, so what we are going to do, we are going to do it like dp at I is equals to dp at I minus 1 plus 2 plus, now we need to add the previous answer, right? That was present before this particular index. So we need to first check that if this the previous index exists or not. So if I minus dp at I minus 1 minus 2, if this is greater than equal to 0, so what we will do, we will add the answer of dp at, I'll just copy this one here, otherwise I'll just add a 0 in place of it, right? So we will just bind it here again, right? So at last, so whatever the maximum value in our whole dp array will be, we will just return that. So we will just do return arrays dot stream dp dot max dot get as int. So you can use this inbuilt function of arrays dot stream dot max to get the maximum element from the whole dp array or for any corresponding given array, in particularly in Java. So let's just test it. And here you can see the sample test case has been passed. So we'll just submit our solution. And here you can see that we have scored full marks in this solution, right? So I hope the logic for this problem is clear to everyone, right? Okay. So the next problem that we are going to discuss, right? Yeah, so this is the next problem that we are going to discuss today. So what the problem says is that given an array of integers a of length n, find the longest length subsequence which is first increasing and decreasing. So you will be given an array as the input format, right? And you need to return an integer representing the answer, right? And the length of the array can be as big as 10 raised to the power 7. So here you can see that this is 1 to 1. So answer will be equal to the whole array, that is 1 to 1. For this array 1, 11, 2, 10, 4, 5, 2, 1, the longest subsequence first increasing and then decreasing will be 1 to 10, 4 to 1. That is equals to the length 6. So generally, a subsequence which is firstly increasing then decreasing is also called as a biatonic subsequence, right? So let's just see how we can solve the problem. So I guess you all might have already learned about the problem. You might have already learned about the problem of longest increasing subsequence, right? So let's just get our test case here. So 1, 11, 2, 10, 4, 5, 2, 1, right? In this array, we need to find the longest subsequence first increasing, then decreasing, right? Now, what we can visualize here is, we can find the increasing part using this LIS algorithm that we have already discussed in the previous lectures. But for this decreasing sequence, how we will be able to find this decreasing subsequence? Can we say that if we visualize the LIS from reverse direction, then this will lead us to a longest decreasing array from the previous side, right? So let's just see what I'm trying to say. So firstly, I'll make the increasing subsequence array. So for 1, the longest increasing subsequence will be 1. For 11, it will be 1, 11, that is 2. For 2, it will be 1, 2, that is 2. For 10, it will be again 1, 10 or 2, 10, that is equals to 2. Then for 4 also, so for 4, we will be having 1, 2, 4, that is 3. For 5, we'll be having 1, 2, 4, 5, that is 4. For 2 again, we will be having 1, 2, that is 2. And for 1 again, that will be equals to 1. So this is the increasing subsequence. Now what we need to do, we need to find the increasing subsequence from the reverse direction. So if you will visualize from the reverse direction, so here you can see that this is equals to 1, right? So 1 will be equals to 1 only for the longest subsequence. Now if we will just see 2, so what we will check that 2, 1 is going to make the longest decreasing subsequence, or if we can just visualize from the reverse side, it is what, 1, 2. So for 2, we will be having the answer as 2 only. Yes or no? Okay. Now for 5 again, we will do the same thing that we were doing for longest increasing subsequence, that we are at 5. We will go to the next index of 5, that is 2. Is 5 greater than 2? Yes, it is. So whatever the longest increasing subsequence, longest decreasing subsequence we were having, which was ending at 2, we can just append a 5 in front of it to make it of length 3. So we'll add a 3 here. Now we'll go to 1. So longest decreasing subsequence ending at 1 is equals to of length 1. If we will append 5 in front of it, it will be of length 2. So it is not better than 3. So we'll do nothing. So for 4 also, it will be appended to 1, 2, 5, 4. That will be equal of length 4. For 10, it will be of length 5. For 2 again, it will be of length 2. For 11, it will be 1, 2, 5, 4, 10, 11. That will be of length 6, right? Small mistake. So this was 1 to 5. Now for 4, we will be having 1 to 4, not 1 to 5, 4. Now for 10, we will be having either 1 to 4, 10 or 1 to 5, 10. Irrespective of the fact, whatever subsequence we are having, it will be of length 4. Now for 2 again, it will be of length 2. For 11, we will be having 1, 2, 5, 10, 11 or 1, 2, 4, 10, 11. So it will be of length 5. And for 1, it will be of length 1. So this is the decreasing subsequence array, where at each index I, we are having the longest decreasing subsequence, right? Now how we will be able to find the longest increasing decreasing subsequence? Here you can see that. If you will just sum up the values of both the arrays, so what we'll get? We will get a 2 here, then we'll get a 7 here, we'll get a 4 here, then we'll be having a 6 here, then we'll be having again a 6 here, then we'll be having a 7 here, then we'll be having 4 here, and then we'll be having a 2. Now, what these values are representing? Let's just consider this 6. So this 6 is representing the fact that there was a subsequence of length 3 that was increasing, and then of length 3 that was decreasing. So let's just see what was that. So we were having 1, 2, 4 as the increasing, then 4, 2, 1 as the decreasing. That's why the length here is 6. But can you see that you have considered 4 twice here? And for any valid subsequence, we need to consider all the elements once only. So we'll just subtract 1 from each index here. So this will be 1, this will be 6, this will be 3, this will be 5, this will be 5, this will be 6, this will be 3, and this will be 1. Now let's just see what these represent. So let's just take this 6. So this 6 represents that we are having a subsequence like 1, then 11, and then we are having 10, 4, 2, 1, or 1, 11, 10, 5, 2, 1. In both the cases, the length of the subsequence is equals to 3. So what we need to do in this problem is, you first need to calculate the longest increasing subsequence. Then you need to calculate the longest decreasing subsequence ending at each index. Just sum the elements of all the indexes and just subtract -1 to avoid the repetition of elements. Right. So let's just try to code our solution and see that if we are able to do so or not. So we will have first the length of the array, that is a.size. Right. Okay. Now what we will do, we'll first make increasing DP array. Let's just mark it as DP only. So DP is equals to new int of size n. Right. Then DP of 0 will be equals to 1 always. So what we'll do, we'll start from I is equals to 1, I less than n, I plus plus. For int j is equals to 0, j is less than I, j plus plus. This is exactly equal to the code of longest increasing subsequence. Right. Now what we'll do, if now we need to check the values, right? So if a dot get I is greater than a dot get at j, right? If this value is greater than the value present at j, the current value is greater than the value present at j, what we'll do it like dp at I is equals to math dot max of dp at I, whatever solution we are having till now. Apart from that, dp at j plus 1, right? This can be a good candidate. Now we can do similar thing for a new array, right? So we'll be having a dp2 array for the longest decreasing subsequence, right? The n-1th index will be having a value of 1. We'll start from n-2. We will go to greater than equal to 0, and we'll just decrement the ith pointer. Apart from that, we will start from I plus 1th index. We will go to I less than n for jth iteration, and so on. Now again, if a dot get at I, if this value is again greater than a dot get at j, so what we'll do, dp2 at I is equals to math dot max of dp2 at I, or dp2 at j plus 1, right? So this will be the corresponding solution. Now what we'll do, we'll just add both the indexes and just subtract 1 from it. So for int I is equals to 0, I less than n, I plus plus, we'll just add in the increasing array itself. So dp at I plus equal to dp2 at I minus 1, right? So this will be dp, and at last we will just return the maximum value. So we just saw that how we can just easily return in single line. So arrays dot stream dp dot max dot get as int, right? So let's just see that if the solution is working or not, or if you are not having any runtime or something solutions like that. Okay, so we need to handle one more case, that if the array is empty, what we need to do. So if n is double equal to 0, we need to handle this. So we will just return 0, right? Okay, so there is some bug. So your function returned the following, and the expected output is the following. Okay, so let's just debug once that if you are having any error or not. So we just had n is equals to 0, then we return 0. So one thing that also we need to do is we can do it like arrays dot fill. We can just fill all the indexes with 1. Why? Because for any index, what we can assume is initially when we have not computed any longest increasing or decreasing subsequence, the maximum length increasing subsequence or decreasing subsequence ending at that point is equals to 1 only. So we'll just fill this all the values with 1. We can do similar thing here as well, right? This is dp2. Okay, now starting from ith index till nth index, then from 0th index to ith index, we compared I and check if it is greater or not, and this is good. Now we will go to int dp2, and then we will just fill this up, right? Then we'll start from n minus 2th index, go to the 0th index and decrement I. Then from I plus 1th index, go till n and increment the jth variable. Then a dot get I is greater than a dot get j. So what we are going to do, we are having this as dp2, cool. So dp2 at I is equals to mat.max of dp2 at I or dp2 at j plus 1, cool. This is working perfectly fine, right? Now we can do this like dp at I plus dp2 at I minus 1. Okay, cool. I guess we should test it again. The sample is passing now. Okay, so we are having one issue here. So function is returning 4 and the expected return value is 5. So let's just debug it, that what's going on with this one. So firstly we'll add 5, then first number is, and then okay. So 1, 2, 3, 4, 5. Let's just test it, that what's the exact issue here. Okay, yeah, so makes sense. So let's just debug it, that what should be going on in this particular test case, right? So at 1, so firstly, if our increasing subsequence will be starting from the 1th index, right? And at the last index, it will be storing what? 5, right? And okay, in this dp2, okay, so I got the case most probably. This is dp2 at n minus 1, that is going to be equals to 1, right? And apart from that, let me check that if I'm not manipulating dp1 somewhere. Okay, yeah, so this was a small issue, and here you can see that we have completely solved the problem, right? So there was a small bug that I was just manipulating dp1 instead of dp2, right? So I hope the logic for this problem is clear to everyone, and we will move to the next problem for today, right? So the next problem says that the problem name is max sum without adjacent elements, right? So what the problem says is that given a 2 cross n grid of integer, choose the number such that the sum of number is maximum, and no two chosen numbers are adjacent horizontally, vertically, or diagonally. Okay. So let's say that this was the case. So what we can say here is the output will be 2. Why? We need to choose 3 and we need to choose 5. Why? Because if we are choosing this 3, we cannot choose this 2, we cannot choose this 1 or this 3. Either we cannot choose this 2 or this 4, right? So the next choices we are having is from this particular row only, that is from 4 or 5. So at any particular point, if we are taking any element, we cannot take the vertical element or the diagonal elements or the horizontal elements, right? So let's just see how we can solve the problem. So the test case given to us is, let's just discuss using this test case only, that is 1, 2, 3, 4, and we are having 2, 3, 4, 5. 2, 3, 4, 5. Okay. So what you can say here is, if we are choosing this element, if we are choosing this element, we cannot choose this 2, we cannot choose from this column, we cannot choose from this column, right? We cannot choose from this column, right? And the same thing will happen. The same thing will happen. Let's say this was the case. If we will choose this 2, we cannot choose this 3. We cannot choose anything from this column. We cannot choose anything from this column. Now for this particular column, that is the first column, we had 2 choices. Either we could have chosen 3 or we could have chosen 2. We could get a maximum value by picking up the greater element. What we can say is, for any column, we will always pick the max element. If that's the case, now this problem will boil down to the fact that from the 0th column we'll be getting 2, from the first column we'll be getting 3, from the second column we'll be getting 4, from the last column we'll be getting a 5. Now, having an array like this one, what we need to do, we need to choose the element such that we are not choosing any adjacent element, right? Now, this is a trivial problem to solve. Why? Because if we are choosing this element, let's say, let's just discuss with 4. If we are choosing this 4, what we can say is we cannot choose this 3, right? And whatever the answer we have till this index I equals to 0, we will add 1 to it, or let's say we will add 4 to it. This is one choice, that we are picking 4. If we are not picking 4, then whatever answer we will be having at index I is equals to 1, that will be our answer. So what we can say is dp at I will be depending on the fact that what is the maximum among dp at I minus 1, that is when we are not choosing the current element, or dp at I minus 2 plus array at I. Whatever the maximum we'll be having among these two, we will be just storing that. Okay. So let's just try to code the solution and see that what goes on. So here you can see that you will be getting an array list of array list, or in C++ you will be getting a vector of vectors. So we'll just generate the single array first. So int n is equals to a dot get 0 dot size. Right. So here you can see that it will be a matrix where we will be having 2 single arrays, right? So this will be something like this one. So now we'll construct the array. Int arr is equal to, sorry, this will be an array is equals to new int of size n. Right. Now what we are going to do, for int I equals to 0, I less than n, I plus plus, right? Arr at I will be equals to math dot max of a dot get 0 dot get I, comma a dot get 0 dot get, this will be get 1 dot get I. Why I am doing this? Because there are only 2 rows, that is the 0th index row and the first index row, and then we will be having the element. So first we will extract the 0th index row, then we will extract the ith index element, then we will extract the first index row, and then extract the ith index element from that. So using this, we will be having our array prepared. Now we'll be preparing a dp array is equals to new int of size n, right? So inside our dp array, the 0th index will be equals to what? Arr at 0, right? If n is less than equal, if n is double equal to 1, we will just return this dp at 0, right? If that's not the case, so we'll keep a case here that if n is equals to 0, we will return a 0. So if these two if checks will not be executed, what we can do is we can have dp at 1, right? So what this can be, if arr at 1 is greater than arr at 0, we will be storing arr at 1 here, otherwise arr at 0 here. Why? Because if we will be picking the first index element, then we can't pick the 0th index. If we'll pick the 0th index, we can't pick the first index. So whatever the maximum we'll be having, we'll just store that in our dp at 1. And now what we'll do, we'll just do int I is equals to 2, I less than n, I plus plus. dp at I is equals to math dot max of dp at I minus 1, comma dp at I minus 2 plus arr at I, right? And on the last index, we'll be having our answer. So we'll just return dp at n minus 1. So let's just test the solution. Okay, so sample case has been passed. Okay, so here you can see that we have successfully solved this particular question as well, right? Okay, so one piece of advice I would like to give to everyone, that as you can see that considering the fact that what situation we are having outside, utilize this time as much as possible, right? And you guys can even subscribe to the channel of Scalar Academy to get some awesome content related to computer programming, including data structures, algorithms, some web development stuff, system design stuff, so on and so forth, right? So I hope that you like today's lecture. So thank you guys. See you next time.
Hey everyone, welcome to another exclusive video tutorial by Scalar Academy. Before moving forward, please subscribe to our channel because a lot more tutorials are coming up and you don't want to miss them.
Hi guys, in this video let's talk about the problem longest substring without repeating characters. So, given a string, we have to find the length of the longest substring without repeating characters. For example, the longest substring without repeating letters for this particular string is just ABC, right? So if we look here, then this is the longest substring, which is of the length 3. Therefore, we will simply return the length, right? This is 3 for this particular string, and for the next case, which is this, so the longest substring is the single letter B, right? Because if we consider any other substring, then B and B repeats. So therefore, there is just a single letter here, and therefore we will return the length 1. So now how can we approach this problem? Let's see that. So there is a brute force solution which says that we can consider all substrings one by one and check for each substring whether it contains all unique characters or not. So the total number of substrings are n into n plus 1 by 2. And to check if a substring contains all unique characters or not, we can keep a map of the visited characters. Therefore, this step can be done in a linear time. The total time complexity of calculating all the substrings and then checking if they contain unique characters or not, so the time complexity is going to be order of n cube. Let's understand this with the help of an example. So this is the string, let's suppose A, B, C, B, E. Then what are all the substrings that can be present with the starting from A? So we can have just A, then AB, then ABC, then ABCB, then ABCB, E, right? To check if the substring have the unique characters or not, for that we can use either map or we can use a set. If we use a map, then we can have a mapping from character to integer, which will store the character in a present substring and the frequency of that character, and in the set we can simply store the character only to check its occurrence. Now starting from A, we can have all these substrings. So at present we have just A, let's suppose this is the first string, and for now we are just considering a set. So A is not present, so let's put A and let's maintain a length variable. So length at present, the maximum length is just 1, right? Now let's move to the next substring, so which is AB. So right now A is not present, so let's put A into the set, okay? And B is not present, so let's put B into the set. Now the maximum length is 2. Now let's move to the next substring, so which is ABC. A is not present, let's put A into the set. B is not present, let's put B into the set. C is not present, let's put C into the set. The length, maximum length is 3 now. Let's move to the next substring now, which is ABCB. So A is not present, let's put A. B is not present, let's put B. C is not present, let's put C. Now B is present already, right? B is present. So now even if we move further, even if we check for the next string, then we can say that if this string cannot contain the unique characters, that means string starting from this current I cannot consist of the unique characters. So that means let's check for next substrings. So let's check substring starting from B. So let's reinitialize it. So starting from B, we have just B, then BC, then BCB and BCBE, right? So for just B, we can check that okay, B is not present, so let's put it, but the maximum length is going to be 3 only. Let's check for the next substring, which is BC. So B is not present, let's put B. C is not present, let's put C. Still the maximum length is going to be 3. Now let's check for the next substring. So B is not present, let's put B over here. C is not present, let's put C over here. Now this B is present, right? B is present. So what should we do? If we move even further, that will tell us that okay, it won't help us because the B is repeating. So we can move simply to the next substring. starting from C. So C, CB, CBE. Likewise, we will keep on checking and we will keep on iterating till we have completely iterated this string. Right, the complexity for this is going to be order of n cube, which is pretty huge. So, can we optimize it? Well, yes, let's see. So, this can be further optimized if we check whether the substring consists of unique characters or not while moving the second pointer only. So, what can we do? So, the substring is A, B, C, B, E. Right now, I is at here, right? And J is also starting from here. So, A is not present. Let's put A into the set. So, let's put A into the set. Now, let's move J. Length right now is 1. So, B is also not present. Let's put B into the set. And now, length is 2. Let's move J. C is not present. Let's put C into the set. Now, length is 3. And let's move J. Now, B is present. So, what should we do? Now, we will be moving our I. So, I will come over here. And J will also start from here now. So, B is not present. Let's put B. And length will still be 3 only because that's the maximum. Right. Now, let's move J. C is not present. Let's put C. Right. Length will be same. J is not. So, B, when J is incremented, it comes to B. And B is already present. That means we can simply increment our I now. So, I will come to this location and J will also come to this location. Right. And we will keep on iterating and keep on checking this way. So, C is not present. Let's put C. Right. And length will still be 3 only because that's the maximum. Let's increment J. This B is not present. Let's put B. Right. Now, increment J. E is not present. Let's increment E. Right. And the length is here is 3 and our present maximum length is also 3. So, we need not update it. Now, let's increment J. So, now we have completely iterated over our string and therefore we can stop. And here we are checking the uniqueness of the characters in the string while iterating with jth pointer. So that will take the time complexity of order of n square, right? Now can we even optimize this further? Well, yes, we can do this function, we can do this in linear time as well. Well, let's see how. So we have A, B, C, B, E, right? Our I is starting from here. Let's maintain a set. So we have A over here. So length, current maximum length is just 1. Now let's increment J. So B is not present. Let's put B and let's increment our length. Let's increment J. C is not there. Let's put C and let's increment the length. Now let's increment J. B is already present now. Since B is already present, instead of just incrementing I to one position and moving J back to ith location and restarting and checking all the substrings, can we not move J any further? Can we just do something else? Well, we have to actually make sure that B does not exist, right? So, in that case, we can actually, instead of moving J back, we can increment our I till the point this jth character does not exist in the set anymore. Now, what do I mean by that? Let's see. So, I is incremented and this particular character now can be erased from the set as it is no more in the current window from I till J, right? So, A can be erased. Now, still the character at B is present in the set. So, we need to increase our I further. Let's increase it and let's remove this B now. Now, does this character at J is present in set? Well, no, it's not present, right? That means this B has just one occurrence now and let's put it in the set now. So, we have put the B and the present length is 2 which is less than the maximum length. So, we will keep this same. Let's increment J now. So, J will come to this position and E is also not present. So, we can put E into the set and present maximum length is 3 and the current maximum length is also 3. So, we need not update it, right? And let's move our J now. So, J has reached to the end of the string and that means we have completely traversed our string, right? And that's how we know that when to stop. So, instead of moving J back, we have actually incremented our I till the jth character does not exist in the set anymore, and that's how we are doing it in linear time. We are iterating over each character at most 2 times. So the complexity is 2n to n and in bigger terms it's just order of n, right? And the space complexity is also order of n where n is the length of the string. So thank you so much. Hi guys, in this video let's talk about a problem finding the square root of integer. So given an integer n, you have to compute and return the square root of n. If n is not a perfect square, so return the floor of square root of n. And do it without using the square root function from the standard library. So the range of n is 1 from 1 to 10 to the power 9. Let's say the input is 11, so the output is 3. How? Because the square root of 11 is 3.316. Therefore, we'll take the floor of it. So we'll get 3 as the answer. Let's see how this problem can be approached. So one possible way is, we know that the range of our answer is going to lie from 1 to n, right? So we can simply iterate from 1 to n, and we can check that if x square becomes equal to n, then we can simply return the value of x. Else, if x square is less than n, then we know that this x is one possible answer, and we'll check for higher values of x. So let's say some x plus 1, so the value just greater than x becomes greater than n, the square of it becomes greater than n. So we know the previous value did satisfy, so we will simply return the stored answer, because any x greater than this will not satisfy the condition, right? Will not be the answer. So let's see how can we optimize this problem, because this will give a time complexity of order of n, linear time complexity. Then now let's make some observation. Let's say I have some value of x. We know that it's going to range from 1 to n. Now this value could be x square could be equal to n. In that case, we'll simply return x. But if it's less than n, then we know that the value lesser than x cannot be the answer, right? Cannot be the answer. It's quite possible that the value which is greater than x could be an answer. X or any value greater than x can be one such answer. So we can reduce our search space, and then now we can search between from x to n, right? Now the third condition is when x square is greater than n. If this is the case, then we know that any value which is greater than x cannot be the answer. That means we should look to our left. And we should also ignore this x, because x square was greater than n. So from here comes the intuition to apply binary search, because we have a search space and we have a conditions because of which we can reduce the space into half. So let's see the code for binary search. So here we will take, so if x equal to 0, we'll simply return 0, and otherwise we'll put our start to 1 and end to x, right? Now this is going to be the while loop for the binary search. We'll find the mid, so start plus n minus start by 2. This we have found our mid like this way, because this will avoid overflow, okay? And if mid is less than equal to x by mid, what this means, that if mid into mid is less than equal to x. Now this could cause overflow, therefore we'll write it like this, right? So first we have reduced the value and then we are checking. So if this condition becomes true, that means mid is one such possible answer, right? So we will simply store the answer and we'll move to right. Else, if this condition fails, then we'll move to our left. So at then we'll simply return our answer. Now this particular binary search approach is going to take the complexity of order of log base to n. Let's see this with the help of an example. So here our n is equal to 10. The start is going to be 1 initially and end is going to be 10. Mid is 5. So 5 square is greater than 10, right? Therefore we should move to our left. So end will become mid minus 1 and 1 will remain same. Start will remain same. So mid is equal to 2. Now 4 is less than 10. So we will move to our right. And start will become mid plus 1 and 4 will remain same. End will remain same. Now mid is 3. 3 square is less than 10. So what we'll do? So basically whenever we are getting it as less than something, less than the value, so this particular number could be one possible answer. So first we have stored 2 because 2 square was less than 10. Then when we got 3 square less than 10, so we will simply store 3 now. Okay, and we will move to our right. So we will get start equal to mid plus 1. This will remain same and we'll get mid as 4. Now 4 square is greater than 10. So we will simply exit the while loop and we will return the stored answer, which is 3. So that's the running of the algorithm. So thank you so much.
Hi guys, welcome to Code Drift Day 5. So the first question we have is saving Gotham, where we are given an array of n elements and there's a special kind of an operation and we can do it infinite number of times, and by doing that operation we have to make all the elements equal to 0. So in one operation what we can do is we can select two different numbers in the array, and such that the AND value, let's say we select AI and AJ. So if the AND value of AI and AJ is X, then we can just replace AI with AI XOR X and AJ with AJ XOR X. So we can do this operation any number of times. So we have to find out if we can make all the elements equal to 0 or not. So let's take an example. Let's say this is the array that we've got. So here I've written all the binary representations of the numbers of the array 2, 3, 4, 5. So let's try to do the operation on 2 and 3 once. So what is the value of 2 and 3? Value of 2 and 3 is 2. Now 2 will be replaced by 2 XOR 2, which is 0, and 3 will be replaced by 3 XOR 2, which is 1. Okay, so the updated array is 0, 1, 4, 5. Okay, now let's try to do the operations on 4 and 5. Okay, so this is the updated array. Now let's try to do the operation on 4 and 5. So 4 and 5 gives us 4. Now 4 will be replaced by 4 XOR 4, which is 0, and 5 will be replaced by 5 XOR 4, which is 1. Now what is the updated array? So the updated array is 0, 1, 0, 1. Okay, now we can do the same operation on 1 and 1. So 1 and 1 is 1. So the first one will be replaced by 1 XOR 1, which is 0, and then the second one will also be replaced by 1 XOR 1, which is again 0. So the array becomes 0, 0, 0, 0. So how do you think we can find out if we can make the elements 0 or not? So the brute force solution which comes to our mind is just perform the operation on every pair possible in the array. So the number of pairs in any array of size n are n square. So for every n square pairs, we can perform the operation and find out at the end of all the operations if the elements have become 0 or not. But the what's the time complexity of that method? Since we are doing the operation n square times, so the time complexity would be of n square. So can we do better than that? So if we need to observe what is happening when we are performing an operation on two numbers. So when we performed an action operation on 2 and 3 in this case, so 2 was we were able to make 2 as 0, but the 3 was transformed into 1. So if we look at the binary representations of 2 and 3, only these bits, this bit right here, we were able to destroy it because it existed in both the numbers. But this bit did not get destroyed in 3. Why? Because it did not exist in the other number, which was 2. So the observation here is, in this operation, only those bits which exist in both the numbers, they get destroyed and all the other bits stay as they are. Okay. So what do you think? Let's suppose there's a bit which exists in only one number in the array. Do you think we will ever be able to destroy it if no other number carries it? Let's take an example. Let's take an example where the array just has two numbers, 4 and 8. Okay. So the binary representation of 4 is 0, 1, 0, 1. This is 4. And the binary representation of 8 is 1, 0, 0, 0, right? Okay. So 4 is 0, 1, 0, 0 and 8 is 1, 0, 0, 0, right? So do you think we will ever be able to destroy these bits no matter how many operations we use? No, because this bit will never be paired with other such bit of the same value, because we don't have any other bit of the same value in any other number. Because the only other number we have is 8 and it does not have this bit. And in 8 we have this bit as set, but 4 doesn't have this bit because this bit is in 4 is 0. so we'll never be able to destroy these bits. So the thing we can notice by this operation is that only those bits which exist in pairs can be destroyed by these operations. So let's say there are many numbers. Let's say this is the number A, B, C, D. Let me just write random binary notations. Let's say this is 1 1, this is 0 1 1 1, this is 1 0 0 0, this is 1 1 1 1. Okay, so let's talk about this particular bit. Okay, so this bit is coming 3 number of times. So I think we can destroy these two because these two make a pair. But after performing operation on these two numbers C and D, both these bits will be destroyed, but this bit will never be able to get destroyed because we won't be able to pair it with any other number which contains this bit, right? So the answer for this test case will be no, because we will not be able to ever destroy this particular bit. So we can notice that for every bit, the count of that bit should be even, so that we can divide those bits in pairs of 2 and we can destroy them, right? But if the count of any bit is odd, then we won't be able to destroy that particular bit and all the numbers will not be able to be reduced to 0 at the end, right? So how can we implement this? So let's see. We can just take an integer array, bits of size 32, and just set it to 0 in the beginning. And then let's say we are given an array A. Okay, so for all the elements for each x in A, let's say the given array is called A. Okay, so for every number we will check from I is equals to 0 to 32 if x right shift I and 1, we will increment bits of I by 1. Okay, so what is this piece of code doing? So what this is doing is, when we right shift any number by 2 or 1, so what it does is, let's say the binary notation of x is 1 0 1 1 0. So what happens when I right shift? So this operator is called right shift. What happens when I right shift the number two times? So the extreme right 2 bits will get dumped, and all the bits on the left side will just get shifted to the right. So the updated notation will be 0 0 1 0 1. So why do we use right shift? So let's say we have to access the third bit of the number from the right. So we'll just right shift the number 2 times so that the third bit will come to the extreme end, right? And then we'll just take the AND of the number with 1. That will just tell me whether that particular bit is set or not. Okay, so I need to check for all the bits from 0 to 32, since the numbers are not going to be more than 2 raised to power 32, which is 10 raised to the power 9 in this case. So this is enough. So I'll just, with this for loop, I can just count the number of bits in every number. So after this, I have the count of all the bits. Now in the bits array for int 0 to 32, if bits of I, int I is equals to 0 to 32, if bits I percentage 2 equal to 1, right? That means the count is odd. We will just return false, right? And after the array, if no count was found to be odd, at the end we'll just return true. Okay, so what is the time complexity of this method? Let's see. Okay, so since we are only iterating over the array once, that will make the time complexity of on, plus then after that we are just iterating over the array of size 32. That is a constant time that will make up on. And the space complexity, since we are just using extra space of size 32, we can consider it constant space, on space. So this is the time and space complexity of the method. So I hope this cleared your doubt. Let's move to the second question. Hi guys, so the second question for the day is loudspeaker. We are given a graph which has A cities and few roads which are represented by the array B. Array B contains all the edges, right? telling us which node is connected to which node. And then we have an array which tells us that some cities have loudspeakers. So all the cities which have loudspeakers are in the array C. Okay, and then we have a source city and a destination city. So let's take an example. Let's say this is a graph. Okay, so let's say we have two cities which have speakers, and then let's say this is the source city and this is the destination city. Okay, so what happens is in the beginning this speaker is all turned on, the sound starts traveling. Let's say, okay, so the speaker has an intensity of, let's say the intensity is x, so the sound will only travel up to a distance of x. Let's say x is 2, so its sound will travel to distance in this path, to direction in this path, right? And then it will stop here. But when the sound hits another speaker, that speaker also gets turned on. So what will happen is this will also start emitting sound, and since x is equal to 2, this will also cover a path of 2, and that means the sound will reach E. So the answer will be yes. For intensity 2, this sound will reach from this source to this destination, right? So we have to find the minimum intensity for which this can happen. So the minimum intensity for a speaker can be 0. The maximum intensity we can need can be n. It cannot, we will never need intensity more than n, right? If we cannot do it in n intensity, then we cannot do it at all, because the shortest distance from any node to any other node cannot be more than n, because we have n number of nodes, right? So this is the range for our answer. So one way is to iterate from 0 to n, and the first value for which it can be done, it will be the answer, right? But instead of doing that, since it takes on time, what we can do is we can use binary search in this range, and it will give us the value in log n, right? But for every intensity, how do we check if for that particular intensity we can this is possible or not? So we will binary search between this range, and for every value we'll call a function solve with the intensity. We'll send it the intensity, and it will return a value whether it's possible or not. Okay, so how will that function work? So what we can do is since all of these speakers can be sources for the sound, we can use a multi-source BFS, and we can consider all of these speakers to be different sets, right? Let's call this to be set 1. Let's call this to be set 2. So all the cities which can be reached from this speaker will be in the set 1. All the cities which can be reached from this speaker will be set 2. And if some city collides, that means this sound is reaching from here also, and this sound is reaching here, both the cities. So we will check if the distance between this speaker and this speaker is less than equal to x. What does that mean? That means if a sound ever starts from this speaker, it will reach this speaker as well, and eventually this speaker will also get turned on, and all the cities that this speaker is connected to will also be reached. So what we can do is we can just combine both these sets. So we'll just, at the beginning, all these speakers will have different sets, and after the BFS, some speakers will be connected, their sets will be connected. What that will mean is that all of these speakers are interconnected. That means the distance between them is less than equal to x, and they can be reached from any speaker to the another speaker, right? So no matter from which speaker we start, we can always go to some other speaker, and eventually some node which can be reached from that speaker, right? So we'll just do a DFS. At the end, we will check if the source node and the destination node are in the same set, right? So how do we make sets? So we can use DSU. So let me just give you a brief explanation of how DSU works, right? So let's say we have a few nodes, 1, 2, 3, 4, and let's say 4 and 5 are connected, right? Let's say all of these nodes are islands and these are bridges. So if I say 3 and I'm making a bridge between 3 and 5, so automatically 3 is connected to all the elements which are connected to 5, right? Because if I can travel from island 3 to 5, I can also travel from 3 to 4. If there was a element 6 connected to 5, I could also travel from 3 to 6. So what we do in DSU is, if any element of one set gets connected to any element of another set, that means both these sets are now connected, and now we have gotten a new set, right? So for knowing how we can do these unions and how we can check if the two elements are in the same set or not, you can read more about DSU, right? So now we will look at the code, how we can implement this. Okay, so this is the function solve. Okay, it takes the vector c, which is the edges, right? This is the vector c, which is the all the nodes which have loudspeakers. This is the source and this is the destination, right? So what we do is we make a graph and then just make the graph using the edges, right? And then what I do is for all the nodes which have speakers, I just insert them into a set so that later on it's easier to check if some particular node has speaker or not, right? And then what I do is I just set the constraints low as 1 and high as 1 10 to the power 5. So you can either set high to n, or I'm just taking the worst case here since n goes up to 10 raised to power 5. I just set it to 10 to the power 5, right? Also I've set answer to int max. You can also set it to n or the maximum value, right? Then we start the binary search. While low is less than equal to high, we calculate the mid, and then for that particular mid, call this function can do and see if it's true or not. If it is true, we set answer as mid. That means this mid value is our potential. This can be our potential answer if we don't find some value lesser than this, right? So we just put this in our answer and then put high as mid -1. That means we are trying to find a better value than this, right? But if it doesn't return yes to us, that means that the sound does not reach the destination with this intensity. So we have to find a bigger intensity. So we'll set low to mid +1, right? And then in the end, I just return the answer. If the answer is still equal to int max, that means we never got a value which returned true. That means we have to return -1. Otherwise, I'll just return answer, right? So let's take a look at the function can do. So this is the function can do. So this just takes in all the constraints. The mid goes as x. So x is the intensity for which we are checking, right? This is the graph, this is the set, these are the source and destination. And what's n? N is just a, right? The number of nodes, right? So then this parent size, these are just the arrays that we need to make for DSU. So these are the functions is equal and union. These are the functions which we use to this union. Basically, we need this function to make two elements, unite two elements, bring them into a same set, right? We just make this loop to reach the root node of A. We use this loop to reach the root node of B. C, if they are equal, that means they're already in the same set. We don't need to do anything. If they are not, we just combine them, right? You can read more about this, why we are doing this. This is just to make the tree balanced so that the search happens in log n, right? And this tells us if the two elements are in the same set or not. So we just travel to root of B. If they are equal, they're in the same set. Otherwise, they're not, right? Okay. In the can do function, what we do is we just perform the BFS and then we perform the function is equal. Set D, set E are the sets in which D and E lie. And this is the we are passing the parent array to check if they are in the same set or not. So what does BFS do, right? That's the main thing. So what we do is we create a array distance. So this is just to, we just initialize it by distance I is equal to -1. That means all the nodes which are not yet visited, we have set the distance to -1, right? And since we are starting from all the sources, which are the speakers, we are doing a multi-source BFS. So for all the sources which have all the nodes which have speakers, I set distance I equal to 0. Since we earlier talked about how starting from all the speakers will be equivalent if those speakers can be reached from the destination speaker, right? So in the end, if all the speakers that will be in the same set as D, we will know that these speakers can be reached by the speaker D, right? And then we can just see if D and E are in the same set, right? So this is
what we are doing this, we are just setting the distance of every I, which is the speaker, to 0, right? And then we are assigning some sets to these nodes. Set of I is equal to j plus plus. So we just start j by j with 1, and we do j plus plus. So just numbering from 1 to, we just keep increasing it and keep assigning a different set to every node which has a speaker, right? Then we just start the DFS for every element in the front. What we do is, if we'll come to this in a second, but so what we do is, for all the elements that are connected to T is the element in the front of Q, right? So all the elements which are connected to T, if distance of JJ, which is the element which is connected, is equal to -1, that means it has not been visited yet. So what I'll do is, I'll just add that to my set. So I will just assign the set of JJ to set of T. That means that element and the speaker we have started from, which is the T, we just put them in the same set, right? And then distance of JJ is distance of T plus 1. This is very logical. The distance will just keep increasing by 1, and then I just push JJ to the backside, right? This is how BFS works, right? So in the else condition, which means if distance of JJ is not equal to -1, that means JJ has already been visited before, right? So if it has been visited, distance of J must be some positive value. It means it has been visited from some other speaker, right? So we'll just check if this set and this set can be joined together. For that, the distance between the speaker from which JJ has been visited and the speaker from which T has been visited, the distance between them must be less than equal to X, right? That's only when these two speakers can be in the same set, right? So we just check. This is the distance till T, and since we are going one step further, we add 1 to it, and the distance which was already covered to reach J, this is the total distance between the two speakers. If this is less than equal to X, what we do is, we just unite the set that T belongs to. That means the speaker from which we have reached T, the set which JJ belongs to. That means the set of the speaker from which JJ was previously reached, right? And then we just unite them, put them in the same set, right? Yeah, we just keep doing this for all the elements, and in the end, we just check in the can do function if T, the set of T, and the set of E are connected. If they are, that means the sound will travel from D to E, right?
So now let's see what the time complexity of this program is. Okay, so we are performing a binary search from 0 to n, right? And for every query, we call the function solve for that particular mid value, right? So in the function solve, we perform a BFS, and there are n elements, n nodes, and since we don't revisit any node, only we will visit n nodes in total. For every node, we use that query union set, where we attach this every node to some particular set from whichever speaker it has been visited, right? And that query takes up log n time, right? And the function and the binary search takes log n time too, which makes total time complexity n log square n, right? Talking about space complexity, in DSU we are using 3 linear arrays, so that makes the time complexity linear. And for the BFS also, we use a queue, which will we will push n nodes in the queue, that will take up linear memory as well, right? So the overall time space complexity is also linear, which is O of n, right? So when we were using DSU for the queries, we can also use you can read more about it about DSU and read more about path compression. We could have used path compression and made this login factor as O1, but we don't need it for this question. But if you want, you can read more about it and try to optimize the solution from n log square n to n log n, right? So I hope this solution was clear. Do like the video, share the video, and consider subscribing to the channel for more content like this. Hi guys, welcome to CodeRiff Day 7. So the first question for the day is multiple sum set. We are given an integer array of size n, and we need to find the number of subsets of A whose set multiplication value is distinct, and it's equal to sum of any subset of array A. So in layman terms, let's say there's a value x, okay, we should be able to find a subset whose sum value is equal to that x, and we should be able to find a subset whose multiplication value is equal to that x, right? So how many distinct x values can we find? That's the answer. So let's take an example. Let's see, this is the number, okay? So how many subsets does this array have? It would be 2 raised to the power 3, which is 8, right? So the one would be the empty subset. So let's just skip that. And I have listed all the 7 subsets and their multiplication values and the sum values, right? So let's try to find how many different x values can we find here, for which both a subset whose multiplication is equal to that and a subset whose sum is equal to that. Okay, so 1 can be this, 2 can be an answer, 3, 6. Okay, so these are the 4 distinct values. So answer is 4. So what could be the brute force approach? It can be to find all the possible subsets and their multiplication values and their sum values, and then see how many distinct values are true, right? But what is the time complexity? The number of subsets for any array of size n are 2 raised to the power n, and when n goes to the power value 100, it will be 2 raised to the power 100, which is exponential time complexity. So can we do something better than that? Okay. So if we look at the constraints, n goes up to 100 and ai goes up to 100, right? So what we can do is, let's take another example. Let's take 3, 1, 3, right? So when we talked about the constraints, n goes up to 100, right? And ai goes up to 100. So the worst case could be when n is 100 and every number is 100. Even then, the total sum would be 10,000, not more than that. Okay, we'll come to it why we are discussing this. We'll come to it in a minute. Okay, so what is the total sum for this array? It's 7, right? Although we know that the multiplication of some subsets can be bigger than 7. Like if we take the whole array, it's also a subset. The product is going to be 9. Similarly, in the these constraints also, we know that product of some subsets will be bigger than 10,000, but the sum can never be bigger than 10,000. So are we really interested in numbers which will be bigger than the total sum? No, because although we can find subsets whose multiplication value will be bigger than total sum, but can we really find subsets whose sum will be bigger than total sum? No, because this is the maximum sum. So we are only interested in the values from 0 to total sum. This is the range where the distinct values of x will lie, right? Because we want both subsets, one sum subset and one multiplication subset, right? So what we can do is, we can make a DP of size sum plus 1. So I'm adding a 1 so that we can use 1 based indexing instead of 0 based indexing. Okay, so let's try to build it. We'll make 2 DPs, DP and DP of 2, one for sum and one for product. Okay, so let's try to build it. It will be of size 8. Okay, so the array is 3, 1, 3. This is DP. This is DP of 2. These are the indexes. Okay, so in the beginning, DP of 1 is going to be true. Why? Because the empty subset has a product 1. And all the other values, we cannot have 0 as a product of an empty subset. We cannot have 2. All the values will be false. We can only have 1 as the product of a empty subset. Similarly, the sum of an empty subset is always going to be 0. That's why dp2 of 0 is true. That means we can have a subset with sum 0, which is the empty subset, right? And the other values are 0. Okay, for the first iteration, let's just do the dry run for the first iteration, which is the number 3. So we will do the iteration right to left, not left to right. Why? Because let's say we iterate from left to right. Okay, we know that dp of 1 is true, and if I can multiply it by 3, I can make dp of 3 to be true. But then when I iterate from left to right, I reach 3, then dp of 3 is also true. Then I will try to multiply that by 3 again. I'll make dp of 9 true. Okay, this will exceed, but let's try to imagine of an example where the product will still be in the range. Okay, so I'll make 2 multiplications for the same number. So when I reach any point, I won't be able to know when it's true if this was made true in this current iteration or it is true from the previous iteration. So that's why what I'll do is, I'll iterate from right to left. What I'll do is, I'll check, can I multiply, is the product 7 possible already from previous iteration? It's not, so there's no point. So I'll keep moving right to left, right to left, right. So when I reach dp of 1, I know that the product 1 is already possible because dp of 1 is true. I'll multiply it by 3 and make dp of 3 true. And then I move to the left side. So there will be no duplicates, right? So when I was in dp1, I multiplied it by 3 and made dp3 to be true, right? When I was at dp0, it's 0, so I cannot really multiply anything by it. Similarly, for the sum dp, I'll iterate from right to left. So the first true value I'll find is dp of 0. I know the 0 is true, that's why I'll try to add the current number, which is 3. I'll make dp of 3 to be true, right? And then similarly, I will iterate right to left for the second number and for the third number as well. And then at the end, we will have the both dp grids. So let's try to look at the codes to understand it better, how we can implement it, okay? So this is the function. It takes in the array and it returns an integer, okay? So first of all, we calculate this total sum, which is going to be the size of our dp. We initialize both the dp arrays, one for multiplication, one for sum. Then we initialize the base cases. dp of 1 is 1, so that means the product of an empty subset is always 1. So we'll set dp of 1 to true. And for sum, the empty subset has a sum 0. So that's why dp of 0 is true, right? Then we iterate for all the elements, and for every element we iterate from right to left, right? And then for every number, check if dp of j is already true. Is it true? Yes. If it's true, then I can also, this number I can also make a contribution to it. Why? How? I can multiply that already number j by I, then check if the total product will be in the constraints, that is less than or equal to sum. If it will be, then I'll set dp of j into I also equal to 1. In the case of sum, I'll check if dp2 of j is already true. Is it true? Okay, then I'll try to add this current number to that sum and try to make j plus I also equal to true. If it's under the constraints, I'll set dp2 of j plus I equal to 1, right? I'll do this for all the numbers, and at the end, I will have my dp and dp2 fully. I will have the values which I can make at the end, right? And then I will take a variable count, and then for every value from 0 to sum, I'll check if dp of I and dp2 of I is true for both the numbers. That means that will count as a distinct x, right? So I will increase the count by 1, and at the end I'll just return the count, which will be the answer. Okay, so I hope this was clear. Let's move on to the second question.
So now we are going to solve the second problem of today, that is another counting problem. So in this problem, Alice and Bob were fighting over the last piece of cake. And then Bob said to Alice that if you can solve this problem, then you can have the rest of the cake. You are going to generate an array of size A. Elements of the array can be elements from 1 to B. So there are B to the power A possible ways to generate an array. The score of an array is equal to the number of distinct elements in array to the power C. You need to find the sum of all the possible scores of B to the power A possible arrays modulo 10 to the power 9 plus 7. Alice asked you for the help, please help him. And constraint on this problem is that A, which is the number of elements in the array to be generated, is from 1 to 10 to the power 9, and B, which is the maximum value an array element can have, is from 1 to 10 to the power 9. And the value of C in this problem is from 1 to 2000. Now let's take an example to understand this problem. So now let's take example of A equal to 3 and B equal to 2 and C equal to 2. So it means that we want to generate arrays of size 3 and all the values element can have is 1 and 2. So now let's generate all the arrays. So one array is 1, 1, 1, then 1, 1 and 2, then 1, 2 and 1, and last is 2, 1, 1. And symmetrically there are going to be 2, 2, 2, then 2, 2, 1, then 2, 1 and 2, and 1, 2, 2. Now let's calculate number of unique element in each array. So in this array there is only one unique element. In this array there are two unique element. In this array there are two unique element. In this array there are two unique element. And in this array there is only one unique element. And in this array there are two unique element. And in this array there are two unique element. And in this array there are two unique element. And we have to raise every number by the power of C. So we will raise all the number by the power of 2. So 1 to the power 2, 2 to the power 2, 2 to the power 2, to the power 2, 1 to the power 2, 2 to the power 2, 2 to the power 2, 2 to the power 2. So now we are going to add them up and calculate their sum. So their sum is going to be 1 plus 4 plus 4 plus 4 plus 1 plus 4 plus 4 and plus 4, and their sum is going to be is equals to 26. So this is going to be our answer for this example. Now one way to approach this problem is using dynamic programming. So we will create a dynamic programming of dimension dp I j, where I can take values from 0 till a and j can take values from 0 till b, and dp of ij denotes in how many ways we can create prefix of I elements such that out of them there are j unique elements. So dp of I j is going to be equal to dp of I minus 1 j multiplied by with j plus b minus j minus 1 times dp of I minus 1 j minus 1. So this term here denotes that we already had j unique element in first I minus 1 elements, and this j is the ith element. So this j is one of those elements that has already appeared in I minus 1 prefix. And this term here denotes that our current element is the unique element. So the ith element is unique element and it has not appeared in its prefix. So dp of I minus 1 j minus 1 is the number of ways in which we can generate prefix of I minus 1 element such that there are j minus 1 unique element. Now this ith element is going to be a unique element, so it has to be one of b minus j minus 1 elements. And after iterating over all the values of I from 0 to a and all the values of j from 0 to b, we can calculate our answer. So this is how we can compute our answer using this algorithm. The time complexity of this solution is going to be O of a cross b, which is very large, and now we have to optimize our solution. Now before solving the entire problem, let's solve a subpart of this problem. So in the subpart of this problem, we are going to calculate our answer, but we are going to fix the number of unique elements. So let it be k. So we have now fixed the number of the unique element in our array. So in this subproblem, we have to solve this problem in such a way that after creation, array A has exactly k unique element. So here out of b elements, we have selected k elements. So now we are going to use these k elements to create our array A. So in array A, there are a indexes from 0, 1, 2 till a minus 1. So all of these indexes are going to have one element out of these k elements. So we have to allocate these a indexes to those k elements. Now let bk1 be the first element selected from 1 to b, and bk2 be the second element selected from 1 to b, and bk3 be the third element selected from 1 to b, and let bkk be the last element selected from 1 to b. So we have selected these k elements from b, and now let's consider that out of those a indexes we gave a1 indexes to bk1 and a2 indexes to bk2 and a3 indexes to bk3 and ak indexes to bkk. Now the total number of ways of doing this allocation are going to be a factorial divided by a1 factorial multiplied by a2 factorial multiplied by a3 factorial till a k factorial. So now we have to iterate over all the combinations of a1, a2 till ak such that their sum a1 plus a2 till ak is exactly equal to a, and all these value a1, a2, a3 till ak are non-zero. So these values must be greater than or equal to 1. It means we have to give at least one index to one element. So now let's calculate if our array A has exactly k unique element, then how much that is going to contribute to our answer. So the total contribution is going to be bck multiplied by a factorial divided by a1 factorial multiplied by a2 factorial till ak factorial, such that all a of I are greater than or equal to 1, and summation of all of these ai is exactly equal to a multiplied by k to the power c. So this is the number of ways of selecting k elements from 1 to b, and this is the number of ways of allocating indexes to those k elements, and this is the contribution of individual array. Now this term here and this term here can be easily computed. Now let's try to understand how we can compute this term here. So now let's try to evaluate this term as a coefficient of some polynomial. So now what we can do is that if we write k polynomials of the form x plus x square divided by 2 factorial plus x cube divided by 3 factorial and so on, and one more polynomial of the form x plus x square divided by 2 factorial plus x cube divided by 3 factorial and so on till the kth polynomial. And here you can see that the number in the power and the number in the denominator, so these factorials in the denominator are exactly same. So now if we multiply all of these k polynomials, then in the end we are going to get a polynomial of the form x and x square and x cube and so on. So all of these terms are going to get some coefficient here. So now let's try to understand what is going to be the coefficient of some generic term x to the power alpha. So now let's consider that from this polynomial we took an element with the power x to the power alpha, and from this polynomial we took a term with x to the power alpha 2, and from here alpha 1, and till from this last polynomial we took an element with x to the power alpha k. So their multiplication is going to be x to the power alpha 1 multiplied by x to the power alpha 2 till x to the power alpha k, and in the denominator we are going to get alpha 1 factorial, alpha 2 factorial till alpha k factorial. So on simplifying we are going to get x to the power alpha 1 plus alpha 2 plus alpha 3 till alpha k, and in the denominator we are going to get alpha 1 factorial multiplied by alpha 2 factorial till alpha k factorial. So the coefficient of a generic term x to the power alpha is going to be the summation of 1 over alpha 1 factorial, alpha 2 factorial till alpha k factorial, such that alpha 1 plus alpha 2 plus alpha 3 till alpha k are equal to alpha. And these alphas will never be zeros, because here in this polynomial we are always taking all the powers that are greater than or equal to 1. So these alphas will always be greater than or equal to 1. So now if we consider the coefficient of x to the power a, then that coefficient is going to be the summation of 1 over a1 factorial, a2 factorial till ak factorial, such that a1 plus a2 plus a3 till ak are equal to a, and all of these ai are going to be greater than or equal to 1, because all the powers in our polynomial are greater than or equal to 1. If we look at this function, then this is nothing but e to the power x minus 1. Now the total contribution of all the arrays with exactly k unique element is going to be bck a factorial multiplied by e to the power x minus 1 to the power k and k to the power c. So all the polynomials of the form x plus x square divided by 2 factorial plus x cube divided by 3 factorial were nothing but e to the power x minus 1, and those polynomial were multiplied k times. So finally we are going to get e to the power x minus 1 to the power k. So the total contribution is going to be the coefficient of x to the power a in this polynomial. And if we iterate over all the values of k from 0 till b, so we are iterating over how many unique elements we are going to have at the end in our array a. So if we iterate over all the values of k, then this summation here is going to give us our final result, and this a factorial is common. So we have taken this out. So the coefficient of x to the power a in this polynomial is going to be our final result. So each term of this summation is a polynomial, and if we add all these polynomial together, then in the end the coefficient of x to the power a is going to be our final result. So now let's try to calculate the coefficient of x to the power a in this polynomial. So what we can do is that we can substitute e to the power x minus 1 with a y, and this a factorial is a constant, and we can take this out. So the new equation is going to be summation of k goes from 0 till b, bck y to the power k and k to the power c. Now let's try to write multinomial expansion of 1 plus y to the power b. So it is going to be is equals to the summation of k goes from 0 till b, bck and y to the power k. And if we differentiate both the side by y, then we are going to get b 1 plus y to the power b minus 1 is going to be equal to summation of k goes from 0 till b, bck y to the power k minus 1, and we are going to get k here. And now let's multiply both the side by y. So we are going to get b times y times 1 plus y to the power b minus 1 is equal to summation of bck y to the power k and k here. So we have multiplied both the side by y, and now we are going to again differentiate this. So we are going to get b y 1 plus y to the power b minus 2, and we are going to get b minus 1 here, plus b 1 plus y to the power b minus 1, and we are going to get a 1 here, and it is going to be equal to summation of bck y to the power k minus 1 and k square. So now again we are going to multiply both the side by y. So we are going to get b into b minus 1 y square 1 plus y to the power b minus 2 plus b times 1 plus y to the power b minus 1 multiplied by y, and on this side we are going to get summation of bck y to the power k and k square. And here we can see that we differentiated this function twice, and we got here 2 in the power of k. So if we differentiate this function c times, then in the end we are going to get k to the power c here and y to the power k, and summation of B, C, K. And this is something we want to evaluate. So after differentiating both the sides C times, we can calculate the coefficient of x to the power A on the right side. After differentiating both the side C times and multiplying both the side by y C times, all the terms on the left side are going to be of the form y to the power A multiplied by 1 plus y to the power B and some coefficient here. And using dynamic programming, we can maintain these coefficient. And after differentiating both the sides C times, we can resubstitute y equal to e to the power x minus 1 and calculate the coefficient of x to the power A on the left side. One thing to notice here is that this A and this B are always add up to a capital B. Now let's look at the solution code. In our solution code, we have created two functions. One is expo and the second function is a compute. So here what we are doing is that in this expo function, we are performing an exponentiation function here. So we are going to compute base to the power exponent modulo a mod. So here base to the power exponent can be very large, and this helper function is going to help us to compute the value under a modulo. So here we are doing that, and this compute function here is going to help us in computing all the binomial coefficient that we need in our solution. So to compute the binomial function, what we are doing is that we are using the property of Pascal triangle, that is Cij is nothing but C of I minus 1 j and C of I minus 1 j minus 1 modulo mod. Now let's look at the actual solution code of this problem. So before solution code here, what we have done is that we have created global DP matrix, a G array and a PW array. In the solution code here, we are getting the variable n, m and k. So these n, m and k are nothing but capital A, capital B and capital C, as we understood in our solution approach. So here we are doing our pre-computation, and here we are storing the value minus 1 in our DP matrix. And in this statement here, for all the values of I from 0 to k plus 1, what we are doing is that we are computing PW of I. So PW of I is nothing but B minus 1 to the power A. And in this segment of the code, we are computing G of I. And for calculating G of I, this is the formula. So for every value of I here, we are iterating over all the values of J from 0 till I, and we are computing this function. So in this statement here and here, we are doing that computation. And as values can be very large, we have to do all the computations under a modulo. And here we are calling the function fill of k0. So this function, what this function is going to do is that it is going to compute the value of dp of k0, and it is going to return it. And in the end, we are going to return that value because that is going to be our final answer. Now let's understand what this fill function is doing. So it is taking three argument diffs a and this tot. So this tot is always constant, and its value is nothing but a capital B, as in our solution approach. And here after that, if dp of diffs a is calculated, then simply return it. And then we are creating a variable b, which is nothing but tot total minus a, which is nothing but capital B minus small a. And after that, if diffs is 0, then this is a base case. In that case, value of dp of diffs a is nothing but g of a, and we are going to return that. Or else we are going to calculate the value of dp of diffs a, and this is the formula for calculating dp of ij. So dp of ij is nothing but j times dp of I minus 1 j plus b minus j dp of I minus 1 j plus first. And here by multiplying 1 ll, we are making sure that we are doing all the calculations in long and we are not running into an overflow. And here in the end, we are taking a modulo. And in any case, if a is 0 or b, this small b is 0, in that case we are evaluating this thing to a 0 long. After computing the value of dp of diffs a, it is going to return it. So that was the solution code for this problem. We are creating a DP matrix of size C square, array G of size C, and array PW of size C. So the time complexity of this solution is going to be O of C square, because we are creating a matrix of size C square and we are then computing it. And the space complexity of this solution is going to be O of C square, because we are creating a matrix DP of size C square. So the time complexity as well as the space complexity are going to be of the order of C square. Thank you for watching. Please like, subscribe and share it with your friends.
Hello everyone. I welcome you guys again in this Scalar Academy's live session. So in this particular live session, we decided let's actually do something about Python interview questions. So Python is a language which is used across a lot of industries and it is used across the world. So whether you are working in an e-commerce industry, or maybe it's a biotech industry, or maybe if you're an academician, Python is widely used and it has a lot of different purposes. And the best part about Python, as I've been stating, is with the help of it, you can probably do web development, you can develop games with it, and you can also implement data science and machine learning tasks with this amazing language. So now that we've understood Python is so amazing, let's actually see what does it actually take to crack those Python related interviews. And since there are a lot of aspects related to Python, what we'll do is in this particular live session, we'll cover almost everything that is there in Python to card. So Python is a magical language and you can do a lot of things with it. So whatever you want to do, Python springs up a library for that purpose. So let's say if you'd want to do web development, Python gives out a library for that. Similarly, let's say if you'd want to do game development, Python again gives out a library for that. If you'd want to do any of the data science or machine learning related tasks, Python again gives out a library for that. So now that we know Python has all of these varied purposes, so as I've been stating, we'll be focusing on all of the different things that Python can do. Now that we know what we'll do is we'll start off with the basic stuff. Let me go ahead and share my screen over here. And let's start off this live session by understanding some of the basic features of Python. So this Python interview questions live session will be conducted in such a way that we'll be understanding all of the Python fundamentals through this set of questions. Let's start up by understanding what exactly is Python. Now, Python is platform independent. So what exactly do I mean when I say Python is a platform independent language? Well, the answer is pretty simple. You can run Python on any operating system. Let's say if you have a Mac operating system, if you have a Mac, you would have iOS. Similarly, let's say if you have a Windows laptop, or maybe if you're running a Linux system, whatever the operating system is, you can run Python on top of it. Now, this is very beneficial because let's say if you're a developer who probably is working on a Mac and you develop your entire app on this Mac system, but your client does not have a Mac, your client probably has a Windows laptop. Now, it is necessary that the same application is able to properly run on your client's laptop as well. And this is where, since Python is a platform independent language, whether you develop your application on a Windows laptop or on a Mac laptop, it really doesn't make a difference because it's platform independent. And this is what is meant when I say Python is platform independent. Going ahead, Python is also an object-oriented programming language. So we hear this term object-oriented programming a lot, but what does it actually mean? So in simple terms, let's understand object-oriented programming this way. Now, when you look around you, what do you actually see? You'd see a lot of objects, isn't it? So let's say I have this bottle beside me. What exactly is this? This is a real life object. Similarly, what I have over here is a phone. What exactly is this phone? This phone again is a real life object. Now, if I'd have to represent all of these real life objects in a programming paradigm, what I would need is an object-oriented programming language. Isn't that very simple? So we have a lot of object-oriented programming languages out there, and one of those very important object-oriented programming languages is Python. So obviously with the help of Python, we can represent all of these real-life objects in a programming roadmap or in a programming blueprint. Then Python is also a dynamically typed programming language. Now, what do I mean by this? I have something called as a statically typed programming language and dynamically typed programming language. So let's understand this by opening up Jupyter Notebook. So I'll just open up Jupyter Notebook over here. Now, if you have worked with other programming languages such as C, C++, or Java, to work with variables, what you would normally do is, let's say, write in something like, let me also increase the size of this so that it's much more visible to you. Right? So let's say if you'd have to create an integer variable, you will write something called as int a. Similarly, if you'd have to create maybe a Boolean value, so you will write something called as bool b. Similarly, if you'd have to create a character variable, you will write down char C. And now this is what is known as a statically typed language. What you are doing is you are predefining a data type to the variable which you are creating. Right? So let's say if I write int a, this would mean that I am creating a variable called as a, which can only hold integer type values. But this is not the case when it comes to a dynamically typed programming language. So let's say if I have a variable called as a, the data type of variable a would be determined on the basis of the value which I store in this. So let's say if I store a value such as 37 in this variable, let me just hit enter. And if I check the type of this, type of a, and you would see that this is an integer. Now, similarly, what I'd want to do is, let's say instead of storing the value 37, I would probably store a string value. And let me go ahead and store over here Scalar Academy. Now, if I check the type of this, type of a, you would see that this is a string. So what is happening over here is the data type of this variable is dynamically being decided. And that is why we call Python a dynamically typed programming language. And Python is also a strongly typed language. Now, what exactly is a strongly typed language? Let's also see an example for that. So let's say if I try to do something such as 12 plus a, I get an error. And in the error, you see unsupported operand type for int and string. Now, this is because this is strongly typed, which would mean that this is fixed, this is an integer, this is also fixed, this is a string, and you can't combine these two different types together. But on the other hand, let's say if I'm working with JavaScript, now what I'd want to do is I'd want to view the page source, not probably the page source. I'd probably want to inspect this. Let me click on inspect, and over here, probably I'll go ahead and go to console. And in console, let's say if I type in 1, I'll have 1. Similarly, let's say if I have a over here, I'll have a. Now, if I do something like a 1 plus a, you would see that I have this in the result. Right? So 1 is an integer, a is a string, and when I do 1 plus a, this 1a entirely, what is happening is this is being concatenated into this entire string. So this is a weakly typed language, but Python is a strongly typed language, and that is why you cannot just combine this integer and this variable together. So I hope you guys properly understand the difference between a weakly typed language and a strongly typed language. So now that we have understood this, what we'll do is we'll go to the next question. So we've covered what exactly is Python. So Python is platform independent, which would mean that you can run Python on any of the operating system which you have. Then Python is also an object-oriented programming language, which would mean that you can represent all of the real-world entities in a programming paradigm. Going ahead, Python is a dynamically typed language, which would mean that the data type of a variable would be dependent on the value which you give inside it. And it is also a strongly typed language, which would mean that if you, let's say, have integer, that cannot be combined directly with a string type. So this was our first question. Now, let me go ahead to the next question. So we are supposed to explain about the different types of operators in Python. And we've got some basic operators, which are arithmetic operators, relational operators, and conditional operators. So let's work with all three of them over here. Let me just bring this over here. And let me add a comment. So I shall just write down operators over here. And as the name states, with the help of operators, we can perform basic operations. Now, I will also write down the three types of operators, which would be arithmetic. After this, I've got something called as relational. And then I've got something called as logical. So I've got arithmetic operators, relational operators, and logical operators. Now, after this, what I'd want to do is I'd want to start off by working with the arithmetic operators. So I'll have a variable called as a, and in this variable a, I'll store the value, let's say 35. Now I'll have another variable called as b, and in this I'll store the value 67. Now I'd want to work with the basic arithmetic operators. So the basic arithmetic operators would be, let me add another comment over here. So this would be addition, subtraction, then I'll have multiplication. After that, I'll also have division. And now let me go ahead and perform these operations on top of these two variables. So let's say if I write down a plus b over here, I get 102. And that is because 35 plus 67 is equal to 102. Similarly, if I go ahead and perform a minus b over here, I'll get minus 32 because 35 minus 67 is equal to minus 32. Going ahead, let me multiply these two values. So I'll have a star b. And when I multiply a with b, I get a value of 234y because that is the result. And then finally, let me divide a by b. So here I shall just write down a divided by b, and I get a value of 0.5 because 35 divided by 67 is equal to this particular value. So again, I hope all of you are understanding this properly. And if you have any questions, you can put them up in the chat. So Anil is asking, I have one question regarding Scalar Academy. I've opted for that course and want to know, does knowing only Python will help me into getting product-based companies? So when you talk about getting into product-based companies, knowing just one language, that is only one of the prerequisites. So what actually happens in the product-based company is you would need to be good with data structures and algorithms, and you would need to be able to implement these data structures and algorithms properly with at least one of the object-oriented programming languages. And that would totally depend on you. So you can either pick Python, you can either pick Java, you can either pick C++. So whatever language you're comfortable with, you can pick any of these languages. And with that tool or with that language, you would need to be able to properly implement all of the data structures and algorithm concepts properly. So I hope that answers your question. Now, going ahead, we have looked at arithmetic operators. Next up, we'll also look at relational operators. I'll add another comment over here. Let me just write down relational operators. And relational operators, we will have less than, greater than, and not equal to. After this, we'll also have double equal to. And again, as the name states, with the help of relational operators, we'll be able to understand the proper relation between two operands. So here, what I shall do is, again, I'll probably have two variables. I'll have x. Inside x, I'll store the value 12. Then I'll have another variable called as y. And in y, I'll store the value 15. And I'd want to understand the relationship between x and y. So if I want to understand the relationship, what I'll do is, so let me just start off by writing x less than y. So when I put x less than y, I get a true value because 12 is less than 15. Now, if I go ahead and change this to greater than, so x greater than y, I get a false value. And I get a false value because 12 is obviously not greater than 15. Now, let me go ahead and change this. Let me put not equal to over here. And when I run this, I get a true value because obviously 12 is not equal to 15. So this symbol which you see, exclamation mark followed by equal to, that is called as the not equal to operator. Then finally, we have the double equal to operator, which would help us to compare the values in two different operands. So now when I execute this, I can get a false because obviously 12 is not equal to 15, and that is why it is a false. So these are some basic relational operators which you have focused on. Going ahead, we shall focus on, we've got logical operators. Let me add a comment for that as well. So here I shall write down logical operators. Now, in logical operators, we'll have two things. We'll have the AND operator and we will have the OR operator. Now, when we talk about AND operator, it will give us a true result only when both of the operands are true. When it comes to the OR operator, we'll get a true result when either of the operands is true. So here again, I shall have two variables. Let me have one variable called as m, and in this variable, I'll store true. Then I'll have another variable n, and inside this, I'll store the value false. So now that I have these two variables ready, what I'd want to do is I'd want to compare these two with the help of the AND operator. So I'll start off by writing m and n. I get a false because true and false is equal to false. Now let me change this. Let me change true to be equal to false and false to be equal to true. Now after this, when I again run m and n, I again get a false value. Now I get a false value because false and true is also equal to false. Going ahead, I'd want both of the cases to be false. So m I have false, n I have false. So false and false again is equal to false. And the final case, what I'd want to do is I'll store true in this variable m, and I shall also store true in this variable n. Now, when I have m and n, I get a true value. So true and true is equal to true. So let me reiterate this. We shall get a true result only when both of the cases are true. As simple as that, and that is how the AND operator works. Now going ahead, we shall work with the OR operator. So OR operator, as I've told you, it gives us a true result when either of the operands is true. So we will start off with the same set of values. I'll write m or n. I get true because true or true is equal to true. Now let me change this to be equal to false. And let me directly run this. I'll get a true result again because true or false is also equal to true. Let me change this. Let me make this false and let me make n to be equal to true. Now if I run this again, I can get a true result. And finally, when I make both of these cases to be false and I run this, now I get a false value. Because we'll get a false only when both of the operands are false when it comes to the OR operator. So these are the different types of operators when it comes to Python. Now we'll head to the next question. So what is a tuple in Python? So this is a very interesting question. Let me add a comment for that. So here I shall write down tuple. So till now, what we've been doing is we've been looking at basic variables. And what happens in a variable is you can only store one value at a time. But what if I want to store multiple values at a single go? And for that purpose, we'll have different data structures. So part of those different data structures will have tuple, list, set, and dictionary. And tuple is one of the most primary one of them. So you can create a tuple like this. So what I'm doing is I'm writing T1 and I can create a tuple by using these round braces. And inside these, I'll just give in a bunch of values. So let me just write down 1, 2, 3, 4, and 5. And I'm storing this in this object called as T1. And now let me print out T1. I've got this. Let me also check the type of this. Type of T1, and you shall see that this is equal to a tuple. So a tuple is basically a collection of elements, and a tuple is immutable. Now, what do I mean when I say tuple is immutable? That would mean that once you create a tuple, you cannot change the values which are present inside it. So we've created this, and whatever values are inside this, that cannot be changed. Now, since that we've created this, and also it's not necessary that all of the elements are of the same type. So you can have homogeneous elements as well as heterogeneous elements inside a tuple. So right now we only have homogeneous elements because we've only got integers over here. Let me create another tuple where probably I'll have a mixture of maybe integers. I'll have Boolean values as well, and I'll have a couple of string values as well. And let me store this in a new tuple and call it as T2. Now let me print out T2 over here. And as you see, I've been able to create this. And just to confirm if it's a tuple or not, let me check the type. And inside the type method, I will pass in T2. And you would see that this again is a tuple. And I was able to store all of these values inside this. So this is how we can work with the tuple. And that's quite simple. So now that we have created this, so what I'd want to do is, let's say if I'd want to extract individual elements from this tuple. So that for that purpose, I would need indexing. So I'll write down T2, and from this tuple T2, if I'd want to extract the first element. So in Python, you'd have to understand that the indexing starts from 0, not from 1. So the first element is present at index 0. Second element is present at index 1. Third element is present at index 3, index 2, and so on. So let's say if I want to extract this first element, so first element is present at index 0. So I'll just write 0 over here. And when I hit enter, I get 1 because this is the element which I've extracted. Similarly, if I want to extract true, true over here is present at index number 2. So I shall write down T2 and inside parenthesis, I'll give in the index number which is 2. And as you see, I was able to extract this particular element. So this is how we can extract elements. And similarly, let's say if I have to extract the last element. So for this, we have an interesting use case. Normally to extract the last element, I can just write down -1 over here. And as you see, I was able to extract the last element C from this. So now that we have extracted all of these elements, now let's go to the next question. So how do you repeat the elements in a tuple? So if I have to repeat the elements in a tuple, let me just print out T1 over here. In T1, as you see, I have 1, 2, 3, 4, and 5. Now, if I want to repeat the same set of elements again and again, I can just multiply this variable with a particular value. So here I shall write down T1 into 2. When I write down T1 into 2, you shall see that I've repeated the elements 2 times. So 1, 2, 3, 4, 5, this is happening 2 times. Similarly, let's say if I have T1 into 3, you shall see that this is repeating 3 times. Again, if I, let's say, change this, if I have 4 over here, you shall see that this is repeating 4 times over here. So these are basic things which would happen in a tuple. So we have next question over here. Now, how do you find the sum of elements in a tuple? So if I want to find out the sum of elements in a tuple, again, I will take the same one. So T1, I have all of these values. What I can do is I can just use sum. I will pass T1 inside this. So let's add this up. 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So if I have all of the elements to be integers, and if I just want to directly add them up, I can just use the sum method. And with the help of the sum method, I can add all of the values which are present in this tuple. So I hope you guys are clear with this. Now let's get on to the next question. So how do you find the frequency of different elements in a tuple? This is interesting. So I'm supposed to find out the frequency of different elements in a tuple, which would mean that I want to know the number of times an element is repeating. So again, I will create a tuple. I'll call this T3. And what I'll do is I'll have elements like this. So I have 1 repeating twice, 2 repeating thrice, and 3 repeating 4 times. So I've created this tuple. Let me print it out for you guys. Now we have something called as a counter. So let me just go ahead and import that. So here I shall write down from collections import counter, and I can directly pass in this tuple inside this counter. Let me use this inside the counter. I'll pass in T3, and you see that I get a dictionary, and dictionary obviously has a key value pairs. So key is the number, value is number of times that number is repeating. So here 1 is repeating 2 times, 2 is repeating 3 times, and 3 is repeating 4 times. So if we want to find out the frequency of the different elements in a tuple, what we can do is just use counter, which is part of the collections library. So again, I hope this is clear to all of the folks who are watching this. Now, let me go back and see what is the next question. So we are done with the questions on tuples. Now let's go to the list. What exactly is a list? So this again is interesting. Let me add another comment over here. So what I'll do is I'll probably add a couple of new lines. And here I shall add a comment. I'll call it list. So before understanding list, let's understand the difference between a tuple and a list. When it came to a tuple, the tuple itself was immutable, which would mean that you cannot change the elements which are present in it once you create it. But a list is mutable. Now, when I say list is mutable, once you create a tuple, you can change whatever is present inside that. And so if you create a tuple with the help of round braces, you shall create the list with the help of square braces. So these are some basic differences between a tuple and a list. Now let me just go ahead and create a tuple actually a list over here. So I shall write down L1 and I'll create a list, and let me pass in some values over here. So I've created a list L1. I have all of these values inside this. Now what I'd want to do is I'd want to check the type of this as well, type L1, and you shall see that this is a list. So now that I've created a list and I've also told you that this is immutable, I'll show you how it works. So initially at index number 0, I have the value 1. Let me try to change that value. L1, I'll give in the index, which is equal to 0, and let me try to change the value. So initially the value is 1. I'd want to change that value to 100. So let me give in 100. Now let me print out L1 over here. So you would see that initially we had this list where the element which is present at index number 0, the value of it was equal to 1. Now, since this list is mutable, we have successfully changed that value from 1 to 100. So this is how we can say that a list is mutable. Going ahead, what I'd want to do is I'd want to show this difference with the list. So with a tuple actually. So let me print out T1 over here. Now, if I'd want to change this value from 1 to 100, we'll get an error. So T1 index 0 is equal to 100. And when I run this, you get this error. And if you read this error properly, you will see that tuple object does not support item assignment. And why doesn't it support item assignment? Because tuple is immutable. So as simple as that. And this is the basic difference between a tuple and a list. So now that we've looked at these basic things, let's go to the next question. So how can you use the append method with list? This is interesting. So with the help of the append method, we can add new elements or we can append new elements into the existing list. So again, let me print down L1 over here, and then L1, we have all of these elements. So at the back end of this list, I'd want to append a new value. So I'll just write down L1 dot append, and probably I'll give in 7 over here, and let me hit execute. Now let me print L1. You would see that I was able to successfully append this value 7 at the end of this list. Now, it's not necessary that I can only insert one value at a time. I can probably insert a tuple inside this. I can probably insert a list inside this. I can probably insert a string inside this. So let's see how is that possible. So here I shall write down L1.append, and let me add in a tuple. So to add a tuple, what I want to do is let's just give in these round braces, and inside this, let me just add probably 100, or let me make it 222, 333, and 444. Now, if I print out L1, you would see that I was able to add this tuple. So as you see, this entire tuple is an element in itself. Similarly, let's say if I want to add a new list inside this, I can do that. So here I shall write L1.append, and inside this I'll put in, so probably I'll have A, B, and C. Now let me print out L1 over here. Again, I've added a new list which comprises of these elements. Now let's say if I want to extract this element 333 from this entire list, let's see how can we do that. So let's start off by checking the index of this. So this should be present at index number 0, 1, 2, 3, 4, 5, 6, and 7. So this tuple is present at index number 7. So let me just write down L1 of 7, and I've extracted this. Now from this, what I'd want is this 333. So 333 is present at index number 1. So again, parenthesis 1. And as you see, I have successfully extracted this value 333 from this entire list. So this is basic processing which you can do from a list. Now, going ahead, we have the next question. How can you multiply adjacent elements in a tuple? This is quite interesting. So let's create a tuple first. So let me add in a comment. Multiplying adjacent elements in a tuple, and let me go ahead and create a tuple for the same. I'll call this T5, and in this T5 tuple, what I'd want to do is I just want to create a bunch of values first. So I'll have 1, 2, 3, 4, and 5. I've created this tuple. Let me print out T5 over here for you guys. So now that I've created this tuple, what I'd want to do is I'd want to multiply adjacent elements, which would mean that I would want 1 into 2, 2 into 3, 3 into 4, and 4 into 5. So for this, I'll be using two things. I'll be using the for loop and I'll be using the zip method. So let me show you how the zip method works first. So zip method obviously will be able to zip or combine two tuples together and make it one tuple. So here I'll write down T5 and T5. Here I shall probably write down. So from 1, I would need everything. I'll run this. Let me convert this into a tuple again. Let me copy this, paste it inside this tuple. And now when I run this, this is what we get. So what I have is, I have the same thing pairwise. So 1, 2 has become a pair. 2, 3 has become a pair. 3, 4 has become a pair. And 4, 5 has become a pair. Now it's very easy for me to multiply the elements which are present in this pair. So for that, I would need a for loop. So here I shall write down for I, j in this. So I would not need this tuple over here. Let me remove tuple from this. So for ij in zip of this, what I'd want to do is I'd want to multiply I and j. So I shall just write down I into j. I'll print I into j. So print of I into j, and I shall get the result. So as you see, I have this tuple, and by using this particular logic, I've been able to multiply the adjacent elements. So 1 into 2 is equal to 2, 2 into 3 is equal to 6, 3 into 4 is equal to 12, and 4 into 5 is equal to 20. So this is a very simple question which you are able to solve by using the zip method and also the for loop. So we will head to the next question now. So how do you sort a list in Python? This again is interesting. So let me create a list for that purpose. So let me write down list L1, and what I'll do is I'll have some values. L1 is equal to 5, 7, 8, 1, 3. Let me put in a comma between these two. So I guess these need to be enough. So I've created a list called as L1, and these are the values which are present inside this. Now, if I want to sort this list, I can just type in L1 dot sort. Now let me print in L1 over here, and you would see that these are all of the values which I have. So I've got 1, 3, 5, 6, 7, and 8. And by just using this simple sort method, I was able to sort all of the elements which are present in this list. And now, going ahead, we have the next question. What is a dictionary in Python? This again is a very interesting question. So till now we've worked with tuple and list. And when it came to tuple and list, we had stored individual elements inside them. Now, when it comes to a dictionary, what happens is we have something called as key value pair. And we had already seen one example of that. So let me create an example for this. So I'll create a dictionary called as D1. And to create a dictionary, you will use curly braces. So here I'm using curly braces, and I'd want to create a dictionary by using key value pairs. So here I shall write down K1. K1 is basically the key. After this, I need to give in some values. So here, let's say the value for K1 is 12. Then let me give in the next key, which would be K2. And let's say I give in a value of probably 23 for this. Then let me give in the next key, which would be K3. And for K3, let me give in the value 34. Then let me have K4. And for K4, I'll have, let's say, 45. So I have just created a dictionary over here, which has all of these values. Let me print out D1 for you guys, and let me also check the type of this. Type of D1, and you would see that this is of type dict, which would basically mean that this is a dictionary. Now, these values which you see before the colon, those are the keys. These values which you see after the colon, those are the values. And if I want to individually extract the keys or separate out the keys and the values, that can be done. So from D1, if I want only the keys, I would write down D1.keys, and you would see that I've extracted the 4 keys which are present. I have K1, K2, K3, and K4. Similarly, if I want to extract only the values, here I shall write down D1.values, and you would see that I have been able to extract all of the values, which are 12, 23, 34, and 45. So this is a basic example of how you can work with a dictionary. So now that we have covered this, let's go to the next one. How do you change key name in dictionary? So when we talk about key names, so again, these what you see, these are the keys, K1, K2, K3, and K4. And if I want to change a particular key name, so let's say I have K1 over here, I'd want to change that K1 to probably L1. Let's see how that can be done. So I shall, first what we'd have to do is I'd have to pop this out. And when I'm popping this out, I'd have to add a new element instead of over there. So D1 is my dictionary. And what do I want to pop out? I'd want to pop out K1, and instead of K1, I'd want to add probably L1. So I'll have D1 K1 dot pop, and whatever I'm popping, I'd want to store it in L1. So just remember what we have over here. So this was our original dictionary, K1 going on till K4. I'm popping out K1, and the value will be stored in L1. So int doesn't have this. Let me see what is the error over here. D1 K1 dot pop. Let me remove this. So we get the same error. Probably I'll just write down pop over here. K1. What I'll do is I have D1 over here. I have K1. I get this. POP, or let me just use pop over here, D1, and inside this I shall just write down, probably I'll just write down over here K1, pop is not defined. So what I'll do is probably I'll just remove it out, D1 dot, let me just have K1 over here. Right, so I'll do this in a different way. I'll have D1 dot pop, and what I'll have to pop is basically K1. And once I pop this off, I will go ahead and store this in something called as L1. So this would be the right way to do that. Now, if I print out D1 over here for you guys, you would see that I have successfully changed this. So initially what I had over here is K1, and I've been able to change that to L1 over here. Now, similarly, let's say if I have this K2, I'd want to change it to L2. Let me go ahead and do that. So I'll have D1, and what I'd want to do is I shall do a similar thing, D1 dot pop. I'm popping out K2 and storing it in L2. Now I'll have D1 over here, and as you see, this is what I have. So this is how we can change a key name when it comes to a dictionary. So these are some basic questions which can be found when it comes to a dictionary. Now let's go ahead to the next one. How do you increment the values of a dictionary using a loop? And this is also something which is quite commonly asked. So what I shall do over here is, again, I shall create a new dictionary over here. I'll probably call it D2. And inside this, I'll have a key called as A1, I shall give it 1. Then I'll have a key called as A2, I shall give it the value 2. Then I shall have another key called as A3 and I shall give it a value of 3. Then I'll have A4 and I shall give it a value of 4. So now that I have created this dictionary, I have all of these values over here. What I'd want to do is I'd want to start a for loop. And with the help of that for loop, I'd want to increment all of these values. So here I shall write down for I in D2. Now let me just show you what would happen if I print out I over here. So for I in D2, print I. So what I'm printing over here is the keys. Now what I'd want to update is the values. So I will have I, and over here, this is, I need to change this to D2, and inside parenthesis, I'll have I. So D2 of I is equal to D2 of I plus 10. So what I'm doing over here is I'm updating each value over here with 10. So 1 will become 11, 2 will become 12, 3 will become 13, and 4 will become 14. Let me run this. Now, when I print out D2 over here, you shall see that all of the values have been successfully updated, right? So 1 has become 11, 2 has become 12, 3 has become 13, and 4 has become 14. So we have updated all of the values over here. So now that I have done this, what I'd want to do is, let me go ahead to the next question again. So what is a set in Python? So this again is quite important. So what we've covered till now is the basic data structures. So we've looked at tuple, we've looked at list, we've looked at dictionary. Next up, we have something called as a set. So here I shall add the comment set. And over here, what I'd want to do is, again, if you want to create a set, you would have to create a set by using curly braces. And the important feature about set is you cannot have duplicate values in a set. You can only have unique elements. Now, I'm creating a set like this. So I'll have S1 is equal to, now when I have something like this, now when I print out S1 for you, you would see that all of the duplicates have been removed. So here in the original set which I'm creating, I have 3 ones, but in the result, you would see that I have only 1. Then 2 I have 2 times, but here 2 I have only once. Again, here 3 I have 2 times. In the final result, 3 I have only once because all of the duplicates have been removed. And this is how a set works. And a set is also unordered, which would mean that you cannot really maintain the order of a set. So this is all about a set. Next up, we have the next question. How do you test if a tuple is distinct? This is quite interesting. Now, when you say how to test if a tuple is distinct, you're basically asking if there are any duplicates present in a tuple or not, or if all of the elements in a tuple are unique or not. So since you've already checked what is a set, the best way to find out if a tuple is distinct or not would be to convert this tuple into a set and find out if the length of the tuple and the converted set is same or not. So here I shall create a tuple. Let me have 1, 1, 2, 2, and 3, 3. Now what I'd want to do is I'd want to convert this T1 into a set, and I will again convert that into a tuple. Let me copy this, paste this over here. Let me delete this. And this I shall store in T2. So I have T1 ready, which is equal to this. I have T2 ready, which is equal to this. Now I can just check the length of both of them. So length of T1 is double equal to length of T2, and I shall get a false value over here. I'm getting a false value because obviously the length of both of these tuples is not equal, which would mean that there are obviously duplicates present in the tuple which I've created. So this is how we can find out if a tuple is distinct or not. Next up, we'll see what do we have in the set of questions that we have created. So how do you test if a tuple is distinct, and how do you remove all of the duplicates from a list? So this again is sort of a similar question. So let's say if I have a list like this, I'll have 10, 10, 11, and 11. I shall have 12 and 12. I shall print this out for you guys. So you'd see that there are obviously duplicates present in this list. And if I'd want to remove these duplicates, what I would want to do is convert this into a set. So I will write down set, I will pass in L1 into this, and I shall again convert this into a list. So I'll copy this, I'll paste it inside this, I'll cut this out. Now, when I run this, you shall see that all of the duplicates have been removed. So your simple answer to find out if a tuple or a list, whether it has any duplicates or whether it is distinct or not, would be to just convert this into a set and find out the answer. As simple as that. Next up, how shall you find the greatest among three numbers using if-else statements? This is again a very common question. So let me write that down as a comment over here. Finding the greatest among three numbers using if-else. So first I'd have to get three numbers over here. I'll have A, B, and C. So I'll have a variable called as A. Inside variable A, let me have the value 10. Then I'll have another variable B. Inside the variable B, I'll store the value 20. And I'll also have a variable called as C. And inside the variable C, I'll store the value 30. So now that I have these three variables ready, what I'd want to do is I'd want to check which of these is the greatest. So here I shall write if A is greater than B and A is greater than C, then I'd want to print out A is the greatest. But if this turns out to be false, then what do I want to do? Well, if this turns out to be false, then I'll write elif. I'll check the condition for B. So if B is greater than A and B is greater than C, I would print out B is the greatest. Now, if both of these turn out to be false, what I'd want to do is I'll have the final else statement and I should just print out C is the greatest. Now you see that I get the result C is the greatest, and let's understand this properly. So here what is happening is I have 10 stored in A, 20 stored in B, and 30 stored in C. So we will come to the first if statement over here, and I'm checking if A is greater than B and A is greater than C. So is 10 greater than 20? No, it is false. Is 10 greater than 30? That is also false. So false and false is equal to false. That is why we skip this. Then we come to elif. Here we are checking if B is greater than A. Is 20 greater than 10? Yes, true. Then we are checking if B is greater than C. So is 30, so is 20 greater than 30? No, that is false. So here we have true and false, which is equal to false. So we skip this. So since this is also false, we come to the final else statement and print out whatever is present in the final else statement. And what we are printing is C is the greatest. And that is how we find out the logic to find out which number is the greatest among a particular set of numbers. Next up, we have the next question over here. How shall you create this pyramid pattern? So pyramid patterns are again quite common when it comes to any interview. Again, so irrespective of the language, you are supposed to know the logic behind how to create these pyramid problems. So here, this is a very, very simple pyramid problem. We'll have 1 star at the top and it increases as the number of rows increases. So 1 star at the top, 2 stars in the second row, 3 stars in the third row, 4 stars in the fourth row. And it is quite simple to create this pyramid pattern with Python. So I will add a comment over here, pyramid pattern. And now that I have added this, I would start off by creating a for loop. So I shall write for I in range of 0 to 5. So this would be my outer loop. Then I'll have another loop. And inside this loop, I shall write down for j in range of 0 to I plus 1. Now, inside the inner loop, I'll just go ahead and print out star. Let me just write down star over here. And after this, what I'd want to do is, after I print a star, normally if I use a print statement, I'll get a new line. But I do not want to end it with a new line. I want to just end it with a space. And this is with respect to the inner loop. Now, once we're done with the inner loop, after every row, I want a new line. So I'll use the print statement over here. Let me run this. And as you see, we have been successfully able to print this pyramid pattern. And again, let's understand the logic over here. So for I in range of 0 to 5, so when we write down for I in range of 0 to 5, this outer loop will go from 0 to 4, 0, 1, 2, 3, 4. Let me just show that to you. For I in range of 0, 5, print of, let me add I over here. So for I in range of 0 to 5, let me print out I. You would see that this range goes from 0 to 4. Now, since we have these values going from 0 to 4, initially i's value is equal to 0. So I shall write down I is equal to 0. And over here for j in range of 0 to I plus 1. So I is 0, 0 plus 1 is 1. So this would become for j in range of 0 to 1. So in range of 0 to 1, which would mean that there is only one iteration. So in that one iteration, I'll print out this star. Now, once I'm done with this, I'll have a new line. And once I print out a new line, again, i's value is incremented. I's value now becomes 1. Is 1 less than 5? True. So since this is true, we'll again enter this inner loop. And over here, i's value has been incremented. It becomes 1. So here this goes 0 to I plus 1. What is I? It is 1. 1 plus 1 is 2. So this time the range is from 0 to 2, which will have two iterations, which are 0 and 1. Since this will have two iterations, we'll print 2 stars. After printing 2 stars, again, we'll have a new line. We'll go back. I's value is incremented. Now it becomes 2. We enter the inner loop. Here we shall again have I plus 1. I plus 1 is 2 plus 1, which is equal to 3. And since the range is 0 to 3, we'll have 3 iterations again, 0, 1, and 2. And since we have 3 iterations, we are printing out 3 stars. And this is the proper logic to print out your pyramid problem. So again, I hope this is clear for you guys as well. Next up, I will go to the next question. So this time I'm supposed to write a program to find out the factorial of a number. So, and for this, I will create a method. So here, let me just write down def, which would be a keyword to create a method. And after this, what I'll do is I will name this method as facto. And this will take in one variable, which is equal to x. Now, let me write down the proper logic over here. So a factorial is basic. So let's say if I'd want to find out 5 factorial, 5 factorial is essentially 5 into 4 into 3 into 2 into 1. And here we'd have to keep 2 things in mind. 0 factorial is equal to 1. 1 factorial is equal to 1. And anything negative, that would be equal to 0. So basically, minus 1 factorial is equal to 0. So here I shall write down if x is double equal to 1, I shall have return 0. And if x is double, so let me change this to be equal to minus 1. And if x is double equal to 1 or x is double equal to 0, then what I'd have to return is 0 again. I'd have to return actually 1. And then I'll have the else statement, else, which would mean that x is greater than 1. And here what I'm doing is I'm creating a new variable called as fact. And inside this, I'm storing a value 1. Now, once I do this, I'll have another while loop over here. And inside this while loop, I will again check while x is greater than 1. And while x is greater than 1, what I'd want to do is I'll write down fact is equal to fact into x. And here I shall write down x is equal to x minus 1. And once this is set, what I'll have to basically return is the value which is stored in fact. So I've created this, and inside this, let's say if I want to find out 5 factorial, I've passed in 5 and I've got the result 120. Let's again understand this. So let's say here the x value which I've passed in over here is 5, which is the x value. Now what would happen is I've passed in 5, and since I've passed in 5 over here, I'm checking while x is greater than 1, which would be I am checking if 5 is greater than 1. Since 5 is greater than 1, what is happening is fact is equal to fact into x. So fact is equal to 1, x is equal to 5. So 1 into 5 is equal to 5, and 5 is stored in fact. After that, x is equal to x minus 1. So x becomes 4. X becomes 4. I go back. Here I have 5 into 4. Now again I come back. X is equal to x minus 1. X becomes 3. So here I shall have 5 into 4 into 3. Similarly, x is equal to x minus 1, which is equal to 2. Then I shall have 5 into 4 into 3 into 2. And then finally, when I have x is equal to x minus 1, the value of x becomes equal to 1. And since x is equal to 1, I come out of this for loop, and the final value inside fact will be 5 into 4 into 3 into 2, which is equal to 120. So this is how we'll be able to create a simple factorial program using a method. We'll go to the next question over here. So give an example of lambda function. So again, lambda functions are quite interesting. So when it comes to lambda functions, you can consider these to be anonymous functions or nameless functions. So here what we've done is we've created a function, a proper function by using the def method. But if we want to create, you'd be writing really lengthy programs, and sometimes you just want one-liner functions which would do basic calculations. And for those purposes, lambda functions are the best. So let me just show you how it's done. So first you need to write down lambda. Then you shall pass in the argument. If it has an argument, then just write down the argument over there, put in a colon. And after colon, write down the body. So here, let's say I want to create a function which will multiply my given number by 2. So I shall just write down x into 2. Now, if I just have this like this, what I have is function main dot lambda. So let me just go ahead and store this in a variable. I'll call this variable as p. And inside p, I will pass in 5. You would see that the value has become 10. I've just created a very simple lambda function. And in that lambda function, I've passed in the value 5. And the result I've got is 10. So you can create simple nameless anonymous functions using lambda. Next up, let's see what do we have. So we've got how to create a 1D array and 2D array using NumPy array. So now we are up to the NumPy library. So let me just give you a context of the NumPy library. So Python has different libraries, and one of those important libraries is NumPy. And with the help of NumPy, as the name itself states, you can perform numerical computation. And NumPy also provides you different arrays. And you will have one-dimensional arrays, you will have two-dimensional arrays, and also multiple higher dimensional arrays. And you can perform different operations or different numerical operations on top of all of these arrays. So I'll just give you a simple example of how to create a simple 1D array as well as a 2D array. So here I shall write down import numpy as np. And now that I have created this, I've actually imported the NumPy library. Now that I've imported the NumPy library, what I'd want to do is I'd want to create a single one-dimensional array. So if I'd want to create a one-dimensional array, I shall write down np.array. And inside this, let me give in certain values. So I shall write 1, 2, 3, 4, and 5. And I shall store this in a new object and call it as n1. And when I print out n1 over here, this is what I get. Let me also check the type of this. Type of n1, you would see that this is a numpy nd array, which would mean that this is a numpy n-dimensional array. Here the value of n is equal to 1, which is a one-dimensional array. Similarly, let me go ahead and create a two-dimensional array. So to create a two-dimensional array, what I'd have to do is I'd have to pass in a list of lists. So in the first list, I'll have values 1, 2, and 3. In the second list, I'll have values 4, 5, and 6. And I'll go ahead and store this in a new object, and I'll call that object as N2. And when I print out N2 over here, this is what I get. So you would see that this is a two-dimensional array over here where I have 2 rows and 3 columns. Again, if I check the type of this, type of N2, you would see that this is a NumPy ND array, which is a NumPy n-dimensional array. So folks, I believe we've covered enough topics in today's session, and we are left with a lot of questions. What we shall do is we shall conduct probably a next session after this. And in the next session, we shall look at different topics again. So in the next session, we shall probably cover something related to pandas. We shall cover something related to mac.lib and cborn as well. So until then, thank you very much. And we again have another live session at 9 p.m. today, which will be taken by Mohit. And that live session would be a live mock interview, and that would be related to system design. So if you want to know how a mock interview related to system design works, please do attend our 9 p.m. session today. So folks, thank you very much, and let's meet again in the next one.
Hey guys, my name is Lakshay and I am a research analyst at Scalar Academy, and welcome to another video of ours. Now in this video, we will be discussing about C++ interview questions. And if you are new to the channel, make sure you like, follow and subscribe our channel and hit that bell icon for further notifications. Now C++ is a powerful and all-purpose programming tool that was developed by Jan Strostrup, and he was in Bell Labs at that time. Now this language is an extension of C and is by far one of the fastest object-oriented programming languages. C++ is a super popular because of its high speed and compatibility. Now it is widely used in development of games and servers, while some of the real-world applications of C++ may be using in operating systems, graphical user interface applications, distributed systems, or it can be in databases, banking applications, and maybe into advanced computations and graphics as well. So today we will understand the different C++ questions asked in an interview at a basic, intermediate, and advanced level. Now before we start with the session, did you guys know that we do have a blog where we are covering more insights, or you can say more important questions on the C++ interview questions as well. Now do check it out, and the link is given in the description below for this. Now I also want to tell you guys that before I start with the technical questions that are asked in interview, I also wanted to give you guys a little bit of insight of how you should give an interview. Now I have some tips for you, and I thought this might be useful for you guys. The first one being, be on time and never be late for an interview. And always, whether you know the questions or you don't know the questions, always tell the truth. And afterwards, be very specific with the interviewer's name or its pronunciation, and you might have a great conversation with the interviewer as well. And one more tip I can give you guys is, listen very carefully to the interviewer, that what he's asking and what he's expecting you to answer. Now with this, I also want to tell you guys that you must always be prepared for some basic personal questions that the interviewer might ask you, and you should always be ready to answer them. Now with this, let's start with the technical questions as well. Now guys, I'm basically starting with the fundamental questions, or you can say questions for the freshers in the starting, and then we'll move on to the advanced question or the experienced question, okay? So the first question that I have for you guys is, what are the different data types that are present in C++? Now before I answer this, I want to tell you guys that if you guys want to answer this and you guys don't want to answer, or you don't want to see the answer, you want to try it yourself, I would request you that you can pause the video right now and you can answer them in the comment section below, so that you guys can have a confidence in yourself, and then you can also see the correct answers. Now if you also want to see the answer that is there and you want to learn it, that is also fine, just have a note of it, okay? Now let's moving on to that answer. Now basically there are 4 data types in C++. The first one we have is primitive data type. Now this is a very basic data type. Examples that I can give you is character, short, int, float, long, double, bool, etc. Now the second type of data type that is derived data type, that is derived from the main classes. The example that I can give you is arrays, pointers, or this pointer, it can be anything. Okay. Now after this, the third point I have is the enumeration. That's example, we use enum in the coding language. And finally, the fourth type of data type we have is user defined data type. The example that I can give you is either a structure or a class. Now moving on to the second question that I have for you guys is, what exactly is the difference between C and C++? Now to answer this, I actually have tabular format that is there so that you guys can have a clear picture for it. Now starting off with C, now C is a procedural oriented programming language, while C++ is an object oriented programming language, or OOPS. You guys must have heard about OOPS. Now C does not support data hiding, but actually data is hidden and by encapsulation to ensure that data structures and operators are used as they are intended to in C++. Now C is basically a subset of C++, while C++ is a superset of C. Next point that I have is function operator overloading is not supported in C. And while in C++, operator overloading or function overloading both are supported. Now in C, namespace features are not present, while in C++ namespace is always used that avoids name collisions. Now in C, functions cannot be defined inside structures. Now if you guys really know what structures and classes are, this will be a very easy task for you guys to remember the difference between C and C++. While in C++, functions are always defined inside structures and it is very easy to do. Now calloc and malloc, these are functions that are used for memory allocation, that are used for memory deallocation as well. Now while there is calloc and malloc in C, we actually have a new operator. The name new is used for memory allocation, and that deletes operator is used for memory deallocation as well. So I hope this difference is clear to you guys. Now moving on to the third question, what are classes and object in C++? So yes, I was telling you that structure and class. Now the next question is, what are classes and object in C++? So basically a class is a user defined data type that has data members and member functions. Now data members are the data variables and member functions are the functions that are used to perform operations on these variables. Now an object is an instance of a class. Since a class is a user defined data type, so an object can also be called a variable of that data type. Now in this example that is there, a class is defined, that's class A. Now the following is a class. What I'm going to explain to you guys is with the pictorial representation. So the following is a class car that have properties like name, color, etc. And they have methods like speed, or it can have methods like speed or acceleration, brakes. So that's how a class works, and that's how an object works. So we have a class car and we have an object red, Ford, Mustang, or it can be Toyota, it can be different company. So that's how classes and objects work. Okay, so moving on to the fourth question. So what is the difference between a structure and a class? Now you guys must be wondering that I am explaining these interview questions, but when you study these interview questions, I am hoping that you have basic knowledge of C and C++, and that's how you go to the interview question, or that's how you go to an interview after having knowledge. So I am here to just tell you that what are the common questions that are asked in interviews. Okay, so in C++, a structure is same as a class except for few differences, like it can be security. Now the main differences that are there are two differences. Now members of a structure are public by default, while members of the class are private by default. That is the security reason. Now by deriving a structure from a class or from a structure, default access specifiers for base class are public. Now similarly in C++, the default access specifiers are private. Now moving on to the fifth question, what exactly is operator overloading? Now operator overloading is a very essential element to perform the operations on user defined data types. By operator overloading, we can modify the default meaning of the operators like plus, minus, star, division, greater than, less than, equal to, etc. Now for example, Now this code is for adding two complex numbers using operator overloading, as you can see. So we start with the class complex, then we move on to the constructor that is complex, and then we call it in the main function that is 2 and 3, and for the complex B we have 3 and 4, and then we add these two numbers, and that's how basically the result comes. So that's what the operator overloading is. Now moving on to the sixth question, what is polymorphism in C++? Now polymorphism is a simple means having many forms. Its behavior is different in different situations, and this occurs when we have multiple classes that are related to each other by inheritance. Now for example, think of a base class called a car and that has a method called car brand. Now the derived classes of cars could be Mercedes, BMW, Audi, or it can be anything. And similarly, they also have their own implementation of cars as well. Now the two basic types of polymorphism are in C++ are compile time polymorphism and runtime polymorphism. Now I also want to tell you guys this, that even if the interviewer asks you what exactly is polymorphism, you make sure that you tell the whole answer and you explain him everything related to polymorphism. So that's how even I am explaining, so that you guys have a pure knowledge of how to answer. Okay. Now moving on to the seventh question, explain constructor in C++. The interviewer might ask you this. So basically a constructor is a member function that is executed automatically whenever an object is created. So constructors have the same name as the class of which they are members, so that compiler knows the member function is a constructor. And no return type is used for constructor as well. So similarly, as you can see in the example, we have a class A and then we have a constructor that is A with no arguments. Now we can have one argument that is there in A, we have int x, and we give it a value, val is equal to x, and then we have A of 3. So that's how a constructor works. Now moving on to the eighth question. So the interviewer might ask you in a way that tell me about virtual function. So that's how you should answer. So virtual function is basically a member function in the base class that you redefine in a derived class. So a virtual function is declared using the virtual keyword. When the function is made virtual, C++ determines which function is to be invoked at the runtime based on the type of object that is pointed by the base class pointer. So that's basically virtual function. So the ninth question that I have for you guys is, compare compile time polymorphism and runtime polymorphism. So let me start off with the compile time morphism. So basically in this method, we would come to know at compile time which method would be called, and the call is resolved by the compiler there itself. But while in runtime polymorphism, we come to know at runtime which method will be called, and then the compiler is not able to resolve that. That's what the basic difference is. Now the compile time polymorphism, it provides fast execution because it is known at the compile time itself, not later. While in runtime polymorphism, it has very slow execution because it is known at the runtime. So similarly, in compile time polymorphism is achieved by function overloading and operator overloading, while runtime polymorphism can be achieved by virtual functions and pointers. Now to give you guys a more clarity between these two, I have examples which I'm going to tell you later on in the coming questions. So moving on to the question number 10, what exactly do you know about friend class and a friend function? So basically a friend class can be access private, protected or public members of other classes in which it is declared as friends. Like friend class, friend function can also access private, protected and public members. But friend function are not member functions. Now to give you guys a clear picture, I have a simple code so that you can easily remember or you can easily understand what exactly a friend function is. Similarly, we start with creating a class A, then we have a class B, and then we have a friend function. The starting int, that is name of the friend class, is fun A, B. So that's how friend function works, and we can do all the operations on it. Now moving on to the 11th question. So what are the C++ access specifiers? So in C++, there are three specifiers basically. The first one is public. Now all data members and member functions are accessible outside the class. In protected, all member functions and data members are accessible inside the class and to the derived class as well. Now similarly, in private, all data members and member functions cannot be accessed outside the class. It has to be inside the class. So these are the three access specifiers. Moving on to the question number 12, now define inline function. Now if a function is inline, the compiler places a copy of the code of that function at each point where the function is called at compile time. This is one of the most important advantages of using an inline function is that it eliminates the function calling overhead of a traditional function. So that's how you should explain technically what exactly is inline function. Now moving on to the next question. So what is a reference in C++? Now a reference is basically like a pointer. It is another name of an already existing variable. Once a reference name is initialized with a variable, the variable can be accessed by the variable name or reference name, or it can be both. Now here is an example. If I have an integer x that's value is 10 and I give an integer n% reference to the x, now the reference has the value of 10. So if we change the value of reference, it will be reflected in x. So once a reference variable is initialized, it cannot refer to any other variable. We can declare an array of pointers, but an array of reference is never possible. So that's basically a reference in C++. Coming up with the next question, what do you mean by abstraction in C++? Now abstraction is the process of showing the essential details to the user and hiding the detail while we don't want to show to the user, or hiding the details which are irrelevant to a particular user. Now to give you guys clear picture what exactly abstraction is, if I want to give you guys an example, the example would be when you use Swiggy or Zomato or any other online food delivery apps. What you do is you just order it and it comes to you. That's what the company want to show you. Now you guys don't know what it's happening on the back end, or it can be irrelevant. It doesn't matter what's happening on the back end. You are getting your food. So that's what abstraction is. Moving on to the next question. So the interviewer might ask you, is deconstructor overloading possible? Now if yes, then explain, and if no, then why? Now the answer to this would be no. The destructor overloading is never possible. Now destructors take no arguments. So there's only one way to destroy an object, and that's the reason destructor overloading is never possible. Now moving on to the next question, what do you mean by call by value and call by reference? Now in call by value method, we pass a copy of the parameter that is passed to the functions. For these copied values, a new memory is assigned and changes made to these values do not reflect the variable in the main function. Now in call by reference method, we pass the address of the variable and the address is used to access the actual argument that is used in the function call. So changes made in the parameter after the passing argument. So that's basically what is call by reference. Now if you guys do not understand, let me repeat it for you. So in call by reference method, we pass the address of the variable and the address is used to access the actual argument used in the function call. So changes made in the parameter alter the passing argument. Now moving on to the next question, what is an abstract class and when do you use it? So a class is called an abstract class whose objects can never be created. Such a class exists as a parent for the derived classes. We can make a class abstract by placing a pure virtual function in the class. So that's what abstract class is. Moving on to the 18th question, what are deconstructors in C++? Now this question, I have seen many people or many interviewers asking this question because that is very important for the company as well. So what are deconstructors in C++? Starting with the constructor, it is automatically called when an object is first created, right? So similarly, when an object is destroyed, a function is called destructor. So a destructor has the same name as the constructor, but is preceded by the tilde. That is the tilde sign. If you can see above the tab, there's a tilde sign. So to give you guys an example, I have a class A, I have a variable int, and then I have a constructor that has int x as its argument. So some operations happen, and after that I use a tilde sign and I write a two brackets, that is the deconstructor. So as soon as the constructor is called, it consumes some amount of memory, and when it's called again, the deconstructor comes into the picture and it deletes the memory. So that's how you save memory while using the code. So moving on to the 19th question. So what are static members and static member functions? So when a variable in a class is declared static, space for it is allocated for the lifetime of the program. No matter how many objects of the class have been created, there is only one copy of the static member. So same static member can be accessed by all the objects of the class. A static member function can be called even if no object of the class exists and the static functions are accessed using only the class name and the scope resolution operator, that is 2 colons. Moving on to the next question, explain inheritance. Now yet again a very important question, and you guys always must know about polymorphism, abstraction, inheritance, encapsulation. That is the basics of C++. Now inheritance is the process of creating new classes called derived classes from existing classes. Now these existing classes are called base classes. The derived classes inherit all the capabilities of the base class but can add new features and refinements of their own as well. Now for an example to show you guys, we have a class bus, then we have class car, class trunk that inherit properties of the class vehicle. Now the most important thing about inheritance is that it permits code reusability. So that's how that's what you should explain about inheritance with an example. Now that's it for the freshers guys. Now if you guys are experienced, maybe 1 year, 2 year, 3 year, 4 years, now if you have experience, the questions become a little bit of difficult, and that's how they look like when an interviewer asks you, and I'm going to tell you the answers for it as well. Okay, now starting with, what is a copy constructor? So a copy constructor is a member function that initializes an object using another object of the same class. Now to give you guys an example, we have a class A, and then class A has 2 variables with the arguments, that's x and y. So we use this operator for this, and we can do any operations on that. So that's what a default copy constructor is. I call an object of the class, and then A2 is equal to A1. So that's how I change the value from the one constructor to another constructor. So one more thing for you guys is we can define our copy constructor. If we don't define a copy constructor, then the default copy constructor is called. This is also, you should guys try to explain it to the interviewer as well. So moving on to the next question, what is the difference between shallow copy and deep copy? Now this is a high-end question. If you guys don't have any knowledge about C++, so you guys will not understand what this is. Shallow copy basically reflects changes that is made to the new or to the copied object in the original object. Now on the other hand, deep copy never reflect, or it doesn't reflect changes that is made to the new or copied object in the original object as well. So that's what the basic difference between shallow copy and deep copy is. So moving on to the 23rd question, what is the difference between virtual functions and pure virtual functions? Now basically a virtual function is a member function in the base class that you redefine in a derived class. So it is declared using the virtual keyword. Now for example that I can give you guys is, I have a class base, and then how do you declare it? Using virtual void fun. Inside that we have a function there. So that's what virtual function is. Now for the pure virtual function, it's a function that has no implementation and is declared by assigning 0. So and it has no body. Now as an example that you can guys see, now here is equal to sign has got nothing to do with the assignment, and the value 0 is not assigned to anything. It is basically used to tell the compiler that a function will be pure and it will have no anybody. Now moving on to the 24th question. Now this is a little bit of tricky part. Now, if class D is derived from a base class B, when creating an object of type D, in what order would the constructors of these classes get called? Now, take your time and pause the video and understand the question. Moving on to the answer. So, the derived class has two parts, a base part and a derived part. When C++ constructs derived objects, it does not so in phrases. First, the most base class that is on the top of the inheritance tree is constructed. Then each child class is constructed in order to until the most child class is constructed last. So the first constructor of class B will be called and then the constructor of class D will be called. Now during the deconstruction phase, it is exactly the reverse order. Now that is the destructor starts at the most derived class and works its way down to the base class. So the first destructor of class D will be called and then the destructor of class B will be called. Moving on to the 25th question, can we call a virtual function for a constructor? Or say similarly. So to give you guys an answer for this, yes, we can call a virtual function from a constructor. But the behavior is a little bit of different in this case. When a virtual function is called, the virtual call is resolved at runtime and it is always the member function of the current class that gets called. That is, the virtual machine doesn't work within the constructor. And to give you guys an example, I have a class base, then a virtual function, and I have a class that is derived. And I'm using virtual function void fun there. So that's how you can call a virtual function from a constructor. Moving on to the second last question, what are void pointers? So basically a void pointer is a pointer which is having no data type associated with it. It can hold addresses of any type. Now for example, we can assign a pointer of any type to a void pointer, but the reverse is never true unless you typecast it as str is equal to character star ptr. So that's what void pointers are. Now next question, what is the pointer in C++? The member functions of every object have a pointer named this, which points to the object itself. So the value of this is set to the address of the object for which it is called. It can be used to access the data in the object it is pointing to. To give you guys an example, there's a class A and I have a set value with the arguments int x. So I use this pointer to value is equal to x. Now in the main function, I call an object of class A and after that I set its value as 5. So when I set its value as 5, the integer x also has the value 5 now. So that's what this pointer is. So moving on to our last and final questions, how do you allocate and delocate memory in C++? Now the new operator is used for memory allocation and deletes operators that is used for memory delocation in C++. For example, I have an integer value new int and then I delete the value. And similarly, I create an integer array and then I delete the array for delocation and allocation. So that's what basically is. So that's it from our side, guys. If you have any questions or any queries or you want to explain, you want to get more explanation about this, you can always put them in the comment section below and we will always be ready to help you. Now that's it from our side, guys, and stay tuned for more from Scalar.
Hello everyone, welcome back to Sky Academy YouTube channel. Myself Vamsi. In this particular tutorial, we will be discussing about data structures, interview question and answers from interview bit platform. So if you don't know what is interview bit platform, so I will give you a glance about interview bit. So interview bit is a platform where you can practice coding questions which were asked frequently in product based companies, and also you can find plenty of articles and blogs related to the tech and interview preparation tips. Okay, so in this particular tutorial we will be discussing one of the blog which was written on the data structures interview preparation. Okay, so the link to the blog will be available in the description. Please do check it out. Let me walk through the topics that we are going to cover in this particular video. and we will be starting with the definition of data structures and where can we use data structures and what is the usage of learning data structures. And also we will be discussing about types of data structures available, like trees, linked list, stack, queue, graphs. Okay, and we will be talking about each one of them in detail and writing code for defining them and how to use them and what are the applications of each of them. Okay, where can we use in a real world, so how can we build an applications using the data structures. Okay, so it's not limited to theoretical, so we will be writing plenty amount of code as well, and we will be discussing a few important aspects in the while writing the code. Okay, and a logic behind the code. Okay, so I highly recommend you guys to watch this video till the end, and if you are visiting channel for the first time, please do subscribe this channel, and if you like the video, please hit that like button up, and if you have any queries, please let us know in the comment section. We would love to answer them. So before starting the actual video, so I would like to give you few tips for your next interview. So very first one, so if they asked you to define something, like define a graph, define a tree, just don't settle for the definition. So please go on an extra mile and give them some examples, and so that they can understand the concept in a better manner. Okay, so that you can solve the real world problems as well. Okay, then the second one, it is for your DSA rounds. So if they have an interviewer asked you question, and if you know the answer for that as well, but don't directly jump to the solution. So ask them few questions, like if they have given an array. Okay, like ask them like, will there any chance of it contains a negative integers, or what if the size of the array is 0, and also what if there exists no solution for this, what should I return, like -1, 0. Okay, so please clarify all your doubts before starting a solution. Then always start with the brute force approach. Okay, which is an n square, or if it is an recursion based, n 2 power n. Okay, then try to optimize it, so like sorting, then a linear solution. Okay, so this is how our interviewers will understand that you can solve the problem with the very brute force manner to the optimized way. Okay, it involves a lot of thinking, so they want that. They don't want people who mug up the things. Okay, so before getting on to the very first question, let's try to understand what is a data structure and what are the types available in the data structure, and where we can use the data structure in the day-to-day life, and what is the usage of data structures in the current organizations. Okay, and what are the fields that our data structures has been implementing. Okay, so it's very important to understand the applications of any concept. Okay, rather than just solving few problems. It doesn't make sense if you don't know why to use data structure. Then what is the need of using data structures? Okay, so then first we'll try to understand how can we use data structure and what are the data structures available. So the very first question here is, what is a data structure? So a data structure is a fundamental concept of any programming language, essentially for algorithmic design. Okay, it is used for efficient organization and modification of data. So let me put it in a simple terms. Okay, so a data structure is data structure represents a way of organizing or storing the data in the memory, so that it will be easy for us to manage data. Okay, like manage in the sense it will be some operations like insert, delete, update. Okay, kind of operations, so that we generally do perform such operations on any data, right? So here, what is the need? Okay, so what does it make sense? Like, so if I store, okay, like I will be having 10 files. If I store them in my memory, like what is the purpose? Like why we need data structures? So it is going to store in anywhere, right? So okay, if you are talking about 10 files in your mobile, it's okay. Now let me ask you a few questions. Let's take an example of Instagram. So everyone uses the Instagram. Okay, let's assume one profile. Okay, one profile which has a 10k followers. Okay, or let's consider Virat Kohli's profile. Okay, Virat Kohli profile. Okay, where he will be having 150k followers. I'm not sure it's correct or wrong. Okay, I'm assuming that. Okay, let's take an example. Okay, now if Virat Kohli has posted one picture, okay, Virat Kohli has posted one picture, like post, or he has shared some story. Now it has to reach for 150 or 1 million or any number of people, right? So it has to be accessible for the 1 million people. Now, like just imagine you are storing that data in somewhere, okay, in somewhere, and whenever I have opened my Instagram, okay, if I'm huge follower of Virat Kohli, since I'm like whatever post he shares, I will be liking that. Okay, and among all the stories that I have been displaying on my profile, I'll be first seeing the Virat Kohli profile. Okay, within fraction of seconds you can see that, right? So whenever someone posted, it is going to share like amount of time that I have been posted as well, like 1 second, 1 hour, or 10 minutes. So do you think this is going to come in within 1 second? You might be wondering. My answer is yes. It is going to refresh within the 1 second or 2 seconds at max. So to get the data that much faster, okay, Virat Kohli is in Mumbai. Okay, let's assume. Let's say I'm in Australia or US. Okay, then do you think it is traveling from Mumbai to US within that many seconds? No. Okay, like from Mumbai, it is storing in some, like with the help of some CDNs. Okay, it is storing somewhere in data centers, and then it is getting access in the US, okay, by using the CDN, US CDN. Like so how we are getting stored this data, that is the matter. So we need to store the data in such a way that we can access that very easily, very fast. Okay, so if like you can easily assume that, like say you will be storing all your books, okay, like randomly in your room. Okay, now I want to get the one book from the room, okay, where you have stored all your books randomly. Okay, in some books in bedroom, some books in kitchen, some books in hall. Okay, now how much amount of time it will going to take to fetch one book, like search from one book? Now can I say that at max it is going to take 10 minutes for sure, right? Now just assume if you have stored all the books in an organized manner, now how much time it is going to take? I'm pretty much sure that, let's say I have stored all the physics books in one rack, chemistry books in one rack, data structure test books in one rack, then it is going to take at max 1 minute. Yes, 1 minute. Okay, so there is a huge difference between 1 minute and 10 minutes, right? So even if it is not making sense for you, but a client or user who are waiting for your data will going to make, and 10 minutes of waiting time is a little hectic for them. Okay, that is the usage, that is the necessary of organizing that data so that we can easily access the things. Okay, so this is the use case that we need to learn data structure. Okay, now we have talked about what is data structure and why we need data structure. Now how many types are there in data structure? So I can say that all the data structures has been classified into two types: linear and non-linear. What is this linear and non-linear? So linear and non-linear, what is this linear and non-linear? Okay, so I can say that, like, if the elements of a data structure results in a sequence or linear, then it is called as a linear data structure. And when the elements in a data structure results in a way that traversal of nodes is not done in the sequential manner. Like you can easily remember this as a, whenever we are talking about this linear, we can say that storing the data in the linear manner or a sequential manner means I'll write one after one. Okay, let's say if I have stored something here, then right after that I will be storing another. then right after that, then right after that. So if I want the third one, I can easily go there. Okay, I can easily go here and pick up that. So because everything is in sequential order, they are following the order, whatever, like, so first you came, then you go first. Okay, so like that. Okay, now when we are talking about non-linear types, it is not like sequential, it is storing in non-sequential order. So what is this non-sequential? Let's say we will be storing the data structure, like we can assume our file structure. Okay, file structure. Let's say I have a desktop folder. In that desktop folder, I will be having let's say scalar folder, and again in scalar folder I will be having another folder called data structure, and again in data structure I will be having another folder called arrays. Again in arrays I will be storing something. So here you might think that for along with data structure there will be something as well. Let's say my computer, or let's say I have a folder of my name called Vamsi, and in scalar folder as well I will be having many things. Okay, so here the data is not in sequential order, it is in random. Okay, and if you need something, you need to go and search every possible way. Okay, then only you will get to know where it is actually stored. So that is what a linear and a non-linear data structure means. Now we'll talk about what are the data structures that comes under linear and non-linear. So if you observe the things here, for under the linear data structures, we will be having arrays, linked list, stacks, and queues. Okay, we'll talk about them, each of them in detail in the further. Okay, but as of now, let's remember the names. Okay, coming to non-linear data structures, we will be having trees, graphs, tables, and sets. Okay, we'll talk about them, each of them for sure. Okay, please bear with me till the end. Now let's try to understand the where we use these data structures. So I have told you enough examples in the while discussing the data structure as well. Now let me put all of these things again. Like I can simply say that wherever there is something like programming, I can easily say that there is a data structure as well, directly or indirectly. If you are storing something, then directly or indirectly you will be using concept called data structure. It represents how you stored your data. That's it. Okay, and like you can see these things. Okay, so artificial intelligence, compiler design, machine learning, database design and management, blockchain, numerical and statistical analysis, operating system development, image and space recognition, cryptography. Not limited to these things. Okay, there are few more other, like even Android applications, web applications. So everything is being backed by some databases, right? So indirectly we will be using the concept of data structures in storing the data. Okay, like if you're talking about database, how we are using database. Okay, so if you are storing any DBMS database, okay, like a SQL, now can I say that all the data is being stored in the form of tables, where you will be having columns and rows? So can I say that this is going to be non-linear data structure? Yes. Okay, so this is how you will be using the data structure in the day-to-day life. Okay, now let's get into the some. Okay, this is what we have discussed so far, applications of data structures. And this is the most important question that everyone should have to be clear with. Okay, benefits of learning data structure. So yes, if you are a CS guy, or if you are one who is aiming for CS jobs like computer science field, then you are on the right page. You have to learn the data structures for sure. Okay, there is no middle way. And even if you consider all the high paying jobs, okay, all the high paying jobs requires or test you or ask you a data structure on algorithm questions in an interview. Okay, in an interview. So why does this happen? Because these data structure and algorithm problems involves a lot of problem solving skills. Okay, like if you are given an problem where you need to handle a 10 GB of data, okay, 10 GB of data, then how can you organize that? Okay, how can you store that in database, and how can you make it is being reasonable for everyone to access? So such kind of problem solving skills will come under this data structure. That's why companies will ask a data structures and algorithms questions in an interview. Okay, now another most question to be addressed here is data structures in C and Java. So people might be asking like questions like so which language should I pick up for learning data structures, be it C++, Java, Python, or any other language like JavaScript, C#. So all I can say that is the concept is same. Okay, the basic fundamental concept of any data structure is going to be same, but it only differs in way like how you are going to store your answer, and how you are going to represent in the things in a syntactical way, and how you are converting your logical thinking to the programming. So it's, I can say that it's just an syntaxes. Okay, and that is what you need to understand. If you know, if you have the concept, then no one gonna judge you or ask you to only code in this particular language. I don't know that. Okay, so no one is gonna tell you that. So language doesn't matter. Okay, you can learn it in any language. Okay, so let's talk about this as well. Okay, so this is what we have discussed. And in an object oriented programming language like Java, data structures are being implemented using class and objects. Okay, so in object oriented means OOPS languages like Java, Python, C++, we use a concepts called classes and the objects to implement the data structures. And coming to C, which is not an object oriented programming language, we use the concepts called structures, okay, structures and functions to implement the data structures. Okay, and I would like to tell you about this like inbuilt support of languages provided by the different languages as well. Let's say if you are a Java coder and like you wanted to use your data structures in your programming, so you might be wondering, should I learn the implementation of, like, should I manually implement all the things in the programming? No. So Java supports in Java there is a thing called collections library. Okay, where you can get all the inbuilt, okay, all the inbuilt support for the data structures. All you need to do is you need to just declare them, and you can define them and you can use them. Okay, and coming to C++, you will be having STL library. Okay, STL library, where STL will provide all the unnecessary support for your implementation of the data structures. Okay, you don't need to implement them manually every time. Okay, you can just import these either collections in Java, C++, STL in the C++, and you can use them. Okay, I think now let's get started with the actual questions. So the very first question that we are going to discuss is difference between file structure and the storage structure. Okay, so let's talk about first file structure. So a representation of data into secondary or auxiliary memory, may say any device such as hard disk, pen drive that stores data which remains intact until manually deleted is known as a file structure. Okay, it is saying that whatever the data that you are storing, okay, whatever the data that you are storing in your hard disk and pen drives will be called as your file structure. Okay, and what is about storage structure? So a storage structure means whatever the data that you are storing in your RAM, okay, in your RAM, that is called as an storage structure. So what is the difference here? So if you store anything in the hard disk or pen drive, it won't get deleted even after you remove that thing, or if power cuts, if you face any power cut. But in case of the data which is stored in RAM, if you guys have witnessed a power cut or if you have shut down your laptop and restarted your laptop, then you can't see the data which is stored in the RAM. Okay, that is a major difference between the file structure storage and the storage structure. Okay, now the second question. So can you tell me how linear data structure differ from non-linear data structure? So as we discussed earlier, so linear data structure stores the data in the form of a linearly, and these non-linear data structure stores the data in non-linear manner. So which is going to be either you need to traverse to all the things, okay, which is in connected way, then that's how you can access them. Okay, so if you observe in this particular diagram, so this is called as an storing the data in the linear manner, means sequential manner. If you observe, so okay, like you can traverse through these elements using one single type. Okay, what is a traversing? Okay, what is a traversing? So basically, let's say you have an array. Okay, if you don't even know what is array, just tick. Okay, like if you have something like this and you have some data here, 1 2 3 4 5 6 7. Now a traversing means visiting all these blocks. Okay, you can consider this as one block, this as one block, this as one block. Okay, so traversing means you need to visit all the blocks at once at least. Okay, now so if in the case of linear data structure, you will be starting from 1 and you will be coming to 2. From, like, you can't go to 3 here. Okay, so if you are traversing in a linear manner with the speed of 1, and you from here you can go to 3, then 4, then 5, then 6, then 7. So it is going to be linear in fashion, right? But if you consider this, okay, like it is starting from the A, and from A you will be let's assume this things are being represented as a connection. Okay, connection means you can, from A you can go to B, from A you can go to C or E as well. Okay, if there is exist a path. Now from A you will be having 3 choices. Okay, from B again you can go to E or B, A again. So here it is not sticking to one structure, one sequence order. So you can go to any order that you want. Okay, but in case of linear, you can only move to the next thing. Okay, that is in sequential manner. Okay, so that is what a difference between sequential and non-sequential is. Now what is an array? An array is a collection of similar type of data stored in a contiguous memory location. What is a contiguous memory location? Let's say, okay, so this is an array. Okay, and my first element, okay, I have started at the address of 100. Okay, address of 100. Let's say I have stored 20 in it. Then I can say that I am storing all the integer typed values as of now, and I know that integer takes 2 bytes of memory. Okay, integer takes 2 bytes of memory. It means that, so it will assume like it will take 2 bytes. Okay, if it has started at 200, if it is taken 2 bytes, then the next bit will start from 1 or 2. So, and I will be storing another 10 over there, and again I am pretty much sure that it is going to take only again 2 bytes. Okay, so I will be going to 104, and then again I will store another integer and it will take another 2 bytes, so 6. Then I will be storing 3, again it will take 108. Okay, now again I will be storing 1, so it will take 110. So here everything is in sequential order. Now what is an array here? Like, what is the uniqueness of the array? So here if you observe, we will be storing all the integer typed values only. Yes, because in an array you are allowed to store only one type of data. Okay, whatever you have defined it. Now what is it? Defining an array, okay, or declaring an array. So declaring means you need to, if you wanted to use any variable, you need to declare that first. Okay, how can we declare the int like array? So let's say I have a variable called arr, which represents the array, and this symbol will help us to tell this particular thing is an array. Okay, means it is going to store the data in the sequential order. Okay, and it will take multiple values at the same time as well, which are int types. Okay, only int types. Now if I have represented it as a something like character array, okay, if I have defined it as something like this, then it will take a characters, okay, one character at each time. Okay, or only it supports only character or either integers as well, because in C language or in C++, all the characters and indirectly equal to the integers until 256. Okay, and all the numbers until 256 is going to indirectly represent the characters because of the ASCII values. And if you don't know what is ASCII values, please have a look at that. Like just go to Google and search for this and you will find what is ASCII values. Okay, now let's move on to the next question. What is a multi-dimensional array? Okay, so we know that array stores in the data of this manner. Okay, the address might be 100, 102, 104, 108, 110, 112, 114 at last. Okay, now what is this multi-dimensional array? So a multi-dimensional array means, so I can say that, so if you observe this carefully, I can say that it has one row and 1, 2, 3, 4, 5, 6 columns, right? One row, 6 columns. So this is a single dimensional array. So whenever you will be having one row, okay, one row, then it is called as a single dimensional array. So whenever you will be having multiple rows, okay, whenever you will be having multiple rows like this, okay, it is called as a multi-dimensional array. So again, it is going to call, like if you observe this thing carefully, it is in the form of matrix, right? So if I represent this in the matrix, so it will be having 3 rows and 6 columns. So 3 into 6 matrix. Okay, so I can say that 3 rows, 6 columns. Yep. Now here at max, how many elements that you can store here? I can say that you can store 6 elements. Okay, 6 elements. Now here you can store at max 18 elements. Okay, 18 elements. So you might be wondering like how to access these elements. Okay, so for that we will be having a concept called indexing. What is this indexing? So basically, let's say we will be having an array with the size of 6. Okay, size of 6. So 1, 2, 3, 4, 5, 6. Okay, so size of 6 means it can store a 6 values or 6 elements at max. Okay, so if I represent these things in the integer or like indexing, then it is going to start from the 0, then 1, 2, 3, 4, 5, and for every array the last index is going to be size minus 1. Okay, and it will start from the 0. Okay, start from the 0. Now let's assume here we will be storing a 10, 20, 30, 40, 50, 60. Now how can I access these elements? And let's assume the name of this array is ARR. Okay, now if I write ARR of 3, okay, if I write something like this, now we will be getting output as a third index value. Okay, in ARR, okay, array, the third index value. So what in ARR, what is the third index? This is the third index. Now we are going to get the 40 as our output. If I write ARR of 1, what does it mean? It means that in ARR variable, okay, array, we need a 1th index. So we are going to get the 20 as the output. Now if I try to access array of 10, what are we going to get? We are going to first check, is there any index with the number of 10? No, there is no index such that. Now it is going to throw an error or exception. If you are an Java or Python guys, it will throw an exception which is named as a array out of bounds exception. Array out of bound exception. Okay, which means that the index which you are trying to access is not there. Okay, not there. That's it. Now this is okay for this like single dimensional array. How can we access the multi-dimensional array? Okay, multi-dimensional like array accessing. How can we access that? So in the case of like 1D dimensional array, one dimensional array, we will be having only one row and n columns, so we can just represent in one index. Okay, but in case of a multi-dimensional array, we will be having something like this. Okay, now let's try to represent these things in rows first. So it is going to be 0 row, 1 row, second row. And if I represent these columns, 0 column, first column, second column. So it's just as representing the things in the matrix. Okay, representing the things in the matrix. Now, so if I want this particular element, I can represent it as 0, 0. Like, let's say if this is an name of array. Okay, this name of array, then I can say that array. First, I need to mention the row, which is an 0. Then I need to mention the column, which is again to be 0. Okay, the first 0 represents the row, second 0 represents the column. Okay, if I write 2 comma like 2 of 1, which means a second row, this second row, and first column. Okay, this is, now I am going to get this particular value. Okay, so this is how we are going to access the, like we can access the elements in a multi-dimensional and single dimensional arrays. Okay, now what is a linked list? Okay, a linked list is another data structure which follows a linear data type. Okay, so a linked list is a data structure that has sequence of nodes where every node is connected to the next node by means of reference pointer. Okay, we'll talk about that later. Like, now elements are not sorted in adjacent memory locations. They are linked using pointers to form a chain. Okay, and each node is having data field and the reference pointer. So if you observe this particular diagram, we will be like, if you consider this as a node, and at the first half we will be having data, and the second half we will be having the pointer to the next node. What does it mean? Okay, let's say, okay, this is our node. Okay, this is our node, and node has two parts. One is data, another one is linked to the next node. Okay, so this data represents something, let's say 10. I wanted to store that 10. Now what does this part is going to store? I can say that this part is going to store, let's say, okay, let's come to let's try to define a few other nodes as well. Okay, now this is storing 20, this is storing 30. Now this node is being stored in the memory location of 200, and this is being stored in the memory location of 500, and this is being stored in the memory location of 1000. Okay, now I wanted to go to 20. Okay, I wanted to go to 20 after the 10. Okay, I wanted to go to 20 after the 10. So here I need to mention the node address which I would like to go next. Okay, so I wanted to go to the 20. So what is the address of the 20? It is a 500. So I will mention 500 here. Now after 20, I would like to go to the 30. Okay, 30. Now what is the address of the 30? It is going to be 1000. Right? So after 30, I don't want to go anywhere. Okay, I don't want to go anywhere. So now it is going to store the null. Okay, which means that if you would like to not to go anywhere, okay, after visiting some node, okay, then you need to point that as a null pointer. Okay, which represents this is the ending point. Okay, which is the ending point. And every starting node will be having a head node, okay, which represent the starting point of a node. Okay, done. Okay, this is how a linked list is being represented, and if you observe the data, everything has been stored in the form of sequential. Okay, after 1 we will be storing, like, going to the 20. So here we will be just directly representing the things in the form of memory location. Okay, we are not going anywhere, we are directly going to the 500 after 200. So that's what it is in sequential way. Done. Now let's go. Are linked list of linear or non-linear type? Okay, good question. We have seen the answer just now, right? Linked list can be considered both linear and non-linear data structure. This depends upon the application that they are using. Okay, so this can be treated as a both linear and non-linear, but moreover it depends upon the where we are using the context where we are using that term called linked list. Okay, so when linked list is used for accessing strategies, it is considered as a linear data structure. When they are storing data storage, it can be considered as a non-linear data structure. Okay, so it totally depends upon the application that we are using this linked list. Okay, now let's move on to the next question. So how are linked lists are more efficient than arrays? Good question. Okay, so here I would like to mention the term called time complexity and space complexity. Okay, so whenever you are writing an program, or whenever you are writing an algorithm, okay, so these are the two aspects which talks about whether your code which you have written is an efficient or not. Okay, so if it is taking minimal amount of space and time, minimum amount of space and time, it can be called as an efficient algorithm for a problem. Okay, like even in the case of real world applications, let's say you are using a payment. Okay, you are let's say Amazon. Okay, Amazon website, you have bought one product. Okay, you have bought one book, let's assume. Okay, one book, and now you are paying amount for this. Okay, you are doing payment. So you just imagine if your payment took 1 minute of time to finish. Okay, 1 minute of time to finish. How do you think? No, yeah, I won't. I am not interested in doing the paying the online. Okay, because it will take 1 minute of time, and until that you receive the done. Yes, payment has been received. Your order has been successfully placed. You won't be in a peace, right? It is always like lub-dub. Your heart will be like pumping up. Okay, so what if my amount got detected from the account, and if my order is being cancelled? So you might be having these things until you have seen the payment has been done. Okay, so in that case it should be done in the either 1 second or 2 seconds of time. Okay, then only people will go and purchase the things from the Amazon website. Okay, so in this case it is an time complexity. So 1 minute of time complexity and 1 second of time complexity, which one do you prefer? The answer is up to you. Okay, and that is the answer for the time complexity as well. Okay, now let's come to the question. So insertion and deletion operations. So basically what is this insertion and deletion? So insertion and deletion process is expensive in an array, as the room has to be created for the new elements and existing elements must be shifted. Okay, let's say we have an array something like this. Okay, you will be storing 1, 2, 3, 4, 5. Now I would like to, okay, in between 3 and 4 I would like to insert the 6. Okay, like I'm expecting my end array should be looks like 1, 2, 3, 6, 4, 5. Now to perform this operation, what is the process? First we need to create this 6. Yes, we need to create this 6. Then we need to replace this. Okay, we need to put this here. Okay, to put that here, is that as simple as that? No. So at first we need to create a space here. Okay, then we need to move the 4 to the 5th position and 5 to the 6th position, right? So we have created the room here, and then we have shared, like we have shifted 4 to the next guy and 5 to the next guy, then we have replaced 6 over there, like so. Here to insert one element we are doing three operations. Even for delete, if I wanted to delete that, okay, if I wanted to delete that, first what I need to do, I need to delete this 6. Okay, I need to delete the 6. Okay, then I need to move my 4 to here and 5 to here. Again it's taking 3 operations, right? So which is an like complex thing to understand. But in case of linked list, let's see, I have a linked list something like this. Okay, 8. So I have linked list something like this. Now I would like to insert 9 here. Okay, 9 here. Now how can I insert? So it's just simple, right? So I will break this point. Okay, connect a 2 9 after 7, and I will connect 8 after the 9. That's it. It's as simple as that. We don't need to perform any replace operations or move operations here. We are just deleting the, like we are just breaking the bond over there and connecting the bond to the 9. That's it. Okay, this is as simple as that. Okay, and it is going to take the big O of one complex. And if you don't know what is time complexity and space complexity, I highly recommend you guys to watch the tutorials which are being already created on the time complexity and space complexity in this particular channel itself. Okay, so there is a playlist called DSA. Okay, you can go there and you will find a plenty amount of videos over there. Cool. So this is about even if I take a deletion operation, let's say if I wanted to delete this 9 itself, now what I can do, so I will simply break this out and I will connect to 8, and I will break this out and I will delete that. That's it, as simple as that. Okay, we are not doing any complex operations like move and all. Okay, it's very simple. But I would like to talk about something like accessing as well. Okay, accessing as well. So to access an array elements, it is going to be as simple as that. Okay, you will put your index value and you will get the value. So it is going to take constant like time. But if I wanted to access the linked list elements, it is not as simple as that. Okay, if I want to access this particular element, first I need to start from the head. Okay, I need to start from the head. I need to go to every node. Okay, every node until I found a node which I want. Then only I can access that element. So I can't go in the middle and I get that. Okay, I need to start from the starting position. I need to go to the every node and I need to check. Okay, yeah. So the second thing is dynamic in nature. Yep, dynamic in nature. So point to be discussed. So here, what is a dynamic in nature? So basically there were two things, static and dynamic. So static means, let's say if you are defining an array, you will be mentioning how many number of columns that you need here itself. Okay, here you can't modify this in later part. Okay, you can store only 5 elements. It is defined, it is fixed. Okay, but in case of dynamic, you will be giving only like the number of elements, okay, that you required. Okay, let's say, so you have, in the case of static, you have defined 5, but later you observe that you will be requiring 10 elements to be stored. That in that case it won't support. Yes. Now let's say, this is first point, and second point is, let's say you would like to store the 2 elements. Okay, you have defined 5, but I found that I only require 2 elements. In that case, 3 space is waste. Okay, the space for 3 elements is waste. Okay, you are not using that, right? But in case of dynamic, let's say you will be defining the amount of memory or the amount of elements that you would like to share. Okay, then only you can create the things. Okay, let's say if I want a requirement of 2 elements store, then I will create two elements. If I requirement of 100, I will create 100. That's how it works, right? So this is about a static and dynamic. Okay, and in case of linked list, it's always a dynamic. It always dynamic in nature. Okay, it is always in dynamic in nature. There is no boundaries for that. But in case of arrays, while defining the array itself, you need to mention whether like how many elements that you are going to store. Okay, so it is one of the drawback for array. But how can we make this as a dynamic? So there are few concepts, okay, known as malloc, so which helps us to define the memory or allocate the memory in the dynamic space, okay, while runtime. Okay, you can call this as a runtime. So basically we will be having two things, compile time and a runtime. What is this compile time? So compile time means after writing the code, okay, after writing the code you will be putting the things, okay, like let's say while writing the code itself you will be mentioning the things. But runtime means after compiling the program, okay, based upon the user's requirement, the coding has been changing. Okay, that is called runtime, during the runtime. So as we discussed, it's a memory wastage as well. So if I have defined 5, if I have used only 2, then it's a memory wastage, right? So that is what it is discussing about. Now let's move on to the next question. So explain the scenarios where you can use a linked list and arrays. Okay, so I will like leave with this particular question to up to your imagination. Okay, in total. Okay, we have seen hell about these things. Okay, where what are the different types of linked list are available and different types of arrays available. What are the drawbacks here and what are the cons and pros of arrays and linked list. Now just imagine, okay, so just take out just go through this and just try to imagine whether we can apply a in this particular situation, can we apply array or linked list. Okay, so I will just go walk through these things. Okay, so following are the scenarios where you use linked list over array. Okay, so when we do not know the exact number of elements beforehand, so as we said, there is no boundaries for linked list. So it is means that we can, like, if we don't know the requirement, we can go with linked list. So whenever something has been changed, we can append those changes. But in case of array, we can't do that. So when we know that there would be large number of add or remove operations. So as we discussed, linked list is very easy to perform insert and deletion operations when compared to the arrays. So in that cases, we can prefer linked list. So less number of random access operations. So random access operations means a searching. Let's say we have different nodes and I wanted to access this particular node. Okay, so I can't easily go to this particular node directly, right? So I have to start from the starting, then I can go to each one manually. Then only I can access that element. So in that case, let's say if I have 1000 nodes, I wanted to access the 999 node. Then how many nodes I need to check? I need to check 999 nodes, right? So it is going to be little complex operation. So in case of array, I can easily say array of 999. Then I will get the answer. Okay, in such cases, so like if it has a very less number of random access operations, then you can prefer linked list. Then when we want to insert items anywhere in the middle of the list, such as while implementing the priority queue, linked list are more suitable. So we'll talk about these priority queues later. Okay, so as of now, they are saying that if you wanted to insert something in the middle, as we discussed earlier, so in that case, you can prefer linked list over array. Now, what is the second thing? So below are the cases where we use array over the linked list. So as of now, we discussed about using linked list over array. Now let's discuss about using arrays over linked list. So when we need to create index or randomly access element from the frequent, like more frequently. So as I said, if we wanted to access 999th index, we can simply say ARR of array of 999. So you can access the thing very easily. Now the second point, when we know the number of elements in the array beforehand in order to allocate the right amount of memory. So as we discussed earlier as well, so if you know the requirement exactly, let's say if I wanted to have only 20 elements in my array, then you can go with this particular arrays. Okay, if you are not sure about how many elements that are going to are required, then you should go to the linked list. Third thing, when we need speed while iterating over the elements in the sequence. So speed matters a lot, right? So that as speed directly depends upon the time complexity. So if you are going a little faster in the your memory, then like in your array, then your overall time complexity is going to be little faster and efficient. Yes, so this is about scenarios where we prefer either linked list or arrays. Now, what is a double linked list and what are its applications? So till now we have talked about single linked list. Now let's talk about double linked list. So in single linked list, we will be having only the pointer to the next node. Okay, the pointer to the next node. So just imagine if you have a pointer to the next node and the previous node. Okay, the previous node. Then this is called as a double linked list. Okay, so here your node would be containing three parts. One is data and the next pointer and the previous pointer. Okay, and the previous pointer. So this is what a double linked list means. Let's coming to the applications. So here, so applications of DLL. So a music player list with the next song and previous song navigation options. So everyone loves music, right? So if you have opened any music player, okay, if you have opened any music player, you could have observed next pointer let's say so if you are listening one music, okay, there will be options, right? Like go to the next song, go to the previous song and pause the song and resume the song. So something like this. So here, so you can assume that this going to the next song is a next pointer, going to the previous song is a previous pointer. Okay, this is one use case where you will be using double linked list. And the browser cache with the back forward visit pages. Okay, so let's say I have currently opened Google Chrome. Okay, like interview bit blogs website. Okay, interview bit blogs website. Now, like before coming to interview bit platform, I have opened a Scalar Academy website. Scalar Academy website. Okay. Now before back, okay, so like after visiting interview bit as well, I have visited another website, okay, which is called as let's say Scalar Forever website. Now I am currently in the interview bit platform. If I wanted to go to the web page or the website which I have opened before to the interview bit, then what can I say? So here you can see these navigation buttons, right? Navigation buttons. So this one represents the backward, this one represents the forward. So this is the current page which I am in. So interview bit. Now if I click on this back page, I will go to the Scalar Academy. If I click on this forward page, I will go to the Forever, Scalar Forever, right? So this is one use case where we will be using double linked list. Now undo and redo functionality on platforms, right? So let's say like you have opened a notepad, okay, notepad or Word or whatever it might be. So you will be pressing Ctrl Z, right? So Ctrl Z will get the recently deleted the values. So and something so there is something like a redo as well. So redo means you have like entered something and you have given a backspace, like deleted them and you wanted to get back them. So undo and redo. So these operations will also take a double linked list. Okay, so this is about double linked list and applications of a double linked list. Now, what is a stack? What are the applications of a stack? So here this particular diagram represents the enough explanation. I don't need to explain it manually. Let's say, So let's consider this particular bookshelf. Okay, now what do you think about this particular book? So can I say if I have 10 books, okay, I wanted to put them in a one rack. So all I can do is first I will put the one book, okay, this book, then I will put this book, then this, then this, then this, then this, then this, right? So I'll put all of them. And if I wanted to take the, okay, if I wanted to take the one book which is on top, what it would be? It is this particular book. When I inserted that the last. When I'm taking that out, the first. Okay, last inserted, first taken. So this is called an LIFO. So whatever element which has been pushed into the stack, okay, at first is going to take out as the last. Okay, so stack linear data structure follows the last in first out approach. So if you even sees this, first I have pushed 1, then 2, then 3, then 4. Okay, if I wanted to take one element, okay, if I wanted to take one element from the top, okay, it is going to be 4, right? It is going to be 4. That is what a pop. So basically stack has 3 operations primarily. One is push, pop, and top. So push operation helps us to insert the elements into the data structure, and pop operation helps us to delete the topmost element which you have in case of a stack which you have recently added. So here the recently added element is a 4. So when I say pop, 4 is going to be out. Okay, so the top. So this top is going to give us the topmost element. So what is the topmost element? I can say that a topmost element is the element which is been added recently. Okay, which is been added recently. So 4 is the last element that I have added recently. Okay, hope you have understood the stack and stack operations, right? So if you want in detail, like let me put here. So let's say I have these elements 1, 2, 3, 4, 5, 6. Now I wanted to put all of these elements in a stack. So okay, let me put the operations. Okay, I have operations like this. So first push 1, then push 2, then push 4, then push 3, then pop, then pop again, then top. Okay, before coming to top, let's say push 10. Okay, now let's see. So this is our stack. So what is the first operation? It is saying that push 1. So if I push 1, it is going to store something like this. Now again it is saying that push 2. Okay, 2. Now again it is saying that push 4. Now again it is saying that push 3. Now it is saying that pop. So what does pop do? Pop will delete the topmost element which you have added recently. What is the element which I have added recently? It is the 3, right? It is the 3. So I will remove that. Done. Now what is the next one? Again it is saying that pop. Okay, pop. So I will, now what is the top element? It is 4, right? So I will remove this as well. Now what is the operation? It is saying that push 10. Okay, so I will push 10. Now it is saying that top. Okay, so what is the top? So top will give you the topmost element which you have added recently. So it will give the 10. Done. So if you like top, don't delete the element. Okay, it will give you the only topmost element. Only pop will delete the element. Okay, so here these are the applications of the stack. So we'll talk about them as well now. So first is check for balanced parenthesis in an expression. It's going to be one of the interesting problem in DSA. So like where you will be given parenthesis like this. Okay, you need to check whether for every opened parenthesis there exists a closed parenthesis. That is the problem statement. So you can solve this problem using stack. So give it a shot. Okay, give it a try. And evaluation of postfix expression. So there is three things, okay? Prefix, postfix, and infix. Okay, so like these operations are like if you have given a plus b plus into c minus d, you need to convert this into these three operations. Okay, so in one such operation for postfix, you can use the stack. Okay, you can use the stack. And a problem of infix to postfix conversion and reverse string. So a reverse string means you will be given a string. Okay, you will be given, let's assume, string like this, and you require to reverse this entire string. So how can you do that? So let's say you have a stack like this. So I will start from the first element, okay, and I will push everything to the stack. So v a m s I. So once I'm done, now I will take the top and I will delete it, the particular top element. Now if I say top, I will get the I and I will delete this. I will pop out this I now. Now I will again say top and I will delete the pop the top. Now again I will say top, I will get the M and I will pop out. So I will again say top, I will get the A and I will pop it out. Now again I say top, I will get V and I will get top popped out. So if you see, there is nothing in the stack. So, and if you see the output, I got the reverse of a Vamsi. That's how it should work. Okay, so what is a queue? So then the name only suggests that what is a queue. Okay, so just guess. Okay, so a queue is a linear data structure that follows a FIFO, first in first out. So what does it mean? So if you see, okay, like they have given one amazing example here. So you have in a movie mall, okay, you have went to the movie theater. Nowadays everything is online booking, but just imagine, okay, like and 90 kids can imagine this. So there is a movie ticket counter. Okay, you need to go to the queue and you need to collect the ticket. Okay, buy the ticket from there, then only you will be entered into the theater. Okay, so now just imagine, so who is going to be the first person at the counter? Whoever come to the counter first, they are going to be at first. So who is going to get the ticket at first? The person who entered first. Then so who is going to get the ticket at the last? The person who entered into the queue for the last, right? That is how it works, right? Now let's say I have a few operations that we have taken out there. For queue, we will operations have NQ and DQ. Okay, we call this. So NQ will do like something like insert, what we did for push, and DQ will do deletion of top element, and a friend will give you the topmost element. Okay, like the one which is very close to the counter here. Now let's say if I give the operations like NQ1, NQ3, DQ, a top, NQ5. Okay, now so just imagine this is a queue. Okay, this is a queue, and if I have, like, first I have NQ1, so I will put 1 here. Then I have NQ3. Now I have DQ. So when I say DQ, what is the element that I am going to get the out first? The one which is entered into the first. Okay, in this case the element which entered the queue first is the 1. So I will remove the 1. Done. Okay, now I have top. So what is the top element now? Say 3. Okay, after 1 has been deleted, 3 is the top. It will get 3. Now again I say NQ5, so I will say 5. Okay, this is how it should work. Now if I again DQ, what is the element that I am going to get? So it's a 3, right? So this is how queue should work. Now what are the applications of queue? So CPU scheduling task, a BFS algorithm to find shortest distance between two nodes in a graph. So if you don't know what is BFS and graph, don't worry, we are going to learn in this particular video itself. So please watch this video till the end. Website request processing used as a buffers in applications like MP3 media, CD player, etc. Managing an input stream. So these are some of the applications where we use queue. So let's move on to the next question. How is a stack different from a queue? It's very silly question. We have discussed so far. Okay, so a stack follows LIFO manner, last in first out. Queue follows first in first out manner. Okay, so that is the only difference between stack and queue. Explain the process behind storing a variable in memory. Okay, so they are asking us to tell the process how the data has been stored in the memory. Okay, like some variable, take out one example as a variable, then tell me. So at first variable is stored in memory based upon the amount of memory that is needed. So here like say variable is declared as an integer type, a float type, a string type. Okay, so it depends upon the type of the data that we are storing under one particular variable. So following other steps followed to store a variable. So the amount of memory is required is assigned first. So in case of int, we will be requiring 2 bytes. In case of float, we will be requiring 4 bytes. In case of string, we will be requiring the amount of characters it has. Okay, so each character will have 1 byte. So it will be required the amount of characters it has. Then that's done with the first. Then it is stored based upon the data structure being used as well. Okay, so here let's say if we have defined integer typed array, so it is going to require a contiguous memory locations, right? So it is not about one particular starting point. It is about like sequence of operation. Let's say I have given 10 as my memory elements, then it should assign 20 amount, okay, like 20 bytes of amount for that particular array. So it should search for 20 bytes. When wherever there is a possibility of assigning 20, then it will store there. But in case of linked list, it always finds the large amount of space because it is dynamic in nature. Okay, so requirement is not stated in the before assigning the things. So it depends upon the data type as well. Let's see how to implement a queue using a stacks. Okay, so how can we implement? So we are asked to implement queue using stack. So yes, we can use there is 2 methods. One is using one stack, another one is 2 stacks. So as of now we are sticking to this particular approach. Okay, and maybe in some other tutorial we will try to focus on how to implement a queue using single stack as well, but as of now let's try to implement the using 2 stacks. So first, so we know that stack operations are push, pop and top, and queue operations are enqueue, dequeue and let's say front. Okay, so now using these operations and 2 queues, we need to implement these operations, okay, which is for queue. Okay, so first let's try to understand what are the operations and how it is gonna work. So let's say stack works in this particular manner. Okay, when I say push, okay, push 1, okay, and push 3 and pop. So pop means whatever the element which has been inserted into a stack at the last, that is going to come out at the first. Okay, so this is going to eliminate it. Done. Now again I can say top. Now if I say what is the topmost element now, currently it is 1, so I will get a 1. If I perform the same operations like enqueue 1, enqueue 3, dequeue and front. Okay, now how it should looks like, let's say, so enqueue 1, yes 1, and a NQ3 3, and it is saying that DQ. So what is going to happen? So first in first out. So what is the element which has been entered into queue for the first 1? So it is going to be eliminated. Now if I say friend, what will be my output? It would be 3, right? So now you got what is the operations of stack and what is the operations of queue. Now let's try to implement the queue using a stack. Okay, so for that we will be taking 2 stacks, okay, like this: stack 1, stack 2, stack 1 and stack 2, and we are going to perform this series of operations like this: NQ of 1, like NQ of 2, NQ of 5, DQ of DQ, that's it. Okay, so DQ and a friend. Okay, these are a queue operations. Okay, whenever I do NQ, it is going to push. Whenever I queue DQ, it is going to be pop. Whenever I do friend, it is going to give me the top. Now let's try to perform these operations by putting this as a reference. Okay, at first it is saying that while a stack not is empty, so here stack is empty. So what we are going to do, so like first we are going to perform NQ operation, which is a push. Okay, so we'll take this and we'll call this NQ, and we say that while stack 1 is not empty, so here stack 1 is empty, so simply we are going to insert this, push this 1 to the here. Done. Now again we have seen the NQ of 2, so here this time our stack 1 is not empty. Okay, stack 1 is not empty, so what we are going to do, so push everything from stack 1 to the stack 2. So whatever we have in stack 1, we are going to pop out them one by one and push it to the stack 2. Now here we'll pop out this 1 and we'll push it into the 2. Now push data to the stack 1. So what is the data here? 2. So we'll push it here. Now push everything back to the stack 1. Okay, so we'll pop this here and then we'll push whatever we have popped to the stack 1. Done. Now again we have seen the NQ of 5. So again stack 1 is not empty, so push everything from stack 1 to stack 2. So whatever we have in stack 1, we need to pop them, each one of them, and push it to the stack 2. So if we pop everything, so first I will pop a 1 and I will push it to the stack 2, then I will pop the 2 and push it to the stack 1. So first 1 then 2. Now it is saying that push a data to the stack 1. So what is the data? It's a 5. So I will push here, and again it is saying that push everything back to the stack 1. So whatever we have in the stack 2, we'll pop that each and everything, like every element, and push it back to the stack 1. So here first we'll pop 2, and then we'll push it here, and then we'll pop the 1 and push it back here. So it is going to be looks like this. Now DQ. So DQ means a pop operation. So in queue, how it is gonna work? So whatever you have pushed at the first, okay, then it is going to come out of the queue for the first. So in this case, let's say we have called DQ, okay, and if stack 1 is empty, then error. So here stack 1 is not empty, so pop an item from the stack 1 and return it. Okay, so they are saying that pop the item from the stack 1. So if I pop, what is the element? So usually stack eliminates the last in first out. So here last has been entered this. Now I will pop this out and I will say here, okay, for this we got the answer as 1. So in this case 1 is the first thing which has entered into queue, right? So that is what we got. Done. Now DQ. So again DQ. So what is the same? So again stack 1 is not empty. What we will do? We will do pop the stack 1 element. So if we pop, we will get 2 and return the 2 here. That's it. Now they are saying that friend. So we will be getting the topmost element. That's it. So here we have only 5. Return that. So this is how we are going to implement the queue using 2 stacks. Okay. And there is another method. So here we will be making NQ operation little complicated. Yes, right. So we are performing swapping operations, and then we are putting back to the queue stack one, and we are making NQ operation little complicate, but DQ operation is doing in some constant amount of time. So the another approach follows making an NQ operation little easier and DQ operation little costlier. That's it. Okay, so just follow these steps. Okay, I am pretty much sure that you will be able to do this. Okay, now let's go. So the next question is, how do you implement stack using queue? So this is the opposite, reverse. Okay, so earlier we have done queue using a stack. Now they are asking stack using queue. Okay, so now we need to do this. So again we are going to use a two queues, two, and we know the operations of queue, right? So first in first out, and stack is last in first out. So we need to implement these operations. So these are the sequence of operations that we can follow here. Okay, so let's try to check, okay, whether we can able to do this or not. So let's take two queues, q1, q2, and I will take a sequence of operations. Let's say push 1, push 3, push 5, push 6, pop, top, and push. Okay, let's make it little complicated. Okay, now let's do this thing. So first step, push 1, so it will come here and enqueue the data to the q2. Okay, I will be putting it 1 in the q2. Let me change the color. Yeah, now dequeue elements one by one from q1 and enqueue it to the q2. So here currently q1 is empty, so we are not going to do this step. Now swap the names of the q1 and q2. Okay, so swap the names in the sense like whatever we have in the q1, let's put them to the q2, and whatever we have in q2, we will be putting them into the q1. Okay, so here if we do that, like it can be simply changing the names as well, so we can do that as well. So q2 and q1, done. Okay, again we got a push 3, so push 3. So first thing, enqueue to the data to the q2. So here we have q2 as here now. So dequeue elements one by one from the q1 and enqueue to the 2. So here we will be having only 1, so we'll pop this out and put it in the q1. Now swap the names of q1 and q2. So swap the names q1, q2. Now we'll follow this. So push 5. Okay, push 5. So I'm going to push it here. Okay, I'm going to push it here, and sorry. So I need to do this here. Sorry. So dequeue elements by one and put it back into the q2. So here, what is the element that first has got into the q1? It is 3, right? So I need to pop that of 3 first, and I will push it back to the here, and then 1. Done. Now swap the names of 2. So it is going to be q2 and q1. Done. Now again push 6. So I will push 6 in the q2, and then pull out all of these things and then put it back here. So if I pull out all these things, it will be looks like something 5, 3, 1. Right, what is the element that first got entered into the q1? It's a 5, so we have to pop that out first and we need to put it in q2. Okay, now again same, right? Now they are saying that pop, so pop, so we'll come to here. Okay, we'll come to here. So we did not swap the things. Okay, so we'll swap the q1 and q2. Now they are saying that pop, so dequeue from the pop q1 and return it. So what is the element if I pop it from the q1? Like if I dequeue from q1, what is the element that I get? 6, right? Why 6? 6 is the one which has entered into the queue for the first. So if I dequeue, I will get the 6. So So yeah, yes, so this is what I want, right? So if I am doing stack, so I will be getting last in first row. So what is the last element that got into the queue? So 6, right? So I will be getting 6. That's it. So we can eliminate this 6 now. Now again we have pop. Now what is the element that I get? So 5. So I will get a 5. So I will eliminate the 5 here. Now what is the element? Top. So what is the topmost element currently? It is 3. So I will get a 3. Now again saying that push 2. So first I will put it into the Q2. Then I will pop out everything from the Q1. So if I do pop out, I will get 3 and 1, and then I will be eliminating here and then just swapping the names. So it is going to be Q2 and Q1. Okay, that's it. If I perform pop now, I am going to get 2 as my answer. Done. So this is how you can implement the stack using 2 queues. Okay, so I'm not writing the code here. Okay, I hope you can able to do that here, and we'll do a separate video on that as well. Now let's move on to the next question. What is hash map in data structure? So hash map is being called as different names in different programming languages. Let me put it here. So in Python we use a dictionary. Okay, in C++ we use a map or unordered map. Okay, and in Java we use hash map. Okay, so the operations is same. Okay, the operations are same, and the names only different while changing to the language to language. So a hash map is a data structure that uses implementation of hash table data structure, which allows access of data in constant time complexity if you have the key. So basically, let me tell you how the data has been stored into the hash map first. So hash map follows 2 rules: key and value. So what is a key and what is a value? So a key is a unique value. Okay, a key is a unique value, so which helps this particular thing to the identify the data from the or access the data from the map. So let me take one simple example. So let's say you will be given an array of elements. Okay, array of elements like this, and now you need to calculate the frequency. Okay, frequency of each element. Okay, frequency of each element. Now how can you do that? So by using the hash map we can do that easy. So let's say first I will check whether 1 is there in the queue or not. Okay, like hash map or not. Yes, 1 is not there, so I will put 1 and I will make sure value is assigned to the 1. Okay, so what does it mean? So till now 1 has been occurred only once. Okay, now again I can see that there is a 1. So here first I will check whether 1 is there in my hash map or not. Yes, 1 is there. So what does it mean? What does it mean? So it means that there is already exist a 1 which has occurred for once. Okay, now what do I need to do? If I can simply update this value, then my job is done. So here key is element and value is frequency of that particular element. Done. Now again I have 1. Okay, now which is like already have 1 in my map. So what I need to do, I need to just increment my value. So if I do that, it will become 3. Now I have 2. So 2 is not there in the map, so I will create 1. Okay, done. Now again I have a 2, but I have already 2 is exist in my map. So what I can do, I can simply increase the value. So now it is a 3. So whether 3 is there in my map? No. So I can just say 3 to the 1. Now the next element is 4. So 4 is not there in my map, so I will increment it back. Now I have 2. Okay, I have 2. So but already 2 is exist in my map. So what do I need to do? I need to simply increment the value of the key value of the 2. Done. So now let's cross check the things. Okay, here I have an array size of the 8. So 3 plus 3 plus 6, 6 plus 1, 7, 7 plus 1, 8. So 8. Done. So this is the frequency. So this is how and we store data in the hash map. So what are the things that you have identified here? So in hash map, we can't store the duplicate values. Okay, we can't store the duplicate values. Yes, and if we can't store the duplicate values is an passive statement. Okay, what we can say is it will get overridden, that's it. Okay, like if you have 1 and again if you have seen 1, it will just override that 1 with 1 and it will do whatever operation that you are performing. Okay, that's it. And how to access the hash map elements? By using these keys. Okay, let's say this particular hash map is being under the variable of MP, then you can say MP of 2, then you will get a answer as 3. Okay, like this is a key basically, and if you do this something like this, you will get a value. So this is how hash map works. Now, what is a requirement for an object to be used as a key or a value in the hash map? So we have discussed what is a key and what is a value, and they are saying that what is the requirement for an object to be used as a key or value. So now the key or value object that gets used in hash map must implement equals or hash code method. Now the hash code is used when inserting the key object into the map, and equals method is used when trying to retrieve a value from the map. So basically it's something like equals is used for finding an element, and a hash code operation is being used for inserting an element. Okay, that's it simply. How does a hash map handle collision in Java? So what is a collision? Okay, I will tell you that. So let's say in hash map you have 1, 2, 3. Now again I am trying to map this 1 to first I have mapped 1 like 10, 11 and 12 here. Now again I wanted to map 15. Now in that case this is going to be overridden, right? But I don't want like that. I wanted to be all the values to be handled over there. So in such cases, how to handle this? Okay, this is a collision, right? So we have already data, again we are trying to insert the data back again, so it will collide. So how to handle these things? So they are saying that so this is that in Java, this is how you will be importing the hash map. So in Java uses the approach of chaining the handle collisions. Okay, so we follow the chaining method. So in chaining, if the new values or with the same keys are attempted to be pushed, then these values are stored in a linked list stored in bucket of the key as a chain long with the existing value. Yes, so makes sense. So I will tell you with an example how this is works. Okay, let's say I have a values of 10, 11, 12, 11, 12 and 13, 14 and 15. Now I will be having one hash key as 2. Okay, hash key as 2. Now how does it work? So basically I will be mapping all these things with the mode of, let's say I will take this and 10 mod 2, which is an hash key here. So the value is 0. So I will map all the 0th remainder values to the 1 key and all the 1 remainder values to the 1 key. Let's say here I have a key values of 0 and 1, right? So if my hash key is 2, then I have these are the only 2 possible ways that I can get. Now so 10 mod 2 is 0, so I need to assign the 10 to the 0th key. So I will do that here. Done. Now I will take out the next guy, which is 11. So 11. So 11 mod 2 is going to be 1. So I need to map the 11 to the 1. Now I will get 12. So 12 mod 2 is going to be 0. So it means that I need to assign this 12 to the 0th key. So already if you can observe, already there is a 10 which is been assigned to the 0. Now how can I assign 12? So here I will follow an linked list method. Okay, linked list. So starting with the node of for the key of 0, I will be having a linked list. Done. Now 13. So 13 is going to give me the remainder as 1. So which means that I need to give it to the 1th key. So already 11 is existing there. So I will form a chain here. I will form a chain. Okay. Now there is a 14. So if I divide, like the remainder is going to be 0. So it means that I need to map it here. And again, so you got it right. So I will, for the every key, if there is a collision is occurring, then we are forming an chain like structure. Okay, we are storing the data in the form of linked list. Okay, this is how we handle collision in the hash map or hash tables. In worst case scenario, it can happen that all keys might have the same hash code, which will result in the hash table turning into a linked list. So they are saying that let's say if I have given all the even numbers here, okay, like 10, 12, 14, 16, 18, 20, 22, like this, then all the values are going to be mapped to the 0 itself, right? 0 only, 0th key only. So that is what they are saying that. So in this case, a searching will be taking big O of n, right? Big O of n. So if I start from the, like if I wanted to search for 20, then first I will be starting from 10, then 12, then 14, 16, 17, 18. I will be searching in the max of n elements, right? So that is what they are saying, that in worst case, big O of n will be the complexity, as opposed to big O of one time due to the nature of linked list. Hence, care has to be taken while selecting the hashing algorithm. So this is an you need to be very careful while telling if you have used an hash map in your data algorithm, and you should be very careful while telling the complexity over there, because in worst case you will be taking login time, and in best case it will take big O of n one time, which is a constant time. So please make sure that you won't get confused. Now, what is the time complexity of basic operations get and put in hash map? So yeah, so they are saying that get and put operations. So basically these are the two operations that we perform on hash map. Okay, get is accessing, and put is for inserting. Okay, so they are asking us what will be the time complexity over there. So in best case, okay, if you are following and where you will be storing only one value to the each key, then in that case the both operations will be big O of one time, which is a constant time. But if you have if you are taking like where your map is in this particular form we have discussed earlier, the complexity is going to be, in worst case, it is going to be big O of n. Okay, let's discuss another problem. So the next problem is, what is a priority key? We have talked about queue and stack, right? So what is this priority queue? So a priority queue is an abstract data type that is like a more a queue, normal queue, but has priority assigned to elements. So let's take one example, then I can tell you in a better manner. Okay, so let's say you are in a hospital, okay, and which follows the first come first serve, right? Like first in first out. Now you are all guys are in a queue and you went to hospital for a normal checkup, okay, consultants, okay, normal checkup. Now so you are standing in a queue and suddenly, all of a sudden, someone came up with an accident, okay, met with an accident. Now there is only one doctor, okay, who is whom you are going to check up for. So now what is going to happen? He will stop the queue, okay, he will stop the line here and he will directly jump to the accident patient. Why? Because he is the priority case, right? He is the one which has highest priority. We need to give them priority. So that is what a priority means. Okay, so here in our case of priority queue, everyone will be having some priority. Okay, everyone, let's say if we have taken politicians, okay, someone like MLA, MP, and a governor, a CM, and PM. So everyone has their own priority. Okay, if like MLA, until this PM comes, everyone is like CM is the top one, we need to give them priority, something like that. Okay, so here we will be maintaining two queues. So one to maintain our data and one to maintain our priorities. Okay, so this is what a priority queue means. So the one who is having a highest priority will be going first. Okay, one who is having lowest priority will be going out. So it can be vice versa as well. Like if your program wants to be like who is having a lowest priority, they need to go to the first. So it totally depends upon the application that we are using. Okay, now so elements with higher priorities are processed before the elements with a lower priority. That is what we have discussed. In order to implement this, a minimum of two queues are required, one for data and another one for priorities. So this is what. And another thing about a priority queue is, so we have a concepts called heaps, heap data structure. Okay, which we will be talking about in a later part. Okay, so in heaps we have a max heap and min heap. So mostly for to implement these things, we will be writing periodic queues. Okay, we will be using periodic queues. So we'll talk about what is heap and what are these max heap and min heap in the last question, which is an 40th question, I guess. Okay, we'll talk about that during that time. So just as of now, we can implement max heap and min heap with the periodic keys. That's it. Just keep that in mind. Now, can we store duplicate key in the hash map? So I guess we have answered this question earlier. So we can't store the duplicate values in the hash map. If we try to do that, it will override the values and keep only one copy. That's it. So this is what they are saying. No, okay, duplicates keys cannot be inserted into hash map. If you try to insert at any entry with an existing key, then the old value would be overridden. Okay, so old value would be overridden with the new value. Doing this will not change the size of the hash map, right? So we are just overriding. So size doesn't matter. So this is why the key set method returns all keys as a set in Java, since it doesn't allow duplicates. Now here comes the trees. Yeah. So tree data structure. What is a tree? So what is a tree? So tree is recursive non-linear data structure. As we talked about what is a linear and non-linear, so tree comes under the category of non-linear. Consisting of set of one or more data nodes, okay, where one node is designated as a root and remaining nodes are called as a children of a root. So basically, we again, just like linked list node, for tree as well, we will be having a node. Okay, node. So we can consider this as a node. And here every node will be having three parts. One is data, and this is a right node pointer, and this is left node pointer. Okay, so every node will be having these three pointers. They are saying that so for every tree we will be having one root. So root means the topmost element, the very first element that has been created in the tree, and all other, if we have one root node, then all other nodes will be called as an either children's, okay, or like sub tree kind of things. Okay, so we'll talk about the terminologies and all in the later part. Now tree organizes the data in the form of hierarchy manner. So what is this hierarchy manner? So if you can see, like let's say I have a folder named desktop. Okay, under the desktop I have two folders. One is a scalar, another one is personal. Okay, and again in this scalar folder I will be having few other folders. Let's say arrays, like where I will be storing all the programs related to the array topic, then linked list, then trees, and in personal I will be having, let's say, documents and pictures and videos. And again in trees I will be having different topics. If I say like a 2 pointer, okay, a sliding window technique, and queues or stacks kind of thing. And even in trees as well, we will be having different types like binary trees, binary search trees, AVL trees, red black trees. Okay, so I will be storing something like this. So can you tell me now, this is going to look like as a tree, right? Okay, where we will be having one root that has a desktop. Under that desktop we will be having folders. So this is what hierarchy, right? So 1-2 layers. So on very first layer we will be having desktop, then scalar and personal folders, again folders, again programs kind of stuff. So this is what they are referring to as a hierarchy data structure. So the most commonly used data structure is a binary tree and its variants. So as I said, we will be having different trees, okay, different types of trees. Okay, I will name the few. Okay, binary trees, binary search trees, AVL trees, and complete binary tree, sorry. Okay, and B trees and red black trees. So these are also all called as a trees, okay, but different types of trees. Among all these trees, binary trees and binary search trees are very important, okay, and even binary trees are more important than binary search trees, if I wanted to put it in a name here. Okay, so if you are preparing or if you are aiming for big companies, big tech companies, or big product based companies, then you should need to solve at least 50 plus problems on binary trees. So that is going to be a good count, and you can able to solve any problems. And to learn binary trees or any trees, then the prerequisites would be recursion. Okay, recursion for sure, and some hashing. We use hashing in few tree problems. So yeah, even this is secondary. Okay, this is secondary. Like recursion is a must to learn the tree. So if you wanted to looking to learn tree topics and recursion, please, I have made a video on both trees and recursion, where I will be solving plenty good amount of problems starting from the basics. So you can watch it there as well. Now let's come to the applications of the trees. So first, applications of file systems. We have seen this, right? So we have seen this application here. So this one application where we will be saying that this is how our file architecture is being stored. Okay, then comments on social media. So what is comments on social media? So if I say, let's say someone has posted a picture post, and I have commented, and for my comment multiple people can comment it again. Yes, and for comment multiple people can comment it again, right? And can I say this is going to be tree structure? Yes. Okay, and family trees. So a family structure, so where we will be having starting from the grandparents, then parents, then generations, and then our next generations like children, and so their children. So this is going to be like tree structure. Okay, and if you want, you can, like, they will be representing few things here. So let me open my, so we will be having a root. Okay, let me take this out. Okay, let me draw this here. Okay, so we will be having first root, a root. Okay, so under this we will be having different trees, right? So I will be writing binary tree here. So here it is an NRA tree, so where we will be having like different number of amount of childs to a particular root. Okay, now this is a root, and here this is called as edge. So what is the edge? So edge is being called as a connecting point to the one level to the another level. Okay, it creates a representation. Okay, it creates a connection between two nodes, and the data present in the node is called as a key. Done. Now these two, okay, like for this particular root, these two will be called as a siblings. Yeah, siblings. these two will be called as a siblings. So what is a siblings? So in general, in real world, we call one level. Okay, like if I say me and my sister, we call as a siblings, right? So we are belongs to one same generation. You can consider this as one generation. Okay, and then we have a parent. Okay, and we have parent. Let's say if I want a parent of, if I wanted to parent of these guys, I can say that for these two, this is the parent, right? And I can say that this is also another subtree. Okay, subtree. And the nodes which don't have any children, are called as a leaves. Okay, nodes which don't have childrens are called as leaves. Okay, the subtree means a part of a tree. A parent means which has some childrens, then that is called as a parent. An edge means connecting point between the two nodes. A key means data which is present inside a one particular node. And the root means the topmost element where a tree has been begun. A siblings means which belongs to the same generation or which belongs to the same parent. Okay, which belongs to the same parent. So we have discussed enough, and now let's move on to the next question. So what are binary trees? Yeah, good question. What are binary trees? What is a binary? What is a binary? I can say that two, either 0 or 1. So when I say binary, it is 2, right? 1 or 0. So this is what a binary tree means. Okay, so for each parent or for each root node, we will be having two children, at most two children, at most. Okay, so let's say I have a root. Okay, let's say I have A, and for A we will be having two children, B and C. Okay, and for B again I have two children, for E and D. And for C I have only one children called F, and for F again I have two children. So let's say G, H. Okay, and for E I have another children called X. So here you can if I say for each node we will be having at most two children, then it is called a binary tree. Okay, so a node, okay, a tree which has, okay, at most two children for every node, then it is called as a binary tree. So you can consider these two diagrams as well. Okay, so where in the first, left hand side we will be having a normal tree. Okay, where we will be having three nodes here, then again like for everything we will be having again 3. So which is not a binary tree, right? Which is not a binary tree. So if you consider this tree, so here we will have two nodes for this, and for this we will be having 2, for this 2, for this 2, and for this we will be having 0, 0, 0. So I said at most 2. So it can be 0, it can be 1, it can be 2. Okay, these are the 3 valid things accepted. So this is what a binary tree means. Now let's move on to the next question. So what is the maximum number of nodes in a binary tree of height k? What is a height? Okay, what is a height? So let's say a height is the number of levels it has. Okay, so from this it can be considered as a 1 height. It can be considered as a 1 height, 2, 3. Okay, like 3, 4. Okay, this is a height of 4. Okay, now their question is, there will be having a height k, and they are asking us to what is the maximum number of nodes that you can have for the height of k binary tree. So let's see. Okay, first let's try to draw the tree which has the some minimum number. Okay, let's say, okay, so I have this, then 2, then 3, then I have this, 3, and 4, 5, this 6, 7. For this again I have 8, 9, 10, 11, 12, 13, 14 and 15. So this is the height of tree. Okay, 3. So here, okay, like so until here 1 and 1. Okay, so the height is 3 here. Okay, the height is 3. So now tell me how many nodes are there. Can I say that 15 nodes? So here it belongs to the 8, it belongs to the 4, it belongs to and 1. So what is the one thing that you have identified? So by increasing the one level at each time, we will be going in a 2 power manner. Okay, so for 3 size we will be having at max we will be having 15 nodes, which is going to be 2 power k plus 1. So here k is 3, right? So 2 power 3 plus 1 is going to be 4. So 2 power 4 is 16. So and minus 1. So this is the formula that we can get. Yes, so they are given something like that only. Now write a recursive. Next question is write a recursive function to calculate the height of a binary tree. Okay, height of a binary tree. So let's take one binary tree here. 10, 2, 3, 4, 5, 6 and 7. So in this case the height is 3. Okay, the height is 3. So if I am currently standing at this particular node, so can I say that the maximum left subtree, the height of maximum left subtree and the height of maximum right subtree plus 1. So why plus 1? I need to include this particular node as well, right? So can I say that max of a left subtree, okay, sorry, a max of left subtree comma right subtree plus 1 as my answer? Yes, I can. So by using this formula, how can we write our code? So for this we need to know a traversal. We need to traverse through all the nodes of a tree. Yes, all the nodes. We need to traverse through all the nodes of a tree. So how can we traverse through all the nodes? So we have 3 things, okay, to traverse through all the nodes. So which is, we have 2 techniques. One is DFS and BFS. Okay, DFS means a depth first search. We will be first, let's say we have a tree something like this. So we will go till the depth wise, like we'll reach till the leaf node, and then we will go back and then we will come to the another way. Okay, which means we will come to the start from the root, come to the leaf, then again we'll go to the another way. Okay, but in BFS manner we will be going in the fashion of breadth wise. Okay, so 1 breadth, 2, so breadth means horizontally, DFS means vertically. Okay, so for this we have again under this BFS again we have 3 things: pre-order, post order and in order. Okay, pre-order, post order, in order, and we'll discuss about them in detail, okay, in later part. Now just try to solve this particular problem, then we'll see. Okay, so if I'm currently, let's say I have tree like this. Okay, now first I will give the pass the argument as my root node. Okay, which means I'm standing at here. Now what is the first thing that I need to check? So I need to check if that particular root node is null or not. If it is a null, what does it mean? I don't have any nodes. Okay, so I can simply return 0, right? So first thing, check if root equal to null. So if this is true, you can simply return a 0. Right? If it is false, what does it mean? You need to go to the left subtree, then you need to go to the right subtree, and you need to check the maximum of them. Okay, you need to get the maximum out of the left subtree and right subtree. Okay, now let's say I will go here. First I will go to the left side. Okay, then I will calculate the height of this particular 2. Okay, again I will check. Okay, I will make a recursive call. Okay, you can see that here. Okay, I will be making a recursive call, and then I will check root is equal to null and no. So I will go to the left subtree now. Left subtree. Now again I can check root is null or not. So again I can see root is not null. So I will go to the left. Now is there anything here? No, there is nothing. So I will return 0. I will return 0 here. Okay, I'm done going to the left side. Now I will go to the right side, and I feel that there is nothing here as well. Okay, there is nothing here as well. So the right subtree of 4 is going to return 0. Now you need to take the maximum of, for each node you need to take the maximum of left subtree, right subtree, and then you need to add the 1, which is a current level, right? So maximum of 0 and 0 is going to be 0, right? Now you need to add the 1. So 0 plus 1 is going to be 1, okay, which is this. Okay, the left subtree of 2 is going to return 1. Okay, and then you will be going to the left side, right side of the 2, and again you will say that it will return 0, it will return 0, so you will return 1. So among 1 and 1 of 2, so left subtree of 2 is 1, right subtree of 2 is also 1. So if you take the maximum out of them, you will get 1, and you will add the current node, which is again 1, so 2. Okay, so I'm going to the left subtree of 1, you will get a height of 2. Done. So now let's go on to the right subtree. So I will go here, and I can see that there is the root is not null, so I will go to the left, and then again root not, so I will go to the left. So here I will say it will return 0 and return 0 because it don't have any left and right subtree. So I will return 1 here, right? 1. Now it will go to the right, which is a null. Okay, it will return 0. So among 1 and 0, which means a left subtree and right subtree, the 1 is the maximum one, so it will return 1 plus 1, so 2 here. Now for 3 it will go to the right, and there is nothing, so it will return 0, and out of 2 and 0, 2 is the maximum, so it will return 2 plus 1, so which is a 3. Done. Now for this again you will return 2 plus 1, which is a 4. Done. So for this the height would be the 4. Done. I hope you have understood. So this is how, like, if you wanted to write the code for this, you can check this out. This is how you will be writing the code. So write a code to count the number of nodes in a binary tree. So they are asking us to write the code to check the how many number of nodes present in the binary tree. Okay, let's say if I have given a binary tree like this. Okay, now how many nodes are present in this? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So at max I have 9 nodes. 9 nodes. So my answer would be 9 here. So can I say if I want the total number of nodes here, then can I say that the total number of nodes at the left hand side plus the total number of nodes right hand side is going to be my answer plus 1, like so. Count left side, okay, plus count right side plus 1, right? So whatever how many number of nodes are there in my left hand side, it is going to return 3, and how many number of nodes are there in my right hand subtree, it will return 5, and here I will do plus 1 for the current root nodes. I will do plus 1. So at max it is going to be 3 plus 6, it is totally 9. Done. Okay, so it is simple. Okay, you can try it on your own. So this is the code that you can check it out. So tree traversals. Okay, as we have discussed, there will be 3 traversal techniques. Now let's try to understand 3 traversals.
In this tutorial we will be learning about trees right from the basic. So what are the contents that are going to cover in this entire tutorial is different types of trees available, and binary trees, and what are the techniques to traversal in an particular tree, and also we are seeing the implementation of trees and implementation of traversal techniques. And coming to prerequisites, it will be good if you know what is a structure and a class. And to study trees, the recursion is must and should. Okay, so if you don't know what is recursion, please go and watch my previous video which is made on recursion. And yeah, that's pretty much. Okay, so let's get started. Oops, before starting we do have few formalities to do. So first one, if you are visiting channel for the first time, don't forget to subscribe. If you like the content, please hit that like button up, and if you have any queries, please let us know in the comment section. Now let's get started.
Now let's get started with the introduction to the trees. So I can simply say that a tree is a non-linear data structure. What does it mean by non-linear? So basically, data structures has been classified into two types. One is a linear data structures, linear data structures like arrays, linked list, stacks, queues. Okay, and another types are a non-linear data structures. So non-linear data structures means trees, graphs. Why this is or called as an these are all called as an non-linear data structures? Basically, a tree and graphs stores the data in the form of hierarchical. Okay, so what does it mean by hierarchical again? So let's see. So basically, if there is something here, okay, if there is something here, and data has been stored inside to that, like whatever it stores, it will be linked to that on top of that level. Okay, now again for this level, it might have something. Okay, so it might be anything. Okay, it can have n number of things. Okay, so can I say that these are all one level, these are all one level? Can I say that? So these are all in one hierarchy. So here one hierarchy, then hierarchy, it has something, it has something, it has something, right? So this is how that tree stores the data. Okay, now by this means we are calling it as a hierarchical data structure. Now let's see, there are a few things that we need to know before starting the actual tree representation or coding, whatever it might be. Okay, so first one, a root. Okay, so I will take a simple tree. Okay, now then I will explain everything on that tree itself. Okay, so let's assume we have a tree something like this. Okay, now let's see, so what is a root? So a root can be defined something like this. So root will be the starting point of the tree. Okay, so here where did that root has been started, sorry, tree has been started here, right? So is there anything on top of a? No, there is nothing in top of a. Is there anything below the a? Yes, everything, whatever the comes, whatever the data comes, that will be below the a. So can I say that a will be my top? So by that means I am calling it as a root. Okay, now something parent. Now the next one is parent. What does this mean by parent? What does this mean by parent? So a parent is a node. Okay, so which has some childs. Okay, let's see. So I can say that a has this b and a c. Okay, so from a there are two things are coming. Okay, so they are called as an childs. Okay, childs. So these b and c are childs of a. Okay, so now these are all the childs who will be called as a parent. A, right? So it's a parent a, and childs are b, c and b of childs of a. Cool. Root is a. Now what are all the other parents that you can see on this particular diagram? So here can I say that b is a parent of d and e, right? So b is also a parent. So can I say that g and h are childs of c? Yes. Okay, now is there anything below this d? Nothing. So I can say that d is not a parent. Okay, so that is what happens. Now the next one is, so basically each so I forgot to say, everything will be called as an one node. Okay, so this will be called as one node, this will be called as a node. Okay, this will be called as a node. Now a degree of a node. What is a degree of a node? A degree of a node means the outgoing nodes, number of outgoing nodes from that particular node. Let's say from C, how many nodes are going, like how many childs, let's say childs. Okay, so how many childs are there for C? There are two childs, right? This is G, this is A, H. So there are two childs. For A, how many childs are there? Again two. Okay, now tell me, if I add one thing to G, something X. Okay, now tell me what is the degree of a G? It's a 1. Right, hope you got it right. So I can say that a degree is something, the number of children it has. Okay, particular node has. Now parent done, root done, child done, degree done, and center. So and center, what is this mean by and center? So and center is something like this. Okay, so let me draw another tree. Okay, so okay, now can I say that for this particular node, this is an center? So the top, okay, the previous one where it has been generated. Okay, now can I say that this is a ancestor of this particular node? Yes. So let me tell you one simple trick. Okay, so this will be your current generation. Okay, so this will be called as a parent, grandparent, grandparent, right? So these are all the ancestors of this particular guy. Okay, now what are the ancestors of this guy? Who are the ancestors of this guy? This one, this one. Okay, so who are the ancestors of this guy? No one, because a root itself is the starting point. Okay, so there will be no ancestors for the root. Okay, now if there is an ancestors, then there will be a descendants as well. So who are called as descendants? Okay, the one which it has like the childs of that particular node. Okay, let's see. Okay, let's see. So this is one thing. Okay, now if I wanted to say who are the descendants of that particular node, I can say that this guy and this guy. I can say that, right? These are all. Now you can simply call as an, so consider this as your parents. Okay, parent. Okay, now you might be having, like, he might have one daughter, one son, something like that, right? So you can relate to that particular thing as well. And the next one will be siblings of a node. Let's say what are all the siblings. Okay, so the siblings means which comes from the same parent. Okay, the nodes which comes from same parent. Let's say I have a tree, something like this. Now for these two guys, who is the parent? The same one, this one. Now can I say that these two nodes have came from same parent? So by that means this particular node will be an sibling of this guy. Okay, again it will be a vice versa as well. So for this guy, who is a sibling? He might, right? So let's suppose he has another node, okay, another child. Then for this particular node there are two siblings. Okay, two siblings. So this is how things works. And the next one is a leaf node. Leaf node. What does it mean by leaf node? A node which don't have any outgoing nodes. Okay, a node which doesn't have any children's, okay, child nodes, then we are calling it as a leaf node. Okay, so here if you consider this particular node has no childs, this particular node has no change, this particular node has no childs, and this guy has one node, this guy has one node, this guy has one node, this guy has two nodes, this guy has one node again, right? So this is the, okay, so a last level of a particular node, okay, will be called as a leaf nodes. Okay, and again internal node. Okay, a internal can be defined as a node which has at least one node, one outgoing node, or one parent, oh sorry, one children, is called as an internal node. Okay, a node which has at least one children is called internal node. Okay, now let's see. Now there is another important term, height and depth of a tree. Okay, height and depth of a tree. So in basic, okay, so height can be defined as the max path from root to leaf node. Let's say I have a tree something like this. Okay, I have something like this. Okay, now tell me what is the highest path from starting from a root to leaf node. Okay, now this guy, this guy, this guy. So here I have path which is very highest. Okay, it has a 4 nodes. Okay, 4 nodes path. So if I consider this path, it is only 3. It is only 3, right? So here we have a 4 nodes. 4 nodes. So by means that we can say that number of nodes in a path minus 1. So then that will be your height. Okay, so here since we have 4 nodes involved in that particular path, it's a n minus 1. Okay, 4 nodes minus 1, it's a 3. Okay, I can say that the height of this particular tree is an 3. Okay, now what will be the depth? Okay, now let's say what is the depth. Okay, you have a tree like this. Now if I wanted to find depth of this guy, okay, depth of this guy, I can say that from root, okay, starting from the root, what is the number of nodes involved in that particular till that particular node. So there were only one node, which is a root, right? You can exclude this guy. Okay, so now I can say that a depth from this particular from starting from root to this particular node is a 1. Now at the same time, if you want to find this guy, what will be the depth of this guy? It will be 2 now. It will be 2. So why? Because starting from the root till that particular node, there are 2 nodes involved. Okay, you can simply call it a path as well. So 1 guy and 2 guy. Okay, so you can consider that as well. Okay, so that will be defined as a depth. Cool. Let's discuss about a binary tree. So binary tree is a very important tree which is being asked in many interviews. Okay, so you can expect a lot of tree questions from binary tree and binary search trees. Okay, we'll talk about binary search tree later. Now we'll discuss about what is a binary tree. So a binary tree is a node or every node. Okay, let's call every node in a tree must have at max of 2 children. Okay, to a node. So I'm saying that let's say you have a node. Okay, it must have either 0 or 1 or 2 children of the only. Okay, let's say so we have a node and for this particular node we have 2 children. This is valid. Okay, we can have 0 or 1 or 2. Okay, at max 2 children. Okay, now we have a 2, it's valid. Now for this particular node, again we are having 1 node. Yes, again it's valid. Now for this we have 2 child nodes. It is also valid. Now for this particular node we don't have any child nodes, so the degree of that particular thing will be 0. It is also valid. Okay, you can consider these things as a degree as well. Degree of every node should be less than or equal to 2. Okay, now then we can say that it is a binary tree. Now again in binary tree we have a couple of types. The first one is full binary tree, or it can be called as a proper binary tree and strict binary tree as well. Okay, a proper binary tree and a strict binary tree as well. And then next one will be complete binary tree. Okay, then the next one will be a perfect binary tree, then a degenerate binary tree, at last it's a balanced binary tree. Okay, now we'll talk about each one of them. Okay, so full binary tree means so a tree which has either a 0 or a 2 nodes or 2 childrens, then it will be called as a full binary tree. Let's say unlike a binary tree, for binary tree what are all the possible child nodes? 0, 1 and 2. Okay, so in this particular full binary tree we can say that 1 is not allowed. Okay, so 0. Okay, so root, and for this we have 2, and for this again 2, and for this particular node we don't have any child nodes. It is a full binary tree. Okay, we have only either 2 or 0 possibilities. Okay, now let's say if I say, just tell me, is this a full binary tree? And no, this is not a full binary tree, just because of that fact that for this particular guy, for this particular node, we have only one node, one child node. So 1 is not allowed. Okay, it has to be either 0 or 2. Okay, in that, by that means we can say that it's a full binary tree. Now we'll see what is a complete binary tree. A complete, there are certain rules to follow. Okay, so first rule is all the nodes are completely filled except the last level. Okay, let's see. So if I have a tree something like this, okay, so before coming to this particular level, we need to first fill this level. Okay, so let's say, so here we missed out entering into this particular right of that particular node. We have just going in a left manner, right? So this is not allowed. Okay, so before coming into this particular level, you have to finish this level. Okay, so let's say first I have to fill the root, then I have to enter the left. Okay, then I have to enter the right. Okay, so now it's completed because binary tree has only at most 2 things, 2 child nodes. And now I need to start from the left. Okay, left. So for this guy here and this, and now let's say I can't enter like this. Okay, I can't enter like this, just because I need to first, before coming to right side, I need to first complete the left side of that particular node. So I have to complete this, then only I have to come like this. Okay, now this is how a complete binary tree looks like. Okay, now the second point is, in last level all nodes must be as left as possible. Okay, let's say we have another level. Okay, so I have stopped here. Okay, there are nothing to enter in a tree. Okay, nothing to push in a tree. Now, so where I'm ending at, so I'm ending at leftmost side of that particular tree. I can say that, right? Now that is what this second definition is. Now third rule, so the node should be added from the left. So as I said earlier, we need to start from the left side of the each level. Okay, so this one is one level, this is one level, this is one level, this is one level. Okay, now for every time we are starting fresh, a new line, fresh level, we need to start from the left side. Okay, now that is a complete binary tree. Now let's see a perfect binary tree. So now perfect binary tree can be defined like all the leaf nodes of particular tree should be in a same level. Okay, same level. Let's say we have a tree like this. Now tell me, what are all the leaves here? This one is a leaf, this one is a leaf, this one is a leaf. Now all the leaves are in a one level? No. Okay, so this is one level, this is one level, this is one level. So one leaf is in second level and all other leaves are in third level. So this is not a perfect binary tree. So how does that perfect binary tree looks like? So like this. So here all the leaves. Okay, so this one is a leaf, this one is a leaf, this one is a leaf. Okay, there is no another leaf. So all these leaves are in same level. So this is called as a perfect binary tree. Now the next one is degenerated tree. Okay, degenerated binary tree. So basically it's very simple. Okay, so it looks like this. Okay, it keeps on going at one end only. Okay, so there is something like this as well. It is going in a one side. Okay, so let's say I have started from a root. Okay, and then I move to right, then again 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 move to right. Now there is another possibility. I have started from the root, I have moved left, then I have moved left, then again I have moved left, again I have moved left. So I'm going starting from the root and going in a left manner, otherwise I'm starting from a root and going in a right manner. That's it. Okay, so that is called degenerated. Let's see how to implement an binary tree in programming. Okay, so in this particular thing I will be discussing the code of binary tree in both languages like C++ and Java. Okay, let's see. So a general binary something looks like this: 2 and 3 and 4, and this will again have 5 and 10 and 11. Okay, let's assume. So let's try to implement this particular binary tree in a program. Okay, so I can say that this is one node. Okay, so this is one node, one node, one node, one node, one node. So everything is a node. Yeah. So, and what every particular node has, like every node has some data, and this particular node is pointing to something. Okay, and this particular node is pointing to something. So can I say that it is pointing two things? One is a left, one is a right. Yes. Now let's see how this particular thing will be represented. So 2, it will have something like this. Okay, now this a left. Okay, so left thing will be pointing to again 3, so again which is a node. Okay, so again 3 left is pointing to something called 4. Again a 3 right is pointing to node 5, and right to the 2 is a 10, again which is a node. Again right to the 10 is 11. So here the things that you need to observe here is every node has something like data and a left pointer and a right pointer. Okay, now let's discuss about C++ code. So how will you represent the same in C++? Okay, there is much difference between both C++ and Java code. Okay, it's only syntactical changes. Let's see. So in C++, we will be using a struct to define a node. Okay, so what it contains? A particular node contains some data that is in the int format, and again we have some both a left and right pointer. Can I say that again a left and a right pointers are nodes, right? Again, then what will be the type of these things? Again, struct node star left, struct node star right. Good. Yes. Now let's see how will you implement the same in Java. Okay, so in Java you don't have any struct. Okay, so you have to use a class. Okay, a class node. Okay, so you will have int data. Okay, then here the type of a particular left and right are node left, node right. Now, so how to assign a data? Okay, so we have a concept called a constructor. We use that concept to initialize the values to an node. Okay, so how it looks like. So here a constructor name should be equal to either a struct name. Okay, so here the struct name is node and here the class name is a node. Okay, so constructor name should be equal to that. So int value. Okay, so since we will be having some value, like, so while creating a particular node we have to pass that a value to that particular given node. Okay, now so we need to assign that value to data equal to val. Now what will be our left and right? Okay, so just assume so you are creating a node. Okay, so since you are just creating a node of root, you don't have any kind of left and right, so you have to initialize them to the null. Okay, so left right equal to null. Okay, the same code goes in Java as well. A node into value, so here you will be assigning this dot data equal to val, and both a left and the right equal to null. Okay, in case of Java your null should be capital. Okay, we are done. Now you have created an like definition for how to define an tree node. Now how to assign a values to this? Let's see. So we'll have a main class, main. So first you need to create a root of a tree. So struct node star root equal to new node. What is the data of our node? So like a root node, it's a 2. Okay, so you will pass 2 here. Done. So it will create an something like this. Done. Now, so you need to create a left and right to that particular things now. So how will you do that? So root left equal to, so now you are pointing to here. Okay, so root left. So again it will be a new node of, let's say 3. Okay, so you have created a 3. Done. So now you will be creating a left to the left. Okay, so root left 3, 3 left 4. Okay, so you have to create something like this. Then how will you do that? Root left equal to new node of 4. Done. Now I wanted to create an right to this guy, right to this 3 node. Okay, so what will be the path? So root left and root left right. Okay, so root left right equal to new node of 5. Done. Now I wanted to create an root right. Okay, so I wanted to create something like this, a root right of 7. Okay, so how can I create a root right equal to new node of 7? That's it. Okay, so this will form a tree something like this. Okay, so done. So there is not much difference between C#, C++ and Java code. So here instead of using these things, you will simply use a node, and instead of these pointer symbols you will use dot. Okay, so that's it. So you can try on your own as well. So now let's see the traversal techniques of an tree. So what is a traversal? So basically in arrays and linked list, right from the 0th index you will be going to the nth index. So how you are using that, how you are going that? So by using for loop, right? So you will be initializing int I is equal to 0 and I less than n and I plus plus. So something like that. So we need something similar, okay, to traverse in a tree as well. So what are they? Okay, so we call them as a traversal techniques. So we have two things. One is a BFS, breadth first search, and a DFS, a depth first search. Okay, so we'll see. Okay, well, we'll take some one example, and we'll try to apply these techniques on this tree. Okay, so let's assume we have a tree like this. Okay, so 1 and 1 to be right, 3, 4, 5, 6 and 8. Now let's say, so first we'll see the BFS. So BFS, what is a BFS? So breadth first. So breadth, right? So I can say that this is one thing, breadth, this, then this, then this. So similarly, can I say that we are going level by level? So first we are printing first level, then we are visiting next level, which includes a 3, 2 and 3, then these values of 4, 5 and 7, and then this last level 8. So simple, right? So breadth first means, so we are going a level by level. So we are printing level by, first we will completing the first level, and then we are going to second level, and we are seeing all the visiting all the values or nodes in an particular level, then we are going to the next level, then we are going to the next level. So this is the breadth first search. Now we'll talk about the depth first search. Okay, so which is a very important, very important. Okay, so again in this particular DFS we do have 3 types. So pre-order, in order, post order, very important. Okay, so you can do wonders in entries by using these 3 things. Okay, so you can solve many problems. I can say that without these things you can't solve most of the things. Okay, most of the problems in entries. Okay, let's see one by one. So before going into finding and how to traverse by using these things, now you have to remember a few things. One is for pre-order, okay, pre. So in one particular node, what are all the things we do have? A data, left and right. Okay, so every node has these things. Now with these things we are using like we are traversing through the entire tree. Okay, let's say in pre-order first we are printing the root. So when I say root, it is the data, root data. Okay, now then left, we are moving to the left. Okay, left, then we are moving to the right. Okay, so first we'll do the whatever the data it has, we'll visit that particular data, then we'll go to the left. Okay, then we'll go to the right of that particular tree, okay, particular node. Okay, so now what is about in order? Okay, so it's a first we'll move to left, then we'll move to root, then we'll move to a right. Okay, so in post order first we'll move to a left, then we'll move to right, then we'll move to a root. So now we'll take one example tree and we'll try to traverse, we'll try to use these 3 DFS techniques on that. Okay, so let's assume we have a tree something like this: 2, 3, 5, 6, 7, 8, 10 and 12. Okay, so let's take, so first we'll start with pre-order. What is a pre-order? Okay, so pre-order, what are the rules, what are the formula for pre-order? So it's a root data and left and right. Okay, now where do we start from? We start from this particular root. Okay, so what is the formula? RLR. So here it's an root data. Okay, root, and this R is right. Okay, so what is the first thing that we have? It's a root data. So whenever we have seen a root data, we have to get that particular node data to the output board. Okay, so here in this case, here we have 2. Okay, so we'll print 2 here. So by means that we have done with this particular R. Now what is the thing next thing? It's a L. So it means that it is stating that go to left side. Okay, we'll move here. Now again we'll repeat the same task for this as well. So first thing, root data. So we have 3. Now it is stating that go to left. Okay, by going left we will come here. Now RLR. So now again it is stating that root data. So we will have 6. Done. Now again it is stating that go to left. Is there anything to the left? It's a null. There is nothing. Okay, done with this L as well. Okay, so since it's a null, we are not going there. Okay, now go to left, right. So is there anything to the right of the 6? No. So we are not going to the right as well. So we are cancelling. So done. With that thing, I can say that we are done with 6. Okay, now we'll go to the top, whoever called this particular 6. Okay, it's a 3. So we are done with this L. We have moved to L and performed all the operations, right? Now we have to go to right side of 3. So it's a 7. Now again we need to repeat the same task for 7 as well. It's a R. So it is stating that print the root data. Now go to left. Is there anything to the left? Is there anything to the left? No. Is there anything to the right? No. Right. Is there anything to the left? No. Is there anything to the right? No. So we'll cancel that thing as well. And then we'll go to the top, whoever called this particular thing. So we have visited the right as well. So we'll cancel that. Okay, now again from here we will go to top. So you have done this operation, you have done this, you have moved to right, left as well. Now you have to go to a right side. So you will come here. So again you need to repeat the same task. So first R. So R means visit the data. So it's a 5. Now again it's a left. So you will go here. What is a left? Okay, it's a, again you will simply repeat the things. So again you have 8. Then it is saying that go left side. There is nothing left. Okay. Now is there anything onto the right? No. So we are cancelling and we are going to the top. Okay. Now currently you are here. You are done with, you have moved to left. Now you have to move to right. Okay. So right is 10. So RLR. Okay. Now again first is data. So we will print that 10. Now it's a L. So L means go left. Is there anything to the left? Yes, there is 12, right? So you will move here and you will have LR. Okay. Now again first is R data. So you will print 12. Then again it is saying that left, go left. So there is nothing left. Again it is saying that going go right. There is nothing onto the right of the 12. So by means that we have completed this particular node as well. Now we'll go to top, whoever called this. Now we are done with L. Now we left with this R. So is there anything to the right to that particular 10? No. So we have completed that, and we have completed this node as well, and we'll go to the top. Okay, so we have completed the R as well. Okay, these are all the R, right? Now we'll go to the top. We have completed, and we have completed the R. So now check. So we have nothing to visit. We have done with all. Now check whether we have visited all the nodes of a tree or not. Okay, so first thing 2, then 3, then 6, then 7, then 5, then 8, then 12, 10. So done. We have visited the all the nodes on a tree. So this is how a pre-order works. Now let's see the in order. Okay, in order. So became little mess. Okay, let me draw the tree again. Now we'll try to see the in order traversal of this particular tree. Okay, so what are the in order traversal rules? First you have to go to left, then you have to move to root data, then you have to move to right. Okay, so let's write these things L R R. Okay, second thing is a root. Okay, now first it is saying that go to left. Okay, go to left. Now again you will have LRR. So again it is stating that go to left. Again you will have LRR. Now is there anything to the left of 6? No. So it means that we are done with left. Now what is the next thing? It's a root data. So whenever you have seen root data, you have to print that output, like whatever the node value, you have to print that in the output board. So here it's a 6. Okay, so by means that we have completed the R. Now it is saying that go to a right. Is there anything to the right? No. Okay, so we have completed this, and we'll go to the top. Okay, now we are done with left. Now what is the next thing? It is saying that print the data of the particular node. So here the node data is 4. Okay, we are done with this R. Now it is stating that go to right. Okay, so we'll come here. Now we'll again have the LLR. Okay, now first thing it is saying that go left. Is there anything left? No. Now the second R is a root, right? Root data. So we have to print the 7. Now it is stating that go to right. Is there anything right to the 7? No. Done. We'll cancel this. Then you will go to top. So you are done with second R. Then you have done with third R as well. So you have visited, you have traversed the entire subtree of this left side. Now we will go to the top. Now we are done with this R, LL, sorry. Now we will try to see this R. So here a root data. So whenever you have seen root data, you have to print that particular node data. So it's a 2. Now we are done with the second R. Now we have to go to the right side. Now you have to repeat the same task, LRR. So it is saying that go to left first. Okay, so you will come here. Okay, now it is same. Is there anything to the left? No. And next one is our root data. So what is the data here? 10. So we will print 10 here. So is there anything to the right? No. So completed. Go to the top, call this particular thing. Now you are done with the left. Then what is the second thing? You have to print the data. So it's a 5. Now it is saying that go a right side. Okay, we will come here. So it's a 12. Okay, sorry, LRR. Okay, now you will say go left again. So is there anything to the left of 12? Yes, it's a 13. Okay, you will come here. Now it's a, is there anything to the left? No. Then it is a print. It is saying that print a root data. So we'll print 13. Then it is saying that go right. Is there anything to the right? No. So since you are done with this, then you will go here. So we are done with the left, and what is the next? You have to print the root data. So it's a 12. Now it is saying that go right. Is there anything to the right of 12? No, there is nothing to the right of 12. So we have visited this as well, and you will go to here 5. Now you are done with L, you are done with R, you are done with this R. You have moved to right as well. So I have done this. Done. So did we covered all the nodes? So 6, 4, 7. So let's count 8. Okay, so 8. Yes, we have covered the all the visited. We have visited all the nodes in a tree. Now what is the last order? So it's a post order. Now again we'll take another example and we'll see. So it's a 2, 3, 5, 4, 7, 6, 8 and 10. Okay, now we'll try to find the post order traversal of this particular tree. So what is a post order travel? It's first go left, then go right, then go root data. Okay, so L R R. Okay, so here R means this second thing is a right. So last we are having a root data. So make sure you don't confuse. Okay, let's start. So first it is saying that go left. Okay, so we'll come here again, we'll say RR, then we'll go again, it is saying that go left, LRR. Now again it is saying that go left. Is there anything left of 4? No. Now it is saying that go right. Is there anything to the right of 4? No. Then it is saying that root data. So we have to print the data here. So it's a 4 first. Now you are done with this. Then you will go here. Okay, so you are done with left. Now you have to go to a right. Okay, so here right means 7. So here. So is there anything to the left of 7? No. Is there anything right of the 7? No. The last one is a root data. So it's a 7. Now you are done with this. Then you will go here. Now you are done with this right as well. Now you have a root data. So it's a 3. Now you will go to the top. You are done with this 3. Now you are done with this left. Now you have to go to the right side. Okay. Now it is saying that go left again. So you will come here. Now is there anything to the left of 6? No. Is there anything right of 6? No. Is there any, is that? So you have to print the data. So it's a 6. You have done with this node, then you will go here. So it's a 5. So you are done with the left. Now you have to go to the right side. So first thing you will come here, and it is saying that go left. Okay, go left. So it's a 10. Okay, so is there anything to the left of 10? No. Is there anything to the right of the 10? No. It is saying that print the no. So it's a 10. Done. Now you will come here. Okay, so it is saying that go left. So done left. So it is saying that go right now. So is there anything to the right of the 8? No. Okay, now it is saying that print the root data. So what is the root data? 8. Now done with this. I will go here. Now we have moved to left, we have moved to right. Now we have to print the data of node. It's a 5. Now done with this. Now we'll go here. We have moved to right as well. Now it's a root data. So it's a 2. So how many nodes are there? Totally 8. So we got 8. So this is how we'll travels these things in a tree. Okay. So again, I am saying that these are all very, very important. So if you don't understand, please make sure that take another example tree, try it on your own. Okay, try it on your own. Solve take 2 to 3 examples and try to write the in order, pre-order, post-order traversals of that particular tree. Okay. Now we'll see the code of this, how like implementation details of this particular traversals. Now let's see how to implement and add these tree travels in C++. Okay, in C++. So there is no big difference between C++ and Java code. Okay, so if you could have understood C++ logic, then you can easily implement Java logic if you know recursion. Okay, so let's see. First we'll start with pre-order. What are all the rules of pre-order? So first we move to first root, then left, then right. So this is the pre-order traversal. So let's say, now tell me one thing, tell me. So this is the root. Okay, so we need to start from here. So I will have a function like this, void pre-order, where I will be taking a node star a root. Okay, root. Now tell me, so let's assume if that particular given node is null. Okay, if that given root is null, what you need to do? You need to simply return nothing to return. Okay, so like you won't have anything. Okay, let's say if root equal to null, you will simply just statement like a return. Okay, you are not returning anything, that's simply return. That's it. Now if that is not the case, if root is not null, what you are going to do? So first thing, you will print the root data in your output. So cout a root data. Okay, root data. Okay, root data. Now tell me, so we are done with this part. Now what you need to do? you need to go to a left subtree, right? A left subtree. So let's go there. So again, tell me, after going to the left subtree, what you need to do? You need to do the same task what you did for root, right? So I can call a pre-order of root of left. Now my root will become a 3. Okay, now my root will become a 3. Now again I will check with whether root is null or not. So if it is null, I will simply return. That's it. If it is not null, I will print a 2, then 3. Then I will go to the left of 3. So I will come here. Now again I will do the same task. First I will print the 5. Then I will go to the top. I will check. Now I will go to the left of this 5. Now left of 5 is null. So here my root is currently null. So I will simply just return from that. Okay, so if I return, I will come here. Now what is the statement? So after returning to the 5, so here we are done with the root, we are done with the L. Now we have to do it. Go to right. Pre-order of root to right. That's it. Now again, after going into right side, I will find that again my root is null. So I will simply return from there. Okay, so I'm done with this. Now I will go here. I'm done with left of this. Now I have to go to right of this. Now again I will do the check for root equal to null. No, it's not null. So I will come here. So I will print a root data. So root data is 6. Now I will come to this second line here. Now I can say that go to a left. Okay, so after going to the left, it says that it's a root is null now. Okay, so you will come to here. Now I am saying that go to a right. Right, go to right. So again the root is null. There is nothing to do. Now you will come back to previous node. You will come back to who call. That's how you will get to here 3. Right. So after coming to 3, you are done with everything. Right. So you have visited R, you have visited L, then you have visited right as well. So done. So you will go to here. Now you are done with R done, L done. You have to go to R side. So right side. So you will come here. Now RL. So again root. So it's a 4. Okay, you will print 4. Then you will move to left side. Again you will print the 4, 7. Okay, then you will move to left. You find out that there is nothing left on the left of the 7. So go and then you visit the right side of the 7. There is nothing. Then you are done. You will come here. So you are done with the left. So you will move to 8, right. So you will go print 8. Then you say nothing. You will go to 4. Then you will go to 2. Done. So this is how pre-order code looks like. Now let's go simply. We can quickly write the code for in order. So only one change, right? Only one change. What is that change? What is that change? So if root equal to null, what we will do? We'll simply return from there. If not, first we need to move to in order. LRR. So this is a root. So we need to first move to left of the root. So root a left. Okay. Now what you need to do? Now you need to print the data after moving to which a root data. Okay. Now after doing this, you will move to right side. So in order root right. That's it. Right. That's it. Now the one which is left is void post order. Again you will have a node star root. If that root is null, if root equal to null, you will simply return. If not, in all other cases, you will move to left side. So post order root a left. Then after moving to the left, you will move to next right. So post order root right. After moving to the right, at last you will print the root data. Root data. Done.
So let's discuss another question number 29. So the question number 29 is binary search tree. What is this binary search tree? So it is also a binary tree.
This is also a binary tree for sure, and but it will have few conditions. Okay, it is a binary tree, but it will have few conditions. What are the conditions? So if we have a root like this, okay, and all the right side to the root elements must be greater than root data, and all the left side must be less than a root data, right? So this is the condition, and which is also a binary tree. So we know what is a binary tree. So a binary tree is a tree which we can have at most we can have 2 children. Okay, so valid is 0. We can have 0 children, we can have 1 children, and we can have 2 children. So at max 2. And what is a binary tree? Binary search tree. So binary search tree is a combination of binary tree with some conditions. Okay, so what are the conditions? So if we have a root and all the left side nodes of a root must be less than the root data, and all the right side nodes of a root must be greater than the root data. Okay, and if it has followed that condition, then we can say that it is a binary search tree. Now let's try to implement one binary search tree. So let's say we have given this data 1 5 7 3, let's make it 10 here, not 1, and 12 and 13 and 4 and 18. Okay, we have given this particular array. Then we need to try to write a binary search tree for this particular array. Now first element is 10. So first at max we will check if the root is null or not. Yes, a root is null. So whatever data we get as a first, we will be keeping that as a root. Done. Then we will move on to the next guy, so which is a 5. So now what is a 5? So 5 is so I will check first whether root is null or not. So here root is not null. We have 10 here. Now and then I will check the condition. So whether this 5 is less than the root node or root data or greater than the root data. So I found that 5 is a less than the root data. So I will keep that as a my left node. Done. Now let's assume I have 17. Okay. Now I have 17. So a root is not null. Okay. Now what I will do, I will check whether which is greater than or less than. So I find that 17 is a greater than 10. So I will say 17 to the right side. Okay. Now I will go to the 3. So root is not null, and I will go to the left side again, which is 3 is less than right. So I will go to the left side again. I can see that left to the 10 is also not null. So I will say again, I will check left to the 5, right? Left to the 5. So which is a empty. Now I will say put it here. Now I will go to 12. So root is not null. Then I will 12 is greater than. So I will come to the right side, and then I can find that right side is also not null. So I will check whether 12 is less than or greater than the 17. So I find that 12 is less than 17. So I will keep this at the left side. Now the 13. What is a 13? So I will check from the root, not null. Okay. So 13 is greater than 10. So I have to come to the right side. So I found that right side is also not empty. Then I will say check whether 13 is less than or greater than 17. So which is an less than. So it has to come to the left side. So again at the left hand side, which is also not empty. Now again I need to check whether 13 is greater than 12 or less than 12. I found that which is a greater than 12. So I will go to the right hand side, which is a empty. So I will put it here. Now I have 4. Now I have 4. So 10, it has to come to the left side of the 10. So which is not empty here. Again I have 5. So 4 is less than 5. So I have to come to the 3. Now again which is not empty. So now I will compare with 3. So I can see that 4 is greater than 3. So 4. Now I have 18. So I will start here. Root is not empty. Root right is not empty. Root so then I can find that 18 is greater than 17. So I will come to the right, which is an empty. Done. So this is how you construct an binary search tree. Now if you can observe all the left subtree or values are less than root, and all the right subtree values are greater than a root. And if you can pick up any parent, you can see this particular formula. So for 17, the left side we will have 12, which is less than 17, and right side we will have 18, which is greater than 17. So this is the thing that we need to follow. Okay, this is called a binary search tree. Now let's move on to the next question. Now what is a AVL tree? So AVL tree is also a binary tree, but which follows an height balanced binary tree. What is this height balanced? So basically we will be having height, right? Let's say I have a node like this. Okay, I have tree like this. Okay, and here it is saying that height balanced. So for every node to its left and right subtree, height should be, okay, if you subtract, then let's say, let me write, okay, current balance equal to height of left subtree minus height of a right subtree must be equal to the either of -1, 0, +1. Okay, so if this current balance equal to any of these three, -1, 0 or +1, then it is an AVL tree. If not, then this is not a AVL tree. Okay, we should convert that as a AVL tree by swapping the nodes. Okay, so this is what an AVL tree is. Okay, so AVL trees are height balanced BSTs. AVL tree checks the height of a left and right subtrees and assumes the difference is not more than 1. Okay, the difference is called balance factor and is calculated as a height of left subtree minus height of right subtree. Done. Now we have a print left view of binary trees. Let's see the question number 30 first. So print left view of any binary trees. Okay, so you will be given in a binary tree. Okay, you need to print the left view. What is a left view? Okay, let's say if you are given this particular tree and you are standing here. Okay, you are standing here. Now what are all the nodes that you can see here from here? So this is the node which you can see. This is the node. This is, and this is the node which you can see. So so now what are all the nodes that you can see? You can say that 4, 2, 1, 9. Right, so this is called left view. And if they were asked you to find the right view, then what could be your answer? 4, 6, 7 and 9. 4, 6, 7, 9 for right. For left, this is the answer. So if you observe, can I say that, let's consider this as one level, one level, one level, one level. Can I say that in each level you need to print the very first element, the very first node that you can visit. So here for this particular level your answer would be 4. For this particular level your answer should be 2. For this particular level your answer should be 1, then 9. Is this what my left view? Yes. So if I print the last node, okay, if I print the last node in each of my level, then it could be my right view. Yes, can I turn this particular question to like that as well? So now how to write a logic to print all the left view nodes of an binary tree. Okay, so please pause the video for a while. Okay, think of it. Now we'll see one approach. Okay, where can we can do something like that. So we have studied about map, right? Hash map. So in this particular hash map we can store all the nodes. Okay, let's say I will call this as a one level. Okay, so for 0 For 0, this is an 0 level, this is an first level, this is a second level, and this is a third level, right? Now, so for each level, if I'm visiting the level for the first time, okay, if I'm visiting level for the first time, and whatever a node that I am getting, can I say I can put that in my map? So let me do some dry run here. Okay, so let's pick up the tree. So 4, 2, 6, and 1, and 3. Here it's a 5, and here it's a 7, and it's a 9. Now let's say currently my level, while passing, I will pass this root node and I will pass my level as a 0. And let's put some map here. Okay, map. So as of now map is empty. Okay, now first I will come here, and I will just check whether my root is null or not. If it is root null, then I don't have any nodes in that particular tree, so I should return the empty. Okay, so in this case the our root is not null. So what we can do? So I will just check, okay, before going on to the other part. Okay, I will just check if the level, okay, level can is there in my map or not. So what is my level now? Level is 0, so which is not there, right? So I can say that, so just put level and put that particular node data. What is the node data here? It's a 4. Done. Now we have seen the traversal techniques, right? So let's move on to the another guy, okay, to the left side. Now while moving on to the left side, I should do level plus 1. So currently my level is 0. Now my current level is 1. So now I will just check first whether root is null or not. So root is not null. What does it mean? It means that it has some data, so we should traverse that. So before moving on to the next left and right, what should I do? I should just check whether this particular level has been already visited or not. Okay, and what is the level now? It's a 1. Okay, level is equal to 1 now. So here level is equal to 0. Now level 1 is not occurred earlier. So what does it mean? I'm visiting it for the first time. So I should put that. So what is the data? It's a 2. Okay, done. Now I will go to the left again. Now this time level is going to be 2. Now this level is not occurred earlier, not visited earlier. So I will do 2 and 1. Now both are empty, so no need to traverse them. Then I will go to the top again, and then I will go to the right. Okay, right. Now what is the level here? Again, it's a level is 2. Okay, so currently here a level is 1. From this particular node we have called level plus 1, so it is level is equal to 2. Now tell me, if I search, level is already occurred, so 2 level is already there. So I should not modify the value. Okay, I can just ignore that and will continue with my process. So there is no right and no left. There is no right, there is no left. So I will go to the top down and I will go here. Now from level 0 here, now it's a level 0 plus 1. It is going to be level 1 here, right? Now I can say that, is there level 1 in my map? Yes, already there. So I won't do any modification over there. So simply go to there. So again, it's a level 2. So level 2 there. Yes, level 2 there. Now again, I have left here. So I will come here. So it's a level 3 now. Now tell me, is there level 3 in my map? No, not exist. So what I can do? Level 3, like a 3 key, and it's a 9. Done. Now I don't have any left and right, so I can simply go here, and from here there is no right and left. Okay, I can again come here and I can go here. So from level 1 plus 1, it's a level 2. Now already level 2 has been occurred, so I won't modify that. So there is no left, no right here. Okay, done. So I'm done with visiting all the trees. Okay, now what are all the values are there in my map? 4, 2, 1, 9. Is this what the left view of a binary tree which we have taken? Yes. So done. This is our answer, right? How? So are you able to do this on your own? Now just try for so we have wrote this thing for left view. Now try for right view. Try for right view. So what is happening for the right view? So you need to store the node data which is been occurred at the last, which is visiting at the last. So when can we visit at the last? So it is what so whatever the data you are seeing, whether it irrespective of it is already visited or not, you need to keep on modifying your data, right? Let's try it out as well. So we'll take the same thing, 4 2 6 1 3 5 7 and 3. Okay, now so here currently level is equal to 0. Let me put my map here. So now level 0 is not visited, so I will put that here, and my data is 4. Now I will go to the left side. Okay, now what is happening? I have been this is going to be level 1, and which is not occurred earlier, so I will put that as a 2. Now I will go to the level 2, which is also not visited so far, so I will put level 2 as 1. Okay, so there is no right, so I will go to the top. From here I will come here again, it is going to be level 2. Yes, level 2. Now I need to level 2 has already been visited, okay, for the first time, but we are searching for an element which is being visited at the last. So until whatever the data has been put so far, we need to modify that. Okay, so we'll modify this level 2 with the second value. Sorry, it's a 3 now. Okay, 3. Yeah, 3. Now we are done with this. So there is no ref and no right here, so we'll go to the top. From here we'll go to the here. Now we are done with this as well, so we'll go to the right side. Now this is time for the level 1. Okay, level 1 has been already occurred, right? So what we need to do, we need to modify the data as to the 6. Yes, done. Now again we'll come to the left side. Okay, if I come to the left side, it is going to be level 2. So level 2 has already been occurred, but I need to modify that, modify to the 5. Now again I have left, so it's going to be level 3. Level 3 is not occurred earlier, so I will put level 3 as 9, and there is no left, no right, so I will go to the top. Now from here I will go to the right, so there is no right, so from here I will go to the top, and from here I will go to the right. Now this time it is going to be level 2, so level 2 has already been occurred, but I need to modify that to the data currently, which is 7. Okay, which is 7. Now done. There is no left, no right. Okay, go to the top, and from here I am done with this. Go to the top, and this is what I have. So what is the data I have? 4 6 7 9. Is this my right view? Yes, I'm done. Okay, if you want to write this as a code, you can simply write this as something like this. Okay, let's say left view, and I am taking a root and a level. Okay, and I will just check if root double equal to null. What does it mean? You should return simply 0. That's it. Else, like if not, you need to check whether your map contains the particular level or not. So map dot contains is for Java. If you are C++ coder, it is going to be this find. Okay, contains a level, so it will return either true or false here. So if it is contains, then it should return true. Okay, so when and only if you get false, then you need to put mp dot put what is the level comma root data. Okay, and in all other cases you need to go to the left, and left. While moving on to the left, then you say left view or root to the left and a level plus 1. So here it's a point. Okay, so since it's a Java, it's in class based. Okay, now it's a, if you are moving right, left view, root dot right and level plus 1. So at the end just return. Okay, like this map is going to be either you can pass it as a reference, or you can take that as a global variable. So at the end you can traverse through all the values which are there in the map, then you will get it. Okay, this is one way. Okay, this is one way. There is another way where you can maintain a global variable. Okay, global variable called max level. So you know that you will be visiting each node for the first time. So if you're you will be initializing your max level as -1 in the beginning, and if you are visiting like so instead of this particular code, you can just check if your max level less than current level. Okay, so you have initialized max as global variable. Okay, then what you can do, you can update your max level equal to current level, and you can you can just print cout root data. Or if they ask you to return all the left view nodes in the form of a vector, then you can just create a take a vector like output dot pushback root data. Okay, so in this case you are not using an extra memory here. Okay, so you are eliminating this map, that's it. And you guys know sometimes a map will take login time. So in this case, yeah, it mostly big of 1, but yeah. And this is using DFS technique. Okay, and if you wanted to use BFS technique, even that you can try out as well. So in this case you will be using Q. Okay, so try it out. Okay, we have discussed how to print all the nodes using BFS technique, right? So try it for this particular problem. Now let's move on to the next problem. Yes, what is a graph data structure? What is a graph? So a graph is a type of nonlinear data structure that consists of vertices and nodes connected by a edges or links for storing data. Okay, edges connecting the nodes may be directed or undirected. So here we'll discuss that. Okay, so here let me draw the same thing again. So A, then A to B and A to E, C. Okay, now this is a graph. You can consider this as one area in your city, and you can consider this as one area, this as one area, this as one area, and this as one area. So now let's try to relate this thing. Okay, if you are standing at area some A, okay, now from this you will be having two choices. Okay, two streets. Okay, if you are standing in a circle, you will be having two choices. Either if you can go in this particular path, you can reach to the B. If you go in this particular street, you will reach to the E. Okay, so again from E, again you have a path to the D. Okay, you can either reach to D, okay, or A. So if you come back in the same path which you have ended, okay, which you have came till now, and from B, if you have visited in this particular path, for B as well, you can, if you follow the same path which you have came in, then you will be reaching to the A, and if you have chosen different path, you will be reaching to the C. Now from D as well, you have three choices, either B, E, C. So you can, again you will be having two choices, either you can go to the B or you can go to the C, and you can traverse to the same path which you have coming from. Okay, so here you can consider this as a edge. This is called as a edge. What is this? So this edge helps us to connect the two vertices or two nodes. Okay, this is called as an either vertex or a node. Okay, now this is what a graph means, and yeah, we have seen directed and indirected. So basically a graph will be of two types. Okay, a directed graph, undirected graph. What does this mean? Okay, so directed means, let's say I have all the edges which are representing some path. So so now here there is some directions, right, where edge is representing 2. So from A, now you can go to only to the B. Okay, you can't go to the E because there is no path here. So the path here is you can traverse from E to A only. Okay, so you can see these arrow marks, right? So this arrow mark represents the directions which you can traverse through. So this is called directed graph, and this is called undirected graph. Undirected, it is a directed. Okay, so directed means where your edges will be pointing to the node which you can traverse from the current vertex, and undirected graph won't have any directions. It means like it's a bidirectional. You can either go and you can come back on the same path. Okay, that's it. And the next question is, what are the applications of data structure, graph data structure? So which means where can we use graph data structure? So graphs are used in a wide varieties of applications. Some of them are as follows. Social network graphs to determine flow of information in social media websites like Facebook, LinkedIn. So this is the one of the major application of a graph data structure. What it is? Social media. What is social media? How graph is being used in social media? So everyone uses social media nowadays. Even I know, like when I was in my very first year, I don't even know. I use Facebook, but I don't know what is being happening over there. So whenever I was started studying graph, I got to know that yes, this is the algorithm where they were using. So now let's say profile A. Okay, there is a profile A, and profile A has around let's say 2 friends. Okay, let's put it as a undirectional only. So 3 friends, B, C and D, and again B will have a few more friends. Yes, so let's say you can call them as a E, F, and even B and C are also a friends. Okay, now a C and like C has few friends, okay, H and D and a G. Now, so how does a social media work? So let's say A has posted one post. Okay, so A has posted some photo. Now it will reach to the B, C and D. Okay, suppose B has liked this particular post or commented this particular post. Now this particular post will be shown to the E, F, means all the people, all the connections of a B as well. So this is how a social media work. Suppose if D has commented or posted your post, okay, A's post, then the friends of D can see the post. Okay, the friends of this is how connection has been made. Okay, this is how social media is being working. Even the one of the major application of graph is Google Maps. Let's say we have a Bangalore and Mumbai and some Hyderabad and Pune, and these are all the cities that you have, and you need to go to the Goa, let's assume. Okay, so I don't know what is a minimum path, but let's assume few things. So from Bangalore to I just wanted to go to the Goa. Okay, now let's assume the path is I need to come to the Mumbai and I can go to the Goa. Now let's say Mumbai to Bangalore, it will take 2 hours of flight journey, and from Mumbai to Goa it will take 2 hours of flight journey. And there is another option for me. If I can come to Pune, then from Pune as well I can go to Goa. So let's say from Bangalore to Pune it will take 3 hours. So and Pune to Goa it will take 2 hours again. Now from there is another path, okay, from Bangalore to Hyderabad it will take a 1 hour, and Hyderabad to Goa it will take 2 hours. Now my question is, if I take which path, okay, which path I can reach the Goa in minimal time? Now this is the question, okay, the answer is up to you. Okay, this is how a Google Maps works, right? So where you will be having different options, but Google Map is suggesting you the best path, okay, that you can reach your end destination in a minimal time, right? So here in this way you will choose this particular path, right? From Bangalore you go to the Hyderabad, from Hyderabad you go to the Goa. So here what is the amount of time that you are taking? It's at 3 hours, which is the minimum among all the path. If you have went in this particular path, it should have taken 4 hours. If you have taken this particular path, it could have taken 5 hours. So if you are following this particular path, it will take 3 hours. So this is how a Google Maps works, and this is where your graph data structure comes into picture. So this is called as an shortest distance as well. Okay, you will be having different algorithms for this, like Dijkstra. Okay, and yeah, so you will be having different options right there, and we will be having different algorithms as well. Based upon that, it will be recommending you the minimum time. Okay, so and second one is neural networks graph, where a nodes represent neurons and edge represents synapses between them. So neural networks are one of the applications of artificial intelligence, or category of artificial intelligence. In that as well, we will be using concept of graph data structure. And transport grids, where stations are the nodes and routes are the edges of the graphs. So this is the example which we have shown. And power or water utility graphs, where vertices are connection points and edge the wire or pipes connecting them. So this is a true real world problem. Okay, so like a water line or a power lines. Okay, and the shortest distance between two endpoint algorithms. So this is where, so if I wanted to go to Goa from Bangalore, so this is where shortest distance come picture. Now let's see the next question. So how do you represent a graph? So yeah, we have two ways to represent a graph. One is adjacency matrix and another one is adjacency list. So adjacency matrix will contain only zeros and ones, okay, where a 0 represents there exists a edge, and the 0 exists represents no edge. Okay, if you observe here, so we have a P, Q, R, S, T. Okay, now we will be taking like vertices into a vertices matrix. Like if you taken this example, we will be having 5 vertices and we will be having 5, so we need to take 5 into 5 matrix. So PQRST, PQRST. Now wherever there exists a path, just put it as a 1 over there. So P to Q, there exists a path, so P to Q you will put 1. And also, since it's in direction, okay, undirected graph, you need to put the both the cases, like P to Q, Q to P. Okay, so Q to P as well you will put a 1. Okay, now this is how you fill this particular matrix. And there is another way. Okay, what is that way? So is adjacency list. So mostly people prefer this over adjacency matrix over matrix. Okay, it's an easy to accessible and little efficient as well. So here what is the thing? So you will take an hash map, like kind of vector of array. Okay, let's say if you have taken an array like this, so where you will be having all your vertices like P, Q, R, S, T. Okay, then you will create a vector here for each node, where you will be putting all your path. Okay, from P to Q you can go, from P you can go to Q as well. So you will create Q. Okay, and it's an directed graph. Okay, there is, okay, so yeah, this is a directed graph, means you can go to the only the way which where your arrow will be pointing towards. Okay, now from P you can go to R as well. Okay, so you will put a R here. That's about the P. Now let's go to the R. Okay, so from R you can go to the S. That's the only choice you have, so S. Now from Q you can go to S, you can go to T. Okay, S and T. Done. Now from S you can go to P, you can go to S itself. Okay, so you can go to P, you can go to S, and you can go to T as well. Okay, and from T you can't go anywhere, so it's an end here. Okay, this is how an adjacency list looks like. Okay, now we'll try to code all of these whatever we have seen so far, and also there is a concept called graph traversal techniques. Okay, so what is this graph traversal techniques? So these graph traversal techniques are DFS and BFS. What are these? So we will be given this graph, right? Like how to traverse through entire graph. Okay, traverse means where we can go to each and every node in case of graph. Okay, so for that we will be having two approaches. One is DFS and one is BFS. So a DFS follows a recursive approach and BFS follows an iterative approach. And a BFS uses data structure called queue, and a DFS, since it's an recursive approach, it will use a stack. Okay, now we'll try to understand what is this traversal techniques and how to how to code them, and how to represent our graph in adjacency matrix and adjacency list.
In this tutorial, we will be learning about graph traversal algorithms, and namely breadth first search and depth first search. So coming to prerequisites, it will be good if you know how to represent a graph using either Java or C++. But in this particular video, I will be coding in C++. Okay. So yeah, without wasting any time, let's get started. Before starting, if you are visiting channel for the first time, please don't forget to subscribe. And if you like the content, please hit that like button up. And if you have any queries or questions, please let us know in the comment section. Now let's first discuss a breadth first search, then we'll see depth first search. Okay, so probably if you have seen my earlier video which was on trees, you might end up hearing this word called a BFS over there. So yes, like what is the difference? So in this video we will be talking about graph. So the same topic now, BFS. So there also BFS, here also BFS, both are same, right? No. Okay, so these are all different because the data structure has been different. So trees and graphs. So again, so you might, if you know what is a graph earlier, so you might think that yes, we do have nodes here, we do have adjacencies here, like we do have edges, and we will travel from one edge node to another node. Okay, that's it, right? So yes, but the difference is in trees usually there will be no cycles. So what is a cycle? Let's say you have a node like this. Okay, you have a tree something like this. So now you will start visiting from here. Okay, you will go here, then you will go here, then you will go here, again you will come here again. So it is never ending process, right? Just because of the fact that you never see a route which is a null, right? So it will go in an infinite loop or infinite recursive calls. Now what is the solution? So basically, so you won't see this kind of situation in trees. Okay, but in graphs we do have that situation. Okay, so where you will be having cyclic graphs. Okay, so graphs are being, we have a different graphs. Okay, directed, undirected, cyclic and acyclic graphs. So here we need to handle both. Okay, so for that we are having something special for graphs. Okay, so let's see. So first we'll see one example where we can find BFS for that particular graph. We'll see couple of examples until we get some familiar about how BFS works in a graph. Then we'll jump on to the logical. Then we'll see coding part. Okay, let's start. So let's see. We have a graph like this. So 1 and 2. then 4 and 5. Okay, so from here you will have a, so here, then here. Okay, now first you will start from here 1. Okay, you will visit this guy, and let's assume this is your output. Okay, now tell me what are all the adjacents to the 1. These are all the adjacents. So what is meant by adjacents? So the nodes are vertices. So basically we call these particular things as a vertices in a graph. In tree we call them as a nodes. Okay, so here can I say there is some path from 1 to 2 and 1 to 3. So if there exists a path, then I can say that they are adjacencies. Okay, so from 1 there is a path from 2. Okay, from 1 there is a path to 2 and 3. So I will first visit 1, then I will go to 2, then I will visit 3. Okay, good. Now what is the next element? So I will go to 2. Okay, and I will travel. Okay, I will go to all the adjacencies of 2. Okay, what are all the adjacents of a 2? It's a 4, 5 and 1. Okay, so did we visited 1 already? Yes, we have seen 1 already. So we'll print 4 and 5. Done. So now we will go to 3. So what are all the adjacencies of 3? It's a 1 and 5. So we have visited 1 already here, and we have also visited 5. 2 done, 3 done, 1 done, 4 done, 5 done. Okay, so we have visited 5 as well. Okay, now you will go to 4. Okay, what are all the adjacents of a 4? 2, 5 or 6. Okay, so you have visited 2, you have visited 5, right? So you will left with 6. So you will add a visit here, like you will visit that particular 6 now. Now it's a 5. So what are all the adjacents of a 5? 3, 6, 4, 2. Okay, 3, 6, 4, 2. So you are done with 2, you are done with 3, you are done with 4, you are done with 6. So you won't add anything. Okay, from you will at last you will come to 6. What is a 6? So what are all the adjacents of a 6? 4, 5. Okay, so you have visited 4 already, you have visited 5 already. So can I say that now on this node I have visited all the nodes, visited all nodes, all vertices. Done. Okay, so hope you got some idea how BFS works. Now we'll see another example. Okay, another good example, so that you will get some clear picture about how this BFS algorithm works. Okay, so let's take another tree and we'll see. So graph, sorry, 1 have 2 and 3, and for 2 you have a 4, and for 2 there is a 5 as well, and there is a cycle, and you have another node. Yeah, and surprisingly we have another graph here. Let's say 7 and 8. Okay, 7 and 8. So is this a valid graph? You might have that question, is this a valid graph? Yes, this is a valid graph. So basically this entire graph will cause a one component, and this one entire graph will cause another component graph. Okay, so there will be a lot of questions, like there is some important questions based upon this component graphs. Okay, so hopefully we'll see them in next videos. So here now let's say I will start with 1. Okay, I will start with 1. So I will put a 1 here. Now what are all the adjacents to the 1? Say 2 and 3. So I will pick up a 2. Now I will go to all the adjacents of a 2. So who are all the 3. So now I will go to adjacents of a 3. So it's a 5, 4, 1. Okay, so 1 is already visited, 5 and 4. So you will have a 5 and 4. Done. So I have completed 1, I have completed 2. Now I have 3. So 1, 4, that's it, right? So I have already visited 1, I have already visited 4. So I'm done with 3. So now I will go to 5. So for 5, who are all the adjacents? It's a 2, 4, 6. Okay, 2, 4, 6. So 2 already done, 4 already done. So there is only left with 6. We'll add that. Now we'll go to 4. Okay, so for 4, 2, 5, 6, 3. Okay, 2 done, 3 done, 5 done, 6 done. Okay, there is nothing to add. Now we'll go to 6. Okay, so for 6, who are all the adjacents? 5 and 4. Okay, 4 done, 5 done. Okay, so on this node I'm done, so there is nothing to visit again. Now here one thing. So is this also a graph? We need to traverse this as well. Okay, so I will again start from this node. Okay, so then I will add 7. Okay, now who are all the adjacent to the 7? It's a 8. Now we'll complete at 7 and now we'll go to 8. So is there anything connected to the 8? Yes, it's a 7. So already 7 is visited. So we are done with here. Now there is nothing to add to the next. So this is how it works. Okay, now let's see how our logic will be for BFS. Okay, so listen carefully. So which is very important concept for any interviews. If you are attempting, like if you are attempting some good product based companies, these are all the questions that are going to target. Okay, you might think that this is just an traversal algorithm. Don't think like that. This is beyond that. Okay, this is beyond that. You can solve a lot of problems using this particular BFS and DFS algorithms in a graph. Okay, now let's take one good graph and we'll try to build our logic by using that graph. Okay, let's say I have it graph something like this: 1, then 2, 3, 4. Okay, I will have 5, 6 and 7, 8, 9. Okay, so from here, here. Okay, so first thing, so whenever you have given a graph, you need to draw an adjacency list. Okay, you need to form an adjacency list of that particular graph. So you might be wondering what is adjacency list. So you can consider, if you are a C++ coder, so you might think as a vector of list. Okay, and generally there were two ways to represent a graph. So one is adjacency matrix and another one is adjacency list. So in adjacency matrix, you will represent the graph in terms of ones and zeros, where you will be taking vertices to the vertices. Okay, so how many, like if there were 9 vertices in a graph, you will take 9 columns and 9 rows. It's a 9 by 9 matrix. And you will be, if there is a path from one particular vertices to one particular vertices, let's say 1, 2, 3, you will represent a 1 over there. If there is no path between 1 and 3, you will represent 0. Okay, so it contains only zeros and ones. Okay, so that is how adjacency matrix is going to look like. And while coming to adjacency list, so here you will be having a vector of list. Okay, let's see how. So adjacency list. So basically, let's say you will pick up node 1, okay, vertices 1, and tell me who are all the adjacent to the particular vertices, like 1, so 2, 4, right? 2, 1, 4. You are done with 1. Now you will go to next, you will go to 2. Who are all the adjacents to the 1, 2, sorry. So 1, 3 and 5. You will have completed this. Now you will go to 3. Who are all the adjacents to the 3? It's a 2, 7, 4. 2, 7, 4. Now we will go to next one, this 4. Who are all the adjacents to the 4? So 1, 3. 1, 3. Then you will go to 5. It's a 2, 6. Now you will go to 6. It's a 5, 7. Now we will go to 7. It's a 3, 8, 6. Now we will go to a 8. So it's a 7, 9. Then you will go to a 9. It's a 8. Okay, so from 7 you have 3. Okay, done. So this is the adjacency list looks like. So you can call this as a, or you can consider this as a vector index. Okay, so one index, and for one index you will be having a list. Okay, list means you can consider the array. Okay, vector of array. So where you will be having 2, 4 and all. Okay, so the idea is you will stick to that particular vertex. Okay, then you will traverse to that particular array, so that you will get in all the adjacencies of that particular vertex. So that's it. So now we'll see how we will implement BFS by using this for this particular graph. Okay, so you will have a visited array or vector. Why this? So earlier, so what is the problem that we have identified in trees? So you are visiting the same node for the multiple times. Okay, so the same thing happens in graph as well. Yes, right? Don't you think? Yes. So to reduce that particular problem, we are having a visitor array where you will be keeping all the visited vertices. Okay, so with zeros and ones. Okay, you can consider 0 means not visited, 1 means visited. So by default, we will be filling them with zeros. By means that we are not visited. Okay, so how much indexes we need to take? So it will be, so if you have n vertices, you need to take n plus 1 vector array, just because of the fact that we will be starting from the 1th index, 1th vertices. Okay, so let's take an array, looks like this. So we do have 9 vertices, so I have to take 10. Okay, so starting from 0 1 2 3 4 5 6 7 8 9. Okay, so this. Okay, now you will fill all the zeros over there. You can consider, okay, if you don't like consuming a lot of memory, you can use a bool as well, which takes 1 byte only. Okay, for bool you can consider false as an not visited and 1 as a visited, sorry, true as a visited. And also you will be having another thing, what is called a queue data structure. What is a queue? A queue is a data structure which follows the principles of first in, first out. Like whoever comes into the first, they will go out first. That's it. Okay, now we'll see how that works. Okay, so this is a queue and this is a visitor array. Okay, so first we'll start with this 1. Now tell me, is that 1 visited? No. So what you will do? So you will call a BFS, like assume like that. Okay, so now you are visited, sorry, in BFS. Now we will mark this guy, this particular 1 as a visited. Okay, 1 as visited, so 1. Now you will enqueue this particular vertex into the queue. Okay, you will say 1. Okay, done. Now what I need to do? I need to visit all the adjacents of a 1, right? So I will iterate in a loop. Okay, so I will enqueue all the adjacencies of this 1. Okay, if they are not visited. Okay, if they are visited, no problems, they will be in my output, right? So if they are not visited, I will push enqueue all of them into my queue. So it will be first 2, then 4. So on this note, I can say that I'm done with 1. So whenever I'm done with this particular guy, I will push that into my output, like I will print that into my output. So let's say this is my output. Okay, so 1, I got 1. Now is that queue empty? No. I will pick up this guy and I will visit all the adjacents of that particular vertices. Now before that, what I will do, I will mark this guy as a visited. Okay, so 2. Okay, here 1. Now I will enqueue all the adjacents of a 2. So what are all they? 1 3 5. 1 is already visited, right? 1 is already visited. Is 3 visited? No. So I will push that 3. Now is that 5 visited? No. So I will push 5 as well. Done. Now what I will do? So on that node, I can say that I am done with the 2. So I will erase that. Okay. Now the next one is 4. Okay. So first I will mark 4 as a visited. Now I will go through all the adjacents of a 4. So who are all the adjacents of a 4? It's a 1 and 3. So is 1 already visited? Yes, already visited. Okay, so sorry, I forgot to overwrite this. Yeah. Okay, so now 1 already visited. Yes. So is 3 already visited? Yes. Is 3 also visited, right? So you are done with 4. So you will print output that. Now you will come to 3. Okay. Now what are all the adjacents to the 3? 2, 7, 4. Okay. Is 2 visited? Yes. 2 is already visited. Then 7 is visited? No. So you will mark 7 as a visited and push it to the queue. Now is 4 visited? Yes, 4 is already visited. Okay. So you don't need to worry about that. You have completed this and this. Okay. Okay. So you are done with 3 and you will add the output. Now 5. So who are all the adjacents to the 5? 2 and 6. Is 2 visited? Yes, it's already visited. So no work with 2. Is 6 visited? No. So you will mark it as a visited and you will push it to queue. Now, so you are done with 5 as well. So I will print it to the output board. Okay, now it says 7. For all the adjacents to the 7, 3. So 3 done, yes, already visited. So is 8 visited? No. So you will mark it as a visited and push it to the queue. Now 6 already visited, no work. Okay, done. So I am done with 7 as well. So I will print it to my output board. Now 6. So who are all the adjacents to the 6? It's a 5 and 7. 5 already visited, yes. 7 already visited, yes. Okay, no work. So you are done with 6 as well. Okay, we'll print 6 here. Done. Now it's a 8. Who are all the adjacents of 8? 7 and 9. So 7 already visited, yes. So no work. So is 9 visited? No. So you will mark it as a visited and you will push that to the queue. And on this note, you can say I'm done with 8. Okay, so you will put that in the output board. Now it's a 9. Okay, so who are all the adjacents to the 9? It's a 8. So is 8 visited? Yes, it's a visited. So no work. So on that note, I can say that I'm done with 9 as well. So did we covered all the vertices? Let's see. Okay, so did I visited 1? Yes. 2? Yes. 3? Yes. 4? Yes. 5? Yes. 7? Yes. 6? Yes. 8? 9. Done. So this is how binary best first search algorithm looks like. Okay, so without wasting any time, let's go on code for this particular approach. So now let's discuss the C++ code of an BFS algo. Now first we will be taking two inputs from the user. One is vertices and the edges. So vertices are the number of vertices we will be having in particular graph. And again, I am saying that it's an one based indexing graph. Okay, so means I will be starting the vertices names from 1. Okay, now edges. So why we need edges? So it will represent the how many edges we are having in entire graph, so that we can iterate that many times and we can form an adjacency list. Okay, so we'll see that now. So for that, to form an adjacency list, I will be creating array of vector. Okay, where so for one particular array we will be having indexes, right? So how many indexes we will be having? So vertices are 9. Okay, so since we are considering one based indexing, we will be using vertices plus 1. Okay, plus 1, and then it's a vector. Okay, so here in loop we are iterating throughout the number of edges we will be having, and for every time we will be taking two inputs. One is from vertex, another one is a two vertex. Okay, so we will be taking that and we will be forming an graph adjacency. So why 2? So you are forming u to v and v to u. So why? So basically, since it's an undirected graph, okay, so we might have an both sides, right? So let's say I have a path from 1 to 2. It is equivalently to 2 to 1 as well, right? So that's why it's okay if you use only one thing, like if you form only one edge, that's totally okay. Okay, not a big problem. Now let's see. So now I'm assuming that you have a adjacency list, okay, which is having all the edges. Now we will be having a visited vector. So where initially we will be storing all the zeros. Okay, initially we will be storing all the zeros in it. Now we will be starting from the 1. Okay, always my starting point is 1. So I represent the BFS starts from 1. So here I am passing visited vector and adjacency list. Okay, now I will go here. Now here what happened? So first whatever I started like, so I will make that start as visited first, right? 1 represents visited, 0 represents not visited. So I will make it as a 1. Then I will create a queue. Okay, in that queue I will firstly push that starting point. Okay, now I will iterate through the queue until that queue is empty. Okay, so since my queue is not empty now, I will enter into the loop and I will make a friend. Like what is a friend happens? So it will give me that top element. Okay, so first element. So what is the first element? It's a 1 now. So my current vertices is 1. Now I will pop that 1. So I will remove that. Okay, now I will print that onto my output screen. Now I will iterate throughout that, like I will move to all the adjacents of that current vertex, right? 1. So this is how I can use now. So I will, let's assume, okay, so from 1 first vertex we do have a 2 and 3. Okay, first I will go to 2 and I will check whether if that is a visited or not. If that is a visited, it could have been a 1. if that is not a 0. So if it is 0, I will enter into this particular if block. Okay, now if it is 0, what I will do, I will first mark it as a visited, then I will push it to my queue, right? I am doing that. I will go to 3. Okay, now I will do the same. Okay, now after doing, I will come here again loop. Okay, so my queue is not empty, so again I will repeat the same for current value vertex is 2 now, right? So I have popped out that 1. Okay, so it will do all these things until this queue is empty. When this will become empty, it will become empty when all the vertices are visited. Okay, so what visited vector will become 1, all ones. Okay, so this is how a code looks like for a normal BFS, like if it's a component graph. But we have discussed something different, right? What is that something different? So here you might have a graph like this. So here, right? So I will pass 1 here and I will done with this particular graph. Now what about this graph? So I have to repeat the same again, right? I need to repeat the again. So since I don't know what is the starting point, always. So what I will do now, I will return a loop. Okay, let's say, which will starts from 0 and goes on till vertex plus 1. Okay, and I will check if that particular I is visited. If it is not visited, okay, I will go. Okay, so first 1, okay, I will go. I will call BFS and visited and adjacents. Done. Okay, so I will visit all this graph, right? I'm done with this graph. Now again come. So I will come after this loop and I will say increment to 1 to 2. So I will make my 1 as 2 now. So 2 is already visited. Yes, it's visited. So why? So I'm passing this visit as my reference. Okay, so whenever it will visited, it will get updated here as well, and I will mark it as 1. So 3 visited, 4 visited, now 5. I is 5 now. So is 5 visited now? No, 5 is not visited. So what I will do, I will make a call to BFS. Okay, now it will do this thing. So again I will come back and I will say 6 already visited. Done. So this is how code looks like. Okay, so nothing much. Okay, so it's just an loop. So I will remove that here and I will make int I equal to 1 and I will say iterate to vertices I plus plus. Okay, so if visited of I is not equal to 0, if not equal to 1, I need to say BFS of I and visited and adjacency. That's it. This is how the code looks like. Okay, so if you are in an interview, it will be good. Okay, so interviewer expects you to write this coding like Algo for to have in multiple components. But if you are still have that doubt what to write, you can ask your interviewer. Okay, so can I assume is there only one component in this graph or multiple components exist? Okay, so the complexity of this approach looks like, you can guess, right? So yeah, it will be mostly big O of n since we are visiting all the vertices, and you might think, yes, we are doing for couple of times, right? So we are calling here and we are having, in worst case we will be, so let's say it's a one component, then it will be big O of n first time. Now again I am calling all these vertices, so you might think it's a big O of n plus 1, n into n, but if you carefully observe, it will end up at n plus n. Okay, so I can say that max it will be big O of n. And coming to space complexity, so here you will be using this, okay, visitor array. So for that you will be using big O of n, like big O of vertices, number of vertices. Then also you are using a queue here, right? A queue. So again, at worst it might take big O of n, right? So you can have a big O of n plus 1, it will be, you can say that, but it's okay. So if you can say big O of n as well, okay, be accurate. Okay, so try to figure it on your own. Okay, that will be a good practice. Okay, cool. Now let's discuss the DFS. What is a DFS? A depth first search. Depth. Okay, depth. Okay, let's see. Okay, so we'll consider a small graph. Okay, so 1, and from 1 to 3, and from 2 it's a 4 and it's a 5, and 3 to 5 and here. Okay, so this is a graph we have given, and you asked you to find the DFS of this particular graph. So how do you start? So let's say we'll start from 1. Okay, I will say 1. Now, so in DFS we have moved simultaneously to all the adjacents of a particular vertex, but in DFS we don't do that. We'll pick up one of its adjacent and we'll traverse all of its particular adjacents. Okay, so like let's say, so now what are all the adjacents of a 1? Say either 2 and 3. Okay, we'll pick up 2 first. Okay, now we'll pick up 2. Okay, so from 2, who are all the adjacents to the 2? 4 and 1. Is 1 already visited? Yes, it's already visited, so we don't need that. So we'll say we'll go to 4 now. Now from 4, what are all the possible adjacents? 2, 3, 5, 6. Right? Now is 3 visited? No. So you will say I will go to 3. Now I am currently here. Now what are all the adjacencies of a 3? It's a 1, 5, 4. So 4 already visited, 1 already visited. Now I'll go to 5. Now from 5, who are all the adjacents of a 5? 3, 4, 6. 3 already visited, 4 already visited. Now I will go to 6. So from 6, is there any unvisited? Is there like what are all the adjacents? It's a 4, 5. So 4 is already visited, 5 is already visited. So nothing to go. Okay. Now I will check all other vertices where I left. Okay. So in this way, it looks like this is the DFS of this particular graph. Is there any other solution? Yes. So at beginning, instead of going at the 2, I will go at the 3 now. Okay. So first I will visit 1, then I will go to 3 path. Now what is the from 3? What are all the possible ways we have? I can go to 1, I can go to 5, I can go to 4. So now I will pick up, I say I know that 1 is already visited. Now I have to go either 4 or 5. So I will go to 5. Okay. Now from 5, what are all the adjacencies? 3, 4, 6. Okay. Now I know that 3 is already visited. Okay, 3 is already visited. Now I can choose 6 now. I will choose 6. Okay. Now from 6, I have 5, 4. Okay, 5 is already visited. Okay, I will go to 4. Okay, I will go to 4. Now currently I am at here. Now what are all the adjacencies of 4? 2, 3, 5, 6. Okay, so 3 visited, 5 visited, 6 visited. So I will go to 2. Okay, so from 2 I will go to either 4 or 1. Okay, so since both are already visited, I can stop here. That's it. So this is also an correct solution. Okay, so on this note I can say that there might be a different solutions for one particular graph. Okay, so it depends upon how you are going and what text you are currently picking up. Okay, so now let's simply jump into our logic. Okay, so I will take up simple a graph. Let's say I have a 1, then 2, then 3, 4, 5, 6. So this is one component. Have another component, let's say 7 and 8. Okay, so now first step, we need to find the adjacency of this particular graph, adjacency list. So how does it looks like? So we have first one index, so first vertex. Who are all the adjacents of the first? 2, 3. So and for 2 it's a 1, 4, and for 3 it's a 1, 5, and for 4 it's a 2, 6, 5, and for a 5 it's a 3, 4, and for 6 it's a 4, for 7 it's a 8, and 8 it's a 7. Okay, this is the adjacency of this particular graph. Now let's see. So first thing is first, we do have one visited array. Okay, where it will be by default it will be marked as all the zeros. So here, since we have 8 vertices, it will be 8 plus 1, it's a totally 9. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so let's write the indexes of this. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now so all these were filled with zeros. Now how this works? Now basically this DFS is an recursive algorithm. Okay, so if you are in an interview, they are not interested in recursive manner, so you know how to write, right? By using stack. Okay, you can write this in an iterator approach by using stack. Okay, but let's see. Okay, so I will tell you recursive approach, but it's your job to write the iterative approach. Okay, so it's very easy. I gave a hint, right? Try it on your own. So let's say first I will start from 1. Okay, so while discussing the code of BFS, I have shown you how to, if the given graph is an component based graph, so if you have different components, I have shown you how to traverse to that, right? So for I is equal to 1 to vertices plus 1. Okay, if that vertex is not visited, I can say that do DFS of that particular vertex. That's it. Okay, this is how it looks like. So first we'll start from a DFS of a 1. Okay, so from here, what are all the ways? So I have 2 and 3. Okay, I have 2 and 3. So I will pick up this time. I will go with 2 side. Okay, so DFS of 2. So before moving on to DFS of 2, I will mark DFS 1 as visited. 1 as visited. Now since I started 2, I will mark it as a visited. Okay, now from 2 where I can go. Okay, so on my output board I can say that till now I have 1 and 2. Okay, so now again what are the adjacents of 2? It's a 1 and 4. Okay, so I know that 1 is already visited and I will go with 4 now. So DFS of 4. Okay, cool. 4 done, 2 done, 1 as well done. Okay, 1 is also visited. Now so from 4, who are all the adjacents? So before moving on, I will mark it as a visited. Now who are all the adjacents? It's a 2, 6, 5. Okay, since I know that 2 is already visited, okay, I will go with next element called 6. Okay, 6. So before moving on, I will mark it as a 1. DFS of 6. Okay, cool. Now who are all the adjacents of 6? It's a 4. Okay, I know that 4 is already visited, right? Visited. Now I will go with, so since we are here, so 6 we have been to 4. Okay, now for 4 we have been done with 6. Okay, so we come here. Okay, we'll come here. So for 4 we have another option called DFS of 5, right? So there is no going from here. So after 6 we have only 4. 4 is already visited, so we'll come back to the top like previous call and we'll go to the next adjacency of that particular vertices. So it's a 5. Okay, I will mark 5 as a 1 and I will go to the 5 now. So for 5 it's a 3 and 4. Okay, so first I will go to check with 3. So is 3 visited? No. So I will mark it as a visited and I will go DFS of 3. Okay, now how does it look like? So since I am at 3, who are all the adjacents of 3? It's a 1 and 5. Okay, 1 and 5. So 1 already visited, 5 already visited. Okay, 1 already visited and 5 already visited. So there is no mid away from 3. Okay, it's blocked. So I will go to top. So for 5, so 3 done and 4 left. So is 4 already visited? Yes, visited. Now again I will go to 4. So out of 4 is also done, 5 is also done. Now from top of the 4, I will go to 2. Okay, so is there anything left in 2? No. From again I will go here. There is nothing in here as well. Okay, so 3 we left with 3. So 3 is already visited. So till now we have on our output to 1, 2, 4, 6, 5, 3. Okay, so happens, stop. Okay, so this is what happens. Now what I will do? So I will go to my main now. So all this happens for first one. Okay, so first iteration. So I is equal to first. Now what I will do? I will go with, I will increment my I to 2. Okay, so is 2 visited? Yes. 3 visited, 4 visited, 5 visited, 6 visited. Now currently I am at 7. So 7 is not visited. Okay, what I will do? So I will make a call to DFS of a 7. Okay, so I will mark it as a visited and I will put it on my output. Now what happens? So from 7, who are all the adjacents? It's 8. I will make a DFS of 8, mark it as a 1. Okay, so from 8, who are all the adjacents? It is 7. 7 is already visited. Okay, so blocked. Okay, I will come here. Is there anything to visit from 7? No. So I will return to main. So from main, I will increment my I. So it's 8 now. 8 is already visited. So that's it. Okay. So did we cover all the vertices? 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I highly recommend you to take another graph and try out this approach. Okay. So it's very, very important. Okay. So now let's see the coding part of this particular DFS. Now let's discuss the C++ code of our DFS algorithm. So it's the same like before, like till creating an adjacency list, it's same as BFS. Okay, so we have seen that earlier. So till here, it's the same. Okay, so after we have adjacency list, we will be doing something different. Okay, so not much. Okay, so let's see. So first we will be having a vertices. Okay, so visited array. Okay, where we would be initializing with a 0 by default. If it is visited, we will be marking it as a 1. Okay, then so here I am assuming in case of components. Okay, we have different components to visit. Okay, so if it is not, it's very simple, right? So you will say a DFS of, you will start with 1 and you will go visited and you will go adjacent. That's it. So it's as simple as that. If since it is a different components, it has different components, I am making it as a for loop and I am traversing to all the vertices and I am checking if that particular vertex is visited. I won't go anywhere. If that particular is not visited, I will call DFS. Okay, so since 1 is not visited, I will call DFS for 1 and I will come here. Okay, I will come here. So since my start is 1, right? Then I will say, so I will take visited vector and adjacency. Now I will marking a visited of start as a 1 since I started visiting. So and I will print the start as well. Okay, now I will iterate through all the adjacents of a particular start. Okay, so let's see. So first I got let's say I have an adjacency from 1 to 2. So I will pick up 2 and I will start DFS. Okay, so here, so again I will go to make a recursive call for 2 and I will again start, right? So if there is a 2 has 3 and I will again start for 3. So it's gone like that. So since that is why it's called as a depth wise. Okay, so it will reach till the depth, so till the last vertex, and then if it does particular vertex doesn't have any next vertex to go, then it will make a call to come back. Okay, it will go to previous call, then it will go to previous, and it will from that previous call, if there is any adjacency to visit, then it will do that. Okay, so I will keep on doing that, and if that happens, okay, so I will come back here and now I'm done with 1. Now I will check with 2. Since 2 is visited, again 3 visited, 4 visited, 5 visited, 6 visited, 7. Yes. So hope you have remembered our example, right? 7 is not visited. So I will make a call to 7. So I will mark 7 as visited here. Okay, I will print 7 in my output board and I will go through all the adjacency of a 7. Okay. Now what is the adjacency of a 7? It's 8, right? So I know that it's a not visited, so I will make a call to DFS of 8. Okay, I will visit that again and I will mark it as a visit and I will print it on my output board, and from 8 there is only 7 which is already visited. Okay, nothing to go. Okay, so I will come back to this loop. That's how it works. Okay, so that's as simple as that. Okay, so again I'm saying that these two algorithms are very, very important in perspective of interviews. Okay, if you are aiming for the high, so please don't try to not to skip these algos. Okay, so please try to practice as much of problems you can. Okay,
so the next question is, what is the difference between tree and graph data structure? Okay, so tree versus graph. So tree and graph are differentiated by fact that tree structure must be connected and can never have a loops, whereas in graph there are no restrictions. So the major difference between tree and graph is tree won't contain loops, okay, but graph can contain loops. Okay, where like we will be calling them as a cyclic graphs. Okay, a kind of thing, but trees won't contain graph, like trees won't contain loops forever. Tree provides insights on relationship between a nodes in a hierarchical manner. and graph follows a network model. So here in tree we will be following the hierarchical manner, right? Like structure, we have seen one example of file structure, but in graph we are not following the hierarchical structure. We will be following the network model, where one node is being connected to many other nodes, and that particular node is being connected to many other nodes, okay, like this. So this is the difference between graph and tree. Okay, now next question, what is the difference between breadth first search and depth first search? Okay, so both are traversal techniques only, okay, but we'll see what is the difference, okay, major differences between both. So here BFS versus DFS, graph traversal techniques, graph traversal, but even it can be for tree and tree as well. Okay, the main difference between DFS and BFS is the BFS travels by level, and whereas DFS travels by the starts from the starting node and reaches till the end node, okay, the leaf node, and then again it will go back to the starting node, then again come to the leaf node. Okay, let's say I will take one example. Okay, so let's say if you have a tree like this, BFS follows this thing. Okay, first it will complete all the level 0, then level 1, then level 2, but a DFS would works like this. Okay, it will start first this particular node, and it will complete this path, okay, this path, then again it will go back to the top and it will complete this path. Now again go back to the loop, like starting point, and again it will complete this path, and again go back to the root, and then it will complete this path. Okay, so depth wise it will starts from the root node, and then it will come to till the leaf node, and again it will go back to the another path. Okay, this is another difference. So further BFS, yeah, so the data structure, the type of data structure it uses to compute the traverse the graph. So BFS takes queue, which follows the first in first out logic, and DFS takes FIFO, which is like queue stack, LIFO stack, okay, last in first out. So DFS yields deeper solutions that are not optimal, but it works well when solution is dense, whereas the solutions for BFS are optimal. Okay, so DFS solutions are not that much optimal because it will go on deep, like it will take out all the possible path. Okay, it will consider all possible ways to solve a problem to reach till the end, to reach till our solution. But whereas BFS won't do that. Okay, it will go in a linear manner and checks whether this is what we are searching for or not. Okay, that's it. Now the next question, how do you know when to use DFS over BFS? Yeah, very good question. So I have seen many areas where we can solve a problem using both a DFS and BFS solution, but often that selecting the which solution to write the code is also an kind of much needed one in an interview. Okay, because it matters a lot in searching, okay, finding the optimal solution. So probably this question would answer those questions. So the usage of DFS heavily depends upon the structure of the such tree or graph, the number of and locations of solutions needed. So following are the best cases where we can use DFS. Okay, so if it is known that solution is not far from the root of the tree, a breadth first search might be the better. So they are telling that, okay, like if there is a tree like this and solution is what you are searching for is exist here. Now tell me, so DFS, if I follow DFS, it will come down till here, then okay, then it will come down here. So till now we have visited 4, right? 4, or we have visited like paths. Okay, if we have considered path, we have visited 5 nodes, then we are going to the solution which we are searching for. But if I consider a BFS, I first complete this level, then I will complete this level. So to come to our solution, I have visited only 2 nodes, right? So now it's up to you. Okay, you guys know clearly seen what is an advantage of using a BFS in sometimes in these cases where our solution is very nearer to the root. Now, so second point, the tree is very deep and solutions are rare. Okay, the height of the tree is very big. Okay, but solution is very rare. Then going for DFS, going for depth first search will extremely take a longer time to compute the solution, which involves finding hell lot of ways to solve the problem. Okay, that is going to yield an big amount of time, okay, which is not efficient. Now if the tree is very wide, okay, like the width of the tree is very high, a BFS might need too much of memory. Yes, right. So if it has for each level, okay, if this is an n array, if it is an n array a binary tree, if it is an n array tree, so n array tree, it should looks like this, something like this. Okay, where each node will be having more than one node. Okay, like it's an infinite. Okay, a parent node can contain infinite number of child nodes, then it is called as an n-array tree. Okay, so in this case the width of the tree might be very high, right? So in this case, by going till depth breadth first wise will take a lot of space. Okay, so in this case going for DFS is a good option. So if solutions are frequent but located deep in the tree, we opt for DFS. Okay, they are saying that if your solutions are very rare and it might enter very if your solution might exist in very deep, means a very lower order, okay, then going for DFS is the right approach. Okay, it's just an opposite to the what we have discussed in the first point. Okay, now next question is, what is topological sorting in graph? So what is topological sorting, which is a very, very important algorithm. Okay, if you are preparing for companies like Amazon, so Amazon, this is one of the most frequently asked graph question in an Amazon. So it will be having different algorithm, like you can solve this problem using different algorithms like Khan algorithm. Okay, topological sorting itself is have one algorithm which follows both a BFS and DFS technique. Okay, so yeah, if you are aiming for such big companies, please have a look at this topological sorting algorithm. Okay, and this is one such problem you won't get afraid of, because most of the people feel that graph is a little complicated topic, but it is not. Okay, all you need is with some strong basics, then you can able to easily solve the graph problems. And one of the advantage of graph problems is, in an interview you will get only standard problems. Okay, like it's very rare, okay, I can say that it's very rare to get new problems, like unseen problems or unsolved problems, either in lead code or interview bit platform. Okay, so you will get only the frequently asked problems. Okay, because it's little tough to create any problems. Okay, so let's come to this topological sorting. So a topological sorting is a linear order of vertices such that every directed edge I, vertex I comes before joining ordering I. So I'm pretty much sure that you haven't understood that definition. So let me put down like this. Okay, so let's take it as a becoming a SDE. Okay, becoming a SDE. So let's say everyone end goal is to become SDE. Now to become SDE, we have different path. So one path is like to learn system designing for sure. So to learn system designing, you should be very good at algos. If you want to learn algo, then you should be very good at DS. It's like something like this. Okay, and if you want to be good at data structures, then you should learn OOPS. If you wanted to learn OOPS, you should pick up any OOPS language, either C++ or Java or Python. Done. Now you can, in this is one path where you can become software engineer. And there is another path, okay, to if you wanted to get into startups. Okay, you can learn web development, Okay, so and you should learn some basic DSA as well. Basic DSA as well. To learn basic DSA, you should learn programming language, either C++ or Java or JavaScript if you wanted to web dev. And you can become Android dev as well, Android or iOS. Then again, this is going to be same path. Okay, so this is an overview of like where you will be having different options, and you can become an SD. Now I wanted to be sort this thing as a topological sorting. So the topological sorting means, let's say for everything, for if I wanted to become an software engineer, if I would like to take out this particular path, what is the first thing that I need to do? First thing that I need to do, I should learn programming language, C++, Java or Python. Then I should learn OOPS, then DS, then Algo, then SD, then SDE become. This is one way, right? And another way is learn C++ or Java or JavaScript and learn solve some basic DSA problems, then learn full stack development, then become SD. This is another path that you can become SD. What is another path? Learn either Android or iOS and learn some basic DSA. Then sorry, okay, so yeah, here it is an C++ Java kind of. Okay, so C++ or Java or JavaScript or some Kotlin, which are Android languages, or Flutter, and solve some basic DSA, then become SD. So to become an SD, these are all the paths that you need to consider. Okay, and this is called a topological sorting means. Okay, so here I can say that to become an SDE, you are dependent upon system designing. To learn system designing, you have to learn the algorithm. Okay, to solve algorithms, you should be very good at data structure. To learn data structures, you should be very good at OOPS. Okay, then to learn OOPS, you should learn any of these particular languages. So so this is the order of becoming an SD. Now what is the order of learning path? Okay, so you need to start from where there will be no dependencies. What are these here? So you should pick up at least one OOPS language, either C++, Java or Python. Then you should, after learning that language, you should go to the OOPS, then DS, then Algo, then SD, then like system design, then SD, right? So this is what topological sorting means. Okay, so before moving on to the any dependencies, okay, you should visit all the no dependencies, then only you can visit the dependencies. Okay, so I hope you got some good idea. Like I tried the best because it is going to be a good example. So, and these are all the few of the applications where topological sorting has been using. Applications are job scheduling algorithms from the given dependencies and among the jobs. Okay, ordering of formula cell evaluation in spreadsheets, ordering of compilation tasks to be performed in make files, and data serialization, resolving symbol dependencies in linkers. Okay, so it's very simple. Okay, it's very simple. Like if you haven't understood the above example, I can tell you the one as well. Let's say I have a given an statement like a result equal to x plus y plus z. Okay, so to solve this particular problem, first of all you require x, then z, then y. Okay, I can say that x equal to x into y. Okay, so for this again you require x, right? So I can say that x is equal to 2. Now again still you require y, so for y I can say that 2. Okay, now your x, you have solved the x. Okay, you have the y. Now what about z? You still require z, then I can say that z equal to y into 2. Okay, so you have y. Okay, you have y and you have 2, so it is going to be, you have answered. So after getting all these things, you will be computing your result, right? So here, before moving on to solving the problem, you need to get all your dependencies done, then only you can solve the particular problem. So in whatever wherever such cases or constraints are exist, then you can use the topological sorting. Okay, I hope you have understood. Now I'm not explaining this code as of now, probably might be in another separate tutorial because it will take a lot of time and it needs a very good amount of attention as well. So I will create a separate tutorial for this where we will be solving two problems of topological sorting. And again there is a problem. Okay, so go through this problem. So this problem is called as an number of islands problem, which isn't very good. Okay, we'll try to cover this in another separate tutorial. Now let's solve this particular problem. Yeah, heap data structure. Heap data structure. So heap is a special tree based non-linear data structure in which the tree is complete binary tree. I will tell you what is complete binary tree. So a binary tree is said to be complete if all the levels are completely filled except possibly the last level, and the last level has all the elements towards as left as possible heaps of two types. So basically complete tree is something like this. Okay, so let's say suppose you have a root, okay, and you will be starting from the left first, okay, and then you will be going to the right, and then after this completing this right, again you need to start from the right. So it means like you need to follow the sequence. Okay, first you need to complete this, then this, then this, then this. You should not go something like this. Okay, so here your right is empty, right? So this is not a complete tree, this is a complete tree. So which means that your left subtree should not be the empty, and the above levels are also not be empty. Okay, before moving on to the next levels. So then we can say that it's a complete tree. Okay, now we have heaps are two types, as I said, max heap and min heap. Okay, I will give you an overview of what is max heap and how max heap will be representing, and min heap. Okay, so in a max heap, the data element present at the root node must be greatest among all the data present in the tree. Okay, so they are saying that, let's say if I have a root of 100, then all my children's should be less than 100. Okay, so here like the root has to be good, like the root or parent node should have the greatest element among all the children's. Okay, here let's say here I have 100. Now I should have 90 here, and I should have a 99 here. Okay, and I can have a 5, and I can have 4, then 3, then 2, I can have 1 here. Okay, so here if you can see the parent nodes, okay, this is a parent, this is a parent, this is a parent. So parents are greater than the children nodes, right? Then this is called as a max heap. Okay, then you can guess what is a min heap, right? So a min heap will be having, it's an opposite. Okay, the root node, okay, like a root, okay, sorry, let's say 10. Okay, the root node will be the lesser among the all the children's it has. Okay, so here 10, so I can say 20, and I can say 30, and it will have a 40 and 60, and it is having 35 and 40, like sorry, it can have 50. So it should be like this. Okay, parent node should be less than its children node, then we can say this as a min heap. Okay, now I guess we are done. Okay, so this property should recursively true for all the subtrees. Yeah, they are saying that the smallest the root, okay, the parent node should be smallest among its all children's. Okay, now I guess we are done with all the data structures interview preparation questions. Okay, so for more such interview questions, you can check out the interview blogs. Okay, you can find a hell lot of questions or which are specific to the language or framework or library. Please do check out the interview bit blogs. Okay, so that's it. Hello everyone, welcome back to Scalar Academy YouTube channel. Myself Vamsi. In this particular tutorial, we will be looking into the another article from the interview bit. Okay, what is this article all about? So often I used to get a lot of questions from my juniors regarding the product-based company interviews. Not even product-based companies interviews. It's it's about every company interviews. Okay, so the question was, apart from coding, what are the other areas they will be asking questions from? So I used to say DBMS, OS, and computer networks. So yes, so these are the very important things. So that will be focused in an interview apart from coding as well. So in this particular tutorial, we will be learning one such topic like subject named database management system. So what is database management system and what kind of questions that you can expect in an interview? Okay, so now in the next 1 hour, 1.5 hour, what are we going to cover? So we will be starting right from the what is it data, and then database, then DBMS, and how the data has been stored in a different manners, and where that database has been placed, and how to interact with the database, and how to access the database data from the databases, and what are the ways to access the data, and how to store such a huge data in one singular database. Will it be over, like we will be discussing all the pros and cons of storing data in the database, and what are the other alternatives that are being we will be having. And also we will be learning about normalization, two-tier architecture of a database, three-tier architecture of a database, and what are different types of database structures. Okay, like so it will be easy to code and it will be easy to represent, like store, but how to communicate with others? Okay, how to, like, it's not like, oh okay, tell me about how did you store your data in this particular database. It's easy to show your database like code. So this is how I have written the code, and this is how I will be storing my data. So here comes the picture called entity relationship diagram. Okay, so that is the actual thing. So we'll be asked in a system designing rounds. Okay, if your interviewer is focusing more on to the low level designing. Okay, so I highly recommend you guys to watch this video till the end. Okay, so that you will get a bigger picture and better picture on what we are going to do in next 2 hours, and how to answer such a questions if you are in an interview. So before moving on to the actual video, I highly recommend you guys to please do subscribe to this channel. Please hit that like button up, and please let us know in the comment section how did you feel about this particular video. So let's discuss the very first question. So the question stated was, what is mean by DBMS and what is its utility? Explain RDBMS with examples. So they are asking us, so define what is DBMS and what is its necessity, like what is the need of DBMS, and RDBMS. So RDBMS is one type of DBMS. Okay, and they are asking us what is a DBMS, RDBMS, and explain it with some example. Okay, so let's try to understand what is DBMS first. DBMS. So let's try to decode this whole word. Okay, so a database management system. Okay, and again we'll talk about this first. So even in this we'll talk about this data. So what is a data? What is a data? So can I say that a raw input which is needed in the future, with that aim we will be preserving that. Okay, like what I'm trying to say was, so the data is something which you felt, okay, which is a very needed one. It might helpful in our future, so that if you felt that is needed and helpful in the future, then you must need to store that, right? Preserve that data. So then it is called as a data. Now what is a database? Now you can say that a group of interrelated data. What is this interrelated data? So let's say um, we are in a college. In college there will be around 5,000 to 10,000 students, right? 5,000 to 10,000 students. Now I need to keep them, like I need to keep all the students data forever, like at least for next 4 years. If I joined in my first year, I need to preserve that data for the next 4 years. So what will college do? So they will store all the details of CSC people in some place, in some table, let's say, like in some place. Just assume that it's a block, okay? CSC, and then ECE, then EEE, and even they do all this storing in some other folder. Let's say 2017 to 2021. So 2017 to 2021 is a, you can consider as a folder, and again in that folder we will be having other folders like CSC, ECE, EEE, and in that CSC folder we will be storing our data. So here all the CSC data has been stored somewhere. So can I say that this is an related data? So that is called a database. So this entire thing now is called as a database. Done. Now we'll move to the next thing called management system. So basically let's say I have stored all the data of first year students. Now after moving them to the second year, so I need to update the courses which they have enrolled, or let's say a few students left the college. Okay, few students left the college, so I need to update the DB, or I need to update my so delete few students, or so there were some people who joins in the second year, right? So I need to insert the students. So can I say that all these were few operations that I need to perform on database? So just imagine, okay, just imagine like you will be having some kind of interface. Okay, you will be having some kind of interface, and you will be having your database here. This is your database, and this is your interface, which helps you to perform all these kind of operations easily. Okay, then this is called as a management system, and with the combination of this mission is called as a DBMS. Now you got the what is DBMS, right? So database management system. So you will be having database, okay, and also you will be provided one interface, which is we are calling here it as a language, so that you can easily update your tons of data in a single go. Either it can be delete, insert, update kind of stuff. Okay, so that is what DBMS means for. So now I guess we have answered the very first question. Now explain RDBMS with example. Now what is this RDBMS? So we know what is DBMS. So in DBMS we have different types, like types in the sense how we are storing our data, that's it. Okay, so one of the way is RDBMS, so which is called as a relational database management system. So a relational means storing the data in the form of tables. So what does it mean by tables? So let's say I have this kind of one table. So generally for every table we will be having some rows and columns, right? Rows and columns. So all these were rows. Row 1, row 2, and these are all columns. Column 1, column 2, column 3, column 4, column 5. Now what does this column states for? So the column states attributes or properties, and columns are like rows are the data which we wanted to store. So let's take one example and then I will try to explain it with you. So earlier we have talked about college data, right? So now let's say we are storing some student details. So if I wanted to store the student details, what are all the details which I am going to store? So can I say that I have to store the student ID, which in terms called as a roll number, and I need to store the name, mail ID, and branch, and like CGPA, so etc., mobile number. So these are all the common properties of every student. Okay, common properties. So these are called as attributes as well. Attributes. Okay, attributes. Now what is a row? So row means each student data. Each student data. Okay, we'll draw one table here. So we'll be taking only few columns. So roll number, name, and a branch. Okay, now this is our table. Yeah, this is our table. Now I will be storing the very first student. Let's say roll number is 100, name is XYZ, branch is CSE. Now again I need to store another student, which is roll number is 101, name is ABC, branch is ECE. Then goes on. Okay, so this is, can I say that this is called as a one student data, student one data. This is called another student. So all these were rows, and also these can be called as a tuples as well. Tuples. So these were columns or referred as attributes. So this is what, if we store our data in this particular format, this is called as an RDBMS. Okay, relational DB. So this is called relational DB, and RDBMS means it's a language. So it provides an interface called, it might be MySQL, SQL, MS SQL. Okay, so yeah, these are all the very famous RDBMS languages. Now you can use any of these things and you can interact with the DB, and you can perform some operations on the DB, whatever you want. Okay, so there were some commands, so known as SQL commands, MySQL commands. So by using that you can interact with your DB. Okay, so we'll talk about those things as well in the later part. Now that is what we have seen for this thing, this particular example. Okay, so they have taken one website. Okay, they have taken one website. So yeah, so here there is a website front end, and you just assume you have requested some data. Okay, like you have an interface like this. Look, where you will be giving the student roll number like 100 or 200 something, then submitting. Okay, so after submitting, you will be getting all the student all the details of that particular student who is bearing that roll number. Okay, now how it should go. So you have a website, then it will make a call to the DB, which is an fetch. Okay, fetch data. Then it will go to the database. So here you can find the student record. Okay, so that is been returning here, then it will return here. Okay, this is how the flow, the control should go here. Okay, I hope you got some enough idea on what is what is data, what is database, what is DBMS, what is RDBMS, and how does it work. Okay, and what kind of data we store there and how we store there. Okay, now the second question is, what is mean by database? I guess we have answered this question earlier, so let's go try to walk through this definition. That's it. So a database is an organized, consistent and logical collection of data that can be easily updated, accessed, manageable. Okay, so earlier we have discussed a formal, like informal definition. Now you can see the formal definition. So if you are in an interview, you should first tell something like this. Okay, then you can pick up one example, then you can explain it in a better way. Okay, so if you are in an interview, your interviewer expects you to tell the concept rather than a formal definition, but don't directly jump into the a real world example as well, because it won't show you your communication skills. Okay, so first tell this, okay, then explain it with an real world example. Database mostly contains a set of tables or objects. Okay, so that is what it is showing, like whatever we have discussed. So they have taken RDBMS here. Okay, that's why they are representing as a table. Okay, so just go through that, you will get it. Now the next question, mention the issues with traditional file-based systems that make DBMS a better choice. Okay, so they are asking us actually why we need databases. Okay, why we need databases? We have file systems, right? Like we are storing all our data here. Then what is a need? So the need was they are given 3 examples. I think that should be sufficient if you are in an interview. Okay, now the very first thing is searching. They are referring it as indexing as well. So searching means what does this searching? So let's assume you are in a file system environment, like where you are storing all the details in your computer manually, like folders. Now I wanted to search for one particular student whose roll number is 201, right? 2001. Now imagine, okay, there were 10,000 students in a college. 10,000 students in a college, and you need to search the student roll number where it is being referred as in 2001. Now how much time it will take, how much effort you need to put here. So in worst case, if that 2001 is being stored in the very last, okay, then you need to cross check 1,000 files. Okay, is this what I'm looking? So if it eventually makes your job little hectic and complex, right? So that is the one of the major issue with the file system. So this issue has been overridden by the DBMSs. Okay, so they will be providing an interface, okay, like language. Then you can simply write a query, okay, like give me the 2001 ID student. Then it will give you. That's it. It's as simple as that. Okay, so all you need to know is just one query. That's it. Okay, it will get your job done within fraction of seconds. Okay, so you might be thinking 10K is reasonable search, but nowadays people are searching it, well, like the data has been gone to PBs, okay, like 100 TBs. Okay, it's up to your imagination. Okay, now what you can think of in a bigger way. Now the second solution that we were considering is concurrency control. So if you don't know what is concurrency control, it's okay, but as of now I will be stating this in a very simpler manner. So let's say you can consider it as a multitasking. Okay, so lack of concurrency control, which leads to one operation locking the entire page. So they are simply stating that, let's say if you are searching for a 2001 student, okay, then you are blocked by this particular activity only. You are not able to do other activities, like you need to delete some student details. Okay, delete student details. Now what you need to do, first you need to complete this, then you need to come back to this, right? Which is like, if this particular task is taking 30 minutes, then you, to complete this particular task, you need to wait for 30 minutes, right? So this is one of the major problem in file system. It is overcoming by DBMS. Okay, so where DBMS supports concurrency control, where you can do a multiple task at a time. Now integrity check, data isolation, atomicity, security, etc. So these are some of the advantages over the file based systems in DBMSs. Okay, so let's move on to the fourth question, which is an explain a few advantages of DBMS. I think like we have covered two advantages in the earlier question only, but yeah. So yeah, these are all the few advantages. We'll talk about each of them in detail. First one is data sharing. We'll talk about a scenario a 100 years back, sorry, a 40 to 50 years back. Okay, let's say earlier they used to store all the details in one mainframe system. Okay, mainframe system. So where there is nothing called a DBMS earlier. Now they have this. So this is their system, and they have stored all the data here. Now this is employee 1 and this is employee 2. Now employee 2 needs the data. Employee 2 needs this particular data. Now what happens? You need to copy these things. You know that it won't happen, because either he has to go and use this particular system. That's it. That is the only possible way there. So which is not possible, right? Every employee needs an own problem, like one work. So what is the kind of problem that way? So they decided to terminate this particular problem. So how did? So just imagine the case where this data has been in some central storage. Okay, central storage, one room kind of stuff. Now all the systems were being linked to this. Okay, all the systems were being linked to this. Now everyone, like every employee, can access the data with some credentials. Okay, that's it. That's as simple as that. So this is one of the biggest advantage here. So you will be storing all your data in this database, like cloud or something. Okay, you will be putting it somewhere, and you will be giving connections to all the employees. They can access it, right? So you can imagine, like whatever the data you are using nowadays, like whatever the app, whatever the website, whatever the YouTube video. Okay, so do you store all the YouTube videos in your mobile? No, it is coming from somewhere. Okay, they are storing it in some big data centers, and we are getting that. That's it. Okay, and integrity constraints. So the existence of such constraints allows storing of data in an organized and refined manner. So basically, these integrity constraints helps us to access the data uniquely, okay, and which helps to reduce some problems like anomalies. Okay, we'll talk about them later. Now, third one, controlling redundancy in the databases. So redundancy means a duplicates. What is this duplicate stands for? Let's say like file based scenarios. So you will be storing all the students details. Unfortunately, you you like just imagine, okay, you are copy pasting everything, okay, so you have copied and pasted for the multiple times. So now all your files, so for each student, let's say 2001, it will be storing 3 copies of it, and 2002 3 copies. So now just imagine if you have 1000 students, then each student copy is been storing for the 3 times, then it could have been gone to 3000 copies. Now you are wasting a lot of storage here, right? And it will make your system little slow on accessing and searching as well. So to overcome these problems, our databases usually don't allow redundancy. Okay, it will try to reduce the redundancy as much as possible. Okay, so it will store only the unique values. So it will help you to search it easily, and it will provide an way so that you can maximize your utilization of databases. Now data independence. So here let's say now in this case we'll take this particular file system example. So you have identified that, okay, for every student you will be having 2 copies. Okay, for every student you will be having 2 copies, or you will be storing the things in 2 folders. Okay, 2001. Now you wish to delete one file. Okay, you wish to delete the student record. Now you will go to this folder and you will delete this. Okay, now you thought this is the only folder where I am storing all the data. You forgot about these 2. But after few years you find that I haven't deleted the data here, and which leads to the complexness, right? So to overcome that kind of problems, so your DBMS provides an way to, okay, so to link all the data, and if you delete somewhere, okay, if you delete that particular ID or file in some table, it will delete all the existing or the same files in some tables as well. Okay, so that you can use the things in an efficient manner. Now provides backup and recovery facility. So yeah, so like just imagine, okay, you have stored all the data in some folder, and you mistakenly deleted that particular folder. Now what happens? You can't retrieve that data now. So with that thing, DBMSs provide a way to back up your files, and you can recover them even after deleting them as well, okay, by mistakenly. And data security. So usually, okay, nowadays we will be having lot of security like passwords, file folder passwords, file passwords and all, but back then that was not the scenario. And just imagine you will be saving all your bank details in one folder, and if I go and if I open that folder, then I can able to access all your bank details. Now what happens? Bankrupt, right? So to overcome that kind of problems, DBMS has provided better security for your data. Okay, you can give personalized authentication, and you can keep track of whoever are using login using that particular authentication. Okay, so this is the advantages of DBMS. Okay, so let's see the next question. So explain different languages present in the DBMS. So following are various languages present in the DBMS. So languages in the sense like to interact with your DB. Okay, so here languages were some commands. Okay, commands. So in that language we will be having 4 types. Okay, first one is DDL, data definition language, so which helps us to create a tables, create a DB. Okay, so it contains commands which are required to define the database. Okay, like create, so it will help us to either create tables or database. Okay, we have seen what is table, what is database, right? And we have alter, which helps us to alter the things, okay, alter the things present in the either in the table, like table names, okay, column names, sizes and type, like that. And drop, a drop is used to drop the data present in the tables, and truncate as well. Okay, so there is a small difference between drop and truncate. We'll talk about them in later part. So rename, so rename is helps us to rename the tables and database names. Now the second one is data manipulation language. So it contains commands which are required to manipulate the data present inside the database. Okay, like we will be having a data, okay, and then we will be manipulating it, means either we are updating and we are inserting and we are deleting, and these are all the commands which are there for DML command. Okay, DML language. So select is used to retrieve the data. Okay, retrieve the data. And update is used to update the data present in the table, and insert is used to insert the data into the database or table, and delete is used to delete the tables, okay, or data. Now the third one is DCL, so data control language. It contains commands which are required to deal with the user permissions and controls of a database system. So basically we have talked earlier, so a database provides a better data security. So how does it work? So let's say we have a person, okay, and we want to, like, there is some table, okay, student table or student database, okay, and there are 2 people for in college, let's say principal or students. Okay, now what I need to do, I need not to allow the, okay, I need not to allow the access permission to the students, right? Because students are not cannot access this student table, so only principal and support staff should be able to access this particular student database. Now just imagine another case, okay, where our students are working in some project, okay, and they need some database access, so that we can access some database, like we can grant the permissions, and after some time, like whenever their work is done, we can revoke the permissions. So to grant and revoke, we will be using data control language commands. Okay, data control language commands. Now the last one, transaction control languages. So here transactions means like you will be performing a lot of sequence of operations, right? Be it update, be it delete, be it inserting, okay, and we will be keeping track of all these things, okay, like whatever we have done so far. Okay, now we need to save them up. Okay, here commit means like whatever transactions you have made, be it inserting, update, you need to store them. Okay, you need to store them before you are leaving. That is what commit means. And rollback means, let's say you have unfortunately deleted few tables, now you need to get back those things, so then you can use rollback. So save points helps us to save at the current point. Okay, and these are all the different languages provided by the DBMS to interact with your databases. Okay, now the next question was, what is mean by ACID properties? So very important question. Okay, very important question. So it's a crime if you are not prepared ACID properties, and if you are attempting any product based company, so you are for sure you are going to screw up your interview, I guess. Okay, so what is mean by ACID properties in DBMS? So ACID stands for atomicity, consistency, isolation, and durability. So we'll talk about them each. Okay, each one. Now in simpler manner, they are saying that atomicity means all the changes to the data must be performed successfully or not at all. So we'll take one phone pay transaction or anything. So nowadays everyone using phone pay and all, right? So just imagine you started one payment. Okay, you started one payment to the one shopkeeper. Okay, started one payment to the shopkeeper. So now what is your aim? Either it has to go to the shopkeeper successfully, or it should not go. Okay, it should not debited amount and not credited. So in either of the cases you don't have any problem, right? This is what an user wants. It's not like, so my amount got detected from my bank. Okay, amount got detected from my bank and it is not credited into the shopkeeper account, then there is a problem. So a DBMS states that make sure that either of the things, okay, either it should be success and it should not happen at all. So this is the principle that it follows. Okay, it should not go, it should not start and it should not end in the middle. Okay, so that is what atomicity means. Okay, so if you have started, you need to finish that. Okay, there is no midway coming back. That is what it is saying that. And second one is consistency. So consistency means whatever the data, okay, so this property ensures that the data remains consistent before and after a transaction. So you will be let's say, so in a earlier example, so your current balance was 2000. Okay, and you have started a payment of 1000 rupees to the shopkeeper. Now after, okay, now just imagine the scenario as this is a success status. Okay, means your payment got successfully completed. So if you open the current balance now after payment, then it should reflect 1000 here, and in shopkeeper account it should be like balance plus 1000, right? If in any of the cases, any of the reasons, if it fails to update like this, okay, then we can say that this is an inconsistency data. Okay, so if it is something like this only, then we can say that it consistency. So whatever the data happened, like transaction happened, it has stored all the data over there, so we are good now. Okay, so the second principle must be, so after performing any operations, the data has to be keep on updating. That's it. It must be stored all the updated data only. Now the third one is isolation. So what is this isolation means? So you might be performing different or multiple transactions on the same side. Let's say so there is a shopkeeper, shopkeeper, and customer 1, customer 2, and customer 3. So everyone is doing phone pay transaction only. Okay, so you are sending 100 rupees and this customer 2 sending 50 rupees, customer 3 sending 200 rupees. So here, if you are doing your transaction, you can't say stop it, like, okay, hey customer 2, so sorry to interrupt, please be away, so let me complete my transaction. No, you should not tell like that. Okay, so whoever transferring amount to a shopkeeper, you should respect them and you should make sure that everything goes well. Okay, so it's support, like this is how it works in the DBMS. Okay, so irrespective of any number of people are doing the same operations at the same time, okay, the data has to be stored or preserved all the time, and there should be no interruption occur to the other customers who are sharing at the same time. Okay, so that is another principle or property of a DBMS. And the next one is durability. What is durability? So here, let's say like in your current balance is 1000 rupees. Okay, and all of a sudden your mobile got switched off. Okay, switched off. Now again you put some charging and you opened again. Okay, open your mobile again, and you have seen that there is a 900 balance in your account. So this should not be the case. So every time, like after every transaction, you need to like keep track of whatever happened so far. Okay, and everything has to be preserved for forever in the future. So here our data is like, so just imagine, okay, you have sent 200 rupees to someone, 200 rupees to someone, and still after 1000, okay, so your correct from the 1000 you have sent 200 to someone. So now your database should reflect 800. Instead of this 800, if it is still showing 1000 rupees, then it is failing, right? So anyhow, like we are getting benefited, but this is failing, right? In case of missionaries. So that should not be the case. So the same state should reflect everywhere. So if you checked it in a phone pay, if you checked it in Google Pay, so all the same amount has to be shown. Okay, so in phone pay it is showing 800, in GPay it is showing 1000 rupees. If I go to bank passbook, it is showing 500 rupees. That should not be the case. Okay, after every transaction, either it has been failed or passed, it should save the previous state, and if it is successful, it should show the current state. Okay, in all the possible ways that he or she can store. Okay, in case of different applications that nowadays we are using. Okay, that is what this durability means. Okay, now these ACID properties make sure that every transaction, like whatever operations you are performing, or everything are going pretty good. Okay, nothing is happening in between, and these are all the principles that every DBMS should follow and will follow as well. Okay, now let's move on to the next question. So the next question is, are null values in database the same as that blank space or zero? Good question. Good question. Like personally, as a software developer, I see a lot of null values in the lot of databases. Okay, after seeing them, like if you feel that this is not the case, so I can't handle this, and what all these null values, so uh, then you might be in some wrong thing. Okay, you should be wondering how we need to handle that. Okay, what if there is no data but I need to put it on the UI part? Okay, so then you need to understand the context over there, like what kind of scenario that you are considering. So just imagine, okay, just imagine you just imagine as a phone pay only, phone pay, and you need to print all the current balance. So if your current balance is null as of now, okay, null, so which means no data at all, no data. So which it doesn't mean that 0 rupee in your current balance, right? So just imagine like where in your from to your database you have a null value, okay, and at the same time user has asked for current balance. Now since you have assumed that null balance as a 0, if you assume null balance as a 0 and for user you have shown 0 rupees in your current account, now user will straight away ping the client services like customer support, because in current balance he is thinking that he might have 25k, but you are showing 0 as current balance. Okay, so 0 means 0, null means not 0. Okay, null or blank space, whatever here. Okay, this is probably a very good example. I have personally seen this problem many times as a fintech company developer. So no, a null value is a very different from that of 0 or blank space as it represents as a value. Okay, so they are saying that null value is null value, 0 is something 0 only. Okay, so they have given one example here as well, but yeah, so whatever I have discussed from my experience is also good. So null values in number of courses taken by a student represents that its value is unknown, whereas 0 means that student hasn't taken any courses. So here they are considering a scenario like table where they will be storing number of courses a student has been enrolled. Okay, so like just imagine you have a UI and you will be providing the roll number, and you will be having button like submit, and after submitting this after clicking on this particular button you will be getting all the course details where student has been enrolled, right, where student has been enrolled. Now if you got all the null values, like all the null like empty values, it doesn't mean that student hasn't enrolled in any courses. Okay, it means only that you will be like data is not available only. Okay, it doesn't mean that student does not enroll in any courses. If and only if you get 0, it means that student does not enrolled in any courses. Okay, null not equal to 0, blank space not equal to 0. Okay, let's see another question. So question number 8, what is meant by data warehousing? So the process of collecting, extracting, transforming and loading data from multiple sources and storing them into one database is known as a data warehouse. So they are saying that we will be getting data from the different sources. Okay, and from that different sources we are extracting the data what we wanted. Okay, and like let's say there is this YouTube, right? YouTube. So in YouTube everyone gets the like customized ads, right? Customized ads or some advertisements, okay, posts and all. So you can mostly you have related to that, like, so if I went to Amazon, okay, if I go to Amazon and if I search for any TVs, okay, if I search for any TVs or laptops, and then if I go to YouTube, I will get advertisements or in between ads which are related to the either laptops or TVs. And even if I did the same in Google search, if I go and search for few MacBook prices, MacBook Air price, MacBook Pro prices, then if I come back to YouTube, again I can see the ads of YouTube with the prices tag. Now how this is working? So here the sources are very different, right? So here we are getting the data from apps, here we are getting the data from internet browsers, but we are using that particular, like we are combining all the data together, and we are just suggesting the things, right? So this is what a data warehousing means. Okay, like you will be getting data from the different sources and storing in one place and processing it together, and again you will be using that same data for different purposes, not only for one purpose. Let's say like I got the data like Amazon data and Google search history, and I'm storing them in one place. Okay, I'm storing them in one place. Now this is being used for YouTube, and also in for Amazon also, like it will try to show all the things what I have searched previously on my screen only, right? For apps itself, and for Google, and for Play Store. Okay, if I go to Play Store and if I search for any shopping app, then I will get all the shopping apps, right? All the like Flipkart, Amazon, Meesho, all the things. So how this is being happening? So you are getting data from different sources, and from that different sources you are processing it together, and they felt that you are looking for one MacBook Pro, and then they are keeping on advertising that MacBook Pro everywhere you go. Okay, if you go to YouTube you will see that, if you go to Google you will see that, if you go to Amazon website you will see that. Okay, so this is how a data warehousing works. Okay, let's move on to the next question. So explain different levels of data abstraction in a DBMS. Okay, so here what is a data abstraction first? So if you don't know what is data abstraction, so a data abstraction means, in simpler, in OOPS terminology, hiding the unnecessary complexity and showing only unnecessary parts. Okay, the best example would be the ATM. Okay, like we only care about like putting the card and entering the password and getting the money, but we really don't know how that is being processed in the backend, and how your request, like how your APN pin is getting validated, and how your barcode is being scanning and all. We don't care about that. We only want money. We are getting that. That's it. Okay, this is what abstraction means. So they are asking us what is happening behind this particular data, and what are the levels are there in the database transactions. Okay, so here I would like to point out, divide this whole part, okay, into the three parts. Okay, let's say this is part 1, part 2 and part 3. So 1, 2, 3. So just imagine, you can assume this part 3 as an like UI, where a user can access the data. Okay, like you can simply consider this as one website. Okay, consider this as a one website, and now what all you can do, so you can request the, like you can submit your roll number and you can get the results, right? That's it. Now that is what happens at the user screen. Okay, and then in the second level, this is for a developers. Okay, this is for a developers. Okay, this is for developers who are developing your website. Okay, so where they can directly interact with the DBs, okay, by using some commands. They can manipulate the data, they can retrieve the data, they can update the data. Okay, so this is what a developers can do at the level 2. Okay, level 2. And now this level 3 people, like where users cannot access this level 2 permissions. Okay, so level 3 is only like level 3 people can only access the level 3 thing, but level 2 people can access both level 3 and level 2. Okay, and there here comes the last level, which is a level 1. So in this particular level we will be providing only the details of how much data has been stored, okay, and how much memory has been used and who are all using that. It will be for organizing heads, okay, organizing heads, okay, like all the databases are being created, okay, database creation and all. So here this is for developers and this is for clients, okay, who are using your end product. Now if you wanted to put it in a hierarchy, so this level people, level 1 people can access all the 3 levels, but level 3 people can access, sorry, level 2 people can access only 2 levels, first 2 levels, and level 1 people, level 3 people can access only level 1. Okay, so these are all the levels or abstraction layers available in the DBMS. Now we they have named these levels as well. So this particular level 3 is called as a view level, where it can be accessed to the clients. Now level 2 is called as a logical level, where logical implementation and actual data storing happens. And level 1 where actual it is called as a physical layer, okay, physical level or layer, whatever you call it as a, and this is where actual databases are being stored, and there will be some configuration details as well, which is not occurred for developers and users. So this is the abstraction that it is following, and these are all the levels of abstraction, okay, and layers as well. So this is about this question. Let's move on to the next question. What is mean by entity relationship? Explain the terms called entity, entity type, and entity set in a DBMS. So it is in two questions, okay, and 4 definitions, okay. So what is the first question is, what is ER model? So ER stands for entity relationship, entity relationship model. So we are, okay, like, so we are storing a lot of like we are having databases. In that particular databases we will be storing all our tables, and we will be linking, like we will be having some relationship between a few tables as well. So how we are going to represent them? So just like as a developers we can remember them, okay, but to understand, like to put it in a high level context, we need to represent them as a diagrams. So that particular diagram is called as a ER diagram. So if you can observe here, you can see, right? So we will be having a 2 entities, okay, this student is one entity, college is one entity. And what is an entity? An entity is a real world object which has some existence, okay. So student is one object, like entity, college is one entity. And what is the relationship between among these 2 tables? So entity is an table, okay. So studying, so student studying in college, right? So there is some relationship. So every student will have a college, right? And in college students were there, obviously. So this is called as an entity. So entity is an table. So for every table we will be having an attributes. So attributes are also columns. So entity means referring to the only one particular object, okay, a student, like only one person, okay, an employee, one person, that's it. An entity type means grouping like similar kind of things, okay, onto the one thing. Let's say you can see, right? So every student, okay, here, So every student will be having the same attributes like student ID, student name, student email ID, mobile ID. So every student will have the same kind of attributes. Then we can call them as entity type. Okay, an entity type is defined as a collection of entities that has the same attributes. Okay, so if I consider different students, so student 1 will have all this student ID, name and all, and student 2 will also have the same name, college and all, and student 3 will also have the same. So after seeing these 3 students, I can say that ID, name and branch is common for every student. Now I can refer them as a one like entity type. So these are student types. Okay, so it is something like data type in our programming language. Now the next question is entity set. Entity set. So an entity set can be defined as a set of all entities present in a specific entity type in database. For example, set of all students, employees, teachers, etc. So now whatever, like whoever having the same set of entity types, like here student 1, student 2, student 3 will have same entity types, right? Now I can group them all, and after grouping them all, I can say that these are all the students. Okay, whoever having this roll number, name, whoever belongs to this particular college, I can say that all of them as a students. And whoever having employee ID, employee name, and so works in some organization, I am calling them as employees, all employees, right? So this is how the difference between entity, entity type and entity set. Okay, let's move on to the next question. So explain different types of relationship among the tables in a database. So which is an very important and like I won't say it's a frequently asked interview question, but it's good to have this knowledge while, because if you are asked to develop any OOD like object oriented design or LLD or low level design, so this is very important. You must have to point these things. Okay, you must have to tell the relationship between two different tables. Okay, in that case it is very important. Okay, so here we will be having 3 types of relationship. One is like 4 types basically. Yeah, so first one is one-to-one relationship. So what is this one-to-one relationship? So just imagine you have one table here and you have one table here, and in this particular table one row has some relationship between one row in the table 2. In that case we can say that it's an one-to-one relationship. Okay, and this one-to-many relationship means, let's say you have a table 1, okay, where one row from the table 1 refers to the multiple rows in the table 2. Now what happens? So this is called as an one-to-many relationship. Like you can watch out these examples, right? So that's why I'm not telling them. And the next one is many-to-many relationship. So many-to-many relationship means, so from table 1 many rows, okay, many rows refers to the many rows in the table 2. Okay, then that is called as a many-to-many relationship. So the next one is self-referencing relationship. So self-referencing relationship means if your rows, okay, in one table refers to the another rows within the same table, then that is called as an self-referencing relationship. Okay, and there is another thing as well. many to one. Okay, like many to one relationship means many columns, like many rows from the table 1 referring to the single row in the table 2, then that is called as a many to one relationship. I hope you got it. So now let's move on to the next question. So explain that difference between intention and extension in a database. Okay, so intention and extension. So basically intention refers to the database schema. So yeah, intention are popularly known as a database schema. So if you don't know what is database schema, I will tell you. Okay, I will tell you what is database schema. Database schema. So if you consider a database where you will be storing all your student details, then whenever you you decided to create the database of students, you should be figure out what are all the attributes that you need to store, right? So it is a student ID, name, branch, email ID. So you will be creating this skeleton. Okay, so you are telling that for every student we will be having all of them, and whenever you are trying to insert data into the database, you must need to provide all these data. Okay, so that is this particular skeleton is called as a database schema. So a database schema is used to define the description of a database and is specified during the design of database, right? So when can you when you will you decide all these attributes? So whenever you have planned to create a database for student, right? So in the beginning of the storage as well. Okay, while you decided to design, then you need to decide to store, then you need to design an ER diagram, and then you need to mention all of them in that particular diagram itself. Okay, that is called intention. And if you design it once, if you define the schema once, it cannot be modified later. Okay, I will tell you the reasons why we cannot modify that later, the later part. Now the extension. So extension on other hand is the measure of number of tuples present in the database at a given point of the time. So okay, we are done with schema. Now we started inserting our data. Okay, inserting our data. Okay, I have all the schema ready. Schema ready. Now I will start storing the data into the table, right? Now at some point, okay, after inserting some 10 rows, 10 student records, I wanted to figure out how many students tables that I have inserted so far. Okay, then I can figure out that I have inserted 10. Okay, which means it is called as an extension. Okay, so the extension of database is also referred as a snapshot of database, and its value keeps changing as when the tuples are created, updated, destroyed in a database. Like it's just an information or description about your database so far, like what are all the things happen and what are all how many data are present. That's it. Okay, let's discuss another question in the DBMS interview preparation. So explain the difference between a delete and truncate commands in a DBMS. So as we discussed during the languages in DBMS, we have talked about this delete and truncate, right? So now they are asking about the differences between the delete and truncate. So if you remember, I have told both are being used for deleting the data only, but it differs in something else. Okay, we'll talk about that in detail now. So a delete versus a truncate, so which is a very important question. Okay, very important question in interviews perspective. So basically this delete, okay, this delete will delete the rows, okay, delete the rows, but with some condition, okay, with condition, which means, let's say I have all the data of students, okay. Now I wanted to delete the student data whose roll number is equal to 200. Now here I have a condition, whoever a student whoever having a roll number of 200, I need to delete that particular record itself, okay. I need not to delete entire data, okay, like all the student details. Now I have to delete only this 200 roll number student only. So here I have some condition, I will be deleting that particular row. Now after deleting that particular row, can I get that back? Yes, you can roll back. So if you remember, we have discussed about commit and rollback. So commit will help you to save the, like, preserve the changes, and rollback will help you to get your like deleted or eliminated things back, okay. Yes, you can roll back. Now coming to this truncate, so again it will delete the rows, okay, it will delete the rows, but here with no condition, with no condition. It means that if you truncate one table, like it will truncate all the data, it means delete all the data present in a table, okay. It won't even keep single row, single record of a student. It will delete all the data from the table, that's it, without any condition. Now my question, like you might be wondering, can I get the data back? Yes, you can, okay, you can roll back it, but it has some limitations in it, like few versions of MySQL databases doesn't support truncate rollback, okay. Only few things will support the truncate rollback. So if you do that, you might face the data loss as well. Data loss means like suppose if there are 1,000 records, then if you are trying to roll back, you might get 800, or your data might get corrupted as well, okay. And which one is faster and which one is slow? So this one is slow little bit and this is fast. Why? Here you will be having some conditions, you need to check, right? You need to traverse through all the data, you need to search for that particular condition, then only you need to delete. On top of that, you will be maintaining your logs as well. Logs means like what are you doing, what are the data you are deleting and all, because you need to roll back, right? So but here you don't need any conditions, you don't have any conditions, all you can do is just delete everything, okay. So it is faster, and also it won't maintain logs as well, okay. It won't maintain logs as well, means like as we discussed. So that is the reason why while trying to roll back, you might face a data loss issues. That is the difference between delete and truncate, which is very important question in an interview. Let's move on to the next question. So the next question is, what is a lock? Explain the major difference between a shared lock and exclusively lock during a transaction in a database. So which is very easy question, like in terms of all the transaction questions I hate, okay. So it says that like shared lock. First we'll talk about shared lock, okay. So what is a lock first? So basically you will be performing like, so let's say you have a DB and this DB has access to many servers, right? Many servers, so many people can access this data. Now let's say I am performing some write operations here. Like I'm trying to, let's say I have account balance as 100 rupees. Now I'm trying to delete. Okay, I'm trying to withdraw 50 rupees. Okay, now at the same time, like let's say person, or let's say father, son and father. Okay, son, and here father. So they have joint account. Okay, and son is staying in hostel, so he wants to withdraw all the money, and father is staying in some other city. He also would like to withdraw only. Now son assumes that he has seen fetched that particular current balance, and he has seen there is 100 rupees. Now he decided to withdraw 50 rupees, and at the same time dad also trying to withdraw the amount of 100 rupees. Now what happens? It will either fail. Usually it will fail, but to handle such kind of situations we will be having these logs. Okay, so if one user entered into state, then we are locking him and we are not allowing other users to access the data. Okay, so this is how a lock mechanism works, and we'll now have two types: shared lock and exclusive lock. Okay, we'll talk about the shared lock now. So shared lock means for read operations. Okay, so let's say we have a account, joint account, where I have 10k in my account. Now my dad is also trying to check the current balance, and me also trying to check the current balance. Now will there be any problem? No, right? There is no problem. It's just a simple read operation. We are not withdrawing the amount, means not writing the amount. Okay, so it's just a read operation. So you can allow as many users you want. Okay, in shared lock has been used for a read operation specifically. Okay, and you can allow as many users you want to access the same account or same database at the same time. Okay, this is about shared lock, and the next one is exclusive lock. Exclusive lock. So in shared lock we are using that for read operation, but in exclusive lock it will use for write operation. So as we discussed the problem earlier, so write has to be only one person can perform a write operation. Means let's say if son is trying to withdraw the money, so it should not allow the father to withdraw at the same time, because it will lead to the inconsistent state. Okay, they might face a problem in the future. Now what I can do, so let's say I have a account or ATM now. So whenever someone has either whoever comes first, so try to withdraw the amount. Okay, withdraw the amount, then you need to log that up. Okay, so someone is trying to withdraw, then you need to log this particular account. Okay, until this person completed his transaction. So after completing the transaction, you should remove this lock and allow other persons to access the same account. Okay, then they won't see any problem, right? So because they are going one after one, they are not doing the operations at the same time. So after completing one particular task, data will get updated, and further can see that there is no balance. Okay, there is only 50 rupees. Okay, I can't withdraw 100 rupees. Okay, so this is how we can use this locking mechanism to avoid transaction failures and data inconsistency. Now the next question is, what is mean by normalization and denormalization? Okay, so and normalization is very important. Okay, very important topic for interviews. So we will be talking about different types of normal forms available and how to write them and how to create them as well. Okay, now just keep this in mind, normalization is very important topic. So a normalization is a process of reducing the redundancy by organizing the data into multiple tables. So just imagine, okay, just imagine you have a very big table, okay, very big table where you will be storing all your data in single table. Okay, it's a single table. Okay, like where you will be storing all the let's say if you are Amazon thing. Okay, so this table is storing all your Amazon data, like customer details, order details, and payment details. All you are storing in this particular single table only. So now what happens? What is the problem? So it keeps on increasing in an exponential manner. So at some point of the state, it will be overburden for that particular table as well to maintain such a huge database. At the same time, you might be taking different uh, different duplicates in it. Let's say, so I will be storing customer details at some time, let's say 100. And the same time, this particular student customer ID has performed some payment failure, so you will be storing that. So payment success, you will be storing that. So he has ordered something, you will be storing that. So it keeps on storing, expanding, right? So you will be having different duplicate data. So to avoid these kind of problems, we have come up with a solution called normalization. Okay, so what is a normalization? So a normalization divide your big one table to the different small tables, so that the chances of uh, like having a duplicate data will be less, and you will be like you are accessing the data as well from the database will be little faster when compared to the single database, okay, single table. Okay, that is what, and it is also easy to maintain as well, right? So you like if like you are avoiding single point of contact as well. So if that table has been stuck, everything, your entire application has been closed. Okay, you can't use that. So to avoid such kind of problems, so try to normalize your data and try to divide, not to store your data in single table. Okay, try to put it in a different tables, okay, small tables. Now what is a denormalization? So it's a just and reverse process of to the normalization. In normalization, we will be saving the things from one big table to the different small tables. But in normalization, we are doing it in a reverse manner. Means we are keeping all the we are combining all the small table data into a big single table. Okay, that is called an denormalization means. So yeah, now let's talk about the different types of normalization forms in DBMS. Okay, so what is a normalization? So basically a normalization is a process of organizing the data in database, okay, to avoid a data redundancy and some anomalies. So what is a data redundancy? So data redundancy means simply you can call it as a duplicates. Okay, so what is anomalies? Anomalies are problems, okay, that were arised during the uh, data insertion in a table or well, like in database. Okay, so let's see. So let me write the definition of that following. Okay, a normalization is a process of organizing the data in a database to avoid data redundancy, comma, anomalies. Okay, so this particular data redundancy means storing duplicates or means a duplicate values. Okay, anomalies means you can simply call them as a problems. So hope you still might be in a confusion. Let's see what does this. Okay, so let's take an example table. Okay, where you will be having employee ID, employee name, and employee address. Sorry, employee address. This is not address. This is let's consider this is a department, like where he belongs to. Okay, where he belongs to, and the department ID. Okay, department ID. Cool. So let's assume this is our database, and we do have some records in it. Okay, let's say when I say records, it might be, let's say, employee ID 101 and name is Vamsi. Okay, so employee department is let's say we do have department names like Godavari. Okay, so and department ID, let's say department ID is D101. Okay, D101, and we do have another record, let's say Reddy Krishna, he belongs to Krishna department, and department ID goes something like this. Okay, now we do have another thing, so Vamsi, sorry, Vamsi, and he belongs to Spider-Man's team or Avengers, whatever you may call. Okay, and also a Vamsi is like 101. This person is again belongs to another team, let's say Krishna. Okay, he belongs to Krishna team also. Now let's see what are all the anomalies we might get. Okay, so first one, tell me. So let's assume here Vamsi is like 101. Okay, now there is two records associated with 101 employee ID. Now I wanted to update the address of a Vamsi. Okay, I wanted to update the address of an 101 employee. Now how many times I need to update? 2 times. Now let's suppose I forgot. Okay, I forgot to update for 2 times. I have updated only for 1 time. Okay, I have updated this guy. Okay, so I have made it as a Bangalore, and still he belongs to a Mumbai. Now tell me, is this a problem? This might be a problem, right? So this kind of problems is called as an update anomalies. Okay, update anomalies. Now let's discuss about a delete anomaly. A delete. Now let's say, suppose I am trying to delete the department. Okay, so like we have an Spider-Man department with the department 103 ID. We are trying to remove that entire department, like means decompose that particular department. Okay, now so if I delete this particular department, this entire record will get deleted. There might be a chances. So what is happening? We are losing one person. Do you think that? Yes. So that is called a delete anomaly. Okay, now what is an insert anomaly? So let's say so this particular department ID is a primary key. Okay, this is a primary key. Now I'm a new joinee. Okay, so I joined in a company like 2 days back. So still I am in an training phase only. No department is being allocated for me. Okay, now some people is trying to update my database to get an ID card for me. Okay, so now tell me, do I have department ID currently? No, because I am not assigned to any department, right? So whatever the data I have is this particular employee ID, let's say 104, and a name, let's say Sai. Okay, so I don't have department employee department and the department ID as well. So it won't take this record, right? You record this code. Sorry, you record it won't take this particular record. So what happens? Okay, so it won't take that record. So we lost the one particular employee name. So that kind of problem is called as an insert anomaly. Okay, insert anomaly means during the insertions, like insertion into the a DB. So delete anomalies means while deleting the data from a DB. Update means while updating the data which is present in database. Okay. Now this is about normalization and anomalies. So how we are going to solve this kind of problems is called as an normalization. Okay. So we do have different types of normalizations. So those were or classifications. Okay, you might call it as a classifications as well. So first one 1NF, 2NF. So first normal form, second normal form, 3NF and BCNF, and we do have a 4NF and 5NF, but this were not necessary. Okay, not necessary. What does it mean not necessary? So whenever we achieve this BCNF for a particular table in database, then we can say that there will be no data redundancy, there will be no anomalies. Okay, so we can say that that particular table is all set. Okay, so we don't require these things. Okay, so that is the reason why in interviews also, in most of the interviews, they don't track this 4NF and 5NF topics. Okay, they will end up at BCNF. Okay, not even BCNF. Yeah, so in some cases they will ask you BCNF, otherwise they will just ask you to define this what is 1NF, 2NF and 3NF. But when I say like when they ask you to define, it's your responsibility to take an one example and then you need to explain it, because in an interviews mostly interviewers are not interested in hearing the standard textbook definitions. They want something like more than definition, like let's say concept. Okay, what you have understood from that particular point. Okay, that is what they want. Okay, that is what they are expecting from you as well. Okay, now let's see what is 1NF. Okay, let's start with 1NF. Okay, let's say we have a table like this. Student ID, student name, and student mobile number. Okay, student mobile number. So what is the data? It has a student ID is 101, 102, 103. Names are Vamsi, Reddy, Sai. Okay, so now mobile numbers are, this guy has a 2 mobile number. Okay, so I am writing only 5 digits. Okay, so consider in real case. Okay, so another thing, another mobile number is this, and this guy has this, and this guy has this. Okay, these are all the mobile numbers they are holding. Now tell me, so the formula of like what is the principality of 1NF is an attribute of a table cannot hold a multiple values. Okay, it should hold only atomic values. Atomic values in the sense it has to contain only one value under one particular attribute. Let's say, so in our case, under student mobile, we are holding two values, right? So this is not the 1NF principle. So we need to convert this table into the 1NF, right? So we need to convert this table to the 1NF. So here what we can do now, we can simply flat this like entire table. So when I say flat, let's say what we can do now. Okay, so what we can do, let's say 101, Vamsi, 1, this one is 1, and I can make this 13425 with another new record. Okay, so same ID is same, student name is Vamsi, but mobile number is 13425. So now there is no problems in this 102 and 103. If suppose again 102 has 2 or 3 mobile numbers, let's say 3 mobile numbers. Okay, 3 mobile numbers. Okay, so now again this, with this particular student ID, we might have 3 records. Okay, in our flat end, in our 1NF converted table. Okay, so something like this. So here we will have first number, here we do have a second number, here we do have a third mobile number. Okay, so this is what first and first normal form. Okay, now let's talk about a second normal form. So let's first discuss the principles of second normal form. So here the principles are: first thing, a table must be in 1NF. Okay, so whatever, so whenever we are trying to convert one particular table into an 2NF, that table must be in a 1NF. Okay, it must has to satisfy that principality of 1NF. Then second thing is no non-prime attributes. So non-prime attributes in the sense non-primary key attributes, okay, is dependent on the proper subset of candidate keys table. Okay, let's see with one example. Okay, I'm sure by seeing these definitions you are not going to learn anything apart from mugging up those definitions. Let's see. Okay, now let's see. So we do have a table something like this. Okay, so a student ID, a student name, and a student age. Okay, so student ID is a 11, so let's say 11 111. It's not a student name, let's consider it's an course, okay, which a student has been enrolled. Okay, so 101 student ID is enrolled in, let's say, DBMS subject, and his age is 21. Now again 101 student might be enrolled in other courses as well. So what is that course? It's a OS, like operating system. So again his age is 21. So we do have another with a student without ID 120. Okay, so he is also enrolled in computer networks. His age is 22. Okay, now another guy with 120 sim, and he enrolled in an machine learning subject with age is 22. Okay, so this is the data we have in our table. Okay, now it's our job is to convert it into the 2NF. Okay, now let's say, can I say that this particular table is in 1NF? Yes. So for every attribute it is containing only one value, so that I can say that it is in 1NF. Now we need to follow the second principle of this guy. Okay, so the here tell me what are all the candidate keys here. Candidate keys, only student ID, right? So the keys which are helpful as to identify the record uniquely, that is only this student ID. So what we can say, what we can do, so here our primary key is student ID. Okay, primary key is a student ID. Now what they are saying, so they are trying us to every non-prime key attribute has to be dependent on primary key. That is what they are trying to say. Okay, let's say, so what we are trying, so can I say that this course is depend upon this particular student ID? So if I give you particular student ID, can I say all the courses that he enrolled in particular semester? Yes, I can say that. Now tell me, if I give you particular student ID, can I say that so can I get the age of that particular student? Yes, that might be the case. So it's your table has been simplified something like this. Okay, so let me draw here only. Okay, so what I'm trying to do now, so first I will have two different tables. One is a student age, age table, so where I will be having details of all the ages of a particular student ID. Okay, let's say here this guy 111 student ID with 111 having an age of 21. Okay, now again to 111 21. Yes, we do have that. Now again 120 22 age, so 120 and 22 age. Now again 120 22 age. Now whenever I want age of particular student, okay, now I can simply give you the student ID, you will give me the you can give me the student age. That's okay, fine. Now what about this course table? So I will leave you that course as it is, because because so if we wanted to make it as a, how can we make it? So you can make it like this, but we are violating the principality of 1NF. Hope you have remembered the definition of 2NF, right? So that table must be in a 1NF, and also that has to be in an like all the 9 non-prime key attributes must be associated with the prime key attribute. So I will leave that course table. I will leave that course table as it is. Okay, something. So let's say 111, 111, 120, 120. First guy is enrolled in DBMS, then OS, then CN, then ML. Okay, so whenever I want this particular student age, I will simply make a call to this guy. Okay, done. This is what 2NF. Okay, so it's very important to know the examples. Okay, at least if you are in an interview, you have to say these kind of things. Okay, so not even like simply drawing all the stuff. Even let's assume you can say something like this. Let's assume, sir, we have one table with the attributes like student ID, student name, and the student age. So here the principles of second 2NF is the table has to must be in 1NF, and it all the prime non-prime key attributes must be dependent on the primary key. Then you can divide those things into a multiple tables. That's it. Okay, now we'll talk about 3NF. 3NF. So what is this 3NF means? Let's say, so I can say that it has to be in table must be in 2NF. Okay, table must be in 2NF. That is for sure. Now apart from that, so there will like let's say transitive functional dependency of a non-prime attribute on any super key should be removed. Okay, so yep, it doesn't make sense to you. I will take one example and we'll see what it is actually. Okay, let's say we have a table of employee this time. Let's change the table this time. Okay, let's say employee. So employee ID, employee name, and employee address. Now let's consider address. Okay, so pin code. Okay, so pin code or zip code, whatever you might call. Okay, and then I am storing the state, then employee city, then employee district. Okay, so it has some data. Let's assume we have all the data. Now what I'm trying to say now, so this, if I give employee ID, I can get this entire row uniquely. Is there any key, something like that? No. So here candidate key and primary key is employee ID. Now is there any possibility of decomposing this table again? So think yes, I can say one thing. So now let's forget this entire table. Now let's assume we have this only table. You have this table. Now can I say that this, if I give this entire pin code or zip code, whatever it might be, so can I get the entire row in this particular table? Yes, right. And that pin code and zip code or zip code is very unique. Okay, it must not be given to another state, like another districts or another places or another legislatives, right? So what I'm trying to say, so I will decompose that entire table into two tables. So I will have employee ID, employee name, and employee pin code. Okay, I will have something like this. Now I will make this pin code connected to another table called address table, where I will be storing all the pin codes. Okay, let's say I will have a pin code, then a state, then a city, then district. Okay. Now, whenever, so I will give all the pin codes here, particular employee. Now, whenever I search with this pin code, I will get a entire state and city and district details. That works. That works, right? So this is about the 3NF. Now we'll talk about the BCNF. Okay. Now we'll talk about the BCNF. So the full form for BCNF was voice a code a normal form. Okay, voice code normal form. So again, the conditions like our principles of this particular will be, so it has to be in a 3NF for sure. The table must be in 3NF. And a second thing, so like I can say that BCNF is a little stricter than a 3NF. Okay, so a table complies with BCNF if it is in 3NF and for every functional dependency. Okay, let's say x to y, x should be super key of a table. What does it mean? Let's say suppose, let's take one example. There is a company where employees works in multiple departments. Okay, employees works in multiple departments. Let's see. So employee ID, employee nationality, employee department, and department ID, and a number of people in particular department. Okay, now we'll see. So employee ID is 101, and employee nationality is Indian here. Department he works for Godavari. Department ID, let's say 101, and in particular Godavari there were 250 people were working, let's suppose. Okay, and you do have so again this 101 guy, so 1001 guy also works in another department. Let's say again he is an Indian, so he's another department is Krishna, department ID is 102, and in that particular department, let's say 100 people are there, and there is a guy with 100. Again, he works for two different departments, and his nationality is American. Again, he works in both Godavari, Krishna, 101, 102, 250, 100. So this is the table that we have. Okay, now let's try to identify. Okay, so let's try to identify. So can I say that can I say this entire employee functionality is dependent on this, employee nationality is dependent on this employee ID? One thing, yes. Now I can say that employee ID gives you employee nationality. Now what is the other case? So can I say that employee like these things, department ID and number of members in a particular department is dependent upon this particular department. Yes, employee department, yes. So I can say that employee department is equal to employee department ID and a number of employees. Okay, now how we are going to take this into the BCNF? Okay, so we can break this entire table into 3 tables. Okay, let's say how. So first table, let's say nationality table, nationality a table. So in that I do store employee ID and employee nationality. Okay, so 001 is an Indian, and this guy 100 102 is an American. That's it for this particular table. Now I will have another table. Okay, so where department table. Okay, department table. Let's say we'll have department ID, department people, like number of employees. Okay, so first department we do have Godavari, and ID is 1001, and number of people this. And then we do have a Krishna, and it is a 102, and we do have 100 employees in that. Okay, that's it. Now we'll have another table which is currently mapping to that particular both tables, right? Let's say so now I will, in this particular table, I will have only the primary things. Okay, primary attributes. Let's say what is the primary attribute in a table 1? It's an employee ID. Now what is the primary attribute in a second table? It's an employee department. So now I can say that 101 belongs to Godavari. Again 101 also belongs to Krishna, and 102 belongs to Godavari, and oh, this guy belongs to Krishna. Done. So whenever I need entire department details, I will go to Krishna. I will get that. Whenever I need an nationality of a particular employee, I will go to nationality table and I will get the nationality. Okay, so that's all about normalization. Okay, so I highly recommend you to think on your own. Okay, like try to frame. Okay, take a couple of examples and try to divide those things, what kind of problems that you are going to get.
Hey guys, welcome to yet another video by Scalar, and in this particular video we're going to look into interview questions specifically on Amazon Web Services. So before we move on with this particular session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. If you have any queries, leave a comment down below and we would love to help you out. So now, before moving on, let's just understand what exactly is going to be covered in this particular session. To start off with, we'll be covering certain basic AWS interview questions that we'll be understanding and asking few very basic questions like what is AC2 and what is this particular service and how it works. All these basic questions will be covered. And then we'll move on to the advanced questions and we'll understand even more services, and also services which are basic in nature, but we'll also look at them in a more in-depth manner. Okay, so this is what will be covered in this particular session. And also guys, did you know that we do have a blog where we are covering all of these insights and important questions and topics, where we exactly are covering AWS and AWS interview questions. So that is available in the description, the interview bit blogs. You can go check that out. So now let's just, before moving on, I'll just give you a brief about how exactly to address in an interview, because this is exactly about interview questions. It's not just about giving technical answers, right? You should also know how exactly to answer them and what not to answer. So first of all, take your time. So when they've asked you a really huge question which needs some time to think, do not go on and start speaking something which you already have a little bit of knowledge about. Just try thinking about it once, try to solve it in your head, and then go ahead until and unless it's a quick knowledge-based question. If it's a quick knowledge-based question, obviously you have to give an answer really quick. If it's a lengthier question, then take your time and then answer. Give a proper answer. Second, ask questions. This is really important. Do not say I don't have any questions. Ask about what the company is doing. Ask about what are the current projects which are going on. Like obviously they won't give away all the details. They might give you one or two insights about it, right? Always ask questions. So these two are really important. Once that is done, then basically try to be more attentive to what exactly is going on, and also try to basically indulge in what exactly is going on. So do not say I don't know, or no, I do not know that. Just don't try to do those things. If you do not know an answer, try that. Try to saying like, I do not know this, but I'm gonna learn this once I'm going to go out of this interview. And obviously if this is necessary for a job, I'll be able to learn it quickly as I'm a fast learner. So you'll have to basically try to turn your weakness into a strength. So that exactly is the last point which I want to talk about. Now, without any delays, let's begin with the session. So guys, we've understood what exactly is going to be covered in this session. So now let's start with the basic interview questions. So again, in the basic interview questions, some questions would be, the explanation would be less, some the explanation would be more, even though it's basic, so the explanations can differ. So you don't have to basically explain every single thing about a question which is asked to you. For example, let's say the first question is what is EC2? EC2 is the most common service. So it's the first service anybody would learn when they're getting into AWS. You might have learned a different service, but EC2 is the first thing most people would understand and learn when they are getting into AWS or any cloud platform. Virtual machines on cloud would be the first thing they'll be learning. So now, when somebody is asking you what is EC2, it's not necessary you'll have to explain every single thing from scratch. You don't have to tell them what exactly is a virtual machine first, then you can tell, so that's exactly what we have replicated in cloud. Then you don't have to explain what is an hypervisor in order to tell them how exactly a virtual machine is created. You don't have to tell all that. You just have to tell them what is that particular answer for that particular question. So in this case, for the first question, which is what is EC2, the answer is EC2, a virtual machine in the cloud on which you have OS level control. So I think this particular line sums up everything. So it's a virtual machine which is running on the AWS cloud, for which you get OS level control. So you'll be able to control the processes, you'll be able to install software, you'll be able to deinstall, uninstall software, you'll be able to manage everything around that particular virtual machine, right? So these are the things which you will be able to do. So you can run this cloud server wherever you want and can be used when you need to deploy your own servers in the cloud, similar to your on-premises service, and when you want to have full control over the choice of hardware and the updates on the machine. So for example, let's say if it's an on-premises servers, right? So you would have complete control over them, even the network would be yours. But when it comes to AWS, the network would be AWS's, but you would be basically given OS level control. That basically means sometimes you can also select, there's something called reserved instances and on spot instances, where you can also have authority over the choice of hardware, right? Even on-demand instances, that is normal virtual machine, gives you to choose the choice of hardware. That is, you can select how much storage you want, how much memory you want, how much virtual CPUs, that is cores, you want. You can choose all of those hardware components, but it wouldn't give you complete control over how exactly that is, because they wouldn't let you choose 3 GB or like 7 GB. There would be certain numbers. There would be 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, like that. So you wouldn't be able to choose an odd number or something. So you wouldn't be able to modify it, but you will be able to choose what exactly you need. So to be very simple, the answer you will have to give in an interview would be, it's a virtual machine which is running on the cloud, and you have OS level control to it, so that you can install software, you can use it as a web server if you want to, you can use it as a database server if you want to, you can use it as any server you want to. You can also use it as a PC. You can use it as your own computer, normally how you use your own computer, right? So you can use it like that, because it's simply a virtual machine. You can literally do anything on it. So that's exactly what EC2 is. And EC2, the full form is Elastic Compute Cloud. So most probably you would know, and the person would know. It's not necessary that, first of all, Elastic Compute EC2 basically means Elastic Compute Cloud. You don't have to say that. It's not necessary, because I'm pretty sure most of you would have done this in an interview before. But moving further, you don't have to abbreviate something to someone when they're asking you something. You just have to explain what it is. Then they will understand you know it. You don't have to tell the full form, right? Okay. So now this is the first question. That's why I wanted to give you some insights about how exactly you can answer and frame your question. From here on out, I'll be just giving you the answers for the respective questions. So now, what is Snowball? So Snowball is not a feature, or it's not a inbuilt service like EC2 or S3 or RDS. Snowball is basically a small application that enables you to transfer terabytes of data inside and outside of the AWS environment. So it's a small application which runs on Snowball, which is a hardware device. So Snowball is a hardware device. For example, let's say you want to transfer terabytes or petabytes of data. What they do, basically, you can request to Amazon, that is, request to AWS, you need to transfer this much data, you would need Snowball. So they would be transferring Snowball to you, to your company's data center. You would be able to create a job. That is the first thing. You would be able to create a job, right? You would be able to create a job, and once you create a job, that transfer will go on. by connecting to the snowball, and the data would be copied to the device. So now once the data is copied to the device would be given to AWS, and AWS would basically upload it to S3, where your data would be successfully uploaded and stored. So that's basically it. It's pretty simple. This is what you can tell when somebody asks you what is snowball. Okay, next comes CloudWatch. So what is CloudWatch? CloudWatch helps you monitor AWS environments like EC2, RDS instances, CPU utilization. It also triggers alarms depending on various metrics. So to be very, very simple, CloudWatch is a monitoring tool which essentially and especially monitors AWS resources. There's EC2, RDS, all of those resources would be monitored by CloudWatch even if you haven't enabled, because CloudWatch is a free default service which is already running there, and it will basically give you all the details and metrics you need. For example, if you take EC2, you would be able to see how much network, that is network in, network out, how many packets have come in, how many packets have went out, the CPU utilization. There are so many other metrics which you can go through for every single AWS service you want to look into. There is also a paid part of it. For example, in certain resources, there would be something called enhanced monitoring, which you can select. Enhanced monitoring will give you even more in-depth monitoring ability, but that would be a paid one within CloudWatch. But usually you can just go with the free service if you're just practicing CloudWatch, right? And one more thing which is called alarms here. Alarms is basically a service, a feature built in CloudWatch. For example, let's say you have one EC2 instance, and whenever the CPU utilization of that one EC2 instance goes above 90%, you want another EC2 instance to be created. So in that case, you set up an alarm that will trigger itself when the CPU utilization of that particular instance goes above 90%. And when it goes above 90%, that obviously CloudWatch is monitoring, and it will get that data, and once it sees that it's crossed 90%, it will automatically basically it will send a request to EC2, and EC2 will launch another server, right? So this is how it works. So that's a basic example of what alarm is. Next is, what is Elastic Transcoder? So Elastic Transcoder is an AWS service tool that helps you in changing a video's format and resolution to support various devices like tablets, smartphones, and laptops of different resolutions. For example, let's say you're creating an application and you want to have that application, in that application you want a video streaming platform. Okay, so in that case, if you are uploading a video, usually let's say you're creating a web page, you are creating it for the desktop, and you upload a video, and if you try to open that website in your mobile, right, all of your basically the resolution wouldn't, sometimes it wouldn't match, it would be kind of jumbled, it wouldn't be working properly. So you would be able to do, you would be able to basically solve that using Elastic Transcoder. So that's basically this particular tool. Next comes VPC, what you understand by virtual private cloud. So it allows you to customize your networking configuration. So again, without networking, you can't do anything in AWS. So without networking, you can't do anything in AWS. To be very simple, if you are in a company, let's say even if you have an on-premises data center, without networks, you can't do anything, right? Because every single server is connected together because of a network. Without, so a network is basically that. It's multiple servers connected together, or multiple computers or multiple clients connected together. So without a network, there can't be any communication between other computers. For example, without networking, there is no internet, right? So internet is basically a connection between other computers, right? So there are multiple routers which the internet goes through. There are various types of internet. Let's not discuss that. But again, without networking, you can't do anything in AWS. So the first and foremost important thing which you'll have to create, or it's already available in AWS, which is a VPC. So by default, there is something called a default VPC. When you start practicing AWS, you can use the default VPC. But if you are not using the default VPC, in that case, you can create another VPC and create subnets within it. So let's not cover subnets right now. When that question comes, I'll cover that. So VPC is a network that is logically isolated from other networks in the cloud. So even in your AWS account, if you have two VPCs, and let's say you create a server EC2 instance in VPC1 and EC2 instance in VPC2, so these two EC2 instances will not be able to communicate with each other because they are isolated from each other, because they are in two different networks, right? The only way they'll be able to communicate with each other, if the instances are public, they'll be able to communicate through the internet right? If otherwise there is something called a peering connection in VPC, you can create a connection between two VPCs, and these two instances will be able to communicate through that. Okay, so now it allows you to have your own private IP address, internet gateway, subnet, security groups. So these are all other concepts. So for now, when somebody asks you what exactly is VPC, you can tell that it basically lets you configure and customize your networking settings in AWS. And the foremost concept is basically it is logically isolated from other networks in AWS. Even within your account, it still isolates one VPC from another VPC, right? So when you create a VPC, you will be giving certain things like you would be giving a CIDR notation. So within that CIDR notation, so your VPC will have a range of IP addresses. So whenever you create a resource within the VPC, the resource will have an IP address within that particular range, right? So these are the things. There are more things to VPC. VPC is a really huge concept, but when somebody asks you, these 3 points is more than enough. Just say it's the tool which is required to customize your networking configuration. It logically isolates that particular network from other networks in the cloud. Third one, it lets you basically create resources within it, and it will assign private IP addresses within the IP address range given to the VPC. Okay, so these are the things which you can take. Okay, next, DNS and load balancer services come under which type of cloud service? This is a pretty straightforward question. It will be a one sentence answer. So they are part of infrastructure as a service storage cloud service. Okay, so basically DNS, it's a domain name server. Next is load balancer. So what type of cloud service they are? So they are saying that they are infrastructure as a service. So infrastructure as a service in the sense they are providing you infrastructure over the internet. For example, EC2 is an infrastructure as a service. They are providing you a server over the internet which you will be able to use. So that basically is an infrastructure as a service. In this case, they are giving you a domain name server over the internet and a load balancer over the internet. So that they are also infrastructure as a service because they are infrastructural components. There are other services. There's platform as a service and software as a service. So we'll talk about that later. For now, whenever something relates to infrastructure, that basically means what does load balancer do? It balances the load and sends the the incoming requests across all the servers according to the rules you have provided. For example, if you're just going with a classic load balancer, a traditional one, so let's say there are 100 requests coming in and there are two servers. So first request will go to the first server, second request will go to the second server. For example, let's say this is the cloud and users are trying to access the website which is running inside these servers. So when a first request comes in, it goes to server 1. Second request goes to server 2. Third request goes to server 3. So this is the traditional load balancer. So now load balancer does this, and that's why it basically is an infrastructural component which helps you do this. That's why it is an infrastructure as a service. It's not platform as a service because it doesn't provide you a platform to do some operations over it. It's not a software as a service because it's not a software at all. Software as a service, Gmail is a software as a service because it's a software given to you over the internet, right? So I think it's pretty clear they are infrastructure as a services. Next, what are the different storage classes available in S3? So right now there are around 6 storage classes: S3 standard, S3 intelligent tiering, S3 standard infrequent access, S3 one zone infrequent access, S3 glacier, and S3 glacier deep archive. So you can check out this. All of the storage are provided 11.9's SLA, and over here availability SLA is also provided. So SLA basically is service legal agreement, which basically means that Amazon is promising you that this particular resource will be available 99.9% of the time. So that's what they are giving you. So they are saying it wouldn't go down at all. Even if it goes down, it would be just for 0.01% of the time. And let's not discuss more into it. Let me just briefly explain this. So that's all you have to say. So the storage classes are standard, which is the default storage class which will be given to you when you create a S3 bucket, right? And then there is intelligent tiering. There is standard infrequent access. So intelligent tiering basically is, you can see minimum storage duration is 30 days, and in this case the only difference between standard and intelligent tiering is it's a little more expensive, and it has a minimum duration period over here. But other than that, they are pretty much the same. But standard infrequent access is different from standard because standard is considered as hot storage. That is, when you store something in standard, you are basically saying that that particular objects are frequently accessed by someone. But if you store in standard IA, which is standard infrequent access, so you are stating that it's not frequently accessed. Okay, so that's what you are stating. Yeah, so basically that's it. And then coming to one zone, so in these cases, the data will be available in 3 or more availability zones. But when it comes to S3 one zone, it will be stored in just one zone. So that's basically the storage class name. This is not a good practice, but sometimes if it's not important data or old history data, you just want to have it there on AWS, then you can have it on this. For example, in that case, if that availability zone was down, you wouldn't be able to retrieve that data in that particular period of time until AWS comes back up in that region. But that's a risk you would have to take because it's not designed for availability. You can see it's 99.5% of the time it's available. All the other services have 99.99. Intelligent Tiring has 99.9. Glacier and Deep Archive have 99.99. So you can see the difference over availability because it's only available in one zone. Right. Okay. Next comes Glacier and Glacier Deep Archive. The only difference between Glacier and Glacier Deep Archive, you can see the time, the minimum duration, and one more would be the so this Glacier Deep Archive would be much cheaper than Glacier. Why? Because you will be able to download stuff of Glacier within minutes or hours, but in Glacier Deep Archive it will take several hours because Glacier is a backup service, backup storage service. You will be able to back up your data. That's why the minimum storage duration for any data you store on Glacier is 90 days. You cannot delete them before 90 days. That's the minimum lock-in. When it comes to S3 Glacier Deep Archive, it's 180 days because these are data which you're archiving, which you don't want for now. You just want to archive them, like something company history data or project history data, whatever it is, you can just store over there. Right, so these are different types of storage classes. What are explain what are what T2 instances are. Okay, so T2 instances are one particular type of instance in EC2 instance types. There are so many different types. For now, let me just explain this. So T2 instances are designed to provide moderate baseline performance and the capability to burst to higher performance as required by the workload. So each types of instances will have a separate separate need to satisfy. So T2 instances are created to provide a baseline performance, that is regular performance, and also whenever the workload is increasing, they are equipped to give you a burst in performance which will increase the utilization of the CPU in order to provide you a better handling of the workload, right? So that's exactly what it is. So these are the different types of instances within T2: .nano, .micro, small, medium, large, X large, and 2X large. So you can see, so this is virtual CPU. That basically means how many cores that particular instance has. So the nano, micro, and small have 1 core each. Medium and large have 2 core each, and large, X large, and 2X large have 4 and 8 core each. Right. So the difference between the micro, small, and T2.small comes within the memory range and the CPU credits. So let's not go into CPU credits. That's a whole other concept. So memory. So let's just understand the storage and memory and the virtual CPU. So we already understood virtual CPU. So memory, you can see Nano has only 0.5 gigabytes of RAM. Micro is 1. Small is 2, medium is 4, 8, 16, 32, right? And performance low to moderate, low to moderate, low to moderate, low to moderate, moderate. So nothing gives you high network performance. All are nominal performances. So if it's for a practice project or a demo project, go with T2 instances. So also T2.micro is the free tier instance which is provided to you. This is the free tier instance which you will be able to use when you want your instance for free. All right, so these are basically T2 instances. Coming to the next question, what are key pairs in AWS? So when you create a virtual machine in AWS, you would have to create something called a key pair. If you already have a key pair, you don't have to create it. can use the previous one which you already have. But if you do not have, you will have to create a key pair. Without that, you will not be able to create a virtual machine. So it is secure login information for your virtual machines. So how exactly it works? You will be given a public key and a private key. The public key will be stored in the virtual machine. The private key would be given to you, that you will be downloading and storing in your local PC. So when you are trying to log in into the server, right, you will have to upload the private key. So it should be the same private key which is given to you, because only that particular private key will be able to decrypt the public key. Only if it's able to decrypt the public key, you will be given access to the instance, right? So that's exactly how it works. It's pretty simple. Private key, public key. With this private key, you will be able to decrypt the public key. Once it is decrypted, then you will be given access to the server. Then you can start using it. That's basically key pairs. It's pretty simple. Okay, now how many subnets can you have per VPC? So in a VPC, you can create subnets. So you can have about 200 subnets in a VPC, and also it's a matter of IP address ranges available. You can still have more, but again, if you want more subnets than this, you will have to consult. You will have to basically mail AWS support. But usually, by default, you will be given access to create 200 subnets per VPC. So subnets are basically sub networks within the VPC. Again, it's a logical concept, right? Even VPC itself is a logical concept. It logically isolates your resources. Same way, within a VPC, you can create something called subnets, which are subnetworks within the VPC, where you can even isolate the resources within the VPC from themselves. So let's say you can have 10 instances, and there can be two subnets, and 5 instances can be in one subnet, and another 5 can be in another subnet, and they can be also isolated from each other if they don't have any connection between them. So they can only privately communicate with each other if there is a communication portal between them. If not, they wouldn't be able to do it. So that's basically it. Okay, so you can have up to, so for this question, the answer would be you can have 200 subnets per VPC. I just wanted to give you a brief about subnets. Okay, next is list different types of cloud services. This is a pretty straightforward question, and mostly it won't be asked in a again, it's a basic, but these are basic questions. That's why this question has come up. So software as a service, platform as a service, infrastructure as a service. These are the three essential ones. Data as a service could be added if you want to, because if you add data as a service, there are other types of cloud services which could be added, like function as a service, like big data as a service, AI as a service. You can add so many things, right? As a service is just a term. So mainly there are three types: software, platform, and infrastructure. When you talk about software on remote servers, for example, let's consider Gmail. The Gmail is running on a remote server on Google's data center somewhere. You don't know where that application is running. You don't know where the application's code is residing. You do not know where your emails are getting stored. It could be stored in any data center of Gmails. So you wouldn't know all that, but you will be still able to access the software itself, right? So that's basically software as a service. You will be given access to the software, but you will not be given access to anything else apart from that. You will only be able to use the software. Next comes platform as a service. So in this case, application development and deployment. So to be very simple, in this case, you'll be given a platform which will give you a little more access. So you'll be able to build something using this platform. For example, in AWS, there is a platform called Elastic Beanstalk. If you guys want, just type it in Google and see what exactly it is. So I'll just give you a brief. So it lets you upload your code, and it will automatically provision instances, that is EC2 instances, and upload your code and install all the software necessary, and your website will be up in no time. You don't have to do anything else. You just have to upload your code properly, but your code has to be optimized for Elastic Beanstalk accordingly. But all you have to do is create the application and upload it. Beanstalk will take care all of it. That's the infrastructural part would be taken care of Beanstalk. So the only thing you will have to worry about is the platform, handling the platform, right? So that's basically platform as a service. Now coming to infrastructure as a service, as I already explained to you what is EC2. So servers, storage, operating systems. So S3, EC2, so these two are basically infrastructure as a services. So S3 basically provides you storage. You will be able to upload and download and delete and do every operation which you can basically do in your own personal computer. So it lets you do all that. they're providing infrastructure via storage. EC2 gives you infrastructure via servers. So in this case, what they are basically doing is they're giving you, like let's say they're giving you operating system level access to servers. So that's exactly what infrastructure as a service is. In this case, you will be given the access to the server itself. For example, in this case, you only get access to the software, only the platform. Here you get access to the infrastructure itself. You can install any software on it as you want. Okay, so now we've seen the basic questions. I hope the basic questions were helpful. Now let's move on to the advanced questions. Right. So also at the end of this particular session, guys, I'd be asking you a question. So if you know the question, please put down in the comment section. I'd be asking it to you. So for now, let's just try to understand everything about AWS interview questions. Now moving on, we'll be looking into advanced questions. So make sure you understand the basic questions. Make sure you just go ahead and check the documentation, just cross-reference everything. So I've given you the answers, right? You just cross-reference everything, make sure everything is clear for you, because some of these questions are pretty small. If you want to know more about key pairs, go to the documentation and learn more about key pairs. But we are just trying to give you answers for the questions asked, right? All right, so now advanced AWS interview questions. Okay, explain what S3 is. So S3, it's called a simple storage service. So S3 is basically a storage service where you can store, retrieve, delete any amount of data. Basically, virtually unlimited data can be uploaded and downloaded like at any time using the internet. So basically, the payment is pay as you go for most of AWS services. So especially in S3. So basically, let's say you upload 2 gigabytes of data. You only have to pay for the 2 gigabytes of data which is uploaded. And if you deleted that, you don't have to pay anything because there is nothing stored on AWS at that point of time. So basically, you only pay for what you use on S3. So in this case, why I say virtually unlimited is you do not know how much storage space that AWS have. You can literally keep uploading how much ever data you want. AWS wouldn't stop you because obviously you are going to pay them for the data which you are storing, right? So they obviously are a for-profit business who are profiting from this. So they will provide you unlimited, virtually unlimited, because there will obviously be a limit to the data which you can store, which would be really high. You wouldn't have that much data to store, obviously. But again, that's basically what S3 is. It's a storage service which lets you store petabytes or even exabytes of data on it, and you just have to pay for what you use. Okay, next question. How long does Amazon Route 53 provide high availability and low latency? Okay, so the question basically is, how does it provide high availability and low latency? Why should I not go with GoDaddy or any other DNS service, right? Why should I choose Amazon Route 53? So now they're explaining that. So first of all, it provides a globally distributed service. AWS again is the biggest cloud network right now. And obviously they have data centers all around the globe in most of the countries, and they literally have in every single continent, right? They have data centers in every single continent. So that basically helps them serve your website to every single person around the world. You'll be able to serve your website. Let's say you're in India, you're creating a website and you want your product to go global, and you want your application to be available for every single person around the globe. So you can use Route 53 to do that. Next comes dependency, and finally optimal locations. Now let's come from the top. So Amazon is a global service and consequently has DNS service globally. As I told you, they have data centers all around the globe. Any customer creating a query from any part of the world gets to reach a DNS server local to them that provides low latency. So low latency in the sense, they're asking how exactly Amazon Route 53 helps you in order to make sure your application is really fast for any user around the globe. So if the application is if the headquarters is in India, the main customer base in India, so then it makes sense to provide low latency to customers in India. But how exactly Route 53 provides low latency to every single person in the world if you're using this application in a global level? So that's how it is doing, by providing them a local server which is nearby them. So they'll be taken to the local server. From there, they'll be routed to the actual place where the website is hosted, or they could just if the website is available globally, then the local server itself would be able to give them the access to the website. So that's basically how low latency is maintained. Dependency Route 53 provides a high level of dependability required by critical applications. So again, you're paying AWS for something. They are the cloud leader right now. So obviously the dependency is there. They give you a high level of dependability required by critical applications. Even though it's a critical application, you could run on Route 53 and it will make sure it is running really, really well. That provides the website high availability. And finally, optimal locations. So Route 53 serves the request from the nearest data center to the client sending the request. Whenever a client sends a request, let's say my main customer base is in India, and there's a customer from, let's say, Ethiopia trying to basically send a request, and they're sending a request, and they'll be taken to the nearest data center to them, so that it's much faster for them to get the website shown in their browser, right? So AWS data centers are across the world. The data can be cached on different data centers located in different regions of the world, depending on the requirements and the configuration chosen. Route 53 enables any server in any data center which has the required data to respond. This way, it enables the nearest server to serve the client request, that reducing the time taken to serve. It's basically caching. So the website will be cached in the nearest local server, and as it is already cached, it doesn't have to travel all the way to the original server to get the data back. It can just use the cached information and just return it to the user. That would be quick, and the user would be happy about it, right? So this is how Route 53 does it. So there is obviously more to it. That's what we're going to look at right now. For example, let's consider, please cut that small part which I didn't speak. Okay, so now let's consider the requests are coming from a user in India or served from the Singapore server, while the requests coming from a user in the US are routed to the Oregon region. For example, let's say the application is in the US, right? The application is in the US. So now this is the Oregon data center. This is the Singapore data center. So let's say this website is not available in Indian data centers. So now a user is basically trying to request, right, some data on the website. So the user is requesting from India. So request from user routed to Oregon region. So this is basically for this. So now when a request comes from the Indian user, Route 53 checks for the nearest server. So the nearest server this time would be Singapore. So in this case, the request from the Indian user would be redirected to the Singapore server, and the data would be given back to the user as fast as it can. But if a user from the US region itself is trying to access, they will be taken to the nearest server. In this case, it's Oregon. So this is how it maintains high availability and low latency. So this is especially for low latency, not high availability. For high availability, there are so many different things which you can talk about. Other AWS, so there are multiple data centers, so your application can be replicated in multiple data centers, even though one data center is not available. For example, even though if the Singapore data center was not available at that particular point of time, Route 53 would have taken them to the next nearest server, right? Next nearest data center. So that's exactly how it provides high availability. Okay, so now coming to the next question, how can you send a request to Amazon S3? So it's a REST service, and you can send a request by using the REST API, which is available, or you can use by using the AWS SDK wrapper libraries that wrap the underlying Amazon S3 REST API. So basically, you can use the REST API manually in order to do it, or you can use AWS SDK, and you can basically create a piece of code, and you can use that code. Whenever you run that code, it will send a request of whatever request you want to by using the wrapper libraries which you have created, right? So that's how you can do it. Moving to the next question, what does AMI include? So first of all, AMI basically means Amazon Mission Image. So an AMI includes the following things: template for the root volume for the instance. So how exactly the root volume should be formed, how much storage it should have, and what are the things which it should have. Okay. Second, launch permissions to decide which AWS accounts can avail the AMI to launch instances. So when you create an AMI, you can choose whether it's public or private. If it's private, only that particular AWS account would be able to do it, but that particular AWS account would be able to give access to another AWS account even though it's private. but you can also convert it into a public AMI. In that case, every single person in the world would be able to use your AMI to create a or launch an instance. Now, a block device mapping that determines the volumes to attach to the instance when it is launched. So whenever the instance launches, it needs some volume to be attached, right? So that particular volume is basically so that information is also stored in the Amazon Mission Image. So basically, when you use the Amazon Mission Image, you can launch one instance or you can launch multiple instances according to whatever is your requirement. But the AMI will contain all of these things: the template for the root volume, the permissions to launch in whatever AWS accounts, and finally the block device mapping, that is what are the different types of block devices which needs to be attached to this instance. So when the AMI is creating, it will also basically launch the volumes and attach it to itself. So this is basically what an AMI is, right? If you want to know more about AMI, you can go check it out. So what exactly AMI is? It's a template which is used to create instances. So you can't create an EC2 instance without an AMI. Okay, so that's basically AMI. Coming to the next question, what are the different types of instances? So we saw one type of instance. So that is one singular type of instance, but these are basically the groups, the types. So basically groups in types of instances. So there is a compute optimized, there is a memory optimized, storage optimized, accelerated computing, and general purpose. So the T2 instance type, which we previously saw, was a general purpose type of instance, which is basically used for generic usage, and also it will provide you a burst in performance whenever required, but it's mostly basic. But compute optimized will basically provide you really good processing power. So basically it will provide you more CPU cores than the RAM provided. Okay, so that's basically compute optimized. It will be optimized for compute. Memory optimized is optimized for memory, that is, it will give you more RAM, but the cores will be less. The virtual CPUs would be, the number of the virtual CPUs would be comparatively less than the RAM. So this is for memory. So if there is any in-memory processing, you would have to choose a memory optimized instance type. Storage optimized, this is for storage. So for example, in this particular EC2 instance, there is often data coming in, data going out. You want the data read and write to be really fast. In that case, you should go for storage optimized. So that's exactly why you should go for that. Finally, the accelerated computing. So this is basically for example, if you're running an artificial intelligence model or a machine learning model, or if you're transcoding videos, or if you're rendering videos or graphics on the server. In that case, you need accelerated computing, which would provide you a really high performance for these kinds of requirements, right? So these are different types of instances. Coming to the 17th question, what is the relation between the availability zone and the region? So to put it very simply, the region is the entire region. So there could be so the regions are geographical. Within the region, there could be any number of data centers, but usually around there are 6 to 7 data centers in AWS. So an AWS availability zone is a physical location where an Amazon data center is located. On the other hand, an AWS region is a collection or group of availability zones. For example, let's consider in US, there are so many different states. So for example, when they say Oregon, right? In Oregon, there could be multiple data centers in different physical locations, but the group of them in that particular region. So that region, Oregon, is the region, and within that there are multiple availability zones. So they are the availability zones. That's basically it. Availability zones are individual data centers. The region is just to group them together. Okay, so this setup helps your services to be more available, as you can place your virtual machines in different data centers in even different AWS regions. So you can have your data center in Oregon, you can have it in North Virginia, you can have one more server in India, you can have one more server in Japan. So it totally depends on whatever is your requirement. So that's what they are saying. If one of the data center fails, the other one would be running, so that your servers would be always running, and that will make it always available. So this basically provides the failover. It provides you fault tolerance. Even though your server in a particular region goes down, your application wouldn't completely shut down, because there are other regions and other data centers which are actively running. This is basically the difference. It's not a difference basically, because availability zone is within a region. Region is a logical group, but within the logical group there are physical components, which is an availability zone. Next question, how do you monitor VPC? So as I told you already, there is CloudWatch. It's the default tool, but VPC has a separate function, which is VPC flow logs, which will give every single action performed within the VPC as a log. So you can see every single action done in that particular VPC with flow logs. So these are the two different ways you can monitor VPC. So what are the different types of EC2 instances based on their costs? Essentially three types: on-demand, spot, and reserved. On-demand instances are when they are prepared whenever you need. So you can, if I want an instance right now, I can log in AWS and create an instance. That would be an on-demand instance. So that would be created for a short period of time. So basically, on-demand instances are created for short-term requirements. For example, if I currently want to run a particular code and I want to just run a website for a couple of hours just to test it, so then I would go with an on-demand instance, because on-demand instances are more expensive than spot or reserved instances. Let me tell you why when we come to spot or reserved, but they are expensive. So it is cheap for a short-term instance, but it is not cheap for the long term. It will get much more expensive. So that's basically on demand. Coming to spot instances, so these types of instances can be bought through a bidding model. These are comparatively cheaper than on-demand instances. So in this case, you will have to bid for the instance, and if the instance is available, you will be given access to it. So once you win the bid, you will be able to pay for the instance. Basically, that particular bid amount you will be able to pay. Right? So these are spot instances, but reserved instances are the one which companies mostly use for their needs. So why? Because reserved instances are reserved for you. For example, a company wouldn't be like, okay, if I want an instance right now, they wouldn't go right now and create it. They would already reserve some physical hardware which is already available. For example, you can create instances that you can reserve for a year or so. These types of instances are especially useful when you know in advance that you will be needing an instance for the long term. In such cases, you can create a reserved instance and save heavily on costs. Why save heavily on costs? Because when you reserve instances, AWS gives you discounts like 40 to 50%. That's a lot of money, right? Which you can save. And a company wants to obviously cut down on operational costs. They will always go for reserved instances. For example, let's say there's a new project coming up. And obviously, if a new project comes up, the project will be always live, right? So to once for maybe for the testing and all, you can use an on-demand instance, but when it comes to live, obviously reserved instance would be a much better chance, because if the application is going to be live for a long time, you can take a 3-year reserved instance. It won't be one instance. When it comes to a company, it will be 100 or thousands of instances, basically servers. So in this case, you would be reserving them by basically using the reserved instances tactic, where you can basically reserve these number of instances for this period of time, that is 1 year or 3 year. You can put a contract with AWS and you can pay them upfront, or you can pay them monthly, or there are different types of paying models in reserved instances, but it will be much cheaper than going with on-demand instances. It will save you, if it's a 3-year contract, it will save you more than a 1-year contract, because you're reserving instances for a 3-year period of time, right? So these are basically different types of instance based on costs. Coming to the next question, what do you understand by stopping and terminating an EC2 instance? Really easy question, but it comes with certain complications. Even though stopping and terminating may sound similar, but in EC2 it's totally different. Stopping is basically shutting down your system. For example, if you shut down your system and restart it, the PC is still there, right? If I shut down my laptop and open it back and switch it on, it'll still switch on, the instance will still be available. It'll have the storage, it'll have all my files, everything will be there. You can just start from where you left off. But terminating is basically like selling your laptop to another person or breaking your laptop. So once you break your laptop, you can't do anything to it because it doesn't exist, right? So that's basically what terminating is. You're completely deleting the instance, and so nothing would be available. The instance would be deleted, the data would be deleted, this volume will be deleted, everything will be deleted. You would not be able to restart or look into the system later in time. So that's basically the difference in stopping and terminating in EC2. I hope that's clear. Okay, coming to the next question, what are the consistency models offered for modern databases by AWS? So eventual consistency and strong consistency. So coming to eventual consistency, it basically means the data will be consistent eventually, but not immediately. So let's say there are two databases. If I upload some data to this database, I want it to be available in this database as well. But eventual consistency basically means it will get consistent eventually in time, but once I upload it, it won't be immediately replicated. It will take some time to replicate it. So this will serve the client requests faster, but chances are that some of the initial read requests may read stale data because that data wouldn't be available at that point of time because it's not transferred to the other database. So this type of consistency is preferred in systems where data need not be real time. So if you don't want the data to be real time in a particular system, in that case, you wouldn't want this. So you would want this type of consistency. For example, if you don't see the recent tweets on Twitter or recent posts on Facebook for a couple of seconds, it is acceptable. So that's where eventual consistency comes into play because it's not gonna kill anybody, right? It's not a thing which is required immediately. So let's say you're posting something right now and it takes 2 seconds to show up on your profile. That wouldn't hurt anybody, right? So that's basically what eventual consistency is. But strong consistency, it provides immediate consistency where the data will be consistent across all of your database servers immediately. As soon as you upload it to a database server, it will be immediately replicated to the other database servers. Okay, so this model may take some time to make the data consistent and subsequently start serving the requests. So eventual consistency, the data will be available in one database server, but it will take time to replicate to other database servers. So in that case, the data can still be read from that particular database server. But when it comes to strong consistency, as the database servers are currently trying to become consistent by basically replicating it across each other. So when you are trying to request some data, it would take some time because it is trying to make every database server consistent. So however, in this model, it is guaranteed that every single response you get will have consistent data. In the previous one, even though let's say it takes a couple of seconds to show up, it's fine because it's not real time. But in this case, strong consistency, you would need you basically use it for a real time use case. Okay, so this is the difference in consistency models offered. Okay, next question, geo-targeting and CloudFront. So geo-targeting enables the creation of customized content based on the geographic location of the user. This allows you to serve the content which is more relevant to a user. For example, if you take YouTube, some content is available in US, but you won't be able to see that content in India. Or take Netflix, some movies are available in Europe, those movies are not available in China, or that movies are not available in Japan. Why is that? They're using geo-targeting, right? By using geo-targeting, you can basically serve the relevant content to your user. And also, if it's an Indian YouTuber, it wouldn't make sense to show that particular YouTuber's content to a American, right? Especially if it's in an Indian language, they wouldn't be watching it. So it doesn't make sense. So by using geo-targeting, you would be able to deliver content in a proper manner based on the geographic location of the user. For example, using geo-targeting, you can show the news related to local body elections to a user sitting in India, which may not be suitable for a user sitting in the US. Why would they want to watch a local body election happening in India? Same thing if there is a baseball tournament in the US which is going on. We Indians don't play baseball. We play cricket and other sports like football and stuff like that. So maybe if it's a football game, we would watch it. But if it's a baseball game, most probably we wouldn't. So yeah, so that's basically is geo-targeting, right? Okay, coming to the next question, what are the advantages of AWS IAM? So IAM means Identity and Access Management. So it enables an administrator in AWS to provide granular level access to different users and groups. So using IAM, you will be able to provide access to a user you created in IAM. So you can basically create users, you can create groups, and once you do that, you can give them permissions to do certain actions. For example, you want to allow a user to basically work only on EC2. You don't want him to work on other services. You can do that. You can provide him permissions to only use EC2. He wouldn't be able to use other services, right? So that you can do with IAM. So it also allows you to provide access to the resources to users and applications without creating roles, which is known as federated access. Also, there is something called IAM roles, which could provide an user temporary access to that particular service you want them to use. Right? It's temporary access. It's not permanent. So there are more things to IAM. So, but the advantages are you can create users and groups, and you can control the users by you can basically have access to them, and you can have basically you can provide them different level of access according to the user. For example, a developer would need different types of AWS services. Data scientist would need different types of AWS services. Let's say a finance account manager would need different types of AWS services. So according to that, you can provide them particular access. So that's basically what are the advantages of AWS IAM. You would be able to basically administer over users and the permissions they have. Coming to the next question, what do you understand by a security group? So to be very simple, security group is basically like a virtual firewall. So when you create an AWS instance, you may or may not want that instance to be accessible from the public network. Moreover, you may want that instance to be accessible from some networks and not from others. For example, you are creating an instance and only you want to access it. So you know the IP address of your PC, right? So in that case, you can create in the security group, you can pass on your IP address and only you would be able to log in into that EC2 instance, even though somebody else has a private key. Let's say you have given the private key to someone else, they wouldn't be able to log in because they wouldn't have the IP address. Now, coming to second point, security groups are type of rule-based virtual firewall using which you can control access to your instances. So you can create rules defining the port numbers, networks, or protocols from which you want to allow access or deny access. Okay, so it's basically simple. You can provide the port numbers, you can provide the IP addresses, the protocols, all the things you can provide. So this will basically, and also you can allow them or deny them. So let's say if you want a particular range of IP address to be denied, whenever a request comes from that IP address, they wouldn't be allowed to access the instance because the security group will stop them. So it's basically very, very simple. You can control who can access and who can't access the instance, and where the request goes, where the request comes, everything can be accessed using a security group. Okay. Now, what are spot instances and on-demand instances? So I think we already looked into this, but I'll just explain what a spot instance is even better. The on-demand I've already explained in a previous question. You can go check that. So spot instances, while you create EC2 instances, there are some blocks of computing capacity and processing power left unused. So let's say you launch a really huge instance, but only utilize one certain part. So now these blocks are known as spot instances. So these spot instances run wherever capacity is available. So these are a good option if you are flexible about where your applications run. If you don't want your application to be running in a physical hardware which is dedicated to you, in that case you can go for spot instances which are much cheaper in nature, right? So yeah, so if you're flexible with that, you can go with spot instances. So that's basically it. On-demand instances are I've already explained, and you can look into them. You can just go back in the session and you can look into them. Right. Next is explain connection draining. So connection draining is a feature by AWS which enables your servers, which are either going to be updated or removed, to serve current requests. So that basically means, let's say your server, right, it is going to be updated to a newer version, but connections are still coming in, so it will still allow the server to basically serve those requests. So if connection draining is enabled, the load balancer will allow an ongoing instance to complete the current requests for a specific period of time. For example, you can set that up. It will allow, let's say, the incoming request, it will serve for 10 minutes and then but will not send any new request to it. So if already 100 requests have been made, right, so it will allow those 100 requests to be served, but after that it wouldn't let any new requests to come in, but that 100 requests will be served. Once it is served, then it will be stopped. So now without connection draining, an outgoing instance will immediately go off and the requests pending on that instance will error out. So that would be a major problem for users, right? So because if you're trying to retrieve some data and the application was working at that point of time, so once you click on retrieve data and it doesn't give you the data, you would be kind of pissed off. So but in this case, using connection training, that wouldn't happen. If the system is going to be updated, you would get back the data and then it will go to an off state where it's in maintenance. So otherwise you would get the request back. So this is basically connection training, and this feature is available in load balancer. Next, what is a stateful and a stateless firewall? A stateful firewall is basically the one that maintains the state of the rules defined. It requires you to define only inbound rules. Based on the inbound rules, it automatically allows the outbound rules, outbound traffic to flow. So you only have to mention the inbound rules. Basically means you only have to decide on the incoming traffic. So it'll automatically choose, or it'll automatically filter the outgoing traffic. But the only thing you'll have to provide is the incoming traffic rules. So who can access the server from where you don't want, so who can't access the server, all of these things you will have to do. But the outgoing from the server will be taken care of the system itself. So that's basically stateful. In stateless, you explicitly define rules. That is, you can basically decide what are the IP addresses, what are the things which comes in, and what are the things which goes out. Everything could be handled by you, but you will have to do it by yourself. You have to explicitly define those rules. For example, if you allow inbound traffic for port number 80, stateful firewall will allow outbound traffic to port 80, but stateless firewall will not do it, because in stateless firewall, if you provide inbound traffic for port number 80 and leave it, it will only allow inbound traffic for port number 80. But if in stateless firewall, you will have to go ahead and explicitly mention that also I need output traffic for port number 80, right? Once you do that, then it will allow. But in stateful, you basically means if you mention something, if somebody can enter the instance, right, somebody can inbound, they can also go out. So that's basically what stateful does. Stateless doesn't do it. In stateless, you have to give every single detail manually. Coming to the 28th question, what is a power user? Access in AWS. So it's pretty simple. It's like a sudo user in Linux. So a power user will be given administrator access. So using IAM, you are creating a user. Once you create a user, you can give them administrator access. So once you give them administrator access, they can do everything the root user does. Only thing they can't do is like they can't delete the AWS account. They can't check out the billing dashboard. So those are the things they can't check out, but they can do everything else apart from those. So without the capability to manage the users and permissions. In other words, a user with power user access can create, delete, modify, or see the resources, but he cannot grant permissions to other users. So he'll not be able to create other users and grant permissions to other users, but he'll have all the access to use any service in AWS he wants or she wants, right? Okay, next question is, what is an instance store volume and an EBS volume? So it's basically two different things. So instance store volume is a temporary storage. Only temporary data is stored, because let's say the instance is restarted, that data will be gone. That is instance store. It's like RAM. But EBS volume is like your SSD or your HDD. So once the data is stored, it is stored there because it's a storage disk. And once it is stored, even though the instance gets turned off, it will be available. That's the only difference. Instance store is like RAM. When the instance is running, when temporary data is available, it will be stored in the instance store. Once your instance is restarted or it's shut down, that data will be gone. But whatever data is stored in the EBS volume will still be there. 30th question. What are recovery time objective and recovery point objective in AWS? So recovery time objective, it is the maximum acceptable delay between the interruption of service and restoration of service. This translates to an acceptable time window when the service can be unavailable. For example, recovery time objective, let's say AWS tells you that 5 minutes per day. So you can expect that the service will not be available for 5 minutes in a day, but it is not acceptable if it goes beyond that 5 minutes. So if it goes beyond that 5 minutes, you will be able to get a refund or whatever from AWS, but that's the limit given to you. So but it's 5 minutes per day, it's also a lot of time. So that's not the case, it's totally different, but I'm just giving you an example. Next is recovery point objective. So in this case, it is the maximum acceptable amount of time since the last data restore point. It translates to the acceptable amount of data loss which lies between the lost recovery point and the interruption of service. Let's say data is being uploaded and the service has been interrupted, so there would be obviously some data loss, right? So how much data can be lost, how much data loss is acceptable? That's basically a recovery point objective. So these two things has to be given to you when you are trying to create a mission critical application on AWS, because mission critical data can be lost, mission critical applications might be interrupted of service. So these are the things which we'll have to discuss with the AWS team, AWS sales team, the tech team, everything before you basically transition all your stuff into AWS, right? 31st question. Is there a way to upload a file that is greater than 100 megabytes in S3? So in S3, at one go, you can't upload files more than 100 megabytes, but there's an option to do this, which is multi-part upload utility. So it will split the large file into multiple parts. Let's say you're uploading a file of 1 gigabyte, which is 1024 megabytes, right? It will split it into 10 parts and it will upload it, or it will split it into 11 parts and upload it, and then once it's uploaded, it will be clubbed together. So you can also decrease upload time by uploading these parts in parallel. So in this case, larger files can be uploaded in multiple parts that are uploaded independently. So if you want to reduce the time, you can upload those 11 files at the same time, and then you can club them together. After the upload is done, the parts are merged into a single object or file to create the original file from which the parts were created. So you can use multi-part upload to upload a really huge file. Coming to the 32nd question. Can we change the private IP address of the EC2 instance while it is running or in a stop state? So first of all, once you created an EC2 instance and once the private IP address is assigned, you will not be able to change the private IP address. When an EC2 instance is launched, a private IP address is assigned to it. So once it is assigned, you will not be able to change it because it is attached to the instance for its entire lifetime. So once it's terminated, you can create another instance, and that instance can have the same private IP because this instance is dead, it's not available, and the private IP address is free now, so it can be assigned to another a server, but that server cannot have a different private IP address. It can have the same, it will only have the same IP address. 33rd question. So what is the use of lifecycle hooks in autoscaling? So lifecycle hooks are used for autoscaling to put an additional wait time to scale in or scale out event. To make it even simpler, let me just explain using this particular thing. So this is a lifecycle hook and this is a lifecycle hook, right? First of all, scale out. Scale out basically means decreasing the number of instances. Let's say you have 5 instances. Now you don't need 5 instances, you want only 3 instances. So now you are reducing 2 instances, right? Now scale out pending. So lifecycle hook basically pending wait, pending proceed. So it is basically the instances are launching. So sorry, scale out basically means increasing the number of instances. Sorry, my mistake. So once then the instance, once it is launched, it would be in service, and then scale and comes in. So in this case, there is another lifecycle hook which is for terminating. First, once the terminating is started, it will wait, and then it will check how many instances has to be terminated. So once that is decided, it will terminate the instances, and then termination will be done. So in an autoscaling instance, so this is what happens. So it basically gives you an additional wait time to scale in or scale out. That's exactly what lifecycle hooks does, and that's exactly what it helps. And the final question which you're going to look into is what are the policies that you can set for your users' passwords? Okay, so let's say using IAM, you're creating a user's passwords. So what are the different kinds of settings you can do to that user's password so that they create a secure password? First of all, you can provide a minimum length. If you want the minimum length of the password to be 10 characters, you can do that. Second, you can ask the users to add at least one number or special character. Third, you can provide a requirement like a particular character type like @ or hashtag or forward slash or backward slash. So you can provide that you need at least these, or you need uppercase letters, lowercase letters, numbers, and non-alphanumeric characters. So you can ask these requirements. Fourth, you can enforce automatic password expiration. That is, you can set up a password expiration period. After every month, they'll have to change a new password. That's basically the fourth one. And the final one is you can have the AWS users contact an account administrator when the user has allowed the password to expire. So basically, you don't have to manually change the password. You can allow them. So you can basically give the access to the account administrator when the user has allowed the password to expire, right? So if the user allowed the password to expire, then they will be able to contact the account administrator and get their password back if they are not able to create a new password. So these are the different types of things. These are different policies which AWS administrator can set to the IAM users, right? So these are basically the questions, guys. So now coming to the final part, I'm going to ask you a question. So if you know the answer, put down in the question section and we would give you a heart from our side to recognize that yes, that's the right answer. So the question basically is, which of the following is an edge storage or content delivery network? So which of the following is an edge storage or content delivery system that caches data in different physical locations? Four options: relational database service, DynamoDB, CloudFront, associate web services. So I'll repeat it again. Which of the following is an edge storage or content delivery or CDN that caches data in different physical locations? So is it RDS or DynamoDB, CloudFront, or associate web services? If you know the answer, put it in the comment section. So that's basically the session, guys. I hope it was helpful. So meet you in another one. And if you like the session, please leave a like. Thank you.